rays are a form of light, infrared, optical, all this whole electromagnetic spectrum. None of it is emitted as light. It's completely dark. It's only emitted in the ripple.
Why are you going to start streaming using OBS?
A lot of times it's likened closer to sound. Technically, we've kind of argued, and it haven't done an anatomical calculation, but if you're near enough to two colliding black holes, they actually ring space-time in the human auditory range. The frequency is actually in the human auditory range. That the shape of space could squeeze and stretch your eardrum, even in vacuum, and you could literally hear these waves ringing.
The following is a conversation with Jana Levin, a theoretical physicist and cosmologist specializing in black holes, cosmology of extra dimensions, cosmology of the universe, and gravitational waves in space-time. She has also written some incredible books, including How the Universe Got Its Spots, on the topic of the shape and the size of the universe, A Madman Dreams of Turing Machines, on the topic of genius, madness, and the limits of knowledge, Black Hole Blues,
big girl,
other songs from outer space, on the topic of LIGO and the detection of gravitational waves, and Black Hole Survival Guide, all about black holes. This was a fun and fascinating conversation. This is a Let's Stream podcast. Supported, please check out our sponsors in the description. The Knowledge of Friends with Jenna Levin. I should say that you sent me a message about not starting early in the morning, and that made me feel like we're kindred spirits.
Yeah.
You wrote to me when the great physicist Sidney Coleman was asked to attend the 9 a.m. meeting. His reply was, "I can't stay up that late."
Yeah.
So
Sydney was beloved.
I think all the best thoughts, honestly. There's some of the worst thoughts too are all come at night. There's something about the night. Maybe it's the silence. Maybe it's the peace all around. Maybe it's the darkness. And you can be with yourself and you can think deeply.
I feel like there's stolen hours in the middle of the day because it's not busy. Gadgets aren't pinging. There's really no pressure to do anything, but I'm often awake in the middle of the night. And so it's sort of like these extra hours of the day. I think we were exchanging messages before in the morning.
Okay. So in that way, many other ways, we're Pinterest spirits.
Mm-hmm.
So let's go. In one of the coolest objects in the universe, black holes, what are they? And maybe even a good way to start is to talk about how are they formed.
Yeah. In a way, people often confuse how they're formed with the concept of the black hole in the first place. So when black holes were first proposed, Einstein was very surprised that such a solution could be found so quickly, but really thought nature would protect us from their formation. And then nature thinks of a way. Nature thinks of a way to make these crazy objects, just to kill off a few stars. But then I think that there's a confusion that dead stars, these very, very massive stars that die, are synonymous with the phenomenon of black hole. And it's really not the case. Black holes are more general and more fundamental than just the death state of a star. But even the history of how people realized that stars could form black holes is quite fascinating. The entire idea really just started as a thought experiment. If you think of it's 1915, 1916, when Einstein fully describes relativity in a way that's the canonical formulation. There was a lot of changing before then. It's World War I, and he gets a message from the Eastern Front from a friend of his, ROTHSCHILD, who solved Einstein's equations. Between sitting in the trenches and cannon fire, it was joked that he was calculating ballistic trajectories. He's also perusing the proceedings of the Russian Academy of Sciences, as you do. And he was an astronomer who had enlisted in his 40s. And he finds this really remarkable solution to Einstein's equations. It's the first exact solution. He doesn't call it a black hole. It's not called a black hole for decades. But what I love about what Schwarzschild did is it's a thought experiment. It's not about observations. It's not about making these things in nature. It's really just about the idea. He sets up this completely untenable situation. He says, imagine I crush all the mass of a star to a point. Don't ask how that's done, because that's really absurd. But let's just pretend, and let's just imagine that that's a scenario. And then he wants to decide what happens to space-time. If I set up this confounding, but somehow very simple scenario. And really what Einstein's equations were telling everybody at the time was that matter and energy curve space and time. And then curved space-time tells matter and energy how to fall. So he finds this beautiful solution. And the most amazing thing about his solution is he finds this demarcation, which is the event horizon, which is the region beyond which not even light can escape. And if you were to ask me today, all these decades, over 100 years later, I would say that is the black hole. The black hole is not the mass crushed to a point. The black hole is the event horizon. The event horizon is really just a point in space-time or a region in space-time. It's actually, in this case, a surface in space-time. And it marks a separation in events, as well as the event horizon. Everything outside is causally separated from the inside insofar as what's inside the event horizon can't affect events outside. What's outside can affect events inside. I can throw a probe into a black hole and cause something to happen on the inside. But the opposite is true. Somebody who fell in can't seem to probe out. And this one-way aspect really is what I found out. Sometimes we talk about the black holes being nothing because at the event horizon, there's really nothing there. Sometimes when we think about black holes, we want to imagine a really dense, dead star. But if you go up to the event horizon, it's an empty region of space-time. It's more of a place than it is a thing. And Einstein found this fascinating, and he helped get the work published, but he really didn't think these would form in nature. I doubt Carl Schwarzschild did either. I think they thought they were solving theoretical, mathematical problems, but not describing this, what turned out to be the end state of gravitational flux.
And maybe the purpose of the thought experiment is to find out limitations of the theory. So you find the most extreme versions in order to understand where it breaks down.
Yeah.
And it just so happens in this case that might actually predict these extreme kinds of objects.
It does both. So it also describes the sun from far away. So the same solution does a great job helping us understand the Earth's orbit around the sun. It's incredible. It does a great job. It's almost overkill. You don't really need to be that precise. There's relativity. And yes, it predicts the phenomenon of black holes, but doesn't really explain how nature would form them. But then it also, on top of that, does signal the breakdown of the theory. You're quite right about that. It actually says, oh man, but you go all the way towards the center, and yeah, this doesn't sound right anymore. Sometimes I liken it to a dying man marking in the dirt that something's gone wrong here. Right? It's signaling that there's some culprit, there's something wrong in the theory. And even Roger Penrose, who did this general work trying to understand the formation of black holes from gravitational collapse, he thought, oh yeah, there's a singularity that's inevitable. It's in there's no way around it once you form a black hole. But he said this is probably just a shortcoming of the fact that we've forgotten to include quantum mechanics. And that when we do, we'll understand this differently.
So according to him, the closer you get to the singularity, the more quantum mechanics comes into play, and therefore there's no singularity, there's no loss.
I think everybody would say that. I think everybody would say the closer you get to the singularity, for sure you have to include quantum mechanics. You just can't consistently talk about magnifying such small scales, having such enormous ruptures and curvatures and energy scales, and not include quantum mechanics. That's just inconsistent with the world as we understand it.
So you've described brain-breaking idea that a black hole is not so much as super dense matter as it's sometimes described. It's more akin to a region of space-time, even more so just nothing.
Yeah.
It's nothing. That's the thing you seem to like to say.
I do like to say that black holes are no thing. They're nothing.
Okay, so what does it
and
mean?
that's what I mean. That's the more profound aspect of black holes. So you asked originally, how do they form? And I think that even when you try to form them in messy astrophysical systems, there's still nothing at the end of the day left behind. This was a very big surprise, even though Einstein accepted that this was a true prediction. He didn't think that they'd be made, and it was quite astounding that people like Oppenheimer, actually it's probably Oppenheimer's most important theoretical work, who were thinking about nuclear physics and quantum mechanics, but in the context of these kind of utopian questions. Why do stars shine? Why is the sun radiant and hot, and this amazing source of light? And it was people like Oppenheimer who began to ask the question, well, could stars collapse to form black holes? Could they become so dense that eventually not even light could escape? And that's why I think people think that black holes are these dense objects. That's often how it's described. But actually what happens, these very massive stars, they're burning thermonuclear fuel. They're Earthfuls of thermonuclear fuel. And emitting energy in E equals mc squared energy. So it's fusing, it's a fusion bomb. It's a constantly going thermonuclear bomb. And eventually it's going to run out of fuel. It's going to run out of hydrogen, helium, stuff to fuse. It hits an iron core. Iron, to go past iron with fusion, is actually energetically expensive. So it's no longer going to do that so easily. So suddenly it's run out of fuel. And if the star is very, very, very massive, much more massive than our sun, maybe 20, 30 times less our sun, it'll collapse on its own weight. And that collapses incredibly fast and dramatic, and it creates a shock wave. So that's the supernova explosion. So a lot of these, they rebound because once they crunch, they've reached a new critical capacity where they can reignite to higher elements, heavier elements, and that sets off a bomb, essentially. So the star explodes, helpfully, because that's why you and I are here. Because stars send their material back out into space, and you and I get to be made of carbon and oxygen and all this good stuff. We're not just hydrogen. So the suns do that for us. And then what's left sometimes ends at a neutron star, which is a very cool object, very fascinating object, super dense, but bigger than a black hole, meaning it's not compact enough to become a black hole. It's an actual thing. A neutron star is a real thing. It's like a giant neutron. Literally, electrons get jammed into the protons and make this giant nucleus in this superconducting matter. Very strange, amazing objects. But if it's heavier than that, the core, and that's heavier than twice the mass of the sun, it will become a black hole. And Oppenheimer wrote this beautiful paper in 1939 with a student saying that they believed that the end state of gravitational collapse is actually a black hole. And really a visionary conclusion. Now the paper is published the same day the Nazis advance on Poland. And so it does not get a lot of fanfare in the newspaper.
I think there's a lot of drama in that.
Yeah.
Like, here's a guy who predicts how actually in nature would be the formation of this most radical of objects that broke even Einstein's brain, while one of the most evil, if not the most evil humans in history is starting the first steps of a global war.
What I also love about that lesson is how agnostic science is, because he was asking these utopian questions, as were other people at the time, about the nuclear physics of stars. You might know this play, Copenhagen, by Michael Frayn. There's this line that he attributes to Bohr. Bohr was the great thinker of early foundations of quantum mechanics, Danish physicist, where Bohr says to his wife, nobody's thought of a way to kill people using quantum mechanics. Now, of course, then there's the nuclear bomb. And what I love about this was the pressure scientists were under to do something with this nuclear physics and to enter this race over a nuclear weapon. But really, at the same time, 1939, really, Oppenheimer's thinking about black holes. There's even a small line in Chris Nolan's film. It's very hard to catch. There's a reference to it in the film where they're sort of joking, well, I guess nobody's going to pay attention to your paper now, because of the Nazi event.
That's the other remarkable thing about Oppenheimer is he's also a central figure in the construction of the bomb.
Right.
So it's theory and experiment clashing together with geopolitics.
Exactly. So, of course, Oppenheimer, now known as the father of the atomic bomb, he talks about destroyers of worlds. But it's the same technology, and that's what I mean by science is agnostic, right? It's the same technology, overcoming a critical mass, igniting thermonuclear fusion. Eventually, there was a fission. The original bomb was a fission bomb. Fission was first shown by Lise Meitner, who showed that a certain uranium, when you bombarded it with protons, broke into smaller pieces that were less than the uranium. Right? So some of that mass, that E equals mc squared energy, had escaped, and it was the first kind of concrete demonstration of this Einstein's most famous equation. So all of this comes together. But the story of, they still weren't called black holes. This is 1931. And they had these very long-winded ways of describing the end state, the catastrophic end state of gravitational collapse. But what you have to imagine is as this star collapses, so what's the sun? The sun's 1.5 million kilometers across. So imagine a star much bigger than the sun, much bigger radius, and it's so heavy it collapses, it's supernovas. What's left is still maybe 10 times the mass of the sun, just what's left in that core. And it continues to collapse. And when that reaches about 60 kilometers across, just imagine 10 times the mass of the sun, city-sized. That is a really dense object. And now the black hole essentially has begun to form, meaning the curve in space-time is so tremendous that not even light can escape. The event horizon forms, but the event horizon is almost imprinted on the space-time because the star can't sit there in that dense state any more than it can race outward at the speed of light, because even light is forced to rain inwards. So the star continues to fall. And that's the magic part. The star leaves the event horizon behind, and it continues to fall, and it falls into the interior of the black hole. Where it goes, nobody really knows, but it's gone from sight. It goes dark. There's this quote by John Wheeler, granddaddy of American relativity, and he has a line that's something to the effect, the star, like the Cheshire cat, fades from view. One leaves behind only its rim, the other only its gravitational attraction. And he was giving a lecture, it's actually about Tom's Restaurant, from Seinfeld, near Columbia in New York. There was a place, and there still is a place there, where people were giving lectures about astrophysics, and it's 1967. Wheeler is exhaustively saying this loaded term, the end state of catastrophic gravitational collapse. And rumor is that someone shouts from the back row, well, how about black hole? And apparently he then foists this term on the world. Wheeler had a way of doing that.
Well, I love terms like that. Big Bang, black hole. There's some, it's just pointing out the elephant in the room and calling it an elephant. It is a black hole. That's a pretty accurate description. I just wanted to point out that just looking for the first time at the 1939 paper from Oppenheimer, it's like 2 pages, it's like 3 pages.
Oh yeah, it's gorgeous.
The simplicity of some of these, it's so gangster, just revolutionized all of physics with this. Einstein did that multiple times, a year. When all thermonuclear sources of energy are exhausted, a sufficiently heavy star will collapse. That's how I put it. Unless fission due to rotation, the radiation of mass, or the blowing off of mass by radiation reduces the star's mass to orders of that of the sun, this contraction will continue indefinitely. And it goes on that way.
Yeah, now I have to say that Wheeler, who actually coins the term black hole, gives Oppenheimer quite a terrible time about this. He thinks he's wrong. And they end what has sometimes been described as kind of a bitter, I don't know if you would actually say feud, but they were bad feelings. And Wheeler actually spent decades saying Oppenheimer was wrong. And eventually, with his computer work, that early work that Wheeler was doing with computers when he was also trying to understand nuclear weapons, and in peacetime worlds found themselves returning again to these astrophysical questions, decided that actually Oppenheimer had been right. He thought it was too simplistic, too idealized a setup that they had used, and that if you looked at something that was more realistic, more complicated, that it just would go away. And in fact, he draws the opposite conclusion. And there's a story that Oppenheimer was sitting outside of the auditorium when Wheeler was coming forth with his declaration that in fact black holes were the likely end state of gravitational collapse for very, very heavy stars. And when asked about it, Oppenheimer sort of said, well, I've moved on to other things.
Because you've written in many places about the human beings behind science. I have to ask you about this, about nuclear weapons. Was the greatest of physicists coming together to create this most terrifying and powerful new technology. And now I get to talk to world leaders for whom this technology is part of the tools that is used, perhaps implicitly, on the chessboard of geopolitics. What can you say as a person who's a physicist and who has studied the physicists and written about the physicists and humans behind this, about this moment in human history when physicists came together and created this weapon that's powerful enough to destroy all of human civilization?
I think it's an excruciating moment in the history of science. And people talk about Heisenberg, who stayed in Germany and worked for the Nazis in their own attempt to build the bomb. There was this kind of hopeful talk that maybe Heisenberg had intentionally derailed the nuclear weapons program, but I think that's been largely discredited, that he would have made the bomb had he not made some really kind of simple errors in his original estimates about how much material would be, or how they would get over the energy barriers. And that's a terrifying thought. I don't know that any of us can really put ourselves in that position of imagining that we're faced with that quandary, having to take the initiative to participate in thinking of a way that quantum mechanics can kill people, and then making the bomb. I think overwhelmingly physicists today feel we should not continue the proliferation of nuclear weapons. Very few theoretical physicists want to see this continue.
That moment in history, the Soviet Union had incredible scientists, Nazi Germany had incredible scientists, and the United States had incredible scientists. It's very easy to imagine that one of those three would have created the bomb first, not the United States.
Yes.
And how different would the world be? The game theory of that. I think, say the probability is 33% that it was the United States. If the Soviet Union had the bomb, I think they would have used it in a much more terrifying way in the European theater and maybe turn in the United States. And obviously with Hitler, he would have used it. I think there's no question he would have used it to kill hundreds of millions of people.
In the game theory version, this was the least harmful outcome. Yes, but there is no outcome with no bomb that any game theorist would, I think, would play.
But I think if we just remove the geopolitics and the ideology and the evil dictators, all of those people are just scientists. I think they don't necessarily even think about the ideology. It's a deep lesson about the connection between great science and the annoying, sometimes evil politicians that use that science for means that are either good or bad. And the scientists perhaps don't. Boy, do they even have control of how that science is used? It's hard.
No control, right? Once it's made, it's no longer scientific reasoning that dictates the use or restraint. But I will say that I do believe that it wasn't a 31/3 down the line, because America was different, and I think that's something we have to think about right now in this particular climate. So many scientists fled here. They fled to here. Americans weren't fleeing to Nazi Germany. They came here and they were motivated by, it's more than a patriotism. I mean, it was a patriotism, obviously, but it was sort of more than that. It was really understanding the threat of Europe, what was going on in Europe, and what that life, how quickly it turned, how quickly this free-spirited Berlin culture, was suddenly in this repressive and terrifying regime. So I think that it was a much higher chance that it happened here.
Yeah, there's something about the American system. It's cliche to say, but the freedom, all the different individual freedoms that enable a very vibrant and expressive, very vibrant scientific community. That's really exciting.
Absolutely.
scientists, and it's very valuable to maintain that.
Right.
The vibrancy of the debate, of the funding those mechanisms.
Absolutely, the world flocked here, and that won't be the case if we no longer have intellectual freedom.
Yeah, there's something interesting to think about the tension, the Cold War between China and the United States in the 21st century. You know, some of those same questions, some of those ideas will rise up again, and we want to make sure that there's a vibrant, free exchange of scientific ideas. I believe most Nobel Prizes come from the United States, right?
Oh, yeah, I don't have the number, but
it's disproportionate.
It's disproportionate. So, in fact, a lot of them from particle physics came from the Bronx, and they were European immigrants.
How do I explain this?
Inside Europe, precisely because the geopolitics we're describing.
Yeah.
And so instead of being Nobel Prize winners from the Soviet Union or from the Eastern Bloc, they were from the Bronx.
And that's the thing you write about. We'll return to time and time again. You know, science is done by humans, and some of those humans are fascinating. There's tensions, there's battles, there's some are loners, some are great collaborators, some are tormented, some are easygoing, all this kind of stuff. That's the beautiful thing about it. If it gets sometimes, it's humans, and humans are messy and complicated and beautiful and all of that.
Yeah.
So what were we talking about? Oh,
the stars collapsing.
okay. So can we just return to the collapse of a star that forms a black hole? At which point does the superdense thing become nothing? Just like moving on this concept.
Yeah. So if I were falling into a black hole, it would really fast, right as I crossed this empty region, but this demarcation, I happened to know where it was. I calculated because there's no line there. There's no sign that it's there. There's no signpost. I could emit a little light pulse and try to send it outward exactly at the event horizon. So it's racing outward at the speed of light. It can hover there because from my perspective, it's very strange. The space-time is like a waterfall raining in, and I'm being dragged in with that waterfall. I can't stop at the event horizon. It comes, it goes. It's behind me really quickly. That light beam can try to sit there because it's like a fish swimming against the Niagara, swimming against the waterfall.
It's like stuck there.
But it's like stuck there. And so that's one way you can have a little signpost. If you fly by, you think it's moving at the speed of light. It flies past you at the speed of light, but it's sitting right there at the horizon.
You're falling back, crossing the horizon, right at that point, you shoot outwards a photon.
Yes.
And it's just stuck there.
It is get stuck there. Now, it's very unstable. So the star can't sit there is the point. It just can't. So it rains inward with this waterfall. But from the outside, all we should ever really care about is the event horizon, because I can't know what happens to it. It could be pure matter and antimatter thrown together, which annihilates into photons on the inside and loses all its mass into the energy of light. It won't matter to me because I can't know anything about what happened on the inside.
Okay, can we just linger on this? So what models do we have about what happens on the inside of the black hole at that moment? So I guess that one of the intuitions, one of the big reminders you're giving to us is like, hey, we know very little about what can happen on the inside of a black hole, and that's why we have to be careful about making. It's better to think about the black hole as an event horizon. But what can we know, and what do we know about the physics of space-time inside the black hole?
I don't mind being incautious about thinking about the matter. I'm not such an observer, right? I'm very theoretical in my work. It's really pen on paper a lot. These are thought experiments that I think we can perform and contemplate. Whether or not we'll ever know is another question. So one of the most beautiful things that we suspect happens on the inside of a black hole is that space and time, in some sense, swap places. So while I'm on the outside of the black hole, let's say I'm in a nice, comfortable space station, this black hole is maybe 10 times the mass of the sun, 60 kilometers across. I could be 100 kilometers out. That's very, very close. Orbiting quite safely. No big deal. Hanging out. I don't bug the black hole. Black hole doesn't bug me. It won't suck me up like a vacuum in case. But my astronaut friend jumps in. As they cross the event horizon, what I'm calling space, I'm looking on the outside of this spherical shadow of the black hole cast by maybe light around it. It's a shadow because everything gets too close, falls in. It's just this just contrast against a bright sky. I think, oh, there's a center of a sphere, and in the center of the sphere is the singularity. It's a point in space from my perspective. But from the perspective of the astronaut who falls in, it's actually a point in time. So their notions of space and time have rotated so completely that what I'm calling a direction in space towards the center of the black hole, like the center of a physical sphere, they're going to tell me, well, they can't tell me, but they're going to come to the conclusion, oh no, that's not a location in space. That's a location in time. In other words, the singularity ends up in their future. And they can no more avoid the singularity than they can avoid time coming their way. So there's no shenanigans you can do once you're inside the black hole to try to skirt it, the singularity. You can't set yourself up in orbit around it. You can't try to fire rockets and stay away from it. It's in your future. And there's an inevitable moment when you will hit it. Usually for a stellar mass black hole, we think it's microseconds.
Microseconds to get from the event horizon to
the singularity.
Oh boy. So that's describing your astronaut friend's perspective.
Yes, from their perspective, the singularity is in their future.
But from your perspective, what do you see when the friend falls into the black hole and you're chilling outside and watching?
So one way to think about this is to think that as you're approaching the black hole, the astronaut's space-time is rotating relative to your space-time. So let's say right now, my left is your right. We're not shocked by the fact that there's this relativity of left and right. Completely understood. And I can perform a spatial rotation to align my left with your left. Right now, completely rotated left out. If I just want to draw a kind of compass diagram, not a compass diagram, you know, at the top of the maps, there's a north, south, east, west. But now time is up, down, and one direction of space is, let's say, east, west. As you approach the black hole, it's as though you're rotating in space-time. Is one way of thinking about it. So what is the effect of that? The effect of that is as this astronaut gets closer and closer to the event horizon, part of their space is rotated into my time, and part of their time is rotated into my space. So in other words, their clocks seem to be less aligned with my time. And the overall effect is that their time seems to dilate. The spacing between ticks on the clock of their watch, let's say, on the face of their watch, is elongated, dilated, relative to mine. And it seems to me that their watches are running slowly, even though they were made in the same factory time. They're both synchronized beautifully. They're excellent Swiss watches. It seems as though time is elapsing more slowly for my companion. And likewise, for them, it seems like mine's going really fast. So years could elapse in my space station. My plants come and go. They die. I age faster. I've got gray hair. And they're falling in, and it's been minutes in their frame of reference. Flowers in their little rocket ship haven't rotted. They don't have gray hair. Their biological clocks have slowed down relative to ours. Eventually, at the event horizon, it's so extreme, it's so slow, it's as though their clocks have stopped altogether, from my point of view. And that's to say that it's as though their time is completely rotated into my space. And this is connected with the idea that inside the black hole, space and time have switched places. So I might see them hover there for millennia. Other astronauts could be born on my space station. Generations could be populated there watching this poor astronaut never fall in.
So basically, the time almost comes to a standstill, but they do fall in.
Right, they do fall in eventually. Now that's because they have some mass of their own, so they're not a perfectly light particle, and so they deform the event horizon a little bit. You'll actually see the event horizon bubble and absorb the astronaut. So in some finite time, the astronaut will actually fall in.
So it's like this weird space-time bubble that we have around us, and this very big space-time curvature bubble thing with a black hole in it. There's a nice swirly type situation going on.
Yeah.
That's how you get sucked up.
Yeah.
Like if you were perfect, like infinitely small particles, it would just be
Take longer and longer.
and probably just be stuck there or something. But no, there's quantum mechanics.
Eventually you'll fall in. Any perturbation will only go one way. It's unsafe in one direction. In one direction only. But it's really important to remember that from the point of view of the astronaut, not much time has passed at all. You just sail right across as far as you're concerned. Nothing dramatic happens, or you might not even realize you've come to the event horizon. You might not even realize you've crossed the event horizon because there's nothing there, right? This is an empty region of space-time. There's no marker to tell you you've reached this very dangerous point, no return. You can fire your rockets like hell when you're on the outside, maybe even escape, right? But once you get to that point, there's no amount of energy. All the energy in the universe will not save you from this demise.
There's different size black holes. And maybe if we were talking about the experience that you have falling into a black hole, depending on what the size of the black hole is.
Yeah.
Because as I understand, the bigger it is, the less drastic the experience of falling into it.
Yeah, that might surprise people.
Yeah.
The bigger it is, the less noticeable it is that you've crossed the event horizon. And one way to think about it is curvature is less noticeable the bigger it is. So if I'm standing on a basketball, I'm very aware I'm balancing on a curved surface. My 2 feet are in different locations, and I really notice. But on the Earth, you actually have to be kind of clever to deduce that the Earth is curved. The bigger the planet, the less you're going to notice the curvature, the global curvature. And it's the same thing with a black hole. A huge, huge black hole, it just kind of feels like just flat. You don't really notice.
I'm trying to figure out how the thing, because if you don't notice,
and there's nothing there.
But the physics is weird.
In your frame of reference.
No.
Well, so another cool thing, so I'd like to dispel this.
Yeah.
You're holding your head.
There's a sense like you should be able to know when you're inside of a black hole when you cross the event horizon. But no, from your frame of reference, you might not be able to know.
Yeah, at first, at least, you might not realize what's happened. There are some hints. For instance, black holes are dark from the outside, but they're not necessarily dark on the inside. So this is a kind of fascinating that your experience could be that it's quite bright inside the black hole. There's all the light from the galaxy could be shining in behind you, and it's focusing down. You're all approaching this really focused region in the interior, and so you actually see a bright white flash of light as you approach the singularity. I kind of I joke that it's it's like a near-death experience. We see the light at the end of the tunnel, so you would see millennia pass on Earth. You can see the evolution of the entire galaxy. One big bright flash of light. So it's like a near-death experience, but it's definitely a total death experience.
It goes pretty fast, but you looking out, everything's going super fast.
Yeah, the clocks on the Earth and the space station seem to be progressing very rapidly relative to yours. The light can catch up to you, and you get this bright beam of light as you see the evolution of the galaxy unfold. And it sort of depends on the size of the black hole and how long you have to hang around. The bigger the black hole, the longer it takes you to expire in the center.
Obviously, the human sensory system are not able to process that information correctly.
Right, it would be a microsecond and it would be too fast.
Yeah, but it would be so cool to get that information.
But a big black hole, you could actually, hang around for some months.
So yeah, how are small black holes and supermassive black holes formed? Just so we can kind of look that in. Are they all? Is it always a star?
No. So this is also why it's important to think of black holes more abstractly. They are something very profound in the universe, and there are probably multiple ways to make black holes. Making them with stars is the most plentiful. There could be hundreds of millions, maybe even a billion black holes in our Milky Way galaxy alone. That many stars. It's only about 1% of stars that will end their lives in a death state that is a black hole. But we now see, and this was really quite a surprise, that there are supermassive black holes. They're billions or even hundreds of billions of times the mass of the sun. And millions to tens of billions, maybe even hundreds of billions. So extremely massive. We don't think that the universe has had enough time to make them from stars that just merge. We know that two black holes can merge and make a bigger black hole, and then those can merge and make a bigger black hole. We think there's been enough time for that. So it's suspected that they're formed very early, maybe even a few hundred million years after the Big Bang, and that they're formed directly by collapsing out of primordial stuff. That there's a direct collapse right into the black hole.
So, like in the very early universe, these are primordial black holes from the stars. Not quite. Wait, how do you get from that soup black holes right away?
Right. So it's odd, but it's weirdly easier to make a big black hole out of something that's just the density of air, if it's really as big as what we're talking about. So in some sense, if they're just allowed to directly collapse very early in the universe's history, they can do that more easily. And it's so much so that we think that there's one of these supermassive black holes in the center of every galaxy. So they're not rare, and we know where they are. They're in the nuclei of galaxies. So they're bound to the very early formation of entire galaxies in a really surprising and deeply connected way.
I wonder if the chicken or the egg, is it how critical, how essential are the supermassive black holes in the formation of galaxies?
Yeah, I mean, it's ongoing, right? It's ongoing. Which came first, the black hole or the galaxy? Probably big early stars, which were just made out of hydrogen and helium from the Big Bang. There wasn't anything else, not much of anything else. Those early stars were forming, and then maybe the black holes and kind of the galaxies were like these gassy clouds around them. But there's probably a deep relationship between the black hole powering jets, these jets blowing material out of the galaxy that shaped galaxies, maybe kind of curbed their growth. And so I think the mechanisms are still ongoing attempts to understand exactly the ordering of these things.
Can we get back to space-time? Let's go back to the beginning of the 20th century. How do you imagine space-time? How do we as human beings supposed to visualize and think about space-time where time is just another dimension, this 4D space that combines space and time? Because we've been talking about morphing around what is the curvature of space-time. But how are we supposed to conceive of it? How do you think of it?
Yeah.
Time is just another dimension.
There are different ways we can think about it. We can imagine drawing a map of space and treating time as another direction in that map. But we're limited because as three-dimensional beings, we can't really draw 4 dimensions, which is what I'd require. 3 spatial, I'm pretty sure. There's at least 3. I think there's probably more. But I'm happy just talking about the large dimensions, the 3 we see. Up, down, right? East, north, south, 3 spatial dimensions. And time is the 4th. Nobody can really visualize it. But we know mathematically how to unpack it on paper. I can mathematically suppress one of the spatial dimensions, and then I can draw it pretty well. Now, the problem is that we call it a Euclidean spacetime. Euclidean spacetime is when all the dimensions are orthogonal, are treated equally. Time is not another Euclidean dimension. It's actually a Minkowskian spacetime. But it means that the spacetime, we're misrepresenting it when we draw it, but we're misrepresenting it in a way that we deeply understand. I can give you an example. The Earth, I can project onto a flat sheet of paper. I am now misrepresenting a map of the Earth. And I know that. but I understand the rules for how to add distances on this misrepresentation, because the Earth is not a flat sheet of paper, it's a sphere. And as long as I understand the rules, how I get from the North Pole to the South Pole, that I'm moving along really a great arc, and I understand that the distance is not the distance I would measure on a flat sheet of paper, then I can do a really great job with a map and understanding the rules of addition and multiplication and the geometries, not the geometry of a flat sheet of paper. I can do the same thing with space-time. I can draw it on a flat sheet of paper, but I know that it's not actually a flat Euclidean space. And so my rules for measuring distances are different than the rules I would use that, for instance, Cartesian rules of geometry. I would know to use the correct rules from the cosmic space-time. And that will allow me to calculate how long time has elapsed, which is now a kind of a length, a space-time length on my map, between two relative observers, and I will get the correct answer. But only if I use these different rules.
And then, what does, according to general relativity, does objects with mass do to the space-time?
Right, exactly. So Einstein struggled for this completely general theory, not a specific solution like a black hole or an expanding space-time, galaxies, lenses. Those are all solutions. That's why what he did was so enormous. It's an entire paradigm that says over here is matter and energy. I'm going to call that the right-hand side of the equation. Everything on the right-hand side of Einstein's equations is how matter and energy are distributed in space-time. On the left-hand side tells you how space and time deform in response to that matter and energy. And it can be impossible to solve some of those equations. What was so amazing about what Schwarzschild did is he found this very elegant, simple solution within like a month of reading this final formulation. But Einstein didn't go through and try to find all the solutions. He gave it to us. Right? He shared this, and then lots of people since have been scrambling to try to, I can predict the curvature of the space-time if I tell you how the matter and energy is laid out. If it's all compact in a spherical system like a sun or even a black hole, I can understand the curves of the space-time around it. I can solve for the shape of the space-time. I can also say, well, what if the universe is full of gas or light and it's all kind of uniform everywhere? And I'll find a different and equally surprising solution, which is that the universe would expand in response to that it's not static, that the distances between galaxies would grow. And this was a huge surprise to Einstein. So all of these consequences of his theory, came with revelations that were not at all obvious when he first wrote down the general theory.
And he was afraid to take the consequences of that theory seriously, which is in its scope of grandeur and power is scary, so I can understand. But then there's, the antithesis theory where it falls apart, the consequences of the theory that are extreme. It's hard to take seriously. So you can sort of empathize.
Yeah, he very much resisted the expansion. So if you think about 1905, when he's writing these sequence of unbelievable papers as a 25-year-old who can't get a job as a physicist, he writes all of these remarkable papers on relativity and quantum mechanics. And even in 1915-16, he does not know that there are other galaxies out there. This was not known. People had mused about it. There were kind of smudges on the sky that people contemplated. What if there are other island universes? Going back to Kant, thought about this. But it wasn't until Hubble, it really wasn't until the late 20s, that it's confirmed that there are other galaxies.
Wow.
Yeah.
But he didn't, obviously, there's so much we think of now that he didn't think of. So there's no Big Bang, static universe.
But these are all connected.
Wow. Yeah. So he's operating on very little information.
Very little information. It's absolutely true. Actually, one of the things I like to point out is the idea of relativity was foisted on people in this kind of cultural way. But there's many ways in which you could call it a theory of absolute. And the way I got there with so little information is by adhering to certain very strict absolutes, like the absolute limit of the speed of light and the absolute constancy of the speed of light, which was completely bizarre when it was first discovered. Really, that was observed. There were experiments trying to figure out what would the relative speed of light be. It's the only massless particles have this property that they have an absolute speed. If you think about it, it's incredibly strange.
Yeah, it's really strange.
Incredibly strange.
And then so from a theoretical perspective, he takes that seriously.
He takes it very seriously, and everyone else is trying to come up with models to make it go away, to make the speed of light be a little bit more reasonable, like everything else in the universe. If I run at a car, two cars coming at each other, they're coming at each other faster than if one of them stops. It's really a basic observation of reality, right? Here, this is saying that if I'm racing at a light beam, and you're standing still relative to the source, we'll measure the same exact speed of light. Very strange. And he gets to relativity by saying, well, what's speed? Speed is distance, it's space over time. It's how far you travel, it's the space you travel, and a certain duration of time. And he said, well, I bet something must be wrong then with space and time. So this is an enormous leap. He's willing to give up the absolute character of space and time in favor of keeping the speed of light constant.
How was he able to intuit a world of curved space-time? Like, it's like one of the most special leaps in human history, right? Because
it's amazing.
Like, it's very, very, very difficult to make that kind of leap.
I'll tell you, it took me, I think, a long time I can't say this is how he got there exactly. It's not as though I study the historical accounts or his description of his internal states. This is more, having learned the subject, how I try to tell people how to get there in a few short steps. One is to start with the equivalence principle, which he called the happiest thought of his life. The equivalence principle comes pretty early on in his thinking. And it starts with something like this. Like right now, I think I'm feeling gravity because I'm sitting in this chair and I feel the pressure of the chair and it's stopping me from falling. I lie down in a bed and I feel heavy on the bed, and I think of that as gravity. Isaiah has a beautiful ability to remove all of these extraneous factors, including atoms. So let's imagine instead that you're in an elevator and you feel heavy on your feet because the floor of the elevator is resisting your fall. But I want to remove the elevator. What does the elevator have to do with fundamental properties of gravity? So I cut the cable. Now I'm falling. The elevator is falling at the same rate as me. So now I'm floating in the elevator. And if this happened to me, if I woke up in this state of falling or floating in the elevator, I might not know if I was in empty space, just floating. Or if I was falling on the earth. They're equivalent situations. I would not be able to tell the difference. And actually, when I get rid of the elevator in this way by cutting the cable, I'm actually experiencing weightlessness. And that weightlessness is the purest experience of gravity. And so this idea of falling is actually fundamental. It's how we talk about it all the time. The earth is in a free fall around the sun. It's actually falling. It's not firing engines, right? It's just falling all the time, but it's just cruising so fast.
So actually, yeah, so one of them is really one of the ways to experience space-time is to be falling.
To be falling. That is the purest experience of gravity. The experience of gravity, unfettered, uninterrupted by atoms, is weightlessness. That observation, no, it has an unhappy ending, the elevator story, right? Because of atoms again. That's the fault of the atoms in your body interacting electromagnetically with the crust of the earth or at the bottom of the building or whatever it is. But this period of free fall, so the first observation is that is the purest experience of gravity. Now I can convince you that things fall along curved paths, because I could take a pen, and if I throw it, we both know it's going to follow an arc, and it's going to follow an arc until atoms interfere again and it hits the ground. But while it's in free fall, experiencing gravity at its purest, what the Einsteinian description would say is it is following the natural curve in space-time inscribed by the Earth. So the Earth's mass and shape curves the paths in space, and then those curvatures tell you how to fall, the paths along which you should fall when you're falling freely. And so the Earth has found itself on a free fall that happens to be a closed circle. But it's actually falling. The International Space Station uses this principle all the time. They get the space station up there, and then they turn off the engines. Can you imagine how expensive it would be if they had to fuel that thing at all times, right? They turn off the engines. They're just falling. And they're not that far off. They're certainly, people sometimes say, oh, they're so far away, they don't feel gravity. Oh, absolutely. If you stop the space station, it's going like 17,500 miles an hour, something like that. If you were to stop that, it would drop like a stone, right to the earth. So they're in a state of constant freezing, and they're falling along a curved path. And that curved path is a result of curving space.
And that particular curved path's got that in such a way that it curves onto itself you're orbiting.
Right. So it has to be cruising at a certain speed. So once you get it at that cruising speed, you turn off the engines.
But yeah, to be able to visualize at the beginning of the 20th century that free falling in curved space time.
Mm-hmm.
Boy, the human mind is capable of things. I mean, some of that is constructing thought experiments that collide with our understanding of reality. Maybe in collisions and contradictions, trying to think extreme thought experiments that exacerbate that contradiction and see, like, okay, what is action? Is there another model that can incorporate this? To be able to do that, I mean, it's kind of inspiring because, there's probably another general relativity out there
Mm-hmm.
in all, not just in physics, in all lines of work, in all scientific pursuits. There's certain theories where you're like, okay, I just explained like a big elephant in the room here
Mm-hmm.
that everybody just kind of didn't even think about.
Right.
There could be, for stuff we know about in physics, there could be stuff like that for the origin of life on Earth.
Yeah.
Everyone was like, yeah, okay. Everyone was like, in one company was like, yeah. Somehow it started.
Right.
Nobody knows.
I find it wild that that's so elusive.
Yeah, it's strange. In the lab,
It's strange that it's so elusive.
I think it's a general relativity thing. There's going to be something. It's going to involve aliens and wormholes and dimensions that we don't quite understand, or some field that's bigger than, like, it's possible, maybe not. It's possible that it's a field that's different, that will feel fundamentally different from chemistry and biology. It'll be maybe through physics. Again, maybe the key to the origin of life is in physics. And the same there, it's like a weird neighbor is consciousness. It's like, all right,
Weird neighbor, yeah.
it's like, okay, so we all know that life started out there somehow. Nobody knows.
Mm-hmm.
We all know that we're conscious. We have a subjective experience. Nobody understands.
Right.
The people have ideas and so on,
Right.
but it's such a dark sort of. We're entering a dark room where a bunch of people are whispering about, like, aliens, and nobody has a effing clue.
Mm-hmm.
So, and then somebody comes along with a general relativity kind of conception where, like, it reconceives everything, and you go like,
It's like a watershed. Yeah.
It's there, and until
It's there.
we're living the time until that day comes along. It'll be obvious in retrospect.
Yeah.
Right now, we're
Right. Well, it was obvious to no one that space-time was curved, but even Newton understood something wasn't right. So he knew there was something missing. And I think that's always fascinating when we're in that situation where we're pressure testing our own ideas. He did something remarkable, Newton did, with his theory of gravity, just understanding that the same phenomenon was at work with the Earth around the sun as the apple falling from the tree. That's insane. That's a huge leap. Understanding that mass, inertial mass, what makes something hard to push around, is the same thing that feels gravity, at least in the Newtonian picture, in that simple way. Unbelievable leap. Absolutely genius. But he didn't like that the apple fell from the tree even though the Earth wasn't touching it.
Yeah, the action of the distance thing.
The action of the distance.
That is weird too.
No, but
that is a really weird.
It's really weird. But see, Einstein solves that. Relativity solves that because it says the Earth created the curve in space. The apple wants to fall freely along it. The problem is the tree's in the way. And the tree's the problem. The tree's actually accelerating the apple. It's keeping it away from its natural state of weightlessness in a gravitational field. And as soon as the tree lets go of it, the apple will simply fall along the curve that exists.
I would love it if somebody went back to this time.
Told him all this?
Probably some hippie would be like, it's gravity is just curvature of space-time, man. I wonder if he would be able to. I don't think there's, every idea has its time. He might not even be able to load that in.
Mm.
I mean, sometimes even the greatest genius, you can't.
Mm.
Like
it's too out of context.
You need to be standing on the shoulders of giants and on the shoulders of those giants and so on.
I heard that Newton used that as an unkind remark to his competitor Hook.
Oh no! People talk shit even back then.
Trash talking.
It's one of the hilarious things about humans in general, besides just like these huge minds. There's these moments in history where you see this in universities, but everywhere else too. Like you have gigantic minds, obviously also coupled with everybody has an ego. And like sometimes it's just the same soap opera that's played out amongst humans everywhere else. And so you're thinking about the biggest cosmological objects and forces and ideas, and you're still like jealous.
Right. I know.
Your office is bigger than my office.
I know.
This chair, or maybe you got married to this person that I was always in love with. The betrayal was something.
Right. The one woman in the department.
The one woman in the department. Yeah. It's just, but that is also the dual motivation, that jealousy, that tension.
Well, you know the expression, I'm sure, battles are so bitter in academia because the stakes are so low.
Way to face it. But also, we shouldn't forget that I love seeing that even in academia because it's humanity. The silliness, there's a degree to academia where the reason you're able to think about some of these grand ideas is because you still allow yourself to be childlike.
Oh, yeah.
There's a childlike nature to
no
ask this question.
Oh,
but children can also be like
children.
so like, you don't, I think when in a corporate context, maybe the world forces you to behave, you're supposed to be a certain kind of way. There's some aspects, and some really beautiful aspect to preserve and to celebrate in academia. Is like you're just allowed to be childlike in your curiosity, in your exploration. You're just exploring, asking the biggest questions.
The best scientists I know often ask the simplest questions. They're really, first of all, there's probably some confidence there, but also they're never going to lie to themselves that they understand something that they don't understand. So even this idea that Newton didn't understand the apple falling from the tree, had he lived another couple hundred of years, he would have invented relativity because he never would have lied to himself that he understood it. He would have kept asking this very simple question. I think that there is this childlike beauty to that, absolutely.
Yeah, just some of the topics, I don't know why I'm stuck in those two topics, emotional life and consciousness. But there's
talk about this.
Some of the most brilliant people I know are stuck, just like with you and Einstein, they're stuck on it. This doesn't make sense. I know a bunch of brilliant biologists, physicists, chemists that think about the origin of life. They're like, this doesn't. I know how evolution works. I know how biological systems work, how genetic information propagates, but this singularity at the beginning doesn't make sense. We don't understand. We can't being in the lab, they're bothered every single day. They're bothered by it, and that being bothered by that tension, by that gap in knowledge, is that's the catalyst. That's the fuel for the
discovery.
The discovery.
Yeah, absolutely. The discovery is going to come because so many people sleep at night and couldn't rest.
So in that way, I think black holes are a kind of portal into some of the biggest mysteries of our universe. So it's a good terrain I wish to explore these ideas. So can you speak about some of the mysteries that the black holes present us with?
Yeah, I think it's important to separate the idea that there are these astrophysical states that become black holes from being synonymous with black holes. Because black holes are kind of this larger idea, and it might have been made primordially when the Big Bang happened. There's something flawless about black holes that makes them fundamental, unlike anything else. So they're flawless in the sense that you can completely understand a black hole by looking at just its charge, electric charge, its mass, and its spin. And every black hole with that charge, mass, and spin is identical to every other black hole. You can't be like, oh, that one's mine, I recognize it. It has this little feature, and that's how I know it's mine. They're featureless. You try to put Mount Everest on a black hole, and it will shake it off in these gravitational waves. It will radiate away this imperfection until it settles down to be a perfect black hole again. So there's something about them that is unlike, another reason why I don't like to call them objects in the traditional sense, unlike anything else in the universe that's macroscopic. It's kind of a little bit more like a fundamental particle. So an electron is described by a certain short list of properties: charge, mass, spin, maybe some other quantum numbers. That's what it means to be an electron. There's no electron that's a little bit different. You can't recognize your electron. They're all identical in that sense. And so in some very abstract way, black holes share something in common with microscopic fundamental particles. And so what they tell us about the fundamental laws of physics can be very profound. And it's why even theoretical physicists, mathematical physicists, not just astronomers who use telescopes, they rely on the black hole as a terrain to perform their thought experiments. And it's because there's something fundamental about them.
Yeah, general relativity means quantum mechanics, means singularity. And sadly, heartbreakingly so, it's out of reach for experiment at this moment. It's within reach for theoretical.
It's in reach for thought experiments. Which are quite beautiful.
Well, on that topic, I have to ask you about the paradox, the information paradox of black holes. What is it?
So this is what catapulted Hawking's fame. When he was a young researcher, he was thinking about black holes and wanted to just add a little smidge of quantum mechanics, just a little smidge. Wasn't going for full-blown quantum gravity, but kind of just asking, well, what if I allowed this nothing, this vacuum, this empty space around the event horizon? The star's gone, there's nothing there. What if I allowed it to possess sort of ordinary quantum properties, just a little tiny bit, nothing dramatic? Don't go crazy. And one of the properties of the vacuum that is intriguing is this idea that you can never say the vacuum's actually completely empty. We talked about Heisenberg, the Heisenberg uncertainty principle really kept up a lot of quantum mechanical thinking. It says that you can never exactly know a particle's position simultaneously with its motion, with its momentum. You can know one or the other pretty precisely, but not both precisely. And the uncertainty isn't a lack of ability that we'll technologically overcome. It's foundational. So that there's, in some sense, when it's in a precise location, it is fundamentally no longer in a precise motion. And that uncertainty principle means I can't precisely say a particle is exactly here, but it also means I can't say it's not. Okay, and so it led to this idea that what do I mean by a vacuum? Because I can't 100% precisely know. In fact, there's not really meaningful to say that there's zero particles here. And so what you can say, however, is you can say, well, maybe particles kind of froth around this seething quantum sea of the vacuum. Maybe two particles come into existence and they're entangled in such a way that they cancel out each other's properties. So they have the properties of the vacuum. You know, they don't destroy the kind of properties of the vacuum because they cancel out each other's spin, maybe each other's charge, maybe things like that. But they kind of froth around. They come, they go, they go. And that's what we really think is the best that empty space can do in a quantum mechanical universe. Now, if you add an event horizon, which, as we said, is really fundamentally what a black hole is, that's the most important feature of a black hole. The event horizon, if the particles are created slightly on either side of that event horizon, now you have a real problem. Now the pair has been separated by this event horizon. Now they can both fall in, that's okay. But if one falls in and the other doesn't, it's stuck. It can't go back into the vacuum because now it has a charge, or it has a spin, or it has something that's no longer the property of that vacuum it came from. It needs its pair to disappear. Now it's stuck. It exists. It's like you've made it real. So in a sense, the black hole steals one of these virtual particles and forces the other to live. And if it'll escape, radiate out to infinity, and look like, to an observer far away, that the black hole has actually radiated a particle. And the particle did not emanate from inside. It came from the vacuum. It stole it from empty space, from the nothingness that is the black hole. Now, the reason why this is very tricky is because in the process, because of this separation on either side of the event, particle absorbs. It has to do with the switching of space and time that we talked about, but the particle absorbs. Well, from the outside, you might say, oh, it had negative momentum, it's falling in. From the inside, you say, well, this is actually motion and time. This is energy. There's negative energy. And as it absorbs negative energy, its mass goes down. The black hole gets a little lighter. And as it continues to do this, the black hole really begins to evaporate. It does more than just radiate, it evaporates away. And it's intriguing because Hawking said, look, this is going to look thermal, meaning featureless. It's going to have no information in it. It's going to be the most informationless possibility you could possibly come up with when you're radiating particles. It's just going to look like a thermal distribution of particles, like a hot body. And the temperature is going to only tell you about the mass, which you can tell from outside the black hole anyway. You know that's the black hole from the outside. So it's not telling you anything about the black hole. It's got no information about the black hole. Now you have a real problem. And when he first said it, a lot of people described that not everyone understood how really naughty he was being. He did. But some people who love quantum mechanics were really annoyed. Okay. People like Lenny Susskind, Tuft, Nobel Prize winner, they were mad because it suggested something was fundamentally wrong with quantum mechanics, if it was right. And the reason why it says there's something fundamentally wrong with quantum mechanics is because quantum mechanics does not allow this. It does not allow quantum information to simply evaporate away and poof out of the universe and cease to exist. It's a violation of something called unitarity, but really the idea is it's the loss of quantum information that's intolerable. Quantum mechanics was built to preserve information. It's one of the sacred principles. That's sacred as conservation of energy. In this example, more sacred. Because you can violate conservation of energy with Heisenberg's uncertainty principle a little tiny bit. But so sacred that it created what became coined as the black hole wars, where people were saying, look, general relativity is wrong, something's wrong with our thinking about the event horizon, or quantum mechanics isn't what we think it is, but the two are not getting along anymore. And just to tell you how dramatic it is, so the temperature goes down with the mass of the black hole, heavier a black hole, the cooler it is. So we don't see black holes evaporate, they're way too big. But as they get smaller and smaller, they get hotter and hotter. So as the black hole nears the end of this cycle of evaporating away, it takes a very long time, much longer than the age of the universe, it will be as though the curtain, the event horizon, is yanked up. Like it'll literally explode away. Just boom. And the event horizon in principle would be yanked up. Everything's gone. All that information that went into the black hole, all that sacred quantum stuff, gone. Poof. Okay, because it's not in the radiation, because the radiation has no information. And so it was an incredibly productive debate because in it are the signs of what will make gravity and quantum mechanics play nice together. Some quantum theory of gravity. Whatever these clues are, and they're hard to assemble. If you want a quantum gravity theory, it has to correctly predict the temperature of a black hole, the entropy of a black hole. It has to have all of these correct features. The black hole is the place on which we can test quantum gravity.
But it still has not been resolved.
It has not been fully resolved.
I looked up all the different ideas for the resolution. So there's the information loss, which is what you refer to. It's perhaps the simplest, it's most radical resolution. That information is truly lost. This would mean quantum mechanics can only understand it specifically unitarity is incomplete or incorrect under these extreme gravitational conditions.
I'm happy with that. I would not be happy with information loss. I love that it's telling us that there's this crisis, because I do think it's giving us the clues. And we have to take them seriously.
For you, the gut is like
unitary is going to be
preserved. So quantum mechanics is
holding the rescue. Lenny Susskind in his book Black Hole War says his subtitle is My Battle with Stephen Hawking to Make the World Safe for Quantum Mechanics. It's something to that effect.
So then from string theory, one of the resolutions is called fuzzballs. Originating from string theory, this proposal suggests that black holes aren't singularities surrounded by empty space or by horizon. Instead, they are horizonless, complex, tangled objects, aka fuzzballs, made of strings and varying roughly the size of the would-be horizon. Yeah. There's no single point of infinite density and no true horizon to cross.
In some sense, it says there's no interior to the black hole, nothing of a crosses. So I gave you this very nice story that there's no drop mama. Sometimes that's how it's described at the event horizon, and you fall through and there's nothing there. This other idea, well, hold on a second, if strings, if I get close to this magnifying quality and slowing time down near the event horizon, it is as though I put a magnifying glass on things, and now the strings aren't so microscopic. They kind of shimmer around, and then they get caught like a tangle around the event horizon, and they just actually never fall through. I don't think that either, but it was interesting.
So it's just adding a very large number of extra complex
degrees of freedom.
Yeah.
There are no teeny tiny marbles to fall through.
It's similar to what we already have in quantum mechanics. It's just giving me
it's really saying the interior is just not there ever. It falls in, so the information gets out because it never went in the first place.
Oh, so there is a strong statement there.
It's a strong statement.
Okay, so soft hair challenges the classical no hair theorem by suggesting that black holes do possess subtle quantum quote hair. This isn't classical hair-like charge, but very low energy quantum excitations, soft gravitons or photons at the event horizon that can store information about what fell in.
Worth trying, but I also don't think that that's the case. So the no hair theorems are formal proofs that the black hole is this featureless, perfect fundamental particle that we talked about. That all you can ever tell about the black hole is its electrical charge, its mass, and its spin, and that it cannot possess other features. It has no hair. Is one way of describing it. And that those are proven mathematical proofs of complex degenerate relativity. So the idea is, well, therefore I can know nothing about what goes into the black hole, so the information is lost. But if they could have hair, I could say that's my black hole, because it have features that I could distinguish, and it could encode the information that went in this way. And the event horizon isn't so serious. It isn't such a stark demarcation between events inside and outside, and where I can't know what happened inside or outside. I don't think that's the resolution either, but it was worth a try.
Okay, the pros and cons of that one. Pros, it works within the framework of quantum field theory because space-time protection requires less radical modifications than fuzzballs or information loss. Recent work by Hawking, Berry, strongly revitalized this idea. Cons, the precise mechanism by which information is encoded and transferred to the radiation is still debated, technically challenging to work out fully. Indeed, it needs to store a vast amount of information. Okay, another one, this is a weird one. Right? is ER equals EPR.
This is probably it, Chef.
Oh boy. So ER equals EPR is the Einstein-Rosen bridge equals the Einstein-Podolsky-Rosen bridge. Posits a deep connection between quantum entanglement and space-time geometry. Specifically, Einstein-Rosen bridge, commonly known as wormholes, suggests that entangled particles are connected by a non-traversable wormhole. So tiny wormholes connect. Okay.
I can say that this is not a situation where we can follow the chalk. We can't start at the beginning and calculate to the end. So it's still a conjecture. I think it's very profound. I kind of imagine Juan Maldacena, who's part of this with Lenny Susskind, they were kind of like, oh, it's like ER equals EPR. They couldn't even formulate it properly. It was like an intuition that they had kind of landed on and now are trying to formalize. But to take a step back, one way of thinking about ER equals EPR, you have to talk about holography first. And holography, both Juan Maldacena really formalized it, Lenny Susskind suggested it. The idea of the black hole hologram is that all of the information in the black hole, whatever it is, whatever, entropy is a measure of information, whatever the entropy of the black hole is, which is telling you how much information is hidden in there, how much information you don't have direct access to, in some sense, is completely encoded in the area of the black hole. Meaning, as the area grows, the entropy grows. It does not grow as the volume. This actually turns out to be really, really important. If I tried to pack a lot of information into a volume, more information than I could pack, let's say, on the surface of a black hole, I would simply make a black hole. And I would find out, oh, I can't have more information than I can fit on the surface. So Lenny coined this a hologram. People who take it very seriously say, well, again, maybe the interior of the black hole just doesn't exist. It's a holographic projection of this two-dimensional surface. In fact, maybe I should take it all the way and say, so are we. The whole universe is a holographic projection of a lower dimensional surface. And so people have struggled, nobody's really landed it, to find the universe version of it. Oh, maybe there's a boundary to the universe where all the information is encoded, and this entire three-dimensional reality that's so compelling and so convincing is actually just a holographic projection. Juan Maldacena did something absolutely brilliant. It's the most highly cited paper in the history of physics. It was published in the late 90s. It has a very opaque title that would not lead you to believe it's as revelatory as it is. But he was able to show that a universe like in a box with gravity, and it's not the same universe we observe, doesn't matter, it's just a hypothetical called an empty de Sitter space. This universe in a box, it has gravity, it has black holes, it has everything gravity can do in it. On its boundary is a theory with no gravity. A universe that can be described with no gravity at all, so no black holes, and no information loss problem, and they're equivalent. That the interior universe in a box is a holographic projection of this quantum mechanics on the boundary. Pure quantum mechanics, purely unitary, no loss of information. None of this stuff could possibly be true. There can't be loss of information if this dictionary really works. If the interior is a hologram, a projection of the boundary. I know that's a lot.
Yeah. So there's some mathematics there, there's physics, and then there's trying to conceal what that actually means practically for us.
Mm-hmm. Well, what it would mean for us is that information can't be lost, even if we don't know how to show it in the description in which there are black holes. It means it can't possibly be lost because it's equivalent to this description with no gravity in it at all, no event horizons, no black holes, just quantum mechanics. So it really strongly suggested that quantum mechanics was going to win in this battle, but it didn't show exactly how it was going to win. So then comes ER equals EPR. A visual way to imagine what this means. So ER has to do with little wormholes. EPR, Einstein-Podolsky-Rosen, has to do with quantum entanglement. The idea was, well, maybe the stuff that's interior to the black hole is quantum entangled, like EPR, quantum entangled, with the Hawking radiation outside the black hole that's escaping. And that quantum entanglement is what allows you to extract the information. because it's not actually physically moving from the interior to the exterior. It's just subtle quantum entanglement. And in fact, I can kind of think of the entire black hole. If I look at it, it looks like a solid shadow cast on the sky. It's a region of space-time. If I look at it very closely, I will see, oh no, it's actually sewn from these quantum wormholes, like embroidered. And so when I get up close, it's almost as though the event horizon isn't the fundamental feature on the space-time. The fundamental feature is the quantum entanglement embroidering the event horizon.
The embroidering is just tying wormholes. So the quantum entanglement is when two particles are connected at arbitrary distances.
And they're connected by a wormhole.
And in this case, they would be connected by a wormhole.
So the reason why that's helpful, it helps you connect the interior to the exterior without trying to pass through the event horizon.
The cons of this is highly conceptual and abstract. The exact mechanism for information retrieval via these non-traversable wormholes is not fully understood. Primarily explored in theoretical toy model world. Damn, that going hard. Theoretical toy models like the antidisclosure space-time rather than realistic black holes.
We do what we can do in baby steps.
So another idea to resolve the information paradox is firewalls, proposed by Ameri, Mouth, Chinsky, and Sully, AMPS. This is a more Jurassic scenario arising from analyzing the entanglement requirements of Hawking radiation to preserve unitarity and avoid information loss. They argue that the entanglement structure requires the horizon not to be smooth, not to be the smooth and remarkable place predicted by general relativity, the equivalence principle. Instead, it must be a highly energetic region, a quote firewall that incinerates anything attempting to cross it. Okay, so yeah, that's a nice solution. Just destroy everything that crosses. Do you find this at all a convincing resolution to the information?
I would say the firewall papers were fascinating and were very provocative and very important in making progress. I don't even think the authors of those papers thought firewalls were real. I think they were saying, look, we've been brushing too much under the rug. And if you look at the evaporation process, it's even worse than what you thought previously. It's so bad that I can't get away with some of these prior solutions that I thought I could get away with. There was a kind of duality idea or a complementarity idea that, oh, well, maybe one person thinks they fell in, one person thinks they never fell in, and that's okay. No big deal. They sort of exposed flaws in these kind of approaches, and it actually reinvigorated the campaign to find a solution. So it stopped it from stalling. I don't think anyone really believes that the event horizon, at the event horizon, you find a firewall. But it did lead to things like the entangled wormholes embroidering a black hole, which was born out of an attempt to address the concerns that AMPS raised. So it did lead to progress.
So for you, the resolution would...
I'm going back to the vacuum. The empty space. The beautiful event horizon. I'll give up locality, meaning that I will allow things to be connected non-locally by a wormhole.
So that is the weirdest thing you're going to allow for, which is arbitrary distance connection of particles through a wormhole. But quantum mechanics must be preserved.
I'll entertain pretty weird things, but I think that's the one that sounds promising. The implications are so dramatic because this is why you start to hear things like, wait a minute, if the event horizon only exists when it's sewn out of these quantum threads, does that mean that gravity is fundamentally quantum mechanics? Not that gravity and quantum mechanics get along and have a quantum gravity theory, and now know how to quantize gravity. Actually, something much more dramatic. Gravity is just kind of emerging from this quantum description. That gravity isn't fundamental. And what is the only thing that we have when we go rock bottom, when we go deeper and deeper, smaller and smaller, is quantum mechanics. So all of this, like space-time looks nice and smooth and continuous, but if I look at the quantum realm, I'll see everything sewn together out of quantum threads. and that space-time is not a smooth continuum all the way down. Now, people already thought that, but they thought it kind of came in chunks of space-time. Instead, maybe it's just quantum mechanics all the way down.
Quantum threads, so these entangled particles connected by wormholes.
Yeah.
So that's how would you even visualize a black hole that way? So it's all, it's all from our perspective in terms of detecting things, the light goes and going in, it's all still the same. But when you zoom in a lot,
to the quantum mechanical scale at which you're seeing the Hawking radiation, you would be noticing that there's some entanglement between the radiation that I could not explain before and the interior of the black hole. So it's now no longer a perfectly thermal spectrum with no feature that only depends on the mass. It actually has a way to have an imprint of the information interior to the black hole in the particles that escape. And so now, in principle, I could sit there for a very long time, it might take longer than the age of the universe, and collect all the Hawking radiation and see that it actually had details in it that are going to explain to me what was interior to the black hole, so the information is no longer lost.
So information not being destroyed, so in theory you should be able to get information.
Now I can't do that any more than I can recover the words on that piece of paper once it's been burnt, but that's a practical limitation, not a fundamental. It's just too hard. But when I burn a piece of paper, technically the information is all there somewhere. It's in the smoke, it's in the currents, it's in the molecules, it's in the ink molecules. But in principle, if I took the age of the universe, I should be able to, in principle, reconstruct a piece of paper and all the words on it.
Do you think a theory of everything that unifies general matter and quantum mechanics is possible? So we're skirting around it.
Yeah, we're skirting around it. I think that this is the way to find that out. It's going to be on the train of black holes that we figure out if that's possible. I think that this is suggesting that there might not be a theory of quantum gravity, that gravity will emerge at a macroscopic level out of quantum phenomena. Now, we don't know how to do that, but these are all hints.
Emerge. So a lot of the mathematics of anything that emerges from complex systems is very difficult to.
The transition is very difficult, right?
So if that's the case, there might not be a simple clean equation that connects everything.
There are examples of emergent phenomena which are very simple and clean. Like I can just take electromagnetic scattering, which is law of physics, where particles scatter just like electromagnetically. And I have a lot of them, and I have a lot of them in this room, and they come to some average. Well, I call that temperature. And that one number, the fact that there's one number describing all of these gazillions of particles, is an emergent quantity. There's no particle that carries around this fundamental property called temperature. It emerges from the collective behavior of tons and tons of particles. In some sense, temperature is not a fundamental quantity. It's not a fundamental law of nature. Right? It's just what happens from the collective behavior. And that's what we'd be saying. We'd be saying, oh, this emerges from the collective behavior of lots and lots and lots of quantum interactions.
So when do you think we would have some breakthroughs on the path towards theory of everything, showing that it's possible or impossible, all that kind of stuff? If you look at the 21st century, say you're 100 years into the future and looking back, when do you think the breakthroughs will come? So I'll give you some hard problems. Mm-hmm. I guess my question is, how hard is this problem here? Like, what does your gut say? Because, finding the origin of life, figuring out consciousness, solving some of the major diseases, then there's the theory of everything, understanding some of this, resolving the information paradox. So these puzzles that are before us as a human civilization, physics, this feels like really one of the big ones. Of course, there could be other breakthroughs in physics that don't solve this.
Yeah, we could discover dark matter, dark energy. We could discover extraspatial dimensions. We could discover that those three things are linked, that there's like a dark sector to the universe that's heightened with these extra dimensions. That's something that I love to work on. I think is really fascinating. All of those would also be clues about this question, but they wouldn't solve this problem. I think it's impossible to predict. There has been real progress, and the progress, as we've said, comes from the childlike curiosity of saying, "Well, I don't actually understand this. I'm going to keep leaning on it because I don't understand it." And then suddenly you realize nobody really understood it. So I don't know. Do I think it's a harder problem than the problem of the origin of life? I think it's technically a harder one, but I don't know. Maybe the breakthrough will come.
So when you mention discovering extra dimensions, what do you mean? What could that possibly be?
Well, we we know that there are three spatial dimensions. We like to talk about time as a dimension. We can argue about whether that's the right thing to do, but we don't know why there are only three. It very well could be that there are extra spatial dimensions. That there's like a little origami of these tightly rolled up dimensions. Not all of them. Not all the models require that they're small, but most do. String theory requires extra dimensions to make sense, but even if you feel very hostile towards string theory, there are lots of reasons to consider the viability of extra dimensions. And we think that they can trap little quantum energies in such a way that might align the dark energy. The numerology is not perfect. It's a little bit subtle. It's hard to stabilize them. It's possible that there are these kind of quantum excitations that look a lot like dark matter. It's kind of an interesting idea that in the Big Bang, the universe was born with lots of these dimensions. They were all kind of wrapped up in the early universe. What we're really trying to understand is why did three get so big? and why did the others stay so small?
Is it possible to have some kind of natural selection of dimensions kind of
Yeah,
situation?
there is, actually. And people have worked on that. Is there a reason why it's easier to unravel three? Some people think about strings and brains wrapping up in the extra dimensions, causing a kind of constriction, but preferentially loosening up in three. Sometimes we look at exactly models like that, which have to do with the origami being resistant to change in a certain way that only allows three to unravel and keeps the others really taut. But then there are other ideas that we're actually living on a three-dimensional membrane that moves through these higher dimensions. And so the reason we don't notice them isn't because they're small, maybe they're not small at all, but it's because we're stuck to this membrane. So we're unaware of these extra directions.
Is it possible that there's other intelligent alien civilizations out there that are operating in a different membrane? This is a bit of an out there question, but I ask it more kind of seriously. Like, is it possible, do you think, from a physics perspective, to exist on a slice of what the universe is capable of?
I think it is certainly mathematically possible on paper to imagine a higher dimensional universe with more than one membrane. And if things are mathematically possible, I often wonder if nature will try it out.
Yeah.
Which is how people get into the strange territory of talking about a multiverse. Because when you start to say, one of the aspirations was, in the same way that we identified the law of electronuclear matter, that it was a single description that exactly landed on the description that matched observations, people were hoping the same thing would happen for kind of theory that also incorporated gravity. It was one beautiful law, but instead there are proliferations, all of which did okay or did equally badly. They suddenly had trouble finding, not only finding a single one, but sort of that would just beg a new question, which is, well, why that one? And if nature can do something, won't she do anything she can try? And so maybe we really are just one example in an infinite sea of possible universes with slightly different laws of physics. So if I can do some of these things on paper, like imagine a higher dimensional space in which I'm confined to a brain and there's another brain or maybe a whole array of them, maybe nature's tried that out somewhere. Maybe that's been tried out here. And then, yes, is it possible that there's life and civilizations on those other brains? Yeah, but we can't communicate with them. They'd be like in a shadow space.
Can you seriously say we can't communicate with them?
Well,
So
no, that's fair. I'm limited in my communication because I'm glued to the brain, but some things can move. We call the bulk, through the bulk. Gravity, for instance, a gravitational wave. So I could design a gravitational communication system, and I could send gravitational waves through the bulk. And how SETI's doing with light into space, I could send signals into the bulk, telling them where we are and what we do, and
of course,
singing songs.
I think gravitational waves is very expensive.
Very expensive, very hard to localize. It took me long wavelength, but it's very hard to do. A lot of energy moving around.
So is it possible that the membranes are quote unquote hairy in other ways? Like some kind of weird.
It is possible that there's other things that live in the bulk. Yeah, last night, right? Looking at something that lives in the bulk.
This is fascinating. So I mean, okay, can we take a little bit more seriously about the whole look? When I look out there, at the stars, I, from a basic intuition, cannot possibly imagine there's not just alien civilizations everywhere. Life is so damn good. Like you said, nature tries stuff out.
Yeah, nature's an experimenter.
And I just can't, just basic sort of, observation, life, you said somewhere you like files. Life just figures shit out.
Yeah.
It just finds a way to survive. Now, there could be something magical about the origin of life, the first spark, but like, I can't even see that. It's over and over and over. I bet actually once the story is fully told and figured out, life originated on Earth almost right away and did so like billions of times in multiple places, just over and over and over and over. That seems to be the thing that just, whatever is the life force behind this whole thing seems to create life, seems to be a creator of different sorts.
Yeah.
The very original primordial soup thing just creates them. I just can't imagine. But we don't see the alien. So
right, yeah. We don't even have to go to something as crazy as extra dimensions, brain worlds, all of that. What's happening right now in the past 30 years in astronomy, looking at real objects, is that the number of planets, exoplanets outside our solar system has absolutely proliferated. There are probably more planets in the Milky Way galaxy than there are stars. Now we have a real quandary. I don't think it's quandary. I think it's really exciting. It becomes impossible. What you just said, I totally agree with. It becomes impossible to imagine that life was not sparked somewhere else in our Milky Way galaxy, and maybe even in our local neighborhood of the Milky Way galaxy, maybe even a few hundred light years of our solar system.
So my gut says, like, some crazy amount of solar systems have life, bacterial life somewhere at some point in their history had some bacterial type of life. There's something like bacterial lives for different kinds of life. And then I'm just facing the questions of why have we not clearly seen alien civilizations? And there, the answer, I don't find any great filter answer convincing. There's just no way I can imagine an advanced alien civilization not avoiding its own destruction. I can see a lot of them getting into trouble. I can see how we humans are really like 50-50 here.
Well, isn't that kind of appalling? I mean, just take that statement. We've only been around for like a couple 100,000 years tops. That is not very long, and we're at a 50-50. I mean, that's unbelievable. I mean, it's indisputable that we have created the means, at least potentially, for our own destruction. Will we learn from our mistakes? Will we avert course and save ourselves? One hopes so, right? But even the concept that it's conceivable, whales have not invented a way to kill themselves, to wipe out all whales and Earth and life on Earth.
There's one way to see it, but I actually see it as a feature, not a bug, when you look at the entirety of the universe. Because it does seem that the mechanism of evolution constantly creates. You want to operate on the verge of destruction. seems like. I mean, the predator or prey dynamic is really effective at creating, at accelerating evolution and development. It seems like us being able to destroy ourselves is a really powerful way to give us a chance to really get our shit together, to flourish, to develop, to innovate, to grow out amongst the stars, or to destroy ourselves. But like, which I think to me as a human it's a horrible thing. But if there's a lot of other alien civilizations, that's a pretty cool thing. You want to give everybody nuclear weapons. Half of them will figure it out, half of them won't. And the ones that figure it out,
all these civilizations.
And then the ones that figure it out will figure out some incredible technologies about how to expand, how to develop, and all that kind of stuff.
Right. You could use a kind of evolutionary Darwinian natural selection on that, where survival isn't just in a harsh, naturally induced climate change, but it's because of the nuclear holocaust. And then something will be created that is now impervious to that now knows how to survive.
Yep, exactly. So why haven't we seen?
Right. Well, because that's a pretty big bar. So if you look at it, just to say, for comparison, dinosaurs, 250 million years. I mean, maybe not very bright. Didn't invent fire, didn't write sonnets. They didn't contemplate the origin of the universe, but they lived. And in a benign situation without confronting their own demise at their own hands. Hooves. So it's just a sheer numbers game. That's a long time, 250 million years. I do think, though, that life can flourish without wanting to manipulate its environment. And that we do see many examples of species on Earth that are very long-lived, very, very long-lived, and have very different states of consciousness. They have the jellyfish does not even have a localized brain. I don't think they have a heart or blood. I mean, they're really different from us. And that's what I think we have to start thinking about when we think about aliens. Those species have lived for a very, very long time. They even show some evidence of immortality. You can wound one badly, and there are certain jellyfish that will go back into a kind of pre-state and start over. So I think we're very attached to imagining creatures like us that manipulate technology. And I think we have to be way more imaginative if we're going to really take seriously life in the universe.
Yeah, they might not prioritize conquest and expansion. They might not be violent.
They might not be violent. They might be solitary. They might not be social. They might not live in groups. They might not want to leave records. They might, again, not have a localized brain or have a completely different kind of nervous system. I think all we can say about life is it has something to do with moving electrons around. And like neurologically, we move electrons through our nervous system. The brain has electrical configurations. We metabolize food, and that has to do with getting energy, electrical energy in some sense, out of what we're eating. I mean, organisms on the earth that can eat rocks, quite amazing. Minerals. I mean, talk about extremophiles. They can metabolize things that would have thought were impossible to metabolize. And so, again, I think we have to kind of open our minds to how strange that could be, and how different from us. And we are the only example, even here on Earth, that does manipulate its environment in that extreme way.
And can you think of life as you said, electrons? Is there some degree of information processing required? So, like, it does something interesting, in quotes, with information.
I think there are arguments like that. How entropy is changing from the beginning of the universe to today. How life lowers entropy by organizing things, but it costs more as a whole system. So the whole entropy of the whole system goes up. But of course, I organize things today and reduce the entropy of certain things in order to get up and get here. And even having this conversation with organizing thoughts out of the cloud of information, but it comes at the cost of the entire system increasing entropy. So I do think there's probably a very interesting way to talk about life in this way. I'm sure somebody has.
Yeah, it creates local pockets of low entropy, and the kind of mechanism, the kind of object, the kind of life form that could do that probably could take arbitrary forms. Now you could think, now if you reduce it all to information, now you can start to think about physics, and in the realm of physics with the multiverse and all this kind of stuff, you can start to think about, okay, how do I detect those pockets of low entropy?
Mm-hmm. Yeah, I mean, people have tried to make arguments like that. Like, can I look for entropic arguments that might suggest we've done this before? The Big Bang has happened before.
So is it possible that there's some kind of physics explanation why we haven't seen the aliens? Like you said, membranes.
I don't think membranes is going to explain why we don't see them in the Milky Way. I think that is just a problem we're stuck with. Whether or not there are extra dimensions, or whether or not there's life in another membrane, I think we know that even just in our galaxy, which is a very small part of the universe, um, 300 billion stars, something like that, a whole kind of variety of possibilities to be explored by nature in the same way that we're describing it. And I think you're absolutely right. When life was kicked off, first sparked here on Earth, it was voracious. That took a really long time, though, to get to multicellularity. I think that's interesting.
That's weird.
It's weird. It took a really, really long time to become multicellular. But it did not take long just to start.
Yeah, what do you think is the hardest thing on the chain of leaps that got to humans?
I would say multicellularity, which is strictly an energy problem, I think. Again, it's just like, can electrons flow the right way? And is it energetically favorable for multicellularity to exist? Because if it's energetically expensive, it's not going to succeed. And if it's energetically favorable, it's going to take off. It's really just, and that's why I also think that going from inanimates to animate is probably gray. Like the transition is gray. At what point we call something fully alive? Famously, it's hard to make a nice list of bullet points that need to be met in order to declare something alive. Is a virus alive? I don't know. Is a prion alive? So they seem to do some things, but they kind of rely on stealing other DNA and replicating, and I don't know. I guess they're not alive. But I mean, the point is that it really, at the end of the day, I really think it's just, you asked if it's just physics. I think it's just these rules of energetics.
And the gray area between the non-living and the living is way simpler just on Earth. And you said it's already complicated on Earth, but it's probably more complicated elsewhere where the chemistry can be anything.
Carbon is really cool, really useful, because it finds a lot, it's nice. It finds a lot of ways to combine with other things, and that's complexity, and complexity is the kind of thing you need for life. You can't have a very simple linear chain and expect to get life. But I don't know, maybe sulfur will do okay.
Okay, as we get progressively to crazier and crazier ideas. So we talked about these microscopic wormholes, which, my mind is still blown away by that. But if we talk about a little bit more seriously about wormholes in general, also called the Einstein-Rosen bridges, to what degree do you think they're actually possible as a thing to study, creeping towards the possibility, maybe centuries from now, of engineering ways of creating wormholes, using them for transportation of human-like organisms?
I think wormholes are a perfectly good construction to consider. They're just a curve in space-time. Um, the topologically, which has to do with the connectedness of the space, is a little tricky because we know that Einstein's description is completely in terms of local curves and distortions, expansion, contraction, but it doesn't say anything about the global connectedness of the space. Because he knew that it could be globally connected on the largest scales. That's kind of origami that we're talking about, that you could travel in a straight line through the universe, leave our galaxy behind, watch the Virgo cluster drift behind us, and travel in a straight line as possible, and find ourselves coming back again to the Virgo cluster, and eventually the Milky Way, and eventually the Earth. that we could find ourselves on a connected, compact space-time. So topologically, there's something we know for sure, something beyond Einstein's theory that has to explain that to us. Now, wormholes are a little funky because they're topological. They create these handles and holes in these sneaky, by topological, I mean these connected spaces. And
yeah, it's like Swiss cheese.
Like Swiss cheese, and so I could have, I could have two flat sheets that are connected by a wormhole, but then wrap around on the larger scale, all this cool stuff. There's nothing wrong with it as far as I can see. There's nothing abusive towards the laws about a wormhole, but we can reverse engineer. And we were saying, oh, look, I know how matter and energy are distributed. I can predict how space-time is curved. I can reverse engineer. I can say, I want to build a curved space-time like a wormhole. What matter and energy do I need to do that? It's just a process. And it's kind of thing Kip Thorne worked on, very imaginative, creative person. And the problem was that he said, oh, here's the bummer. The matter and energy you need doesn't seem to be like anything we've ever seen before. It has to have like negative energy. That's not great. There are some conjectures that we shouldn't allow things that have that kind of a property, that have negative energies. Only things that are positive energies are going to be stable and long-lived. But we actually know of quantum examples of negative energy. It's not that crazy. There's something called the Casimir effect. You have two metal plates and put them really close together. You can see this kind of quantum fluctuation between the plates. It's called a Casimir energy, and that can have a negative energy. It can actually cause the plates to attract or repel depending on how they're configured. And so you could kind of imagine doing something like that, like having wormholes propped up by these kinds of quantum energies. And people have thought of imaginative configurations to try to keep them propped up. Are we at the point of me saying, oh, this is an engineering problem? I'm not saying that quite yet. But it's certainly plausible.
Yeah, so you have to get a lot of this kind of weird matter.
You need a lot of this weird matter to send a person through.
Right.
That's going to be really challenging. So I'm not saying we're simply an engineering problem, but it's all within the realm of plausible physics.
I think that's super interesting. I think it's obviously intricately, deeply connected to black holes. Is it fair to think of wormholes as just two black holes that are connected?
People have looked at that. They tend to be non-traversable wormholes. They're not trying to prop them open. But yeah, I mean, some of this ER equals EPR quantum entanglement, they're trying to connect black holes. It's really cool. It's not quite following the chalk. And by that I mean we can't exactly start at a concrete place, calculate all the way to the end yet.
So if I may read off some of the ideas that get on this slide about how to artificially construct wormholes. So the first method involves quantum mechanics and the concept of quantum foam. And this is the thing we've been talking about. Now, to create a wormhole, these tiny wormholes need to be enlarged and stabilized to be useful for example. But the exact method of doing this remains entirely theoretical. No shit.
Yeah.
So these tiny wormholes that are basically for the quantum entanglement of particles from how enlarged. Man, playing with the topology of the Swiss cheese is so interesting. If you were to get a hint, that would be like top three, if not one, maybe number one question for me to ask. If I got a chance to ask omniscient being of like a question that I can get an answer to, maybe with some visualization, like the shape, the topology of the universe.
Yeah.
But like I need some details.
Right.
Unfortunately, I'll get an answer that I can
Right. It's a hyperbolic manifold that's identified as us. Yeah, exactly. You need to be able to ask a follow-up question.
Exactly. Yeah, that would be so interesting. Classical quantum strategy. The second approach combines classical physics and quantum effects. This method would require advanced civilization to manipulate quantum gravity effects in ways we don't understand. There's a lot of
ways we don't understand.
There's a lot of, and then there's exotic matter requirements. There's a lot of.
But I can tell you, I'm pretty sure all of them have in common the feature that they're saying, here's what I want my wormhole to look like first. So it's like saying I want to build a building first. So they construct, there's an architecture of space-time that's thereafter. And then they reverse the Einstein equations to say what must matter in energy. What are the conditions that I impose on matter and energy to build this architecture?
Which is unfortunately a very early step of figuring out.
Right, but it's important because it's how they realized, oh wow, they have to have these negative energies, they have to violate certain energy conditions that we often assume are true. And then you either say, oh, well then, all bets are off, they'll never exist, or you look a little harder and you say, well, I can violate that energy condition without it being that big a deal. And again, quantum mechanics often does violate those energy conditions.
But do you think the study of black holes and some of the topics we've been talking about will allow us to travel faster than the speed of light, or travel close to the speed of light, or do some kind of really innovative breakthroughs on the propulsion technology we use for traveling in space?
Yeah, I mean, sometimes I assign in an advanced general relativity class the assignment of inventing a warp drive. And it's kind of similar. So the idea is, here's a place you want to get to, and can you contract the space-time between you with something antithetical to dark energy, the opposite, and skip across, and then push it back out again. That's all. You can do that in the context of general relativity. Now, I can't find the energy that has these properties, but I also can't find dark energy. So we've already been confronted with something that we look at the space-time. The space-time is expanding ever faster. We say, what could possibly do that? We don't know what it is, but I can tell you about its pressure. I can tell you certain features about it. And I just call it dark energy. I actually have no idea. It's just, that name's just a proxy for what this, it should be called invisible, but it's not actually dark. It's in this room. It's not hard to see through. It's literally invisible. So maybe that was a misnomer. But the point being, I still don't fundamentally know what it is. That's not so terrible. That's the state of the world that we're actually in. So maybe warp drive is just kind of a good version of that. I don't know what form of matter can do that yet, but at least I can identify the features that are needed.
So figuring out what dark energy is might
Yeah, it might. It is positive energy and a negative pressure, which is kind of like a rubber band sort of quality because pressure is pushing things outward. And dark energy has a very strange sort of quality that as things move outward, you feel more energy as opposed to less energy. The energy doesn't get lower, it gets more. But it doesn't have the right features for the wormhole, but those are some pretty surprising features. We again can conjecture like, oh hey, quantum energy of the vacuum kind of behaves that way. That would be a great resolution to the dark energy problem. It's just the energy of empty space. And it's the quantum energy of empty space. That's an excellent answer. The problem is by all our methods, all the understanding we have, that energy is either really, really huge, way bigger than what we see, or it's like zero. So that's a numbers problem. We can't naturally fine-tune the energy of empty space to give us this really weird value so that we just happen to be seeing it today. But again, we can think of a kind of dark energy that exists. So the question is just why is it such a weird value? Not how is this conceivable, because we can't conceive of it.
Yeah, but if it's a weird value, that means there is a phenomenon to understand.
Yes, there's absolutely a phenomenon. Nobody's going to say they're happy with that. We're all going to say there's something we don't understand. Which is why we look to the extra dimensions, because then you can say, oh, maybe it has to do with the size of the extra dimensions or the way that they're wrapped up, or and so maybe it's foisted on us because of the topology, the connectedness of the higher dimensional space. These are all things that we're exploring. Nobody's landed one that's so compelling that your friends like it as much as you do.
What do you think would lead to the breakthroughs of dark matter and dark energy?
I think dark matter might be less peculiar than dark energy. My hope is that they're tied together. That would be very bad. These aren't just separate problems coming from different sectors. but that they're actually connected. That the reason the dark matter is where it is in terms of how much it's contributing to the universe is connected with why the dark energy is showing up right now. I would love that. That would be a solution like no other, right? And like I said, if it revealed something about dark dimensions, that would be a happy day.
Correct me if I'm wrong. Dark matter can be localized in space.
Yeah, dark matter is localized in space, so it clumps. I mean, it doesn't clump a lot, but I mean, it's around the galaxy. It's in a halo around the galaxy.
So people get increasingly more confident that that's
it's really compelling.
Yeah.
I mean, you see these images of galaxies clusters that pass through each other, and you can see where the light is, the luminous matter is distributed. And then by looking at the gravitational lensing, which shows you where the actual mass is distributed, so that light bends around the most massive parts in a particular way, so you can reconstruct where the mass is gravitationally quite separate from looking at the luminous matter, which is not dark, and they are separate. Because the stuff, as they pass through each other, the interacting stuff, the luminous stuff collides.
Are you 15.2% body fat, you fat fuck? You gained weight? Great. I have a few questions for you. Are you ready to answer them? Yeah. My first question is, how many games in a row are you going to lose? My second question is, how many games in a row are you going to win? My third question is, why do you suck so much dick as you go? Alright, let's go, baby.
And get stuck, and you can see it colliding and lighting up. The dark stuff, which by definition it's dark because it doesn't interact, passes right through each other, right? And this is, it's so compelling. And there's lots of other observations, but that one is just, before you just look at it, you can see that the mass is distributed differently than the interacting luminous.
So dark energy is harder to get hold of.
Dark energy is much better. I mean, the Higgs field could have also explained dark energy. If you've heard of the God particle, I don't know if you know originally Leon Letterman co-authored a book, and he wanted to call it the goddamn part because they couldn't write it, and his publisher convinced him to call it the God
Neither
particle.
of us still know how to play Uno.
He said they
And we don't
managed
know
to
what the
prevent two
special
groups,
part.
those that believed in God and those that
What
didn't.
are you doing, dude? What are you doing, dude?
He was very funny. He's very good.
Fuck.
So Higgs
That
turned
was
out
an
to be
amazing shot.
Higgs, great discovery,
Dude, that
unbelievable.
was a
There it was, built this
10 out of
massive
10.
collider
9 out of 10
in
shot.
CERN, Switzerland, and there it is.
That was
Unbelievable.
a
Kind of where you
shot.
expect it to be. The reason I say it could be dark energy is
Yeah,
because
but so
the Higgs particle,
easy
the
shot.
particle of light, also
Yeah,
has a field, like an electromagnetic field. So light can have this field that's
Yeah.
distributed through all space,
That was a
electromagnetic
hard
field.
shot.
You shake it around and it creates little particles. So the Higgs field is actually more important than the Higgs particle, the complement to the Higgs particle, because that's what you and I
You guys did 3 shots, dude.
connect with to get mass in our atoms. So the idea is that our atoms are interacting with this gooey field that's everywhere. And that's what's giving us this experience of inertial mass. But we don't actually there's not a lot of quanta lying around. There's not a lot of Higgs particles lying around because they decay. So it's the field that's really important. And that field could act like a dark energy. It's just not in the right place, meaning it's not at the energy's too high to explain this tiny value today. Again, we're back to this mismatch. It's not that we can't conceive of forms of dark energy. It's that we can't make one where we're finding it.
So, I wonder if you could comment on something that I've heard recently. There's some people who say people outside of physics say that dark matter and dark energy is just something physicists made up to put a label on the fact that they don't understand a very large fraction of the universe and how it operates. Is there some truth to that? What's your response to that?
There's some truth to it, but it's really missing a huge point, which is that if we did not understand the universe as incredibly precisely as we do, it's stunning that there's modern precision cosmology. It's absolutely incredible. When COBE, which is an experiment that measured the light left over from the Big Bang in the 80s, first revealed its observations, there was applause. People were cheering, right? It was unbelievable. We had predicted and measured the light left over from the Big Bang. And because of all the precision that's happened since then, that's how we're able to confront that there's things that we don't know. And that's how we're able to confront, like, wow, this is really everything everybody has ever seen and ever will see, as far as we understand, makes up less than 5% of what's out there. And so I would say, yes, we're just giving proxy names to things we don't understand. But to dismiss that as some kind of, they just don't know, it is actually quite the opposite. It is a stunning achievement for you to stare that down and to have that so precise and so compelling to know that there's dark energy. I don't think those are disputed. And they were up until recently. Like, they were still disputed.
I think we're still at such early stages where we're not really even at a good explanation. You've mentioned a few.
Well, I can think of examples of dark matter that exist that don't really know for sure are real versions of dark matter, like neutrinos. Right now they're radiating through us. That's very well confirmed, and they're technically dark. They don't interact with light, and so we can't see them. Right now they're raining through us. If we could see the dark matter in this room, absolutely know is coming from the sun, it would be wild. It would be a rainstorm, but they're just invisible to us. Mostly they pass through our bodies. Mostly they pass through here. Occasionally they get caught in some fancy detector experiment that somebody built specifically to catch solar neutrinos. So dark matter is known to exist. It's just, again, there's not enough of it. It's not the right mass to be the dark matter that makes up this missing component.
I wanted to say that I was recently fascinated by the flat earth people, because it's been a split in the community. First of all, the community is fascinating to study from the psychology, but they did this experiment where I forgot who funded it, but they sent physicists and flat earthers to Antarctica.
Really?
And that split happened because half of them got converted into round earthers.
Wow. Well, good for them.
But then the other half just went, that it was all a psyop.
Really? That's fascinating. Somebody film that? That would be a great documentary.
Yeah, they made a whole thing. This is just at the end of last year. I mean, I think that's such a meaning study of conspiracy theories. Because, there's so many conspiracy theories with some inkling of truth. But there's some elements about the way governments operate, the psychology, it's too messy. Flat Earth to me is just clean. It's like spaghetti monster or something.
Right.
It's just a cleanly wrong thing. So
right.
It's a nice way to
understand
discuss
the psychology.
how a large number of people can believe it.
Yeah, and why? What's very interesting is you trying to use rational arguments. That makes it even more confounding to me. I would understand more somebody who just said, look, I have faith and I believe these things, and it's not about reason and it's not about logic. Okay. I mean, I don't relate to it, but okay. But to say I'm going to use reason and logic and to prove to you that's completely orthogonal conclusion, that I find really interesting. So there's some kind of romance about reason and logic.
Yeah, but also there's questioning the institutions that's really interesting and fun to understand.
Well, I mean, I actually appreciate the skeptic's stance. I don't scientists also have to be skeptical. They have to be childlike, naive, and somewhat, in some sense, really open to anything. Right? Otherwise, you're not going to be flexible. You're not going to be flexible. But also to be skeptical. So I have respect for it. I guess that's exactly what I'm saying is more confusing, because to invoke skepticism and then to want to use rational argument, what is the other component that's going into this? Because as you said, this is something that's easily verified. I mean, we cannot get people in space. So you have to believe a lot more machinery. That's a lot more difficult to justify, explain as a wild conspiracy. So there's something about the conspiracy that stirs a positive emotion.
I think one of the most incredible things, I have to talk to you about this, one of the most incredible things that humans has ever accomplished is LIGO. We have to talk about gravitational waves. And the very fact that we're able to detect gravitational waves from the early universe is epic wild.
It's crazy. Yeah.
Can you explain what gravitational waves are? And we should mention you wrote a book about the humans, about the whole journey of detecting gravitational waves, and LIGO is not going to use the book. But can you talk about gravitational waves? How you were able to actually do it?
Let's just start with the idea of gravitational waves. I have to move around a lot of mass to make sure anything interesting happening in gravity. I mean, if you think about it, gravity is incredibly weak. Right now, the whole Earth is pulling on me, and I can still get out of this chair, walk around. That's insane. The whole Earth. Gravity's weak, right? So to get something going on in gravity, you need like big objects and things like black holes. So the idea is if black holes curve space and time around them in the way that we've been describing, things follow along the curves in space. If the black holes move around, the curves have to follow them, but they can't travel faster than the speed of light either. So what happens is black holes, let's say, move around. Maybe if that two black holes in orbit around each other, that can happen. It takes a while. A wave is created in the actual shape of space, and that wave follows the black holes. Black holes are undulating. Eventually, those two black holes will merge, and as you were talking, that it doesn't take an infinite time, even though there's time dilation, because they're both so big. You'll be deforming space-time a lot. They don't have a little tiny marble falling across an event horizon. It's two event horizons, and in the simulations, you can see it bobble, and they merge together, and they make one bigger black hole, and then it radiates in the gravitational waves. It radiates away all those imperfections, and it settles down to one quiescent, perfectly silent black hole that's spinning. Beautiful stuff. And it emits E equals mc squared energy. So the mass of the final black hole will be less than the sum of the two starter black holes. And that energy is radiated away in this ringing of space-time. It's really important to emphasize that it's not light. None of this has to do literally with the light that we can detect with normal things that detect light. X-rays, form of light, gamma rays are a form of light, infrared, optical, all this whole electromagnetic spectrum, none of it is emitted as light. It's completely dark. It's only emitted in the rippling of the shape of space. A lot of times it's likened closer to sound. Technically, we've kind of argued, and we haven't done an anatomical calculation, but if you're near enough to two colliding black holes, they actually ring space-time in the human auditory range. The frequency is actually in the human auditory range. That the shape of space could squeeze and stretch your eardrum, even in vacuum, and you can literally hear these waves ringing. You're going to get the ball. This one sucks. So the idea is that they're closer to something that you would want to map as a sound than it's something as a picture. Sorry, so what do you think it would feel like to ride the gravitational waves? Like to exist? Because you mentioned when you could literally bob around, like your orbit would change, right? If you were orbiting these black holes, two black holes, you'd be on a kind of complicated orbit, but your orbit would get crossed about.
But how would the experience be? Because you're inside space.
Yes, I see. So the black hole is experienced within space-time as a squeezing and stretching. So you would feel it as a sort of squeezing and stretching, and you would also find your location where you would fall would be redirected. So it's literally like a squeezing and stretching. That's the way to think about it. And it's very detailed. There's sort of
What are the odds
nature
that
of
make
this.
this next shot?
But for many years, people thought, well, these gravitational waves kind of have to exist for these intuitive reasons as described. As space is curved, I move the curve, the wave has to propagate through that curved space-time. But people didn't know if they really carried energy. The arguments went on and back and forth, and papers written in decades. But I like this sound and more than an analogy. I liken the black holes as like mallets on the drum. The drum is space-time. As they move, they bang on the drum of space-time, and it rings. Remarkably, those gravitational waves, things don't interfere with them very much. So they can travel for 2 billion years, light years, in distance, 2 billion years in time, and get to us kind of as they were when they were emitted. Quieter, more diffuse, maybe they've stretched out a little bit from the expansion of the universe, but they're pretty preserved. And so the idea of LIGO, this instrument, is to build a gigantic musical instrument, kind of like building an electric guitar, where the electric guitar is recording the shape of the string, and it plays it back to you with an amplifier. LIGO is trying to record the shape of the ringing drum, and they literally listen to it in the control room. Just sort of hums and wobbles, and they're like trying to play this recording drum back to you. As opposed to taking a snapshot, it's like in time.
Yeah, but to construct this guitar,
yes,
you have to.
gigantic
It
instrument.
has to be very large and extremely precise.
It's unbelievable. I can't believe they succeeded. I honestly, it was so insane. It was such a crazy thing to even attempt. It took them 50 years. Really, people who started in their 30s and 40s who were in their 80s when it succeeded. I mean, the tenacity. The unbelievable commitment. But the sensitivity of this musical instrument, the 4 kilometers, spanning 4 kilometers in a kind of L shape. Tunnels, the largest holes in the Earth's atmosphere because they pulled a vacuum in these tunnels. And they're measuring, they're trying to record the wobbling of space as it passes. Modulation. That amounts to less than 1/10,000th the variation in a proton over the 4 kilometers. It's an insane, insane achievement.
I love great engineering.
I don't know how they did it. I followed them around I just for fun, I'm very theoretical. I don't build things. I'm always super impressed that people can translate something on the page.
That's a shitty shot.
It looks like wires. I don't know. I'm always surprised at what it looks like. But I walked the tunnels with Ray Weiss, who won the Nobel Prize along with Kip Thorne and Barry Barish, one of the project managers. And I walked the tunnels with Ray. It was a delight. Ray's one of the most delightful people. Kip is one of the most wonderful people I've ever known. Ray said to me, the reason why it was called Black Hole Blues is because about a month before they succeeded, he said to me, we don't detect black holes, this whole thing's infested. And we led the country down this wrong path. He really felt like this tremendous responsibility for this project to succeed. It weighed on him. It was just quite tremendous what the integrity, like the scientific integrity. In the first instruments he built, he was building outside of MIT on a table.
What are your thoughts on how good this show
He said, "You're not going to get tenure. You're never going to succeed." And they just kept going.
People like that, huge teams, huge collaboration, are just it's how the world moves forward.
It's an example.
It's there's building cynicism about bureaucracies when a large number of people, especially connected to government, can be productive. Bureaucracy is slowing them down. So it's nice to see an incredibly unlikely, exceptionally difficult engineering project like this.
Oh yeah.
So I understand why there's this weight on the shoulders about greatness. I'm grateful that there's great leaders that push it forward like that.
Yeah. I realize there's so many moment to be able to stumble. And they built the first generation machine just after 2000. It wasn't a surprise to them, but it detected nothing. Crickets. And they have the wherewithal to keep going. Second generation, they're about to turn the machine on, quote unquote, simplification, but do their first science run. And they decide to postpone because they were not ready. September 14th. The experimentalists are out there. They're banging on it, literally driving trucks, slamming the brakes on to see the noise that it creates. So they're really messing with the machine, really interfering with it just to kind of calibrate how much noise can this thing tolerate. And I guess the story is they get tired. There's an instrument in Louisiana, there's one in Washington State, and they go home. Put their tools down, they go home. It's they leave the instrument locked though, mercifully. And it's something like within the span of an hour of them driving back to their humble abodes that they have in these remote regions where they built this instrument.
You lost 2 games in a row.
This gravitational wave washes over, I think it hits Louisiana first. It travels across the U.S., brings the instrument to Washington State. It began over 1.5 billion years ago, before multicellular organisms had emerged on the Earth. Just imagine this from
there are some
this this collision course.
certified anymore.
And it's the centenary.
It's
the year Einstein
published. They don't certify that anymore.
So it's
People kept pushing it.
100 years, and just think about where that signal was when Einstein in 1915 wrote down.
Did you know that
it was almost here.
What do you think is cooler?
literally
Einstein's general relativity or LIGO?
Well, I can't disparage my friends, but of course relativity is just so all-encompassing.
No, but so hold on a second. All-encompassing, super powerful leap of the theory, and
They built it.
they built it.
I don't know, man.
The greatest engineer on the
Yeah.
because I don't know. Humans getting together and building the thing, that's really ultimately what impacts the world, right?
Yeah, I mean, I just, as I said, my admiration for Ray and Kip and the entire team is enormous. And just imagining Ray had been out there on site, he just left to go back home, wakes up in the middle of the night and sees it. Can you imagine? There's a signal. There's something in the log. What was that?
3 games in a row, son.
So speaking of the human story, you also wrote the book Madman Dreams of Turing, connects two geniuses in 20th century, Alan Turing and Kurt.
That was a really bad
What's
shot. You know why?
specific about to connect these two lives?
Yeah.
Because it went to water, son.
I was really mesmerized by these two characters. People know of Alan Turing for having ideated about the computer, being the person to really imagine that. But his work began with thinking about God also. That's where it began, and it began with this phenomenon of undecidable propositions or unprovable propositions. So there was something huge that happened in mathematics. People imagined that any problem in math could technically be proven to be true. Doesn't mean that human beings are going to prove every fact about everything in mathematics, but it should be provable, right? I mean, it seems kind of not that wild supposition. Everyone believed this. All the great mathematicians, Hilbert was a call of his to prove that. And go to a very strange character. Very unusual. He was a Platonist. He literally believed that mathematical objects had an existential reality. He wasn't so sure about this reality he struggled with. He was distrustful of physical reality, but he absolutely took very seriously platonic reality. Often his own way of thinking, and he proved that there were facts, even among the numbers, that could never be proven to be true. You have to think about that, how wild that is. That even a fact about numbers, it's very simple, could be true and unprovable. could never exist as a theorem, for instance, in mathematics, unreachable. This incompleteness result was very disturbing. And essentially, it's equivalent to saying there's no theory of everything for mathematics. It was very disturbing to people, but it was very profound. And Alan Turing got involved in this because he was thinking about uncomputable numbers. So, and that led him. What's an uncomputable number? A number like 0.175. It just goes on forever with no pattern. I can't even figure out how to generate it. There's no rule for making that number. And he was able to prove that there were such things as these uncomputable, effectively unknowable numbers. That might not sound like a big deal. It was actually really quite profound. He was related to Gödel intellectually. But he goes a very different path, almost philosophically the opposite direction. He starts to think about machines. He starts to think about mechanizing thought. He starts to think, what is a proof? How does a mathematician reason? What does it mean to reason at all?
Do you think Alan Turing?
And he begins to imagine
Do you think Alan Turing as much
that will
as you do?
execute certain orders, mechanize thought in a specific way.
Do you think he was 15.2% body fat or
that
more?
does this kind of thinking, and that he can prove it. Even a machine.
Do you think he was 15.2% body fat
numbers,
or
but
more?
where he ends up is the idea of a universal machine that computes, essentially can take different software but execute different jobs. Right? We don't have a different computer to connect to the internet than we do to write papers. We have one machine and one piece of hardware, but it can do all of this huge variety of tasks. And so he really does invent the computer, essentially. And famously, he uses that thinking in a very primitive form in the war effort, where he's recruited to help break the German Enigma code, which is heavily encrypted and largely believed to be uncrackable code. And people believe that Turing and his very small group actually turned the tide of the war in favor of the Allies precisely by using a combination of this thinking and just sheer ingenuity and some luck.
Right. Do you think, though, that
but the other profound
majority of the
revelation
population
that Turing has is that, well, maybe we're just machines.
because you just put it in the water?
Right. And just biological machines.
Oh, you got it.
This is a huge shift for him. It was very different from Gödel. He doesn't really believe in reality. Thinks numbers are platonic realities, and Turing kind of thinking we're kind of like we're actually machines and we can replicate it. So of course Turing's influence is still widely felt.
On many levels, so for the
Many levels, yeah.
in complexity theory, in theoretical computer science, and
all over
mathematics,
the
but also in philosophy with his famous Turing test paper. So, like you said, conceiving like what is the connection that I guess Turing made to mathematics, Turing did. But I think there's another connection to those two people is that they're both in their own way kind of tormented humans.
They're very tormented.
What aspect of that contributed to who they are and what ideas they held?
I mean, I think so much. I don't.
Do you think you need to do that in order to improve it?
Promote the kind of trite trope of the mad genius, or if you're brilliant, you're insane. I don't think that. I don't think you're insane, you're brilliant. But I do think if somebody who's very brilliant, who also chooses not to go for regular gratification in life, they don't go for money, they don't necessarily value creature comforts, they're not leveraging for fame. I mean, they're really after something different. I think that can lead to a kind of runaway instability, actually, sometimes. They're already outside of social norms. They're already outside of normal connections with people. They've already made that break. And I think that makes them more vulnerable. So Gödel did have a wife and a strong relationship, as far as I understand. Was a successful mathematician and ended up at the Institute for Advanced Study, where he walked with Einstein to the Institute every day. and they talked about
People try
certain really unusual things in relativity. You made reference to these rotating galaxies. We were talking, and actually Gödel had a model of a rotating universe that you could travel backwards in time. It was mathematically correct. Showed Einstein that within relativity you could time travel. Just an unbelievably influential brilliant man. But he was probably a paranoid schizophrenic. He did have breaks with reality. He was, I think, quite distrustful and
encounter
feared the government, feared his food was being poisoned, and ultimately literally starved himself to death. And it's such an extreme outcome for such a facile mind, for such a brilliant mind.
I think it's important to sort of not to glorify or romanticize madness or suffering. But to me, you flip that around and just be inspired by the peculiarities of a human mind, how it can be leveraged and channeled creatively.
Oh, yeah.
I think a lot of us, honestly, probably every human has those peculiar qualities. I talk to people sometimes about just my own psychology. I'm extremely self-critical, and I'm drawn to the beauty in people, but because I make myself vulnerable to them, I can be hurt by people.
There's
that therapy, you can lay that out. That's at this particular.
There's like
a
lot of
there's a bunch of people that will say, many of those things you don't want to do. Don't be so self-critical. Don't be so
just let go. That flies
maybe have a little bit more reason
Did you know you
about
lost 3
how
games in a
you
row?
interact with the outside world. Yeah, maybe. Or maybe be that fully and channel that into a productive life. We're all going to die. In the time we have on this earth, make the best of the particular weirdness that you have. And maybe you would create something.
Did you know that you lost 3
and in
games in
the
a
end,
row?
it might destroy. And I think a lot of these stories are that. It's not that.
Oh, yeah.
It's not like saying, because in order to achieve anything great, you have to suffer. No, if you're already suffering, if you're already weird, if you already somehow don't quite fit in your particular environment, in your particular part of society, use that somehow. Use the tension of that, friction of that to create something. And that's what Nietzsche, who suffered a lot from stuff like stomach issues, like
oh yeah,
that could be everything.
Right.
Migraines, it's like
psychosomatic or psychophysical, but
all of that's it's like that can somehow be channeled into a productive life. It should be inspiring. A lot of us suffer in different ways.
Yeah.
Make it, baby.
I'm a big believer in the tragic
Make
law.
it, take it.
I think that we have that right. You're describing what makes us great is ultimately our downfall. Maybe that's just inevitable. The choice could be not to be great. And I guess that's sort of what I mean by they had already broken from a traditional path because they decided to pursue something so elusive and that would isolate them to some extent inevitably and that could fail, right? And whose rewards were hard to predict. And I do think that all the character traits that went into their accomplishments were the same traits that went into their demise. And I think you're right. You could say, well, Lex, you should not be so empathetic. Hold yourself off, cut yourself off a little, protect yourself, right? But isn't that exactly what you're bringing? One of the elements that you're bringing that makes something extraordinary in a space that lots of people try to break through.
Yeah, and we should mention that for every girl on touring, there's millions of people
You missed that shot.
who have tried and who have destroyed themselves and without reason.
I would find it impossible to not pursue a discovery that I could imagine my way through if I could really see how to get there. I cannot imagine abandoning it for some other reason. fear that it would be misused. It's a real fear, right? I mean, it's a real concern. I don't think in my work, since I'm doing extra
I'm sure
in the early universe,
you probably
or black holes, you know, I feel pretty safe. But I mean, who knows, right? Ford couldn't think of a way to
You had one of the best shots I've ever seen the last time.
I cannot imagine pulling back and saying, nope.
What?
You know, I'll give you a counter example.
Dude, what the fuck is that?
Versus Terrence Taik.
Brilliant.
Brilliant mathematician.
Brilliant.
He is better than, out of all the brilliant people I've ever met in my life, he's better than anybody else at working at a hard problem and then realizing when it's, for now, a little too hard.
Oh, that I can do.
Stepping away.
Yeah.
And he's like, okay, this is now a weekend problem.
Uh-huh.
Because he
Absolutely.
has seen too much for him. And it's different. But Grigori Perlman or Andrew Wiles can give
Yes, that's a great story.
completely
Yeah.
many years for
Yes.
social problems.
Yes.
And for every Grigori
And they might
Perlman.
not have had that.
So you choose your life story.
I totally agree. Now, I'm not going to say sometimes I take too long to come to that conclusion, but I will proudly say, as most
You basically think the 2 second dick.
that I kill most of my ideas myself.
Yeah.
And that's, I am absolutely able to say, oh, it's just not. I mean, I'm not going to deny that sometimes I maybe take a while to come to that conclusion, longer than I should, but I will. Absolutely, I will drop it. And that is any self-respecting
Why is that?
business behavior to that. The problem is with somebody like Jeff Wiles, who you're describing from its last theorem. It took him 7 years, is that the number? Something like that, even up
Yeah,
into
but it's like
and did not emerge for 7 years. Is that maybe he did? He
it's
was
like
on the
10
ship. He
times
wasn't
Big
wrong.
Man.
And but that's so it could have been interminable. He still might not have gotten there in the end. And so that's the difficult space to be in, where you're not wrong. You are onto something, but it's just asymptotically approaching that solution. You're never
Dude, I
actually
can
going
help.
to land.
Like, I could
That
get
happens.
450
He had a really, I knew him straight up right.
$80.
He had a proof.
Yes.
So now instead, somebody found a mistake in it. That was just good.
Yeah.
Because you now everything just decided,
Right.
and now you realize that
I mean, it's taking a year for people to check it. It's not the kind of thing you look over in an afternoon.
Dude, that was the most amazing
to have
shot.
the will, to have the confidence and the patience to go
Dude,
back.
you've never scored on this
rigorously go through what to do. But then there's another great story. Grigori Perlman, who spent 7 years and turned down the field medal. He did it all alone. Not after he turned down the field medal, the Millennial Prize in the Poincaré conjecture. He walked
Do
away.
you know that you're sucking dick right now?
That's a very different psychology. That's wired differently.
Doesn't care about money, doesn't care about fame, doesn't care about anything else.
Yep.
In fact,
Where is he now?
in St. Petersburg, Russia, trying to get a conversation with him. It turns out when you walk away and you're recluse and you enjoy that, you also don't want to probably a weird dude in the tie. So it turns out I'm trying.
Well, if you look at someone like Turing, his eccentricities were completely different. Right? It's not as though there's some mold, and I really don't like it when it's portrayed that way. These are really individuals who were still lost in their own minds, but in very different ways. Turing was openly gay, really, during this time. He was working during the war, World War II, so we understand the era, and it was illegal in Britain at the time. And he kind of refused to conceal himself. There was a time when the kind of attitude was, well, we're just going to ignore it. But he had been robbed by somebody that he had picked up somewhere, I think it was in Manchester. And it was such a small thing. I don't know what they took. It took like nothing. You know, it was nothing. But he couldn't tolerate. He goes to the police and he tells them. And then he's arrested. He's the criminal because it involved this homosexual act. Now here you have somebody who made a major contribution to the Allies winning the war. I mean, it's just unbelievable. Not to mention the genius, mathematical genius. I mean, he saved the lives of the people that were doing this to him.
Oh, you fucked it
And
up.
they essentially chemically castrated him as a punishment. That was his sentence. And he became very depressed, suicidal.
It doesn't matter.
And the story is he was
the best time of
obsessed
your
with
life.
Snow White, which was recently released. He used to chant one of the well, I don't know if you would call them poem songs. Dip the apple in the brew, let the sleeping death seep through.
You need the best shot of your
Chant from
life.
Snow White. And the belief is that he dipped an apple in cyanide and bit from the poison apple. Now, I don't know if this is apocryphal, but people think that the apple in the Macintosh with the bite out of it is a reference to the turret. Some people deny this. But some people say he did that so his mother could believe that maybe it was an accident. But yeah, quite a terrible end.
Yeah, but two greatest humans ever.
Mm-hmm. I think the reason why I tie them together, not just because ultimately their work is so connected,
you have an invitation,
but because there's this sort of impossibility of understanding them. There's this sort of impossibility of proving something about their lives. That even if you try to write factual biography, there's something that eludes you, and I felt like that's kind of fundamental to the mathematics, the incompleteness, the undecidable, the incomputable. So structurally, it was about what we can kind of know and what we can believe to be true, but can't ever really know.
Yeah, limitations of formal systems, limitations of
biography, of fiction and nonfiction.
Limitations. So there's so many layers to you. So one of which there's this romantic notion of just understanding humans, exploring humans, and just to explore science and exploring very rigorous, detailed physics and cosmology of things. So there's art, the kind of artistry. So I saw that you're the chief science officer of Pioneer Works, which is mostly like an artist type of situation. It's a place in Brooklyn. Can you explain to me what that is and what role does art play in your life?
Yeah, I can start with Pioneer Works. Pioneer Works, in some sense, it was inevitable that I would land at Pioneer Works. It felt like I was marching there for many years, and just it came together again like a this collision. It was founded by this artist, Dustin Mellon, very utopian idea. He bought this building, this old iron works factory called Pioneer Iron Works in Brooklyn. It was in complete disrepair, but a beautiful old building from the late 1800s. And he wanted to make this kind of collage. Dustin's definitely a collage artist, works in glass, very big pieces, very imaginative and wild and narrative and into nature and consciousness. And I think he wanted to do that with
what are your thoughts on this shot?
He wanted a place, a collage, a living example of artists and scientists. And it was founded by Dustin, and Gabriel Florence was the founding artistic director. It was started just before Hurricane Sandy. I don't know if people feel as strongly about Hurricane Sandy as New Yorkers do, but it was a real moment around 2012, 2013. Sort of paused the project, and you can even see the kind of waterline on the brick of where Sandy was. I came in and collided with these two shortly after that, and it really was like a collision. I'm science, their art. Gabe makes everything, builds everything with bare hands. Dustin's a dreamer. I love science. I really want to science is hard to access. I have always loved the translation of science in literature, in art. I love fiction writers, really literary fiction writers who dabble thinking about science. And I very firmly believe science is part of culture. I know it to be true. I don't think of myself as doing outreach or education. I don't like those labels. I'm doing culture. An artist in their studio working out problems, understanding materials, building a body of work. Nobody says to them when they exhibit, why are you doing outreach? Or are you doing education? It's the logical extension. So I feel that if you've had the privilege of knowing some of these people, of seeing a little bit from the summit, if you've had a little glimpse yourself, that you bring it back to the world. So we boom, exploded, pioneers became science and art. It's not artists.
I can't believe I just that shot.
It's real hardcore scientists talking about science and a lot of live events. We have a magazine called
Now
Broadcast.
it's a focus.
We feature all of the disciplines rubbing together, artists working on all kinds of things. When I first started doing events there, my first guest, like you, I was talking to people. I know how to talk to people because I know these guys. And I've been on the interviewee side so much that I know exactly, it was like fully formed for me how to do those conversations.
Yeah, you're extremely good at that also.
Yeah, thank you. I appreciate that. You learn how to do it too, though. I mean, I don't think the first one I did, I think I've learned, right? You acquire, you get better. It's really interesting. And I love to study. I think you do too. I really look into material. And I love science. I really do. I want to talk to a CRISPR biologist because I don't understand it and I want to understand it.
And that's why there's a bunch of cool events and very, very fascinating variety.
Yes, a really fascinating variety of humans. That's a good way of putting it.
Yeah, so it maybe put in my mental map of like it's a cool place to go and visit in New York.
Yes, you have to come see us. I think you would love it.
Also, I should mention fashion. I see you do a bunch of talks, so there's a lot of fashion.
Yeah. Oh my God.
Appreciation of fashion.
I am so, you're giving me an opportunity to give a shout out to Andrea Lara, who's a designer who makes these amazing jumpsuits that I often wear in a lot of my events. She has a jumpsuit design line called Risen Division, and she just makes these incredible, they're fantastic. We also design patches for all of our events, these string theory patches and consciousness patches.
We should show this as overall.
Right.
Hopefully there's a nice picture. That's about everywhere.
So, I think all of this is just, I just like to experiment with life, I think. Making a magazine was a big, wild experiment.
You said with life?
With life.
Nice.
Yeah. This kind of idea that we were just describing, is, I find it hard to stop the momentum if I think I could make something. I have to try to make it. And to me, this is the closest I come to experimentation and collaboration. Because even though I collaborate theoretically, I have great collaborators, Brian Greene, Massimo Parati, Dan Cabot. These are my really close collaborators. A lot of theoretical physics is alone. You're in your mind a lot. This is something that really was built, this triad of Dustin, Gabe, and I, and all of the amazing people who work there are amazing. Or we really are doing it together. You take one element out, and it starts to change shape, and that's a very interesting
this is my best
experience. I think and making things is an interesting experience.
Did you mention literature?
I know you're not. I don't know if I've ever been
life, whether it's literature, fiction, non-fiction.
I love fiction, which I think people expect me to read a lot of sort of sci-fi or non-fiction, and mostly read fiction. I had a syllabus of great fiction writers that had science in it, and I love that syllabus.
Can you ever make that public or not?
Yeah, I suppose I could. I can tell you some of them as they come to mind. Katsuo Ishiguro, who won the Nobel Prize, wrote Remains of the Day, probably most famously.
Maybe it's always
his book, Never Let Me Go. It's unbelievable. Totally devastating. Stunning. I really love literature, so when people can do that with these very abstract themes,
Let's see it.
it's sort of my favorite space for literature. Not nameless version, but backwards.
You lost 5
I love some of the other things even more,
games.
but Tanjiro was pretty clever.
I don't have a time machine on
like
me,
it when
but if I recall, you said you were going to win 5 games.
are applied to a story that's fundamental.
Why should it suck so much dick?
Some
Now we're going into overtime.
And the beauty of it, like I really
How shitty you are. Doug, you're so
even
shitty.
Orwell is amazing. Hitchens writing on Orwell is amazing.
I know.
There were some plays on the syllabus. I have to think what else
We
was
can
in there.
go back and we can
There was
listen to
one
you
book
say
that
that you were
was
going
kind
to
of
win 5
surprising. I
games
think
in a row.
that's a masterpiece, which is
I just want you to know,
and you might say,
from the bottom of my heart,
well, for sure, Clark
that I
absolutely
think
loves
that
science.
you might be the
Science.
shittiest
And you can field is very subtle.
mini golf player
and that
in the
book is
history, not just
um,
of golf,
it's,
but
it's a
of miniatures. You
really
are that shitty.
remarkable,
If you know that
precise,
you have an
stunning,
invitation,
ethereal, all of these things at once. And there's no who, what, where, when, or how. You might guess it's a nuclear event.
dude, what are you doing? You jerking yourself off raw?
From the movie, but really the book is magnificent. And it's very, very abstract. But there's a sense to me in which it is science is structuring.
And still, fundamentally, that book is about the human story.
Yeah, absolutely. Boy.
Yeah. So the science plays a role in creating the world.
Mm-hmm.
Within it, there's still really it's a different way to explore human dynamics and where it's we blend some clarity and depth that may be a more direct telling us.
Probably to go suck Alex Turing's
and even surreal worlds that I don't know why, but I return to all those animal problems. It's kind of like
we were in the middle of a game.
it's another art form to be able to tell
we were in the middle of a game, and then you fucking left.
Mm-hmm. Yeah.
Well, just simple language.
Oh, no, it was incredible. But some of the I've played with some animals are more equal than others.
Depends how long you do.
There are in-total terrains where there were some infinities for others.
Like if it's like some fucking
there's certain books just kind of
I don't know,
inject themselves into our culture in a way that just reverberates. And, I don't know, as it creates
it's
culture,
interesting.
not
Like
just like influences. It's just like it's
sucking a guy's dick has been dead for like
literature do that.
Yeah.
That's pretty good.
You can have one definitive answer to one
But
single
if he's
question.
been dead like a 10 millennia,
There's an oracle, and you can talk to that oracle. You can ask multiple questions, but it has to be on that topic. So just clarify. What mysteries of the universe would you want that oracle to help you with?
You know, it's funny. I should say the obvious thing, but I feel like I almost want to be greedy. I think it's a complicated response to this. The obvious thing for me to say, I want to grab me for if
speaking of mummified dick,
it's not even something I work on
shot.
day to day. I mostly just look with interest in what others are doing. If I think I can jump in, I would.
You know that I'm
not jumping into the fray. But
5 games
obviously that's the big one. And there is a sort of sense that with that will come the answers to all these other things. My complicated relationship is that, well, you know, part of the scientific disposition is having stuff you don't know the answer to. I mean, we're not going to have all the answers, I hope, because then sort of, then what? Right? It's sort of dystopian.
Yeah, I totally agree with you. I like the mysteries we have.
Yeah.
I kind of had this assumption that there will always be mysteries, so you want to keep solving them.
They will lead to more. In the same way that relativity led to black holes led to information loss paradox, or the Big Bang, or what happened before, or the multiverse. It's because we learned so much, we were able to escalate to the next level of abstraction.
Yeah, by the way, we should mention that if you're talking historical, even if you ask the obvious question about quantum gravity, I almost guarantee with 100% probability that even if all of your questions are answered, it's impossible to get to the end of your questions.
Right.
It says, the oracle will say, no, you can't unify.
Fuck you.
And then you say, well, but...
and then you say emergent, and then the oracle will say, well, everything you think is fundamental is not, it's emergent. You say, okay, well, this is we need some more questions.
Right. I mean, it's been 100 years more since relativity, we're still picking it apart.
Yeah. Mm-hmm. And there may be new ones.
Mm-hmm.
You're right that eventually all our history in this universe will be erased. How does that make you feel?
I'm just going to go for it.
Yeah, it's a tough thought. But again, I think there's a way in which we can come to terms with that's kind of poetic. And you build something in the sand and then you erase it.
Yeah.
So I think it's just a reminder that we have to be concerned about our immediate experience too, right? How we are to those around us.
Dude, you ready
how
for
they
this
are
one?
to
This
us.
is for the win.
What we leave behind in the near term.
In your face,
behind in
son.
the long term. How we contributed and did we contribute overall net positive?
So what's the name of this whole?
Eventually, I think it's kind of hard to imagine. But yes, all of these Nobel Prizes, all of these mathematical proofs, all of these conversations, all of these ideas, all the influence they have on each other, even the AI, eventually will expire.
Well, at the very least, we can focus on drawing something beautiful in the sand before it's washed away. Well, this was an incredible conversation. I'm truly grateful for the work you do.
And me for your work. Thanks so much for having me.
Thank you for talking to me.
Yeah, lots of fun.
Thanks for listening to this conversation with Jan 11. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Albert Einstein on the topic of relativity. When you're courting a nice girl, an hour seems like a second. When you sit on a red hot cinder, a second seems like an hour. That's relativity. Thank you for listening, and hope to see you next time.
Did you know it's your turn? Dude, you're so bad. No, dude.
If we don't ask how long they last, but instead ask what's the probability that there have been any civilizations at all, no matter how long they last. Now, when I ask whether they exist now or not, I'm just asking in general about probabilities to make a technological civilization anywhere and at any time in the history of the universe. And that we were able to constrain. And so what we found was basically that there have been 10 billion trillion habitable zone planets in the universe. And what that means is that those are 10 billion trillion experiments that have been run. And the only way, or the only time that this is, this whole process from, abiogenesis to a civilization has occurred is if every one of those experiments failed, right? So therefore, you could put a probability. We called it the pessimism, right? We don't really know what nature sets for the probability of making intelligent civilizations, right? But we could set a limit using this. We could say, look, as if the probability per habitable zone planet is less than 10 to the minus 22.
You lost 16 in a row.
Then yeah, we're alone.
I mean,
if it's anywhere larger than that, then we're not the first. It's happened somewhere. To me, that was really
pleasure walking your ass.
It doesn't tell me there's anybody nearby. The galaxy could be sterile. It just told me that, unless nature's really against, has some bias against civilizations, we're not the first time this has happened. This has happened elsewhere over the course of cosmic history.
Following is conversation with Adam Frank, an astrophysicist interested in the evolution of star systems and the search for alien civilizations in our universe. This is a Let's Stream podcast. To support it, please check out our sponsors in the description. And now, dear friends, there's Adam Frank. You wrote a book about aliens. So the big question, how many alien civilizations are out there?
Yeah, that's the question, right? The amazing thing is that after 2.5 millennia of people yelling at each other or setting each other on fire occasionally over the answer, we now actually have the capacity to answer that question. So in the next 10, 20, 30 years, we're going to have data relevant to the answer to that question. We're going to have hard data, finally, that will, one way or the other, even if we don't find anything immediately, we will have gone through a number of planets. We'll be able to start putting limits on how common life is. The one answer I can tell you, which was an important part of the problem, is how many planets are there? Right? And just like people have been arguing about the existence of life elsewhere for 2,500 years, people have been arguing about planets for the exact same amount of time. Right? Aristotle and Democritus about this. You can see they have very wildly different opinions about how common planets were going to be and how unique Earth was. And that question got answered, right? Which is pretty remarkable that in a lifetime 2,500-year-old question. The answer is they're everywhere. There are planets everywhere. And it was possible that planets were really rare. We didn't really understand how planets formed. And so if you go back to, say, the turn of the 20th century, there was a theory that planets formed when two stars passed by each other closely, and then the material was gravitationally squeezed out. In which case, those kinds of collisions are so rare that you would expect 1 in a trillion stars to have planets. Instead, every star in the night sky has planets.
So one of the things you've done is simulated the formation of stars. How difficult do you think it is to simulate the formation of planets, like simulate our solar system, through the entire evolution of the solar system? This is kind of a numerical simulation sneaking up to the question of how many planets are there.
That actually we're able to do now. You can run simulations of the formation of planetary systems. So if you run the simulation, really where you want to start is a cloud of gas, these giant interstellar clouds of gas that may have 1 million times the mass of the sun. And so you run a simulation of that. It's turbulent, the gas is roiling and tumbling, and every now and then you get a place where the gas is dense enough that gravity gets hold of it and can pull it downward. So you'll start to form a protostar. And a protostar is basically the young star, the ball of gas where nuclear reactions are getting started. But it's also a disk. So as the material falls inward, because everything's rotating, as it falls inward, it'll spin up, and then it'll form a disk. The material will collect in what's called an accretion disk or a protoplanetary disk. And you can simulate all of that. Once you get into the disk itself and you want to do planets, things get a little bit more complicated because the physics gets more complicated. Now you got to start worrying about dust, because actually dust is the wrong word, smoke really. These are the tiniest bits of solids. They will coagulate in the disk to form pebbles, right? And the pebbles will collide to form rocks, and the rocks will form boulders, etc., etc. That process is super complicated, but we've been able to simulate enough of it to begin to get a handle on how planets form, how you accrete enough material to get the first proto-planets or planetary embryos, as we call them. And then the next step is those things start slamming into each other to form, planetary-sized bodies. And then the planetary bodies slam into each other. Earth, the moon, came about because there was a Mars-sized body that slammed into the Earth, basically blew off all the material that eventually formed the moon.
And all of them have different chemical compositions, different temperatures.
Yeah, so the temperature of the material in the disk depends on how far away you are from the star. So it decreases, right? And so there's a really interesting point. So close to the star, temperatures are really high, and the only thing that can condense, that can kind of freeze out, is going to be stuff like metals. So that's why you find Mercury is this giant ball of iron, basically. And then as you go further out, the gas gets cooler, and now you can start getting things like water to freeze, right? So there's something we call the snow line, which is somewhere in our solar system, out around between Mars and Jupiter. And that's the reason why the giant planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, all have huge amounts of or water and ice. Actually, Jupiter and Saturn don't have so much, but the moons do. The moons have so much water in them that there's oceans, right? We've got a number of those moons that got more water on them than there's water on them.
Do you think it's possible to do that kind of simulation to have a stronger and stronger estimate of how likely an Earth-like planet is? Can we get the physics simulation done well enough to where we can start estimating, like, what are the possible Earth-like things that can be generated?
Yeah, I think we can. I think we're learning how to do that now. So one part is like trying to just figure out how planets form themselves and doing the simulations, like that cascade from dust grains up to planetary embryos. That's hard to simulate because it's both. You got to do both the gas and you got to do the dust, and the dust collide. Once you get up to a planet-sized body, then you kind of have to switch over to almost like a different kind of simulation. There, often what you're doing is you're doing you're assuming the planet is this sort of spherical ball, and then you're doing like a 1D, a radial calculation. You're just asking like, all right, how is this thing going to? What's the structure? Like, am I going to have a solid iron core, or am I going to get a solid iron core with that liquid iron core out around it, like we have on Earth? And then you get, a silicate, kind of a rocky mantle, and then across all those details, those are kind of beyond being able to do full 3D simulations ab initio from scratch. We're not there yet.
How important are those details, like the crust and the atmosphere, do you think?
Hugely important. So I'm part of a collaboration at the University of Rochester where we're using the giant laser. It's literally, this is called the Laboratory for Laser Energetics. We got a huge grant from the NSF to use that laser to like slam tiny pieces of silicon to understand what the conditions are like at the center of the Earth, or even more importantly, the center of super Earths. Like this is what's wild. The most common kind of planet in the universe we don't have in our solar system, which is amazing, right? So we've been able to study enough or observe enough planets now to get a census. We kind of have an idea of who's average, who's weird. And our solar system's weird because the average planet has a mass somewhere between a few times the mass of the Earth to maybe, 10 times the mass of the Earth. And that's exactly where there are no planets in our solar system. So the smaller ones of those we call super Earths. The larger ones we call sub-Neptunes. And they're anybody's guess. Like, we don't really know what happens to material when you're squeezed to those pressures, which is like millions, tens of millions of times the pressure on the surface of the Earth. So those details really will matter of what's going on in there, because that will determine whether or not you have, say, for example, plate tectonics. We think plate tectonics may have been really important for life on Earth, for the evolution of complex life on Earth. So it turns out, and this is sort of the next generation where we're going with the understanding the evolution of planets and life. It turns out that you actually have to think hard about the planetary context for life. You can't just be like, oh, there's a warm pond, and then some interesting, chemistry happens in the warm pond. You actually have to think about the planet as a whole and what it's gone through in order to really understand whether a planet is a good place for life or not.
Why do you think plate tectonics might be useful for the formation of complex life?
There's a bunch of different things. One is that, the Earth went through a couple of phases of being a snowball planet. Like we went into a period of glaciation where pretty much the entire planet was under ice. The oceans were frozen. Early on in Earth's history, there was barely any land. We were actually a water world. It's just a couple of Australia-sized cratons, they called them, protocontinents. So those, we went through these snowball Earth phases. And if it wasn't for the fact that we had kind of an active plate tectonics, which had a lot of volcanism on it, we could have been locked in that forever. Like, once you get into a snowball state, the planet can be trapped there forever, which is, maybe you already had life form, but then because it's so cold, you may never get anything more than just microbes. Right? So what plate tectonics does is because it fosters more is that you're going to get carbon dioxide pumped into the atmosphere, which warms the planet up and gets you out of the snowball. But there's even more really important things. I just finished a paper where we were looking at something called the hard steps model, which is this model that's been out there for a long time that purports to say intelligent life in the universe will be really rare. And it made all these assumptions about the Earth's history, particularly the history of life and the history of the planet, that have nothing to do with each other. And it turns out, as I was doing the reading for this, that Earth probably early on had a more mild form of plate tectonics, and then somewhere about 1 billion years ago, it ramped up. And that ramping up changed everything on the planet. Because here's a funny thing: the Earth used to be flat. That's what I mean by that, right? All the flat Earthers out there get excited for one second.
Flip it.
What I mean by that is that there really weren't many mountain ranges, right? The beginning of, I think the term is orogenesis, mountain building, true Himalayan-style giant mountains, didn't happen until this more robust form of plate tectonics, where the plates are really being driven around the planet. And that is when you get the crusts hitting each other, and they start pushing, into these Himalayan-style mountains. The weathering of that, the erosion of that, puts huge amounts of nutrients, things that microbes want to use, into the oceans, and then what we call the net primary productivity, the bottom of the food chain, how much sugars they're producing, how much photosynthesis they're doing, shot up by a factor of almost 1,000, right? So that the fact that you had plate tectonics supercharged evolution in some sense. Like we're not exactly sure how it happened, but it's clear that the amount of life, the amount of living activity that was happening, really got a boost from the fact that suddenly there was this new vigorous form of plate tectonics.
So it's nice to have turmoil in terms of temperature, in terms of surface geometries, in terms of the chemistry of the planet, turmoil.
Yeah, that's actually really true, because what happens is we look at the history of life. That's an excellent point to bring it up. If you look at the history of life on Earth, we get abiogenesis somewhere around at least 3.8 billion years ago. And that's the first microbe. They kind of take over enough that they really do get a biosphere. You get a biosphere that's actively changing the planet. But then you go through this period they call the boring billion, where it's a billion years and it's just microbes. Nothing's happening. It's just microbes. I mean, microbes are doing amazing things. They're inventing fermentation. Thank you very much. We appreciate that. But it's not until sort of you get probably these continents slamming into each other, you really get the beginning of continents forming and driving changes that evolution has to respond to. On a planetary scale, this turmoil, this chaos, is creating new niches as well as closing other ones. And biology, evolution has to respond to that. And somewhere around there is when you get the Cambrian explosions, when suddenly every body plan, evolution goes on an orgy, essentially. So it does look like that chaos or that turmoil was actually very helpful to evolution.
I wonder if there is some extremely elevated levels of chaos, almost like catastrophes, behind every leap of evolution. Like you're not going to have leaps. Like in human societies, where like an Einstein that comes up with a good idea, but it feels like in an evolutionary time scale, you need some real big drama going on for the evolutionary system to have to come up to a solution to that drama, like an extra complex solution to that drama.
Well, I think I'm not sure if that's true. I don't know if it needs to be like an almost extinction event, right? Because it's certainly true that we have gone through almost extinction events, right? We've had 5 mass extinctions, but you don't necessarily see that there was this giant evolutionary leap happening after those. So with the comet impact, the KT boundary, certainly lots of niches opened up, and that's why we're here, right? Because our ancestors were just basically rodents, rats, living under the footsteps of the dinosaurs, and it was that comet impact that opened the route for us. But it wasn't. I mean, it still took another 65 million years. It wasn't like this thing immediately happened. But what we found with this hard step, because all I did the hard step was it was one of these anthropic reasoning kinds of things, where Brandon Carter said, "Oh, look, the intelligence doesn't show up on Earth until about almost close to when the end of the sun's lifetime." And so he's like, "Well, there should be no reason why the sun's lifetime and the time for evolution to produce intelligence should be the same." And so therefore he goes through all this reasoning, anthropic reasoning, and he ends up with the idea that it must be that the odds of getting intelligence are super low, and so that's the hard steps, right? So there was a series of steps in evolution that were very, very hard, and because of that you can calculate some probability distributions, and everybody loves a good probability distribution, and they went a long way with this. But it turns out that the whole thing is flawed, because when you look at it, of course the time scale for the sun's evolution and the time scale for evolution on life are coupled, because life and the time scale for evolution of the Earth is about the same time scale as the evolution of the sun. It's billions of years. The Earth evolved over billions of years, and life and the Earth co-evolve. That's what Brandon Carter didn't see, is that actually the fate of the Earth and the fate of life are inextricably combined. And this is really important for astrobiology too. Life doesn't happen on a planet; it happens to a planet. So this is something that David Grinspoon and Sarah Walker both say, and I agree with this. It's a really nice way of putting it. Plate tectonics, the evolution of an oxygen atmosphere, which only happened because of life. These things, these are things that are happening where life and the planet are sort of sloshing back and forth. And so rather than, to your point about do you need giant catastrophes, maybe not giant catastrophes, but what happens is as the Earth and life are evolving together, windows are opening, evolutionary windows. Like, for example, life put oxygen into the atmosphere. When life invented this new form of photosynthesis about 2.5 billion years ago, that broke water apart to work to do its chemical shenanigans. It broke water apart and pushed oxygen into the atmosphere. That's why there's oxygen in the atmosphere, only because of life. That opened up huge possibilities, new spaces for evolution to happen. But it also changed the chemistry of the planet forever. So the introduction of oxygen photosynthesis changed the planet forever. And it opened up a bunch of windows for evolution that wouldn't have happened otherwise. Like, for example, you and I, we need that amount of oxygen. Big brain creatures need an oxygen-rich atmosphere because oxygen is so potent for metabolism. So you couldn't get intelligent creatures 100 million years after the planet formed.
So really, on a scale of a planet, and there's billions, trillions of organisms on a planet, they can actually have planetary scale impact.
Yes.
So the chemical shenanigans of an individual organism, when scaled out to trillions, can actually change a planet.
Yeah, and we know this for a fact. So there was this thing, Gaia theory, that with James Lovelock introduced in the 70s, and then Lynn Margulis, the biologist, and Margulis together. So this Gaia theory was the idea that planets pretty much life takes over a planet, like hijacks the planet, in a way that the sum total of life creates these feedbacks between the planet and the life, such that it keeps the planet habitable. It's kind of a homeostasis, right? I can go out outside, it's 100 degrees, right? And I go outside, but my internal temperature is going to be zero. And I can go back to, Rochester, New York in the winter, and it's going to be, 0 degrees, but my internal temperature is going to be the same. That's homeostasis. The idea of Gaia theory was that life, the biosphere, exerts this pressure on the planet, or these feedbacks on the planet, that even as other things are changing, the planet will always stay in the right kinds of conditions for life. Now, when this theory came out, it was very controversial. People were like, oh my God, he's smoking weed, and there were all these Gaian festivals with Gaian dances. And so, it became very popular in the New Age community. But Lovelock, actually, they were able to show that, no, this has nothing to do with the planet being conscious or anything. It was about these feedbacks that by the biology, the biosphere can exert these feedbacks. And now that's become, whether or not, we're still unclear whether there are true Gaian feedbacks, in the sense that the planet can really exert complete control. But it is absolutely true that the biosphere is a major player in Earth's history.
So the biosphere fights for homeostasis on Earth.
What I would say right now is, I don't know if I can say that scientifically. I can certainly say that the biosphere does a huge amount of the regulation of the planetary state, and over billions of years has strongly modified the evolution of the planet. So whether or not a true Gaian feedback would be exactly what you said, right? The biosphere uses somehow, and Sarah Walker and David Princeman and I actually did a paper on this about the idea of planetary intelligence or cognition across a planetary scale. And I think that actually is possible. It's not conscious, but there is a kind of cognitive activity going on. The biosphere, in some sense, knows what is happening because of these feedbacks. So it's still unclear whether we have these full Gaian feedbacks, but we certainly have semi-Gaian feedbacks. If there's a perturbation on the planetary scale, temperature, insolation, sunlight's coming in, the biosphere will start to have feedbacks that will damp that perturbation. Temperature goes up, the biosphere starts doing something, temperature comes down.
Now, I wonder if the technosphere also has a Gaian feedback, or elements of a Gaian feedback, such that the technosphere will also fight to some degree for homeostasis. Open question, I guess.
Well, I'm glad you asked that, because that paper that David and Sarah and I wrote, what we were arguing was is that over the history of a planet, right, when life first forms, 3.8 billion years ago, it's kind of thin on the ground, right? You've got the first species, these are all microbes, and they have not yet, they're not going to enough of them to exert any kind of these Gaian feedback. So we call that an immature biosphere. Mm-hmm. But then as time goes on, as life becomes more robust and begins to exert these feedbacks, keeping the planet in the place where it needs to be for life, we call that a mature biosphere, right? And the important thing, and I'm sure later on we're going to talk about definitions of life and such, there's this great term called autopoiesis that Francisco Varela, the neurobiologist Francisco Varela, came up with. And he said, one of the defining things about life is this property of autopoiesis, which means self-creating and self-maintaining. Life does not create the conditions which will destroy itself, right? It's always trying to keep itself in a place where it can stay alive. So the biosphere, from this Gaian perspective, has been autopoietic for billions of years. Now, we just invented this technosphere in the last, couple of hundred years. And what we were arguing in that paper is that it's an immature technosphere, right? Because right now, with climate change and all the other things we're doing, we're just, the technosphere right now is sort of destroying the conditions under which it needs to maintain itself. So the real job for us, if we're going to last over, geologic timescales, if we want a technosphere that's going to last tens of thousands, hundreds of thousands, millions of years, then we've got to become mature, which means to not undermine the conditions, to not subvert the conditions that you need to stay alive. So as of right now, I'd say we're not autopoietic.
Well, I wonder if you look across thousands, tens of thousands, hundreds of thousands of years, that perturbations, the technosphere should create perturbations as a way for developing greater and greater defenses against perturbations, which sounds like a ridiculous statement, but basically go out and play in the yard and hurt yourself to strengthen or like drink water from the pond.
From the pond, yeah, right. Get sick a few times.
To strengthen the immune system.
Yeah. Well, it's interesting with the technosphere. We can talk about this more, but we're just emerging as a technosphere in terms of as a interplanetary technosphere, right? That's really the next step for us. Is to David Grinspoon talks about, I love this idea of anti-accretion, like this amazing thing that for the first time, over the entire history of the planet, stuff is coming off the planet, right? Used to be everything just fell down, all the meteorites fell down, but now we're starting to push stuff out. And if you have planetary defense or such, we are actually going to start exerting perturbations on the solar system as a whole. We're going to start engineering if we make it, right? I always like to say that if we can get through climate change, the prize at the end is the solar system, right? So we will we'll be literally engineering the solar system. But what you can think of right now with what's happening with the Anthropocene, the great acceleration that is the technosphere, is the creation. That is a giant perturbation on the biosphere, right? And what you can do is, the technosphere sits on top of the biosphere, and if the technosphere undermines the biosphere for its own conditions of habitability, then you're in trouble, right? I mean, the biosphere is not going away. There's nothing we can do. Like the idea that we have to save the Earth is a little ridiculous. Like the Earth is not a furry little bunny that we need to prevent, but it's the conditions for us, right? Humanity emerged out of the Holocene, the last 10,000 years into the glacial period. We can't tolerate very different kinds of Earths. So that's what I mean about a perturbation.
Before we forget, I got to ask you about this paper. It's pretty interesting. There's an interesting table here about hard steps. Abiogenesis, glucose fermentation, tuberonic acid, all kinds of steps, all the way to Homo sapiens, animal intelligence, land ecosystems, endoskeletons, eye precursor, so formation of the eye.
Yep.
Complex multicellularity. Yeah, so interesting. I mean, what can you say about this chart? There are all kinds of papers talking about what the difficulty of these steps.
Right, and so this was the idea. So what Carter said was, using anthropic reasoning, he said there must be a few very hard steps for evolution to get through to make it to intelligence, right? So there's some steps are going to be easy. So every generation, you roll the dice, and it won't take long for you to get that step. But there must be a few of them, and he said you could even calculate how many there were, 5, 6, in order to get to intelligence. And so this paper here, this plot, is all these different people who've written all these papers, and this is the point. Actually, you can see all these papers that were written on the hard steps, each one proposing a different set of what those steps should be. And there's this other idea from biology of the major transitions in evolution, MTEs, that those were the hard steps. But what we actually found was that none of those are actually hard. The whole idea of hard steps, that there are hard steps, is actually suspect. So, what's amazing about this model is it shows how important it is to actually work with people who are in the field, right? So Brandon Carter was a brilliant physicist. The guy came up with this. And then lots of physicists and astrophysicists like me have used this, but the people who actually study evolution and the planet were never involved, right? And if you went and talked to an evolutionary biologist or a biogeophysicist, they'd look at you when you explain this to them and they'd be like, what? Like, what are you guys doing? Turns out none of the details or none of the conceptual structure of this matches with what the people actually study the planet's evolution.
Is it mostly about the fact that there's not really discrete big steps? It's a gradual, continual kind of process?
Well, there's two things. The first most important one was that the planet and the biosphere have evolved together. That's something that most biogeophysicists completely accept. And it was the first thing that Carter kind of rejected. He said, no, that's probably not possible. And yet, if you'd only sort of had more discussions with this other community, it would seem like, no, there are actually windows there. And then the next thing is this idea of whether a step is hard or not. Because for a hard, what we mean by a hard step is that, like I said, every time there's a generation, every time there's the next generation born, you're rolling the dice on whether this mutation will happen. And the idea of something being a hard step, there's two ways in which something might even appear as a hard step and not be, or actually not be a hard step at all. One is that you see something that has occurred in evolution that's only happened once, right? So let's take the opposite. You see something that's happened multiple times, like wings. Lots of examples of wings over lots of different evolutionary lineages. That's clearly not making wings is not a hard step. There are certain other things that people say, no, that's a hard step. Oxygen, the oxygen photosynthesis. But they tend to be so long ago that we've lost all the information. There could be other things in the fossil record that made this innovation, but they're just gone. You can't tell this information. The other thing is the idea of pulling up the ladder. That somebody, some species makes the innovation, but then it fills the niche, and nobody else can do it again. So yeah, it only happened once, but it happened once because basically the creature was so successful, it took over, and there was no space for anybody else to evolve. So yeah, so the interesting thing about this was seeing how much, once you look at the details of life's history on Earth, how it really shifts you away from this hard steps model. And it shows you that those details that we're talking about, like, do you have to know about the planet? Do you have to know about plate tectonics? Yeah, you're going to have to.
I mean, to be fair to Carter on the first point, it makes it much more complicated if life and the planet are co-evolving. Because it would be nice to consider the planet as a static thing that sets the initial conditions.
Yeah.
And then we can sort of, from an outside perspective, analyze planets based on the initial conditions they create, and then there's a binary yes or no, will it create life? But if they co-evolve, it's just it's a really complex dynamic system where everything is becomes much more difficult from the perspective of study, looking out there and trying to figure out which ones are actually producing life.
But I think we're at the point now, so now there may be other kinds of principles that actually, because co-evolution actually has its own, not deterministic, you're done with determinism, right? But complex systems have patterns. Complex systems have constraints. And that's actually what we're going to be looking for constraints on them. And so, and again, nothing against Carter was a brilliant idea, but it just goes to show, this is great XTC. I'm a theoretical physicist, right? And so I love give me a simplified model with, a dynamical equation, some initial conditions. I'm very happy. But there's this great XTC comic where, somebody's working something out on the board, and this physicist is looking over and saying, I just wrote down an equation for that. I solved your problem. Do you guys even have a journal for this? Subtitle is why everybody hates physicists. Yeah. So sometimes that approach totally works. Sometimes physicists do very good at zooming in on what is important and in the details and stuff, so you can get to the heart of an issue, and that's very, very useful sometimes. Other times it obfuscates, right? Other times it clouds over actually what you needed to focus on, especially when it comes to complexity.
Speaking of simplifying everything down to an equation, let's return back to the question of how many alien civilizations are out there, and talk about the Drake equation. Can you explain the Drake equation?
People have various feelings about the Drake equation. It can be abused, but basically it was the story actually is really interesting. So Frank Drake in 1960 does the first ever astrobiological experiment. He gets a radio telescope, points it at a couple of stars, and listens for signals. That was the first time anybody done any experiment about any kind of life in the history of humanity. And he does it, and he's kind of waiting for everybody to make fun of him. Until he gets a phone call from the government, says, "Hey, we want you to do a meeting on interstellar communications." He's like, "Okay." So they organize a meeting with like just 8 people. The young Carl Sagan is going to be there as well. And like the night before it, Drake has to come up with an agenda. How do you come up with an agenda for a meeting on a topic that no one's ever talked about before? And so he breaks what he does. What's so brilliant about the Drake equation is he breaks the problem of how many civilizations are out there into a bunch of subproblems, right? And he breaks it into 7 subproblems. Each one of them is a factor in an equation that when you multiply them all together, you get the number of civilizations out there that you can communicate. So the first term is the rate at which stars form. The second term is the fraction of those stars that have planets. The next term is the number of planets in the habitable zone, the place where we think life could form. The next term after that is the fraction of those planets where actually an abiogenesis event, life forms, occurs. The next one is the fraction of planets on which you start to get intelligence. After that, it's the fraction of planets where that intelligence goes on to create a civilization. And then finally, the last term, which is the one that we really care about, is the lifetime. How long you have a civilization, and how long you live.
We say we humans.
We humans, right? Because we're staring at multiple guns pointing at us. Nuclear war, climate change, AI. So how long in general does civilizations last? Now, each one of these terms, what was brilliant about what he did was, what he was doing was he was quantifying our ignorance, right? By breaking the problem up into these 7 sub-problems, he gave astronomers something to do, right? And so, this is always with a new research field. You need a research program, or else you just have a bunch of vague questions. You don't even know really what you're trying to do. So, the star people could figure out how many stars were forming per year. The people who were interested in planets could go out and find techniques to discover planets, et cetera, et cetera.
I mean, these are their own fields. Essentially, by creating this equation, he's launching new fields.
That's exactly. He gave astrobiology, which wasn't even a term, a roadmap. He's like, okay, you guys go do this, you go do that, you go do that. And it had such far-reaching effect on astrobiology because it did break the problem up in a way that gave useful, sort of marching orders for all these different groups. Like, for example, it's because of the Drake equation, in some sense, that people who were involved in SETI pushed NASA to develop the technologies for planet hunting. There was this amazing meeting in 1978, 2 meetings, 1978 and 1979, that were driven in some part by the people who were involved in SETI, getting NASA together to say, look, how, what's the roadmap for us to develop technologies to find planets? So, the Drake equation is absolutely foundational for astrobiology. But we should remember that it's not a law of nature, right? It's not something it's not E equals MC squared. And so you can see it being abused in some sense. People, it's generated 1 trillion papers. Some of those papers are good. I've written some of those, and some of those papers are bad. I'm not sure where my paper fits in on those. I'm saying, one should be careful about what you're using it for. But in terms of understanding the problem that astrobiology faces, this really broke it up in a useful way.
We could talk about each one of these, but let's just look at exoplanets.
Yeah.
So that's a really interesting one. I think when you look back, hundreds of years from now, was it the 90s when they first detected the first?
92 and 95. 95 to me was that was the discovery of the first planet orbiting a sun-like star. To me, that was the water that broke.
I think that's like one of the greatest discoveries in the history of science.
I agree.
Right now, I guess nobody's celebrating it too much because you don't know what it really means. But I think once we almost certainly will find life out there, it will obviously allow us to generalize across the entire galaxy, the entire universe. So if you can find life on a planet, even in the solar system, you can now start generalizing across the entire universe.
You can. All you need is one. Like right now, it's an any. Our understanding of life. We have one example. We have n equals 1 example of life. So that means we could be an accident, right? It could be that we're the only place in the entire universe where this weird thing called life has occurred. Get one more example, and now you're done. Because if you have one more example, now you have to find all the other examples. You just know that it's happened more than once, and now you are, from a Bayesian perspective, you can start thinking like, yeah, this life is not something that's hard to make.
Well, let me get your sense of estimates for the Drake equation. You also written a paper expanding on the Drake equation. What do you think? What do you think is the answer?
So there was this paper we wrote, Woody Sullivan and I, in 2016, where we said, look, we have all this exoplanet data, right? So the thing that exoplanet science and the exoplanet census I was talking about before I had nailed is F sub t, the fraction of stars that have planets, is 1. Every freaking star that you see in the sky hosts a family of worlds. I mean, mind-boggling. Because every one of those are all places, right? They're either, gas giants, probably with moons, so the moons are places you can stand and look out. Or they're like terrestrial worlds, where even if there's not life, there's still snow falling, and there's oceans washing up on shorelines. It's incredible to think how many places and stories there are out there. So, right, the first term was F sub p, which is how many stars have planets. The next term is how many planets are in the habitable zone, right, on average. And it turns out to be 1 over 5. Right? So, around 0.2. So that means you just count 5 of them, go out at night and go 1, 2, 3, 4, 5. One of them has an Earth-like planet, in the habitable zone. Like, whoa.
So what defines a habitable zone?
Habitable zone is an idea that was developed in the 1958 by the Chinese-American astronomer Xu Sheng. And it was a brilliant idea. It said, look, I can do this simple calculation. If I take a planet and just stick it at some distance from a star, of what's the temperature of the planet? What's the temperature of the surface? So now you're only going to ask, you give it a standard kind of, Earth-like atmosphere, and ask, could there be liquid water on the surface, right? We believe that liquid water is really important for life. There could be other things that's happening, fine. But, if you were to start out trying to make life, you'd probably choose water as your solvent. So basically, the habitable zone is the band of orbits around a star where you can have water on the surface. You could take a glass of water, pour it on the surface, and it would just cool up. It would freeze immediately, which would happen if your planet is too far out, and it would just boil away if your planet is too close. So that's the formal definition of the habitable zone. So it's a nice, strict definition. There's probably way more going on than that, but this is a place to start.
Well, we should say it's a place to start. I do think it's too strict.
I would agree.
We're talking about temperature where water can be on the surface. There's so many other ways to get the aforementioned turmoil, where the temperature varies, whether it's volcanic, it's the interaction of volcanoes and ice, all of this on the moon, planets that are much farther away, all this kind of stuff.
Yeah. Well, for example, we know in our own solar system, we have, say, Europa, the moon of Jupiter, which has got a 100-mile deep ocean under 10 miles of ice, right? That's not in the habitable zone. That is outside the habitable zone. And that may be the best place. It's got more water than Earth does. All of its oceans are, it's twice as much water on Europa than there is on Earth. So, that may be a really great place for life to form, and it's outside the habitable zone. So, the habitable zone is a good place to start, and it helps us. And there's reasons why you do want to focus on the habitable zone, because like Europa, I won't be able to see from across telescopic distance, across light years. I wouldn't be able to see life on Europa because it's under 10 miles of ice, right? So with the important thing about planets in the habitable zone is that we're thinking they have atmospheres. Atmospheres are the things we can characterize across 10, 50 light years, and we can see biosignatures that we're going to talk about. So there is a reason why the habitable zone becomes important for the detection of extrasolar light.
But for me, when I look up at the stars, it's very likely that there's a habitable planet or moon in each of the stars. Habitable defined broadly.
Yeah, I think that's not unreasonable to say. I mean, especially since the formal definition, you get 1 in 5, right? 1 in 5 is a lot. There's lots of stars in the sky. So yeah, saying that in general, when I look at a star, there's a pretty good chance that there's something habitable orbiting it is not a unreasonable scientific claim.
To me, it seems like there should be alien civilizations everywhere. Why the Fermi paradox? Why haven't we seen it?
Okay, the Fermi paradox. We love talking about it. Because there is no Fermi paradox. Dun 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 dun. Yeah. And so the Fermi paradox, let's talk about the Fermi paradox and the history of it. Enrico Fermi, it's 1950, he's walking with his friends at Los Alamos to the cantina, and there had been this cartoon in the New Yorker. They all read the New Yorker. And the cartoon was trying to explain why there had been this rash of garbage cans disappearing in New York. And this cartoon said, oh, it's UFO. This is already, it's 1950, the first big UFO craze happened in 1947. So they were laughing about this as they're walking. They started being physicists, started talking about interstellar travel, interstellar propulsion, blah, blah, blah. Conversation goes on for a while. Conversation turns to something else, they've gone to other things. About 40 minutes later, over lunch, Fermi blurts out, well, where is everybody? Right? Typical Fermi sort of thing. He'd done the calculation in his head, and he suddenly realized that, look, if intelligence is common, that even traveling at sublight speeds, a civilization could cross, kind of hop from one star system to the other and spread it out across the entire galaxy in a few 100,000 years. And he realized this, and so he was like, why aren't they here now? And that was the beginning of the Fermi paradox. It actually got picked up as a formal thing in 1975 in a paper by Hart, where he actually kind of went through this calculation and showed and said, well, there's nobody here now, therefore there's nobody anywhere. Okay, so that is what we will call the direct Fermi paradox. Why aren't they here now? But something happened where people, after SETI began, where people started to, there was this idea of the great silence. People got this idea in their head that like, oh, we've been looking for decades now for signals of extraterrestrial intelligence, and we haven't found any. Therefore, there's nothing out there. So we'll call that the indirect Fermi paradox. And there absolutely is no indirect Fermi paradox. For the most mundane of reasons, which is money. There's never been any money to look. SETI was always done by researchers who were kind of like scabbing some time, some extra time from their other projects to, look a little bit, at the sky with a telescope. Telescopes are expensive. So Jason Wright, one of my collaborators, he and his students did a study where they looked at the entire search space for SETI. And imagine that's an ocean. All the different stars you have to look at, the radio frequencies you have to look at, when you look, how often you look. And they looked, then they summed up all the SETI searches that had ever been done. They went through the literature. And what they found was if that search space, if the sky is an ocean and you're looking for fish, how much of the ocean have we looked at? And it turns out to be a hot tub. That's how much of the ocean that we looked at. We dragged a hot tub's worth of ocean water up, and there was no fish in it. And so now are we going to say, oh, well, there's no fish in the ocean? So there is absolutely, positively no indirect Fermi paradox. We just haven't looked. But we're starting to look. So that's, finally we're starting to look. That's what's exciting. The direct Fermi paradox, there are so many ways out of that, right? There's a book called 77 Solutions to the Fermi paradox that it just, you can pick your favorite one. It just doesn't carry a lot of weight because there's so many ways around. We did an actual simulation, my group, Johnson Carroll, one of my collaborators, we actually simulated the galaxy. We simulated probes moving at sublight speed from one star to the other, gathering resources, heading to the next one. And so we could actually track the expansion wave across the galaxy, have one abiogenesis event, and then watch the whole galaxy get colonized or settled. And it is actually true that wave crosses. Hart was right, Fermi was right. That wave crosses very quickly. But civilizations don't last forever, right? So one question is, when did they exist? When did they come there, right? So if you give civilizations a finite lifetime, let it last 10,000, 100,000 years, what you find is you now have a steady state. Civilizations are dying, they're coming back, they're traveling to the stars. What you find then is you can have big holes open up. You can have regions of space where there is no bound. Millions of years. And so if we're living in one of those bubbles right now, then maybe we were visited, but we were visited 100 million years ago. And there was a paper that Gavin Schmidt and I did that showed that if there was a civilization, whether it was like dinosaurs or aliens that was here 100 million years ago, there's no way to tell. There's no record left over. The fossil record is too sparse. The only way maybe you could tell is by looking at the isotopic strata to see if there was anything reminiscent of an industrial civilization. But the idea that, you'd be able to find iPhones or toppled buildings after 100 million years. There's no way.
So if there was an alien camp here,
Yeah.
an alien village, a small civilization, right? You have a large civilization.
Even a large civilization, you can put
100 million years ago.
and it lasted 10,000 years. Fossil record's not going to happen. Yeah. The fossil record is too sparse, right? Most things don't fossilize.
Yeah.
And 10,000 years is a blink in the eye of geological time. So we call our Gavin called this the Silurian hypothesis after the Doctor Who episode with the lizard creatures, the Silurians. And so that paper got a lot of press, but it was it was an important idea. This was really Gavin's. I was just helping with the astrobiology. That to recognize that, it could have been visited a long time ago. There just be no record. Yeah, it's kind of mind blowing.
It's really mind-blowing.
Yeah.
And it's also a good reminder that we've been intelligent species that have been here for a very short amount of time.
Very short amount of time. Yeah. This is not to say that there was whenever I gave I was on Joe Rogan for exactly this paper, and I had to always emphasize we're not saying there was a Silurian, but we're saying that if there was, that's why I love Gavin's question. Gavin's question was just like, how could you tell, right? It was a very beautifully scientific question. That's what we were really showing. That you really, unless you did a very specific kind of search, which nobody's done before, that there's not an obvious way to tell that there could have been civilizations here earlier.
I've actually been reading a lot about ancient civilizations, and it just makes me sad how much of the wisdom of that time is lost.
Yeah.
And how much guessing is going on, whether it's in South America, like what happened in the jungle.
Yeah, like the Amazon, the Amazon problem. That was, the conquistadors came and wiped everybody out, especially just even like the plague, man, decimated. So yeah, how much of that civilization?
And there's a lot of theories, and because of archaeology only looks at cities, they don't really know the origins of humans. And there's a lot of really interesting theories, and they're of course controversial. And there's a lot of controversial people in every discipline, but archaeology is a fascinating one because we know so little. Right? The storytellers, you're assembling the picture from just very few puzzle pieces. It's fascinating. It makes me. It's humbling and it's sad that there could be entire civilizations, ancient civilizations, that are either almost entirely or entirely lost.
Yeah, well, like the indigenous peoples of North America, that have like millions and millions. We get this idea that this Europeans came and it was empty, but it may have only been empty because the plague got swept up from from what happened in Mesoamerica. So and they didn't really build cities, but they didn't build wooden or stone cities. They built wooden cities.
Everybody seems to be building pyramids, and they're really damn good at it. I don't know
What is that with pyramid? Why does that apply to archetype in our brain?
And it is also really interesting, speaking of archetypes, is that independent civilizations formed, and they had a lot of similar kind of dynamics. Human nature, when it builds up hierarchies in a certain way, it builds up myths and religions in a certain way, it builds pyramids in a certain way, goes to war, all that kind of stuff. Independently, emerges. Fascinating.
Santa Fe Institute, the stuff the Santa Fe Institute does on this, that's complex systems, the origin of hierarchies and such. Very cool.
Yeah, Santa Fe folks. Complexity channels.
Really cool.
What phenomena emerge when a bunch of small things get together and interact. Going back to this paper, a new empirical constraint on the prevalence of technological species in the universe, this paper that expands on the Drake equation. What are some interesting things in this paper?
Well, so the main thing we were trying to do with this paper is say, look, we have all of this exoplanet data, right? It's got to be good for something, especially since two of the terms that have been nailed down empirically are two terms in the Drake equation. So F sub P, that's the second term, fraction of stars that have planets, and then N sub E, the average number of planets in the habitable zone. Those are the second and third term in the Drake equation. So what that means is all the astronomical terms have been nailed. And so we said, okay, how do we use this to do something with the Drake equation? And so we realized we got to get rid of time. The lifetime thing, we can't say anything about that. But if we don't ask how long they last, but instead ask, what's the probability that there have been any civilizations at all, no matter how long they last? I'm not asking whether they exist now or not. I'm just asking in general about probabilities to make a technological civilization anywhere and at any time in the history of the universe. And that we were able to constrain. And so what we found was basically that there have been 10 billion trillion habitable zone planets in the universe. And what that means is those are 10 billion trillion experiments that have been run. And the only way that we're the only time that this whole process from abiogenesis to a civilization has occurred is if every one of those experiments fail, right? So therefore, you could put a probability. We called it the pessimism, right? We don't really know what nature sets for the probability of making intelligent civilization, right? But we could set a limit using this. We could say, look, as if the probability per habitable zone planet is less than 10 to the minus 22, 1 in 10 billion trillion, then yeah, we're alone. If it's anywhere larger than that, then we're not the first. It's happened somewhere else. And to me, that was mind-blowing. It doesn't tell me there's anybody nearby. The galaxy could be sterile. It just told me that, unless nature's really has some bias against civilizations, we're not the first time this has happened. This has happened elsewhere over the course of cosmic history.
10 billion trillion experiments.
That's a lot of experiments.
It's a lot.
Right.
1,000 is a lot.
Yeah.
100 is a lot. If we normal humans saw 100 experiments, we knew that at least one time there was a successful human civilization built. I mean, we would say for sure in 100 you'd get another.
Yeah. So that's what I mean. That's why. So these kinds of arguments, you have to be careful with what they can do. But what I felt like what this paper showed was that the burden of proof is now on the pessimists, right? So that's why we called it the pessimism. There's been throughout history, there's been alien pessimists and alien optimists, and they've been yelling at each other. That's all they had to go with, right? Like with Giordano Bruno in 1600, they burned the guy at the stake for being an alien optimist. But nobody really knew what pessimism or optimism meant. We sort of thought this was like the Planck length. This was sort of the Planck length of astrobiology. It gave you an actual number that, if you could somehow calculate what the probability, of forming a technological civilization was, this thing sort of shows you where the limit is. As long as you're above 10 to the minus 22, then you absolutely it has occurred in the other civilizations that occurred in the history.
So to me, at least, the big question is FE, which is basically abiogenesis. How hard is it for life to originate on a planet? Because all the other ones seem very likely. Everything seems very likely. The only open question to me is like, how hard is it for life to originate?
There's lots of ways to, again, don't know unless we look. And then, you had Sarah walk around not too long ago. She's very interested in origins of life. So, lots of people are working on this. But I think it's hard looking at the history here. Again, you could be basing arguments on this. But yeah, forming life, I don't think it's hard. Getting like basic biology started, I don't think it's hard. It's still wild. It's an amazing process that actually I think requires some deep rethinking about how we conceptualize what life is and what life isn't. That's one of the things I like about Sarah's work. We're pursuing on a different level about life as the only process, the only system that uses information. But still, regardless of all those kinds of details, life is growing. That's my gut feeling.
Yeah, I mean, day by day this changes for me, but I just see that once you create bacteria, it's off to the races.
Yeah.
You're going to get complex life.
Yeah.
As long as you have enough time. I mean, that 1 billion, but I just can't imagine a habitable planet not having a couple billion to spare.
Yeah, a couple
years
to spare. There is a mystery there about why did it take so long, like with the Cambrian explosion, but that may be, again, about these windows. That, it couldn't happen until the window, the planet and the life had evolved together enough that they together kind of opened the window for the next step. Intelligent life and how long intelligent is similar to technological civilizations. I think there's a big question about how long those are. Now, I'm hopeful, but in terms of just I think life is absolutely going to be common. They're pretty common.
Yeah, I think it's absolutely like I think again, if I look at that type of thing, even in advanced civilizations are common. So to me then the explanation is the L. Our galaxy is a graveyard of civilization.
Yeah, because you think about it, we've only been around. I mean, as a technological, truly, when you think about it in Drake's definition, you have to have radio telescope. That's been 100 years. And if we got another 10,000, 100,000 years of history, that would be for us. That'd be pretty amazing, right? But that wouldn't be long enough to really pop up the number of civilizations in the galaxy. So you really need it to be like hundreds of billions of years, and that raises a question which I am very interested in, which is how do we even talk about, I call it the billion-year civilization, right? How do we even begin to hypothesize or think about in any kind of systematic way what happens to a technological civilization across hundreds of millions to a billion?
Yeah, like how do you even simulate the trajectories that civilizations can take across that kind of time scale? When all the data we have is just for the 10,000 years or so, 20,000 years, humans have been building civilizations. And then just, I don't know what you put it at, but maybe 100 years that we've been technological.
Yeah, and we're ready to blow ourselves to bits or, drive ourselves off the planet. Yeah, no, it's really interesting. But there's got to be a way. I think that's really a frontier. So you had David Kipping on not too long ago. And David and I did a paper, and Caleb Sharp, David really drove this, where it was a Bayesian calculation to sort of ask the question, if you were to find a detector picture, if you were to find a signal or, a techno signature, would that come from a civilization that was younger, your age, or older? And you could see, I mean, this is not hard to do, but it was great. The formalism was wrong. It's kind of intuitive. But the formalism was hard to show that, they're older, probably much older. So that means you really do need to think about, like, okay, how do billion-year civilizations manifest themselves? What signatures will they leave? And, what's so cool about it, it's so much fun because you have to imagine the unimaginable. Like, would you still? I mean, obviously, biological evolution can happen on those kinds of time scales. So you wouldn't even really be the same thing you started out as. But social forms, what kind of social forms can you imagine that would be continuous over that? Or maybe they wouldn't be continuous. They drop out. They destroy themselves and they come back. So maybe it's it's a trunk or a punctuated evolution. But we got to sort of. This is the fun part. We have to sort of work this out.
Mm-hmm. Well, I mean, one way to approach that question is like, what are the different ways that you homeostasis as you get greater and greater technological innovation? So, like, if you expand out into the universe and you have up to Karshak scale, what are the ways you can avoid destroying yourself? Just achieve stability while still growing.
Yeah.
And, I mean, that's an interesting question. I think it's probably simulatable.
Could be. I mean, agent-based modeling, you could do it with that. So our group has used agent-based modeling to do something like the Fermi paradox. That was agent-based modeling. But you can also do this. People at Santa Fe have done this. Other groups have done this to use agent-based modeling to track the formation of hierarchies, the formation of stable hierarchies. So I think it's actually very doable. But understanding the kind of assumptions and principles that are going into it, when you can extract from those, that is what is sort of the frontier.
Do you think if humans colonize Mars, the dynamic between the civilization on Earth and Mars will be fundamentally different than the dynamic between individual nations on Earth right now? That's the thing to load into the agent-based simulation we're talking about.
If we settle it, Mars will very quickly want to become its own nation.
Well, no, there's already going to be nations on Mars. That's guaranteed.
Yeah,
the moment you have 2 million people, the moment you have 1 million people, there's going to be 2 tribes.
Right.
And then they're going to start fighting.
Right.
And the question is interplanetary fighting. How quickly does that happen? And does it have a different nature to it?
Distances, Are you a fan of The Expanse? Have you watched The Expanse? Great show. Because it's all about I highly recommend to everybody. It's based on a series of books that are it's on Prime, 6 seasons, and it's basically about the settled solar system. It takes place about 300 years from now, and the entire solar system is settled. And it is the best show about interplanetary politics. The first season, actually, the journal, Foreign Affairs, said the best show on TV about politics. takes place is interplanetary. So yeah, I think, human beings being human beings, yes, there will be warfare, there will be conflict. And I don't think it'll be necessarily all that different. Because really, I think within a few hundred years, we will have lots of people in the solar system. And it doesn't even have to be on Mars. We did a paper where we looked at base because I wanted to know about whether an idea of the expanse was really possible. In the expanse, the asteroid belt, what they've done is they have colonized the asteroid belt by hollowing out the asteroids and spinning them up and living on the inside, right? They have the Coriolis. I thought, wow, what a cool idea. And when I ran the blog for NPR, I actually talked to the guys and said, "Could you calculate this, see whether it's possible?" Sadly, it's not possible. The rock is just not strong enough that if you tried to spin it up to the speeds you need to get 1/3 gravity, which is what I think the minimum you need for human beings, the rock would just fall apart and break. But we came up with another idea, which was that if you take small asteroids, put a giant bag around them, a nanofiber bag, and spin those up, it would inflate the bag, and then even a small couple of kilometer wide asteroid would expand out to, you could get like a Manhattan's worth of material inside. So forget about even colonizing Mars, space stations, right, or space habitats with millions of people. So anyway, the point is that I think, within a few hundred years, it is not unimaginable that there will be millions, if not billions, of people living in the solar system.
You think most of them will be in space habitats versus on Mars and on the planetary surface?
It's a lot easier on some level, right? Depends on how, like with nanofabrication and such. But getting down to gravity well was hard, right? So there's a certain way in which there's a lot easier to build real estate out of the asteroids. But we'll probably do both. I think what will happen is, the next, should we make it through climate change, the nuclear war, and all the other, and AI, the next 1,000 years of human history is the solar system, right? And so, I think we'll settle every nook and cranny we possibly can. And it's, it's a beautiful, what I love about what's hopeful about it is this idea you're going to have all of these pockets. And, I'm sure there's going to be a Mormon space habitat, there's going to be whatever you want, a libertarian space habitat. Everybody's going to be able to kind of create there'll be lots of experiments in human flourishing. And those kinds of experiments will be really useful for us to sort of figure out better ways for us to interact and have maximum flourishing, maximum wellness, maximum democracy, maximum freedom.
Do you think that's a good backup solution to go on to space, so to avoid the possibility of humans destroying themselves completely better?
Well, I think, I want to be always careful with that because, like I said, it's centuries that we're talking about. So, the problem with climate change, I'd say the nuclear war is breathing down our necks now. So it's not trying to establish a base on Mars is going to be so hard that it is not even going to be close to being self-sufficient for a couple of, a century at least. So it's not like a backup plan now. We have to solve the problem of climate change. We have to deal with that. There's still enough nuclear weapons to really do horrific things to the planet for human beings. So I don't think it's like a backup plan that way. But I do think, like I said, it's the prize. It's, if we get through this, then we get the entire solar system to sort of play around in and experiment with and do really cool things with.
Well, I think it could be a lot less than a couple of centuries if there's urgency, like a real urgency, like a catastrophe, like maybe a small nuclear war breaks out where it's like, holy shit, this is for sure a bigger one is looming.
Yeah.
Maybe geopolitically the war between China and the United States escalates, where there's this tension that builds and builds and builds, and it becomes more obvious that we need to really.
Yeah. I think my only dilemma with that is that I just think that a self-sufficient base is so far away that, like, say you start doing that, and then there is a full-scale nuclear exchange. That base is, it's not going to last because it's just, the self-sufficiency requires a kind of an economy, like literally a material economy that we are so far from with Mars, that we are centuries from. Like I said, 3 centuries, which is not that long, 2 to 3 centuries. Look at 1820. Nobody had traveled faster than 60 miles an hour unless they were falling off a cliff, right? And now we routinely travel at 500 miles an hour. But it is sort of centuries long. So that's why I think we'd be better off trying to solve these problems than, I just think the odds that we're going to be able to create a self-sufficient colony on Mars before that threat comes to head is small. So we'd have to deal with the threat.
Yes, an interesting scientific and engineering question of how to create a self-sufficient colony on Mars or out in space as a space habitat, like where Earth entirely could be destroyed.
Yeah, because it's really what about thinking about complex systems, right? A space habitat, would have to be as robust as an ecosystem, as the kind of thing you might see a pond, all the different webs of interactions. That's why I always think that if this process of going out into space is actually will help us with climate change and with thinking about making the long-term sustainable version of human civilization. Because you really have to think about these webs, that through these webs, and recognize the biosphere has been doing this forever. The biosphere knows how to do this, right? And so, how do we build a vibrant, powerful technosphere that also doesn't, mess with the biosphere's capacity to support our technosphere? So, by doing this, by trying to build space habitats, in some sense, you're thinking about building a small-scale version of this. So I think the two problems are going to kind of feedback on each other.
Well, there's also the other possibility of, like the movie Darren Aronofsky's Postcard from Earth, where we can create this kind of life gun that just shoots, as opposed to engineering everything.
Yeah.
Basically seeding life at a bunch of places and letting life do its thing, which is really good at doing, it seems like. So as opposed to, like, with a space habitat, you basically have to build the entire biosphere and technosphere, the whole thing. Yeah. If you just the aforementioned cockroach with some bacteria, place it in Europa, I think you'd be surprised by that.
Yeah.
Like, honestly, if you put a huge amount of bacteria, like a giant number of organisms from Earth into on Mars, on some of these moons of the other planets in the solar system, I feel like some of them would actually find a way to survive.
The moon is hard because the moon is just like, there's no, the moon may be really hard. But, that'd be, I wonder if somebody's done these experiments, right? Like how, because we know they're extremophiles, right? We know that you can go down, 10 miles below the Earth's surface, and there are things where there's no sunlight. There's, the conditions are so extreme, and there's lots of microbes having a great time, living off the radioactivity, in the rocks. But, they had lots of time to evolve to those conditions. So I'm not sure if you dumped a bunch of bacteria, so somebody must have done these experiments. Like, how fast could microbial evolution occur under harsh conditions that you maybe get somebody who figures out, okay, I can do this. I think the moon's too much because it's so sterile. But, Mars, I don't know, maybe. I don't know. That's an interesting idea.
I wonder if somebody has thought about this.
Yeah, you think somebody would. Like, let's take a bunch of microbes.
Take the harshest possible conditions, all different kinds, temperature, all this kind of stuff.
Right, pressure, salinity, and then just dump a bunch of things that are not used to it, and then just see, does everybody just die? That's it.
The thing about life, it flourishes in a non-sterile environment where there's a bunch of options for resources, even if the conditions are super harsh. In the lab, I don't think you can reconstruct harsh conditions plus options for survival. You know what I mean? Like you have to have the huge variety of resources that are always available on a planet somehow, even when it's a super harsh condition. And so that's actually not a trivial experiment. And I wouldn't even, if somebody did that experiment in the lab, I wouldn't be skeptical. Because I could see bacteria doesn't survive in this kind of temperature. And then,
Is there enough, right? Are there other options? Like, is the condition rich enough?
Rich enough, yeah.
There's an alternative view, though, which is there's this great book by Kim Stanley Robinson called Aurora. So there's been a million century ship stories, like where, Earth sends out a generation ship or century ship, and it goes to another planet, and they land and they colonize. And on this one, they get all the way there, and they think the planet's going to be habitable, and it turns out that it's not habitable for Earth life. Like that, there's like bacteria or prions that just kill people in the simplest way. And the important thing about this book was the idea that life is actually very tied to its planet. It may not be so easy. I just thought it was a really interesting idea. I'm not necessarily supporting it, but that actually life reflects the planetary conditions not the planetary, the planet itself, the whole lineage, the whole history of the biosphere. And it may not be so easy just to just sort of be like, oh, just drop it over here and it'll, because the bacteria, even though they're individual examples of life, and I kind of believe this, the true unit of life, it's not DNA, not a cell, it's the biosphere. It's the whole community. Yeah.
That's actually an interesting field to study. It's how when you arrive from one planet to another, so we humans arrive to a planet that has a biosphere, maybe a technosphere, what is the way to integrate without killing yourself
or the other one?
Or the other one. Let's stick to biology like that. That's an interesting question. I don't know if we have a rigorous way of investigating that.
Because everything on life is, has the same lineage. We all come from Luca, the last universal common ancestor. And what you see is often in science fiction, people do things like, oh, well, it's okay because like that that metabolism, that biochemistry is so different from ours that we can coexist because they don't even know each other. Right? And then the other version is you get there, you land, and instantly, the nose bleeds and you're dead. It's
unfortunately, I think it's the latter.
Yeah, it sort of feels
the more like
alien.
So as we look out there, according to the Drake equations we just discussed, it seems impossible to me that there's not civilizations everywhere. So how do this process of setting?
Put on my science hat and just say, my gut feeling is that dumb life, so to speak, is coming. I am a little agnostic about it. I can see ways in which intelligent civilizations may be sparse. But until, we got to go look. It's all armchair.
That's from a sort of rigorous scientific perspective. From my gross science perspective, it seems, again, the smoking the aforementioned weed, it's
after the bomb.
I mean, honestly, it's really just it's impossible to me that there's not potentially dead, but advanced civilizations everywhere in our galaxy.
Yeah, the potentially dead part. I think, right. It could be that like making civilizations is easy; they just don't last. So when we went out there, we find a lot of extinct
civilizations. Apex predators don't survive. Like they get better and then die, kill themselves also. Anyway, so just how do we find them?
Yeah. So SETI, Search for Extraterrestrial Technology, is a term that I am not fond of using anymore. I mean, some people in my field are, so I'm sorry, folks. But what I really like is the idea of techno-signatures. I think, to me, SETI is first of all, intelligence. We're not really looking for intelligence, we're looking for technology. And SETI, the classic idea of SETI is the radio telescopes, Contact, Jodie Foster with the headphones. That whole thing is still it's still active, there's still great things going on with it, but suddenly this whole new window opened up. When we discovered exoplanets, we now found a new way to look for intelligent civilizations, or life in general, in a way that doesn't have any of the assumptions that have to go into classic radio study. And specifically what I mean is, we're not looking for somebody sending us a beacon. You really needed that with the classic model for a bunch of different reasons. You had to assume they wanted to be found and they were sending you a super powerful beacon. Now, because we know exactly where to look and we know exactly how to look, we can just go about looking for passive signatures of the civilization, going about its civilizationing business, without asking whether they want to be contacted or not. So this is what we call a biosignature or a technosignature. It is an imprint in the light from the planet of the activity of a biosphere or a technosphere. And that's really important. That is why kind of the whole Gaia idea ends up being astrobiological. That biospheres and technospheres are so potent, they change the entire planet. And you can see that in 20 light years. So let's give an example of a biosignature. So the signature of a biosphere. Oxygen, right? On Earth, at least, we know that oxygen is only in the atmosphere because life put it there. If life went away, the oxygen, particularly oxygen and methane, that air, they would disappear, very quickly. They'd react away. So if you find a planet with methane, that's a good bet that there's a biosphere there. Okay, what about technospheres? Technospheres, this is what, so I'm the principal investigator on the first grant NASA has ever given to do these kind of exoplanet technosignatures. NASA was kind of for reasons we can talk about, NASA had gotten shy about funding anything other than television. But okay, what's an example of a techno signature? Well, one could be atmospheric pollution. I'm going to put pollution in quotes here. Okay? It doesn't have to be pollution. But gases like chlorofluorocarbons. So we dumped a huge amount of chlorofluorocarbons into the atmosphere by mistake. It was affecting the ozone. But we put so much in there that actually, this is one of the things we did. We did a paper where we showed you could detect it across interstellar distances. You could look at the atmosphere, look at the light coming from a distant planet, pass the light through a spectrograph, and see the spectral lines, the spectral fingerprint of chlorofluorocarbons in an atmosphere. And that was sure to tell you that there was a technological civilization. Because there's no other way to make chlorofluorocarbons except through some kind of industrial process.
So you're looking for, in the case of the biosphere, you're looking for anomalies in a spectrograph.
I wouldn't necessarily call these anomalies. I'm looking for things that, for biosignature, I'm looking for things that a geosignature, right, that just rock and air wouldn't produce on its own.
What kind of chemicals would life produce?
Right, and that's part of that's the interesting thing, right? So that's what so we can use Earth as an example, right? We say, look, oxygen. We know there would be no oxygen in the atmosphere for dimethyl sulfide, which is a compound that phytoplankton dump into the atmosphere a lot. That's sometimes mentioned. And there was a paper that somebody wrote where it was like, well, we're not saying we see it, but there's a bunch of noise in the spectra right there. So there's a whole list of things that Earth has done that are in the atmosphere that might be biosignature. But now we're reaching an interesting point. The field has matured to the point where we can start asking about agnostic biosignatures, things that have nothing to do with Earth physics. But we think that would still be indications of this weirdness we call life, right? What is it in general that life does that leaves an imprint? So one of these things could be the structure of the network of chemical reactions. That biology always produces very different chemical networks each reacting with than just rock and water, right? So there's been some proposals for network, biosignatures. Information theory. You can try and look at the information that is in the different compounds that are defined in the atmosphere. Maybe that information shows you, like, oh, there's too much information here. There must have been biology happening. It's not just rock. Same thing for techno. That's what we're working on right now. That for techno.
So how do you detect techno?
Okay, so with techno signatures, I gave the example of chlorofluorocarbons, so that would be an example of. And again, that one is a non-agnostic one, because you sort of like, oh, we produce chlorofluorocarbons, maybe they will, right? And there's solar panels, right? You can actually get glint off of solar panels. Will produce the way the light is reflected off of solar panels, but no matter what it's made of. There was a paper that Navi looked in 2017. We've just followed up on it. That actually could act as a techno signature. You'd be able to see in the reflected light this sort of big jump that would occur because of city lights, artificial illumination. If there's really large-scale cities like Coruscant and Star Wars or Trantor in the Foundation, those city lights would be detectable. The spectral imprint across 20, 30 light years. So our job in this grant is to develop the first ever library of techno signatures. Nobody's really ever thought about this. So we're trying to come up with all the possible ideas for what a civilization might produce that could be visible across, interstellar distances. And are these good ones, or is these ones going to be hard to detect?
City lights. So if a planet is all lit up with artificial light across 20 to 30 light years, you can see it.
Yeah, you looked at Earth at night from a distance where the spectra, and you had sensitive enough instruments, you'd be able to see all the sodium lights, and the reflected light off of they bounce off the ground, but the light bounces off the ground. So you can involve the sodium lamps with the reflected spectra from the ground, and yeah, you'd be able to see that there's city lights. Now, increase that by a factor of 1,000. If you had a trantor, and you'd be able to detect that across interstellar distances. Thomas Beatty did this work, who's now working with us.
What do you think is the most detectable thing about Earth?
Wow, this is really fun. We just have a Sophia Sheep, this is part of our collaboration. We did Earth from Earth. If you were looking at Earth bunch of different technosignatures. How close do you have to be? And most of them turn out to be pretty close. These obviously work well, but actually it is our radio signature still that is still most detectable.
By the way, you said you had to be pretty close on interstellar cloud. That's not very close, but you mean like from an interstellar?
Interstellar is because the real, we really want to know is like I'm sitting here on Earth, I'm looking at these exoplanets. The nearest star is 4 light years. So that's like the minimum. So what if I'm looking at exoplanets? What kind of signal?
What is detectable about Earth with our current technology from the near solar system?
Oh my God, there's all kinds of stuff. Well, like the fluorofluorocarbons. You can see Earth's pollution. And, I think city lights you have to be within the solar system.
If they do direct imaging of Earth,
they're going to need much more powerful. But let me tell you what's interesting. Let's talk about direct imaging. This is such a cool idea, right? So what we really want in the next generation of space telescopes, such as we're trying to do direct imaging. We're trying to get an image of a planet separated from its star, be able to see the reflected light or the actual emission from the planet. So,
yeah, by the way, just to clarify, direct imaging means literally a picture.
But the problem is that even with the correct, I think it's going to come after JWST, it's going to be a pixel, right? You're not going to get any kind of resolution. You'll be able to get the light from it, but you'll be able to pass through a spectrograph, but you're not going to be able to take a picture. But there is this called the Solar Gravity Lens Telescope. I think that's what it is. And the idea is insane, right? So the general relativity says massive bodies distort space. They actually curve space-time. So the sun is a massive body. So that means that the light passing through the sun gets focused like a lens, right? So the idea is to send a bunch of telescopes out kind of into the Oort cloud and then look back towards the sun, towards an exoplanet that is directly behind the sun, but is, in the direction of the sun. And then let the sun act like the lens and focus the light onto the telescope. And you would be able to get, and they've done that, which is amazing. Like this idea is insane. They'd be able to get, if everything works out, 24-kilometer resolution. Be able to see Manhattan on a exoplanet. And this thing, it sounds insane, but actually, they've already gotten to like 3 levels of NASA. There's the NASA program for like, give us your wackiest ideas, right? And then the ones that survive that are like, okay, tell us whether that wacky idea, is even feasible. And they're marching along. And the idea is that, like, they even have plans for how you'd be able to get these probes out into the Oort cloud out on relatively fast timescales. You need to be about 500 times as far from the sun as Earth is. But right now, it looks like the idea seems to hold together. So probably when I'll be dead, when you're an old man, it's possible that something like this, could you imagine having that kind of resolution, a picture of an exoplanet down to kilometers. So I'm very excited about that.
I can only imagine having a picture like that, and then there's some mysterious artifacts that you're saying. I mean, it's both inspiring and almost heartbreaking to conceive. I think we'll be able to see a civilization where there's like a lot of scientists that agree that this is very likely something, and then we can't get there.
But again, this is the thing about being long-lived. We've got to get to the point where we're long-lived enough. So let's say we found, this is what I always like that. Let's imagine that we find, say, 10 light years away. We find a planet that looks like it's coming down, right? It doesn't end there. Like, that would be the most important discovery in the history of humanity. And it wouldn't be like, well, okay, we're done. The first thing we do is we dig bigger telescopes to try and do those images, right? And then the next thing after that, we plan a mission there, right? We would figure out, like with breakthrough Starshot, there was this idea of trying to use, giant lasers to propel small spacecraft, light sails, almost to the speed of light. So they would get there in 10 years and take pictures. So, if we actually made this discovery, there would be the impulse, there would be the effort to actually try and send something to get there. Probably couldn't land, but, so maybe we take 30 years to build, 10 years to get there, 10 years to get the pictures back. Okay, you're dead, but the kids are, so it becomes now this multi-generational project. How long did it take to build the pyramids? How long did it take to build the giant cathedrals, right? These were multi-generational projects. And I think we're on the cusp of that kind of project.
I think that would probably
control. I think it would be helpful. I mean, human beings are a mess, let's face it. But I think having that record, that's why I always say to people, discovery of life, of any kind of life, even if it was microbial life, we wouldn't have it. That to know that we're not an accident, to know that there is, if we found one example of life, we know that we're not an accident, and there's probably lots of life, and that we're a community. We're part of a cosmic community of life, and who knows what life has done, right? We don't really, all bets are off with life.
Since we're talking about the future of telescopes, let's talk about our current super sexy, awesome telescope, the James Webb Space Telescope, that I still can't believe it actually works.
I can't believe it. I was really skeptical. I was like, okay, guys, all right, sure.
We only got one shot to this incredibly complicated piece of hardware run full. So what kind of stuff can we see with it? I've been just looking through different kinds of announcements that have been detected. There's some direct imaging.
Yeah, like a single pixel.
The kinds of exoplanets we're able to direct image, I guess, would have to be hot.
Usually far away from the, reasonably far away from the star. I think JWST is really kind of at the area to being able to do much with this. What's more important, I think, for JWST is the spectrum. And the problem with spectra is that there's not spectrum. It's like, hey, look at this wiggly line. But to be able to find and characterize atmospheres around terrestrial exoplanets is the critical next step. That's where we are right now. In order to look for life, we need to find planets with atmospheres, right? And then we need to be able to do this thing called characterization, where we look at the spectral fingerprints for what's in the atmosphere. Is there carbon? Is there carbon dioxide? Is there oxygen? Is there methane? And that's the most exciting thing. For example, there was this planet K218b, which they did a beautiful job getting the spectra. And the spectra indicated that an entirely new kind of habitable world called a Hycean world. Hycean meaning hydrogen ocean world. And that is a kind of planet that it would be kind of in the super Earth sub-Neptune domain we're talking about. It may be 8 times the mass of the Earth. But it's got a layer of hydrogen, an atmosphere of hydrogen. Hydrogen is an amazing greenhouse gas. So hydrogen will keep the planet underneath it warm enough that you can get liquid water. You can get a giant ocean of liquid water. And that's an entirely different kind of planet. It could be habitable. It could be a 60-degree warm ocean. So the data that came out of JWST for that planet was good enough to be able to indicate, like, oh yeah, you know what? The model, from what we understand about the models, this looks like could be a Hycean world.
And it's 120 light years away from it.
Yeah. And so isn't that amazing? 120 light years away, we can see into the atmosphere. We can see the atmosphere so well, and we'd be like, oh look, methane. Methane was a 5 sigma detection. Like, you knew that the data were so good that it was like the gold standard of science.
What about detecting maybe direct imaging, or in other ways, megastructures that civilization built?
So you know what's great about megastructures is, first of all, it's fun to say. What is it? Alien megastructure. Everyone. So her example of this is the Dyson sphere, right? Which is amazing because it was literally 1960 that this idea came up.
Can you explain the Dyson sphere?
Yeah, the Dyson sphere. So Freeman Dyson, one of the greatest physicists ever, who was very broad-minded and thought about logic. He recognized that when a civilization progress, what they're going to need is ever more energy to do ever more, amazing things. And what's the best energy source in the solar system? Is a star, right? So if you surrounded the star with solar collecting, sunlight collecting, and the limit of this would be people actually built a sphere, an actual sphere around your star that had all solar panels. On the inside, you can capture every photon the star produced, which is this insane amount of light. You can have enough power now to do anything, to re-engineer your solar system. So that was a Dyson sphere. It turns out that a Dyson sphere doesn't really work because it's unstable. But a Dyson swarm, and that's really what you meant. This large collection of large orbiting structures that were able to collect light.
Yeah, so he didn't actually mean a rigid sphere structure.
Yeah.
He basically meant a swarm. So
Yeah.
that, like you said, when the limit basically starts to look.
People started to say, and we actually almost thought we might have found one of these back with Bourgeois's star. We saw, the way we detect planets is through the transit method, where the planet passes in front of the star. There's a the starlight. It's a little like plus. And we know exactly what they should look like. And then with this one star, there were these really weird transits where like it was like this whole dragon's tooth. And then there'd be another one, and another one, and another one, and then nothing, and then three more. And in the paper that was written about this, they suggested they went through the list of comets, chunks of the planet. And it could also be an alien megastructure. And of course, the news picked up on this, like everybody's news feed the next day. Alien megastructures. Turns out, sadly, they were not alien megastructures. They were probably like gas or dust clouds. But it raised the possibility, like, well, these arms are formed. People have worked out the details of what they would look like. You don't really need direct imaging. You can do transits, right? They're big enough that when they pass in front of the star, they're going to produce a little blip of light. Because that's what they're supposed to, right? They're absorbing the starlight. So people have worked out, like, well, a square one or a triangular one.
So that would be a gas sphere. That would be like one object.
One object, right? Which is what if it's a swarm, you'd expect like the light to be like blinking in and out as these things pass in front of you. If you've got thousands of these, much of the time they'll be blotting out the star. Sometimes they won't be. So you're going to get an irregular sort of signal, transit signal.
Yeah, what you wouldn't expect from a star that doesn't have any.
Exactly. Or just a planet, right? Or a couple of things. So many of these that would be like evenings.
And that usually doesn't happen in a star system because there's only just a handful of planets.
That's exactly right. Everything's coagulant. In a stable solar system, you get a handful of planets, 5, 6, so now suddenly you see lots of these little micro transits. You're telling you there's something else that's big enough to create a transit, but too many of them, and also within the regular shape of the transit itself.
How many people are looking for megastructures?
Well, the main groups looking for megastructures are, again, Jason Wright at Penn State and collaborators. The way they're looking for it goes for infrared light, because, the second law of thermodynamics says, look, if you capture all of this starlight, you're going to warm up your thing's going to warm up and emit an infrared. It's going to be waste heat and waste light from
it. Feels like a louder, clearer way.
Right. And that's actually, Dyson, that's actually why Dyson proposed it. He wasn't really proposing it because, like he was saying, this is what civilization would do. He proposed it because he was like, oh, we want to start looking for alien civilizations. Here's something that would have a technical signature. So Jason and the company have done pretty good search. And recently they made news because they were able to eliminate a lot of places. These are not Dyson. But they did have a couple that were like anomalous enough. They're like, well, it's not a detector. And they were saying they would never say anything. But they were like, they were not non-detectable.
And then potential candidates. Registration candidates. What other megastructures? So that's a very small captured gamma through the stars. There could be other.
Well, there's something called the Clark belt, right? So we have a bunch of satellites that are in geosynchronous orbit. Nothing naturally is going to end up in geosynchronous orbit, right? Geosynchronous orbit is one particular orbit that's really useful for being things straight down. Well, you want to put a space element in it, right? There's this idea that if a civilization becomes advanced enough that it's really using geosynchronous orbit, that you actually get a belt, something that would actually be from a distance via a transit. There's been a couple papers about the possibility of these Clark belts, densely occupied Clark belts, be a mega structure. It's not as mega as a Dyson swarm, but it's kind of planetary scale.
You think it's detectable? Well,
it could be. I mean, like in our list of techno signatures, it would be down there. But it would be, again, if you had an advanced enough civilization to see enough of this, it would certainly, you have a Clark belt. And
yeah, probably Dyson sphere. That's the more exciting.
I think
thing. It's because of the Dyson sphere. Let's talk about the Kardashev scale. What is the Kardashev scale, and where are humans on?
Right. So the Kardashev scale was the same time. This is this golden age of SETI, like 60, 59 to 65, when it just starts. Like this is, Frank Drake has done his first experiment. People are like, oh my God, this is even possible. And so people have just thrown out these ideas. And as I said in the book, science is concerned. And what I mean by that is it's holds on to its best ideas. So Kardashev comes up with this idea that, look, again, it's always about detectability. If we're looking for civilizations, we should think about what are the natural stages, natural quotes, civilization goes through. And he was thinking in terms of energy. So he said, look, the first hurdle in terms of energy, or threshold that investment is using all the starlight that falls onto a planet. He called that Type 1 civilization. Whatever way you're doing it, some large fraction of the starlight that falls on your planet, you're using. Next would be to use all the starlight there is from that star. Right? So that's the Dyson. So he actually, Dyson already proposed his idea of hardship. So that's a Type 2 civilization. Type 3 is galactic scale, a civilization that can use all the starlight in the galaxy. Right? So we are now, where are we now? Remarkably, on a log scale, we're 0.7 Type 1.
So we're not even Type 1.
No. But according to, there's a paper written by Rabbi that said, if we continue on our path, we'll be at a Type 1 at around 2300.
This is a log scale. So 0.7. Type 1 is about 10 to the 16th watts. Type 2 is 10 orders of magnitude larger than that. Type 26 watts. And I think as the galaxy is another 10 orders of magnitude.
Yeah, it's just on a billion
Or almost. So that's a lot.
That's a lot.
Do you think humans ever get to Type 1?
I think, that there's a problem with Type 1, which is that, we already know about climate change, right? The effects of our harvesting energy to do the work of civilization is already changing climate change, right? And that's something that, hardship couldn't have recognized. When there's the first law of thermodynamics, right, which is about energy, the different forms of energy. Then there's the second law, which is about when you use that energy. Hardship wasn't thinking about the second law. If you get all that energy and you use it, there's waste. You don't get to use it all, right? You can only, the second law tells you that if I have a tank of gasoline, I can only use a certain fraction of the energy in that tank, and the rest is going to go to heating up the engine block. So that second law tells you that you can only use so much energy before the climate state is like, sorry, it's going to change on you. So there's a way in which we probably can't get to it without devastating the Earth's climate. So we're probably going to have to figure out. The most important thing actually here is probably why space becomes something. How long things settle in space. We have an idea that we've been working on for a while called service moons, right? That at some point you probably move a lot of your industry off world. Right? We've got Mercury, for example. There's nothing on Mercury, there's no life on Mercury. Why don't you put your energy harvesting there? Right? Because you can't mess with the biosphere. The biosphere is more powerful than humans. So there's limits to how much energy we can harvest to do work on the Earth without really adversely affecting the biosphere.
It does seem that the best response to climate change is not to use less technology, but to invent better technology and to invent technology that avoids the destructive effects.
This is the frontier we are. That was the topic of my last book, Light of the Stars. It's like you have to do the astrobiology of the Anthropocene. You have to see the transition that we're going through now and on a kind of planetary astrobiological framework. And that paper we were talking about with the really world, that was actually in service of the work I was doing where I wanted to know how often are humans related. How often does every civilization, technological civilization, trigger its own planetary crisis, its own climate Anthropocene crisis? And the answer we actually came up doing models was like, yeah, probably. And then the question is, are you smart enough to figure out how to readjust what you're doing technologically so that you're not, that whole book drive, right? You want to figure out how to do this so that the biosphere becomes even more productive and healthy and so yeah, right. It's the kind of technology. I think there's probably absolutely limits on how much it can use. But how do you use that? And then also, getting off planet. If you want to use 10 times more energy than that, you're not going to do it on Earth. So how do we detect this?
Type 1 to civilization. So we've been kind of talking about basically Type 1 civilization protection. Maybe with the SSP we start to get a little bit more Type 2. It feels like if you have a type 2 civilization, it won't be just a nice affair. Right? It feels like that just for the same reason you mentioned, climate change, but now at the star system level, to probably expand. Right, so how would you detect type 2?
How about compulsion? Right? If you're expanding, no, we just I literally just put in a massive proposal now. Thomas Beatty, who's joined us from the University of Wisconsin, has an idea to look for clones, right? If you have a solar system wide thing, so what that means, right? You got space truckers going back and forth, right? You know, from Mars, they're doing the Enceladus run. They're accelerating and decelerating the whole way there, right? If you want to get to Mars in a couple weeks, you have your fusion drive on the entire way out there. You flip and burn and have it on. So you're also always have gravity. So would those clones be detectable? Because now you got stations going all over the place, and the odds that the food is going to be wrong in the field is going to become pretty high. So yeah, I think that's a good way of looking for. That's one idea of looking for large scale interplanetary, which is kind of what we're getting to type 2. Another possibility is looking for the tailings of asteroids. This was an idea group at so that be able to look for if you're really chewing up asteroids to build space applications. And there'd be dust particles left around. And would they look different from just say the dust, from just regular
So pollution of all different kinds.
pollution of all different
And trash also.
Okay, so trash is an interesting idea when it comes to the actual solar system. Right? We are actually, there's a whole other field of which are things in the solar system. What if somebody came by 1 billion years ago, and left some stuff, right? So the Earth has been showing biosignals for billions of years. A species like us, looking at our level, looking at Earth, have been able to know that Earth had life, had a biosignal for billions of years. So maybe somebody sent something by, on half a billion. So this idea of looking, say, at the moon for artifacts that have been there for a long time. It's something that a number of people are doing. Working on a paper where we calculated this. We calculated how long would the lunar lander exist on the moon before micrometeorites just shoot it down. How long would you be able to land up and go, oh, look, there's, somebody was here and left some. So there's this process called gardening, which is just a micrometeorite, constant rain of micrometeorites. And that's where you get the lunar regolith, fine powder on the moon, because it's gardening. And it turns out it is literally hundreds of millions of years.
Oh, nice.
That the lunar lander will be.
Oh, so we should be able to find artifacts.
Yeah, if there are artifacts on it, and people have proposed doing this with artificial intelligence. We have, the moon's been mapped down to like a couple of meters. Various probes, and all that data is sitting there. So why not use machine learning to look for all those things and look for anything that looks not like the lunar surface. And they did a test program where they gave the computer, sort of 50 miles around the Apollo 11, Apollo 17 sites, and it instantly was able to pull out.
I mean, the whole task of looking for anomalies, something that looks not like the lunar surface, to me it sounds obvious, but it's not exactly obvious. Like anomalies is really not. I mean, detect something that doesn't look right about this world. Yeah. It's actually really difficult.
Really difficult. And it's what's cool is really information theoretic kind of proposal. You really have to use information theory to say, what's the background? How do I define something that I can say that's what's weird?
Yeah, maybe we can look at a spectrograph or something like that. It's still it's gonna look really weird. We're kind of hypothesizing all the things that humans would build, right? How you would detect that, right? It could be really different.
That's why there's this emphasis now on these agnostic signatures, right? So actually disequilibrium is one way to define life is a system that is far from equilibrium, right? It's a loss, right? As soon as it dies, it turns into goes back to equilibrium. And so you can look at chemicals in the atmosphere, even if you don't know whether these chemicals, you have no idea whether or not they have anything to do with it. But the degree of disequilibrium the degree to which they show that atmosphere has not, the chemicals have not all kind of like just gotten down to it, they've all reacted away to an equilibrium state. You can actually tell that in very general ways using what's called Gibbs free energy. And that's kind of a signature. Like if you see an atmosphere that is wildly out of equilibrium, that indicates that there's something happening on that planet, biosphere or technosphere, that is pumping gases, into the atmosphere that is keeping the whole system from relaxing.
So is it possible to detect anomalies in space time?
Well, you could detect. There's been some work on this, like with the Kubrick drive, these proposals for warp drives. And we can talk about that later. I'm not skeptical of those, but because it may really be possible to use scale. But people have done work on, like, what would be the signature of an Kubrick drive? What would be the signature? Like, could you detect, if you're using a drive like that, then you certainly are distorting space-time, which means any light that's passing by has gotten, its trajectory has gotten altered because it had to pass through the distorted space-time. So, yeah, there are possibilities along with that. One of the funny things, I don't know if they've gotten past this, but somebody calculated the probability of Kubrick drive, or this warp drive, was that if you dropped out of warp, there would be this spray of gamma rays that would, like, sterilize any planet in front of you. So it's like, well, yeah, you probably don't want to do that, but that would be a great our techno signature. Not another planet obliterated.
So you think it's not possible to travel past this?
I wouldn't say so. But what I think, if you look at the physics we understand, every possibility for faster than light travel really relies on something that doesn't exist, right? So the cool thing is Einstein's field equations. You can actually play with them. The equations are right there. You can add things to the right or left hand side that allow you to get something like the equilibrium. That's a metric that shows you, like, it's a warp bubble. It's a warping of space-time that moves through space-time faster than the speed of light. Right? There's nothing moves across space-time faster than the speed of light, but space-time itself can move faster than the speed of light. But here's the problem with all of those proposals: they all need something. The thing you added, the little fictional term you added into the equations, is something called exotic matter, and it doesn't exist. It's really just something we dreamed up to make the equation do what we want them to do. So, it's a nice fiction, but really, right now, we live in this weird moment of the great acceleration, where, like, the technology we use now is completely different from the technology we used 10 years ago. Is remarkably different from the technology. But I remember playing Assassin's Creed, where everybody's like, what is it, 1200, and everybody's like, stab. I was like, it's a great game. And then I got Assassin's Creed 2, and it was 300 years later, and everybody's like, stab. And it was like 300 years, and the technology hadn't changed, and now Assassin's Creed was most interesting, right? You used your great-grandfather's tools, because there was no need to have any other tools, and he probably did his job. So, we can be fooled into thinking like, technology is going to go on forever, we're always going to find new advances, as opposed to sometimes things just flatten out for a long time. So you have to be careful about that bias that we have living in this time of great acceleration.
Yeah, but also it is a great acceleration, and we also are not good at predicting what that entails if it does keep accelerating. For example, something like Eric Weinstein often talks about, we underinvest in theoretical physics research. Basically, like, we're trying too hard for traditional chemical propulsion of rockets versus, like, trying to hack physics, sort of warp drives and so on, because it's really hard to do space travel. And it seems like in the long arc of human history, if we survive, the way to really travel across long distances is going to be something new, totally new thing.
Right.
So it's not going to be an engineering problem. It's going to be physics, fundamental physics problem.
Yeah, I mean, I agree with that in principle, but I think there's been, there's a lot of ideas out there. People, string theory, people have been playing with string theory now for 40 years. It's not like people haven't. Not like there hasn't been a lot of effort. And again, I think it's fairly possible that we have, there's incredible boundaries of physics that have yet to be. in which case then all bets are off, right? Once you get sort of, vast interstellar travel, but yeah, I tend to be drawn to like science fiction stories that take the speed of light seriously. Like, what kind of civilization can you build for like, 50 years to get to where you're going, and 50 years back? Like, so I don't know. I mean, yeah, there's no way we're going to say that it won't get more. But as of right now, it's all fiction. It's barely a coherent concept.
Well, it's also a really exciting possibility of hacking this whole thing by extending the lifespan, or extending our notion of time, and maybe as dark as the sake of the value of individual human life versus the value of life from the perspective of generations. You can have something like a generational ship that travels for hundreds of thousands of years, and you're not sad that you'll never see the destination because you kind of have the value, the prolonged, survival of humanity versus your own.
It's a wild ethical question. One of that book I talked about, Laura, was I love the book because it was such a sort of inversion of the usual. Because I love science, so many generations of stories, and they get to that planet. The planet turns out to be uninhabitable. It's inhabited, but it's uninhabitable for Earth because you get this idea of life on this particular planet. So they turn around and they come back, and then when they land, the main character goes to. There's still people who are arguing for more generations. Punches the guy out. She's been her whole life in it too. With this, I thought that's really interesting. The interesting thing about these space habits, but if you really had a space habit, not some super cramped, crappy, the usual version of a century, but if you had these like space habitats that were really, like the O'Neill cylinders, they're actually really nice places to live. Like why keep them in the solar system? Maybe space is one of like these sort of traveling space habitats that are in some sense they're worlds in and of themselves.
There's the show Silo, which raises the question of basically if you're putting a generational ship, what do you tell the inhabitants of that ship? You might want to lie to them. You might want to tell them a story, right? Because there is a society of discrimination. It's like, how do you maintain homeostasis of that little society? Then Desif has a technical question, a social question, a psychology question.
The generation shift too, which I talked about in the book, the idea of also you talk about extended lifetimes, or the stasis, the cryostasis, which is a main aesthetic of something. None of these things we know are possible. But it's so interesting. This is why I love science fiction, the way it sees ideas, right? All these ideas we're going to talk about because they've been stable for 50 years. Yeah, where are we at?
I wonder what the state of the art is for complex organisms. How long can you freeze and then unfreeze?
Right.
Maybe like a bacteria can freeze.
Well, bacteria can last. This is things like panspermia, right? How long can how long can the bacteria survive in a rock that's been blasted? It's a common impact across interstellar distances. That does seem to actually be possible. People have done those kind of calculations. It's not out of the realm of possibility. But a complex organism, multicellular, multi-systemic, or multi-systems, right? Organs and such.
So what makes it? Which part do you want to preserve? Maybe for humans, it seems like what makes a personality. It feels like you want to preserve a set of memories. If I woke up in a different body with the same memories, I would feel like I'll be the same person.
Altered Carbon. That's a great series. That's a really great series. But that's exactly the idea of sleeves. Everybody's able to be sleeved in another body. And it raises exactly sort of this question. It's not the greatest cyberpunk, but it's pretty good. It's got some great action.
As we get better and better advancements in large language models that are able to be fine-tuned, it raises the question, because to me, they're very capacity test, as we traditionally define them. So if there's going to be an LLM that's able to copy you in terms of language, it's going to raise ethical and philosophical questions about what makes you human. Like what if there's a thing that can talk exactly like you, like what is the thing that makes you you? It's gonna speak about your memories very effectively.
This leads us to, if we're going to get to the blind spot. I'm of the opinion, heretical person, that, the brain is not the, the whole body. It's embodied in base, actually, sometimes it's community. So I don't, I could be wrong, but this is, this whole work that I did on self-applied philosophy. Because it leads to this question about, maybe we should just download ourselves to the computer. It's like, that's another story. That one tells. I'm skeptical about those. What is that one of the narratives about these travel? And that anybody we meet is going to be, whether it's downloaded bodies or it's just going to be artificial intelligence. Like there's the whole idea, how long does biological evolution last? It's a very short period before everybody goes to, or the machines take over and kill you, or some hybrid.
What do you think aliens look like? We talked about all of these as bio signatures, thematic or technical signatures, but what would they look like when we show up? Are they gonna have arms and legs? Are they with direct acid at all? Are they gonna be carbon based?
Yeah, that's a great question. And this question gets to the heart of thinking about life, right? About what life is. And this is the physical part. There's also sort of the informational part of it. But let's just talk about the physical part of it, which is, life, anything that we're going to call life is probably going to work on Darwinian evolution. That's the nice thing about Darwinian evolution. Just like we know the laws of physics are general, the laws of Darwinian evolution are kind of this logic, this basic logic, that, anything we reasonably call life probably has to operate under these principles. And so, evolution is about solving problems that, to survive, that the environment presents. And the environment is always going to present these problems in physical and chemical terms. So that you expect some kind of balance between what we call convergence, evolutionary convergence, and evolutionary contingency. So, if you've got to move along a surface, a surface between a hard surface and air, then the idea of some kind of jointed stick, right, legs, makes sense. That you're probably going to trigger that. If you look at Earth's history, multiple times, multiple lineages that had nothing to do with each other are going to solve the problem of getting towards energy sources using some kind of stick-like network.
So that's about movement.
Yeah, so that's one problem that has to be solved. One problem that has to be solved is they got to get to food, right? Another problem is they got to get away from predators. You've seen wings. We've seen wings. The line that went through dinosaurs to birds involved wings. Insects evolved wings. Mammals evolved wings. If the gas is dense enough that a curved surface, if you move to the curved surface, you can produce lift. Yeah, there you go. Evolution will trip off that. So I think you can expect certain classes of solutions to the basic problems that life is going to present you. Stay alive, reproduce. But one of the weird things about the UFO things is that we see they all look like humans. They're just like basically humans with triangular heads, and that's where we get to contingency, right? So we've been talking about is convergence. So you expect that evolution will converge on wings multiple times when presented with the problems that wings can solve. But contingency is accidents, right? That you've gotten something that's evolving a certain kind of thing, a leathery wings, right? And then the climate changes and they all die out. Or an asteroid, a total accident asteroid. And so contingency accidents play also a huge role in evolution. And one of the things that lots of evolutionary biologists are talking about is that if you ran the tape of Earth's history over again, would you get the same creatures? Now, Stephen Jay Gould was of the opinion that no way. You wouldn't find anything on Earth that resembled any human species. They've done experiments actually on this with E. coli. You take a bunch of E. coli, you let them evolve for a while, you take a bunch of them out, freeze them, let one, let that population continue to evolve, the other one's frozen, now started over again with frozen. And it seems that contingency tends to win. Right? Contingency, at least from what we can tell. I mean, that's not a hard result, but in those experiments, what you find is that absolutes really do. So the idea, and this is important, so yes, you should expect legs or jointed sticks. How many joints they're going to be? Anybody's guess. You know, do you expect humanoids, you know, things with a, you know, a sensing apparatus on top of a shoulder with 2 arms and legs? That's probably a pretty random set of a person.
I guess what is a brain versus the nervous system? Like where is most of the cognition competition going on? I get to see that in the organisms. Like I don't know how the brain evolved. Why does it have to be in one place?
It doesn't have to be. So my favorite word of the day is liquid brains, right? This idea of distributed cognition, which fascinating idea. We've come to understand how much distributed cognition there is. Obviously, eusocial animals, termites, etc. And ants, that's an example of distributed cognition. The organism is the whole colony. This is one thing that's been really interesting in the state of the study for aliens, is that when we come to recognize that intelligence, it's not actually, it's been distributed. The kinds of things that go into intelligence are distributed all across the biosphere. Lots of different examples that show various pieces of what we have. Jason Wright described this like a deck of cards. The cards are all there. We got the hand that actually led to technological progress. But the kinds of, the basic idea of using tools, the basic idea of recognizing each other eye to eye, all the things that we define as intelligence, you can find many places in many other places across, many other lineages across the earth. So it could be very, very different. With something like, yeah, maybe the hive mind idea, or, you know, bacterial colonies that actually manage to, you know, come to their own version of high cognition.
Well, I wonder if we stretch out time 10 to 20 billion years, whether there's a Darwinian evolution stops working at some point in terms of biology or chemistry of organisms, switches to ideas. You have much more rapidly. You're operating, maybe, I guess it's a kind of Darwinian evolution that's based on names or whatever it is.
Technology seems to operate on, certainly markets can operate in ways that look very Darwinian.
So basically, a planet is working hard to get to the first kind of organism that be a nice platform for ideas to compete. And then it kind of stops evolving there. And then it's ideas that take off.
Right. Because, yeah, cultural, it's true. It's amazing that cultural evolution totally disconnects from the Darwinian evolution. But I'd be careful to say that, like, a planet is working hard to do this. Because, you know, it's really fun. Looking at us, like, what we think of as ideas and culture, and, you know, it's quite possible we're going to make it another 200 years and this is gone. Right? Because it actually wasn't a very good idea long term. I mean, we just don't know.
Oh, so maybe the idea generation organisms actually
not the biosphere, but it destroys itself. It may not be very long term, it may be very potent for a short period of time, but that it's not sustainable. It doesn't become, what we were talking about before, mature. It's very hard to make it integrated into a mature bio/. And of course, you know, evolution is not working for anyone. Well, here's actually an interesting thing, right? So people are very much, you know, evolutionary biologists get very careless now. And if you start talking about evolution having a purpose, but the very interesting about the purpose is that once you do get to an idea-generating species or collective work, then you know, kind of all bets are off, and there is goals, there is teleology, there is a, you know, there's now suddenly, you know, absolutely there's a direction implied. So that's kind of a cool, interesting thing that once you get to that, evolution stops being goalless, directionless, and suddenly, yeah, we're the ones who supply, or any kind of creature like us, has an absolute direction.
Although you could argue that from the perspective of the entire civilization, we're also directional. We have a sense that there's a direction in this cluster of humans. And then there's another cluster that has a different sense of direction. There's all kinds of religions that are competing. There's different ideologies that are competing. And we need to zoom out across, to survive, across thousands of years, and look in direction. So they seem like a pinball.
But, you know, but at some point, like, the expansion into the solar system, like, that would be in both direction. I mean, depending on how you look at it, it was directional. There was a decision that the collective of human beings made to, like, anti-accrete, to start spreading out into the solar system. So there was definitely a goal there. may have been reached in some crazy sort of, non-linear way, but it was still, right? There was still a goal was set. And it was achieved.
If there's advanced civilizations out there, what do you think is the proper protocol for interacting? Do you think it would be peaceful? Do you think that would be more like, what do we do next? We detect the civilization for all the technologies we're talking about. Maybe direct imaging, maybe there's really strong signal. Come up with a strategy of how to actually get there. But what's then the check, as they always do. The military, industrial complex.
We watched that movie.
Where, what kind of rockets?
Yeah.
Kind of
well, I think, so this is also a general question also is Betty messaging extraterrestrial intelligence. And I am definitely of the opinion that we should be respectful, Like, I don't think it's necessarily a bad idea to have your headphones correct. The people who advocate, like, oh yeah, we should be sending, powerful messages that are easily detectable into interstellar space. I'm like, why? We just don't know. Like, I'm not going to say they are warlike. I'm not going to say they're not warlike. I have no idea. But we sure as hell. Well, first of all, who gets to decide that? The idea that a bunch of astronomers who happen to have a radio telescope, who speaks for Earth? So, I definitely, we should be cautious, I would say, because we just have zero information. The idea, you used to have this idea of, well, if they're advanced, they can survive, so of course they're going to be wearing togas, and be singing Kumbaya. But I just wouldn't assume that. It's also possible, though, that, like, their cognitive structure is so different that we're not even living in the same universe in a certain way. I think we have to be prepared for that. We may not even be able to recognize each other in some way as cognizing. One of my favorite movies is Rabbi. I love them because they have a different language, they have different cognitive structure in terms of language, and they're literally kind of living in different different language, different everything. Yeah. But in the case of Iran, we can at least recognize that they're there. They managed to cross the language barrier.
But that's both sides of an interest, which we kind of suppose that an advanced civilization would have a curiosity. Because, like, how do you become advanced without a kind of curiosity about the mysterious about the other?
But also, if they're long-lived, they make us feel like we've done this. We're like, 10 billion years. Sorry, say 10 billion years ago, we were really interested in this and communicating with youngest, but now we're not at all. And that's just, one of the beauties of this again is how to think about this systematically, because you're so far past the area, right, of our experience of what we know that you want to think about it, right? You don't want to be like, don't know, can't say anything, that's not fun. But you also have to sort of systematically go after your own biases, right? So one of the things I love about Arrival too was, Carl Sagan always had to say, we'll teach you math, we'll teach you our math, then they'll teach us their math, and then, we'll be telling each other not jokes, and swapping beers and answers. And, in the movie, like, they send a Carl Sagan guy in, and the Carl Sagan guy fails immediately, right? And it's the linguist who understands that language is actually embodied. Language is not just something that's in your head, it's actually the whole experience. And she's the one who's raised. And it just points to the idea that utterly different the cognitive structures of a human species. So somehow we have to figure out how to think about it, but be so careful of our bias. So figure out a systematic way to break through our biases and not just make science fiction movies. You know what I mean?
Yeah. Speaking of biases, seeing aliens that visited Earth. You mentioned that they could have visited and started civilizations, and we didn't know about it. It was 100 million years ago. How can we even begin to answer this question?
You gotta look, gotta figure out ways to look. So I don't put it, it's not high on my list of, things that I think are probable, but it certainly, it needs to be explored, and unless you look, you never know. So looking where would we find, if aliens had passed through the solar system at any time in the last 3 billion years, where might we find artifacts? Where might artifacts still be around? Earth, probably not, because weathering and resurfacing. It's a good place. Certain kinds of orbits, maybe they parked the probe in an orbit that was stable. You got to figure out which orbits actually can do something there and it'll last for 1 billion So those are the kind of questions. I don't, like I said, it's not high on my list of thinking this could happen, but it could happen. I certainly can. Unless you look, you don't know.
What about, speaking of biases, what about if aliens visiting Earth is the elephant in the room? Meaning, like, the potential of aliens, say, seeding life on Earth.
You mean like in a directed panspermia?
Directed panspermia,
Yeah.
or seeding some aspect of the evolution.
Great story, but always with rays or whatever in science. If I can answer that question without that extra, very detailed hypothesis, then I should. And the idea that evolution is a natural process, that's why I would go for it. Right? That just seems it's so much easier to do it that way than adding, because it's kind of doing it thing of like, oh, then the aliens came down and they solved that problem that they're trying to solve by just coming down.
So to you, the origin of life is a pretty simple thing. It doesn't require.
I wouldn't say that it's not a simple thing, but it doesn't. It's putting. I think because all you're doing is kicking the can, right? Aliens, right? So you're just saying like, all right, I'm just kicking the can down the road to the aliens. How did they have their A minus?
Well, so from a different perspective, I'm just saying, it seems to me that there's obviously the advanced civilizations everywhere throughout the galaxy and through the universe, from the Drake equation perspective. And then, if I was an alien, what would I do? I've gotten a chance to learn about the uncontacted tribes in the Amazon. I recently went to the Amazon and you get to understand how they function and how the humans in the Amazon that are in contact with this plasma, how they interact with the uncontacted tribes. First of all, the uncontacted tribes are very violent towards the outside world, but everybody else tries to stay away from them. They try to kind of protect them and don't talk about them, don't talk about their location, all this kind of stuff. And I've begun to internalize that, understand that perspective, why you're doing that. If I was an alien civilization, I probably would be doing a similar kind of thing. And of course, there's always the teenager in control who's going to start messing with stuff. Or the scientists.
Right.
And so, it's not, from her perspective, yes. If you're in the Truman Show, like Occam's Razor. But like also, Occam's Razor, from the perspective of the alien civilization, we have to have the humility to understand that interaction is just what they do.
Right, I understand the logic of what you're saying, but the problem for me with that is that right there, first you have to assume that alien civilizations are common, which I'm not sure about. That might most of them may be dead, or they're not yet. Still, I think that life is common. And again, this is just my bias, right? So now the problem is, how do we sort out sort of, the biases we're bringing or the assumptions we're bringing from, from the sort of causal chain that comes out of that. I would first want to try and do this without, if we're looking at the origin of life, or the evolution of life on Earth. I want to do it just on its own, without asking for this other layer. Because it requires a bunch of these other assumptions, which also have their own sort of breaking of causal chain. Because I don't really like the idea that when you ask, what would you do with an alien? But again, an alien's minds could be so unbelievably different, right? That they wouldn't even recognize the question. Right, because it's just like we have a very particular kind of cognitive structure, and we're very governed by. Even if you went and talked to, think about, if I could suddenly magically appear 100,000 years ago and talk to a gatherer about their worldview and their motivations, I might find something towards no resemblance to things that I think are sort of, that's what naturally people do.
Well, let me ask you this question. Just together. If we create a time machine that allows us to travel back and talk to them, or we discover maybe a primitive alien civilization on a nearby star system, what would you do?
Yeah, I think that's a great question. I mean, so it's interesting how that even brings up the ethical questions, right? That's the thing, would we have to first sort of sort out what are the consequences for them and what do we feel are ethical are to them.
And also, sorry, from a capitalist perspective, where would you change?
Yeah, right. You look at the missionaries. Missionaries had these interactions because they thought converting them to whatever religion they were was the most important. That's what the game was. So from our perspective, I think we have to sort that out. I think given, if we're doing this voting experiment, we are curious. And I think eventually we want to reach out.
I think when you say we, let's start with people in this room.
Yeah.
There's, I wonder who the dominant forces are in the place. There's a lot of people, the military, they will probably move first. So they can steal whatever advantage they can from this new stuff so they can hurt China or hurt America. That's one perspective. Then there's the capitalists who how benefiting the cost here and how can I make money off of this? There's opportunity here. There's gold. And I wonder if they do the science is just not unlike the movies.
We're not going to get like today.
Hey guys, wait a minute.
They would engage probably. Just as a human society as we are now, we can engage. And we would be detecting in our engagement. Probably. So using that trivial bias logic, it just feels like aliens need to be engaged in a very obvious way. Brings up that paradox of it. What do you make of all the both ideas?
I am all in favor of an open, agnostic, transparent, scientific investigation of UFOs. But the idea that there's any data that we have that links UFOs and UAPs to non-human technology, I just think the standards, none of what is claimed to be the data lives up to the standards of evidence. So let's just take a moment on that idea of standards of evidence, because I've made a big deal about this, both in the book and elsewhere, whatever I talk about. So what people have to understand about science is we are really, scientists, we are really not each other. We are brutal to each other. Because we have this thing that we call standards. And it's the idea of you have a piece of evidence that you want to link to a claim. And, under what conditions can you say, oh, look, I've got evidence of, this claim. And in science, we are so mean to each other about whether or not that piece of evidence lives up to the standards that we have. And we spent 400 years determining what those standards are. And that is why cell phones, right? If you didn't have super rigorous standards about, what you think that, this is the antenna. I've invented a new kind of antenna that's cell phone, and I'll show you how that works. If you didn't have these standards, every cell phone would be perfect. And when it comes to UFOs and UAPs, the evidence you have and the claim shows that, we are being visited by non-human advanced civilization. Just doesn't even close to the same standards I'm going to have to obey or whatever to live under. If my team, the group I work with, is one of them, says, look, we've discovered, must have announced that, we discovered a techno signature on an alien planet. We're going to get it as we expect to be. We expect to be us. And, the UAP, UFO community should expect the same thing. You don't get a pass because it's a really cool topic. So that's where I am right now. I just don't think any of the evidence is even close to anything to support that.
Well, I generally assign a lot of value to anecdotal evidence. Not scientific value, but just it's always nice to get anecdotal evidence as a first step. It's I wonder if there's something there. But unfortunately, with this topic, there's some excitement around it. There's a lot of people that are basically trying to make money off of it. There's hoaxes, all this kind of stuff. So even if there's some signal, there's just so much noise. It's very difficult to operate. So how do we get better signals? You talked about if you wanted to really search for UFOs on it,
right?
And maybe detect things like weird physics. What kind of instruments would you use?
Yeah, so in the book I talk about it's stupid, but you want to look up, you want to look down, you want to look all around.
I think it's simple, not stupid. It's literally.
Right. So you want to do ground-based detectors, upward-looking ground-based detectors of the kind we're already building for meteors, right? For tracking meteors. You want to have space-based detectors, put them on satellites. This is what the NASA UAP panel is about. And then probably on, we have lots of people in the sky. There should be detectors on the planes, or at least some kind of alert system that if some pilot says, "Oh, look, I'm seeing something I don't understand," presses the red button, and that triggers the ground-based and space-based data collectors. And the data collectors themselves, this is something I really don't understand. It's so important. In order to actually do science investigations, the data you have to understand where it came from, like down to the nth degree. You have to know how that camera behaves in a bunch of different wavelengths. You have to characterize that. You have to know what the software does, what the limits of the software are. You have to know what happened to the camera. Was it refurbished recently? In every spectral wavelength and all of its data collection and processing, you have to know all of those things. Especially if you want to claim like, oh my God, I saw something take a right hand turn at Mach 1. Right? You better have all of that nailed down. So we have to have characterized detectors looking up, picking out, and maybe on rays themselves. We need a rational search strategy. So let's say you want to lay out these ground-based detectors. Where do you put them? Right? There's only so much money in the world. So, do you want to put them near places where you've seen a lot of things beforehand, or do you want to, have them try and do a sparse coverage of the entire country? And then you need the data analysis, right? You're going to have so much data, so many false positives, or false triggers, that you need a way of storing enormous amounts of data and figuring out what you're going to throw out, what you're going to shoot. All these things we're used to doing in other scientific enterprises. And without that, if we don't do that, we're going to be having the same damage about these things.
But if I ask you, I give you $1 and ask you to allocate to one place, looking out, studying, or looking at Earth, what should you allocate to looking at?
Because that's the bad, as I always like to say, here's my if you said, hey, Adam, I'd like to find something grass, and I said, oh, good, let's go to the Himalayas. You'd be like, well, why am I going there? I'm like, well, maybe there's some Himalayas, some Nebraska. Say, no, but let's go to Nebraska. If we're looking for aliens, why do we look on alien planets where they live? Because we have that technology now, as opposed to the bucket of assumptions that you have to come up with in order to say, like, oh, they're here right now. They just happen to be here right now. And also, the very important thing, I call this the high beam line. To deal with the UFO stuff, you have to deal with all of it. You have to answer these weird, irrational things that are happening. Like, okay, there's an advanced civilization that is visiting Earth regularly. They don't want to be detected. They've got super powerful technology, but they really suck at using it because we keep seeing them. We keep seeing them, but then they disappear. Right? I mean, explain to me what rational world under like, so there's that whole sort of argument you've got to explain, like, why, if they want to stay in, are they so bad? So, that's why I take that level of difficulty and then I put it on top of where should I look? I should look at where they're from. That makes me want to look at do the telescopic stuff.
Yeah, I think the more likely explanation is either the sensors are not working correctly or it's secret military technology being tested.
Absolutely. I mean, if you listen, that's why again I think UAT, absolutely UAT should be studied scientifically. But if I had to make a bet, and it's just a bet, I would say this is pure state adversary stuff. When I did a New York Times op-ed for this in 2021, and so I had a lot of people talking to me. While I was doing that, I sort of looked at the signals intelligence people, the SIGINT and EINT, electronic intelligence communities, and what they were saying about articles and various videos. And really, none of them were talking about UFO. They were all talking about peer state. That's why I learned the word peer state adversaries. How even simple drone technologies you can, and you purposely want to do this. You want to fake, signals into the electronic of your adversary, so they crank it up. So then you can just soak up all the electromagnetic radiation and know exactly what those advanced radars can do.
That said, I'm not saying that what this is. If I was the head of an alien civilization, and I chose to not minimize the amount of contact, I would try to figure out what would these aliens like to see. That's why, the big heads in the humanoid form.
Yeah.
I mean, that's kind of like how I would approach If I was intelligent, I would observe them enough. It's like, all right, if I wanted to communicate with an colleague, I would observe it long enough to see what are the basic elements of communication. And maybe I would do a trivial thing like do like a fake hand.
Right, a robot hand.
Or a robot hand. But then it's not enough to just do a robot hand. You have to do a robot hand that like moves the way they do. And maybe it's just a shady head. Doing the robot hand without. I just wanted to be the case.
This is the plot actually of a great science fiction book called Ia by Greg Bear. And the idea was like, this is actually where my first, I became sort of more than agnostic and many. Because the idea is that, yes, our aliens come, they sort of make their arrival. And really their point is to get rid of us, that it's the dark forest hypothesis. And what they do is they sort of literally, the way they present themselves is in this sort of classic UFO thing. And they do it, and they arrive at the Soviet Union, they arrive at the USSR, they arrive in China, and they're kind of faking us out so that we never can organize ourselves against. So it was really, they did exactly kind of what you're talking about, but it was more the variant.
Okay, and then you ask the pothead question. Yet another pothead.
The whole conversation.
I'm sorry.
Before breakfast.
Is science and pothead question back and forth. Okay, what if aliens take a form that's unlike what we kind of traditionally envision in analyzing physical objects? What if they take the form of, say, ideas? What if real pothead is the consciousness itself, like the subjective experience, is an alien being? Maybe ideas is an easy one to visualize because we think of ideas as entities traveling from human to human.
When I made the claim that the most important, that finding life, any kind of life, would be the most important discovery of humanity. And one of the reasons is, again, as I said, that life, if we're not an accident, and there's other life, then there's probably lots of other life. And because the most significant thing about life is the community, right? If I give you a star, and tell you the mass and composition, you can basically pretty much use the laws of physics, tell exactly what's going to happen to the star over its entire lifetime. Maybe many details, but overall, it's going to be a white dwarf. I give you a single cell and said what's going to happen in a few billion years. Never be able to predict a giant rabbit that can punch you in the face. Right? So life has this possibility of innovating, of being creative. So what it means is, and that's kind of a fundamental definition of what it means to be alive. It goes past itself. So give life enough time, and what are the end results? Like, there's that's why I love science fiction so much. At some point, does life reach a point where it climbs into the laws of physics itself and becomes the laws of physics? So, these sort of lie at the extreme limits of thinking about what we mean by reality, what we mean by experience. But I'm not sure that much we can do with them scientifically. But they're open-ended questions about the open-ended nature of what it means to be alive and what life is.
Since you said it's the biggest question, which is an interesting thought experiment. What is the biggest scientific question you can possibly answer? Some people might say about what happened before the Big Bang, some big physics questions about the universe. I can see the argument for, how many alien civilizations, or if there's other life out there. You want to speak to that a little bit? Like, why is it the biggest question? Why is it number one in your top five?
I've evolved in this, right? I started off as a theoretical physicist. I went into computational astrophysics and hydrodynamics and star formation. But I always, was a philosophy mind. I always had these sort of bigger questions sort of floating around the back. And what I've come to now is the most important question for physics is what is life? What the hell is the difference between a rock and a cell, fundamentally? And what I really mean by this is where I'm going to go non-traditional, is that really the fundamental question that is agency. What does it mean to be an autonomous agent? How the hell does that happen? It's so. I'm not a reductionist. I'm not somebody who's like, well, I just put together enough chemicals and a big bang boom. It's something that really is going to demand a reconception of what nature itself is. And so, black holes are super cool. Cosmology is super cool. But really, this question of what is life, especially by viewing it from inside. It's really about the verb to be, right? Really, what's the most pressing philosophical question beyond science is the verb to be. What is being, right? This is what Stephen Hawking said when he talked about what puts the fire in the equation. It's the fire, right? The fire is this presence, and this is where it touches things like whatever you want to say. It's sacred, spirituality, whatever you want to talk about. My first book was about science and human spirituality. So it's like so this question of life, what makes life as a physical system, so different is because that's where being appears. Being doesn't appear out there, right? The only place it ever appears to any of us is us. So I can do this kind of projection to this third person thing, but nobody ever has that. That's God's eye view. That's a story we tell. This is where this between us is where the verb to be appears.
So this is something that you write about in the blind spot, why science cannot ignore human experience. Sort of trying to pull the fire into the process of science. It's a kind of critique of materialism. Can you explain to me this?
Yeah, so the idea of the blind spot is that there is this thing that is central to science. So we're using the blind spot as a metaphor, right? So the eye as an optic, and the optic nerve is what allows things to happen. So you can't have vision without the optic nerve. But actually, if you're blind to the optic nerve, the little hole in your vision where the optic nerve is. And what we're saying is that science has something like this. There is something that without which science would not be possible. But that science, the way it's been configured, and actually when we mean the blind spot, we'll get into exactly what it means. But it's not really science. It is a set of ideas that got glued onto science. It's a metaphysics that got glued onto science. And so, what is that thing what is the blind spot? It's experience. It is presence. And if I experience it, I have to be very careful. I'm not talking about being an observer. It's there's lots of words. There's direct experience. There is presence, being, the light world within the philosophical phenomenology. It's this raw presence that you can't get away from until you die. As long as you're around, it's there. But that is the way to say this. That is the precondition for the possibility of science. And the whole nature of science, the way it is evolved, is that it purposely pushes that out so it can make progress. And that's fine for a certain class of problems. But when we try to answer, when we try and go deeper, there's a whole other class of problems. The nature of consciousness, the nature of time, quantum mechanics, that comes back to the life. And that if we don't learn how to understand that is always the background, that experience is always the background, then we're just getting into these paradoxes and properties yoga that require this intellectual yoga to get out of it.
I think you give a bunch of examples of that, like looking at temperature as a number. There's a very sort of objective scientific way of looking at that, and then there's the experience of temperature.
And how you build the parable of temperature, that we call it. So what is the blind spot? We use the term as a constellation. It's not just materialism. It's a constellation of ideas that are all really sort of philosophical. They're not what science says. But because of the evolution of the history of science and culture, they got like pinned the tail on the dust. They were sort of pinned on to tell us that this is what science is. So what do I say? One is reduction, that you are nothing but your nerve cells, which are nothing but the chemistry, which is nothing but, all the way down to the organs. That's it. So that's reduction. The objective frame that science gives us is God's eye view, this third person view of the world, to view the world from the outside. That's what science equates to us, that view. Physical, that everything in the world is basically made of stuff. There's nothing else to talk about, right? That's all there is, and everything is. And then also the reification of mathematics, that mathematics is somehow more real than physics. And there's a bunch of other things. But all these together, what they all do is they end up pushing experience out and saying experience isn't everything. Consciousness. I tend not to use the word consciousness because I think it leads us in the wrong direction. Focus on experience because it's a verb, and it's a way of verb. So yeah, and by being blind to that, we end up with these paradoxes and problems that really not only block science, but also have been detrimental to society as a whole, especially research.
So you actually say that from a perspective of detrimental to society, there's a crisis of meaning, and then we respond to that in a way that's counterproductive. These bigger questions, scientific questions. So the three responses you mentioned: scientific triumphalism, and then on the other side is rejecting science completely, both on the left and the right. I think the postmodernists on the left and the anti-establishment people on the right. And then just pseudoscience kind of does this in-between thing. Can you just speak to those responses and to the crisis of meaning?
Right. So the crisis of meaning is that, on the one hand, science wants to tell us that we're insignificant, we're not important, we're just, biological machines. So we're basically an insignificant part of it. On the other hand, we also find ourselves being completely significant. In cosmology, we have to figure out how to look from the inside at cosmology. We're always the observers. We're at the center of this, collapsing wavefront of light. Quantum mechanics really comes in. The measurement problem just puts us front and center. Some people spend 100 years trying to ignore the measurement. On the one hand, we're insignificant, and on the other hand, we're separate. So which one is it, right? And so this all comes from not understanding actually the foundational role of inability. We can't do science without already being present. We can't reduce what happens in science to some sort of formal. It's a lot of it is about we love our formal systems, mathematics, and we're substituting. That's one of the things that there's two philosophers we really like who are our heroes. One is Husserl, who's a mathematician who invented phenomenology, and the other is Whitehead, one of the greatest mathematicians of the 20th century. And Husserl came up with this idea of the surreptitious substitution. Part of the blind spot is substituting a formal system of calculus, of data, for actual experience, and that's more important. And so let me just do, before I go to those three responses, let's just do the parable of temperatures. I think it'll help them understand what we mean. So think about degrees Celsius, right? We kind of have in the modern scientific culture, we think like, oh yeah, degrees Celsius, they're out there. The universe is, the molecular cloud in space is 10 degrees, Kelvin. The way we got there is we've forgotten how that idea is rooted in experience, right? We started off in science we had an experience, a subjective experience of hot and cold. I feel hot, I feel cold, you feel hot, you feel cold. Science was this process of trying to extract from those experiences what Michel Pitbull, philosopher, calls the structural invariants, things that we could both kind of agree on. So, we figured out we can make a radiated cylinder that's got mercury in it, and that, hot things will be higher in that, radiated cylinder, lower. We can both kind of figure out what we're going to agree on our standards for that. And then we have thermometry. Yeah, we have a way of sort of having a structural invariant of this sort of very personal experience of hot or cold. And then from that we can thermodynamics, etc. And then we end up at the bottom of at the end of that with this idea of every day I wake up and I check my phone and I'm it's going to be 60 degrees out, great. And we start thinking that 60 degrees is more real than hot and cold. That thermodynamics, the whole formal structure of thermodynamics, is more real than the basic experience of hot and cold that it came from. It required that bodily experience. That also, it's not just me, I have to say, it's part of my communication with cold today, isn't it? That from that basic, irreducible experience of being in the world, with everything that involves, I developed degrees Celsius, but then I forgot about it. I forgot the experience. That's called the amnesia. So that's what we mean by how the blind spot emerges, how we end up, how science purposely pushes experience out of the way so it can make progress. But then it forgets that experience. So where does this show? Why is this? What are the responses to trying to get this back in? Where this crisis of meaning emerges? So scientific triumphalism is the idea that the only thing that's true for us are scientific facts, right? Unless it can be codified in a formal system and represented as data, captured in some kind of scientific causal network, it doesn't even exist, right? And anything else that's not part of it, part that can be formalized in that way, is an empty symbol. So, scientific triumphalism is this response to the weirdness of you call them this weirdness of experience by kind of just ignoring it completely. So there's no other truth. Art, music, human spirituality, it's all actually reducible to the neural world. So that's one way that the other way is sort of right. You got on the little postmodern left, academic left, you get this thing like science is just a game. It's just a game from powerful come up, which is also not true. Science is totally potent and requires an account for what is happening. That's another way to push sort of science away or respond to it. The science denial that happens, that's also another way of sort of not understanding the balance that science is trying that we need to establish. And then there's just pseudoscience, which wants to sort of say, the New Age movement or whatever, which wants to have, wants to deal with experience by kind of elevating it in this weird pseudo-spiritual way, so that doesn't have the rigor of science. So all of these ways, all of these responses, we have this difficulty about experience. We need to understand how experience fits into the web of meaning. And we don't have a good way of doing it. And the point of the book was to identify very clearly how the problem manifests, what the problem is, what its effects are in the various sciences.
And by the way, you mentioned at least the first two responses, they kind of feed each other. There's just observe the scientific community. Those who gravitate towards the scientific triumphalism, there's an arrogance that builds in the human soul. I mean, it has to do and all those things that the human nature, the egos is rather built. And of course, that nobody likes arrogance. So those that reject science, the arrogance is fuel. That reject science, and it's just this divide.
That was the problem. Like when I saw, so I said, my first book was about science and spirituality. So I was trying to say that, science is actually, if we look at what happens in spirituality, not religion. Religion is about politics, right? But about, the entire history of the species, we've had this experience, for better or lack of a better word, the sacredness. I'm not connecting this with God or anything. I'm just saying this experience of the more. And then, with the new atheism, we got people saying that, anybody who feels that is an idiot. They just can't handle the hardcore science. But in fact, their views of the world are so diluted of it. They can't even see the role that experience plays and how they came up with their forms. And experience fundamentally is weird. It's serious. It's kind of goes down forever. There's always so that arrogance. Then just if you're telling everybody who's not hardcore enough to do the standard model of cosmology that they're idiots, that's not going to bode well for your advancement.
You're proposing at least to consider the idea that experience is fundamental. Experience is not just an illusion, an emergence from a set of points. There could be something about conscious experience in the world that is at the core of reality.
Yeah, but I wouldn't do it. I wouldn't do this panpsychism, right? Which one
So that's all the way there.
Yeah.
Panpsychism is that's literally one of the laws of physics.
Right. All of those do. It's just the idea of, say, physicalism versus idealism. They're kind of the two philosophical. Physical that exists is physical. Idealism says all that exists is mind. We're actually saying, look, both of these things, to take either of those positions is already to project out into that third person view. Right? And that third person view, we want to really emphasize, is a fiction. It's a useful fiction when you're doing science, right? If I want to do, the Newtonian physics of billiard balls on a pool table, great. I don't want to have to think about experience at all. Right? But, if I'm asking deeper questions, I can't ignore the fact that there really is no third person. And that any story I tell about the world is coming from, it's not just first person, but it's literally, I was going to argue that experience always involves all of it. Experience always originates out of it. That, you're always telling those stories from the perspective of already existing, of already being an experience. So whatever account we want to give is of the world is going to have to take that as experience, irreducible, and the irreducible starting point. So ultimately, we don't have an answer. That's one thing people are what is? Look, that's the work of science. Our job was to point out the problem. But what we would argue with is, we're thinking about this process. This is really going to require a new conception, right? That doesn't sort of jump right to that third person, that fictional third person view, and somehow figures out how to do science, recognizing that it always starts from experience. It always starts from this field of experience or phenomenology of life that you're embedded in. You can't unembed yourself. So how do you do? So one of the things that Whitehead said was we have to avoid the bifurcation. What he meant by that is the bifurcation into like sort of scientific wavelength. Think about like the seeing sunset. You say like, oh look, it's just wavelength, and scattering particles, and your experience of the redness, and then all the other things. It's not just red. There's no quality. There's no pure redness. Everything that's happening in the experiential part is just an epic phenomenon. It's just he said you can't do that. They're both real. They're both accounts. They both need to be integrated. And so that required, I think, a really different conception of what we mean by it.
Is it something like incorporating in physics, in the study of nature, the observer, the experiencing observer, or is that something also?
I think that's what we have to figure out, right? And so actually, a great place to think about this is astronomy, right? Because one of the things we're arguing is like, in the chapter that I wrote, I wrote this with Evan Thompson, who's a wonderful philosopher, who so much wiser. When I was writing the chapter on the origins of life, how this emerged out of history, my subheader was like, well, it made sense at the time, because it did. It really there was a reason why people adopted this third person, God's eye, deterministic view. This view of sort of like, the perfect clockwork of the universe. Yeah, it totally made sense. But by the time you got to the beginning of the 20th century, science itself was telling you, like, and no place does this appear more than quantum mechanics, right? Quantum mechanics slams you with the idea that of the measurement problem. The most important thing about quantum mechanics is you have a dynamical equation, which you put in, like you talked about before, you have initial conditions, and now you got a differential equation, you create out the differential equation, and it makes predictions for the future, right? Exactly like Newtonian physics or its higher versions of Lagrange or Hamiltonians. But then this other thing happens, where it's like, oh, by the way, as soon as you look at it, as soon as the measurement is made, I have a whole other set of rules. That's the Bourne, we call the Bourne rule. And that was telling you right from the beginning that measurement matters. Right? So when you're asking, like, how will we do this, quantum mechanics is actually pointing to that. So there's been all these different interpretations of quantum mechanics. Many of them try to pretend the measurement problem isn't there, go to a really place, like the many worlds systems, literally inventing an infinite number of unobservable parallel universes to avoid the thing that quantum mechanics is telling them, which is that measurements matter. And then you get something like cubism, which is I'm going to or it's a new interpretation of quantum mechanics, which puts the Bohr rule of the set, right? Instead of like focusing on the Schrödinger equation and the weird things that come out of it, like Schrödinger's cat and all that stuff, it says, no, actually there's research. It's the Bohr rule. Let's think about the Bohr rule. Like you said, that puts the agent and information at the center of the whole.
So that's not a thing you're trying to get rid of. That's the thing you're trying to integrate at the center of the thing. In quantum mechanics, it becomes super obvious, but it's the same kind of thing should be incorporated in every layer of the study of nature.
Absolutely, that's exactly it. So one of the things that's really interesting to me, so I've had a project, I'm part of a big project that Chris Luke's Jacques Vanier on cubism, so I've been part of that. What I've been amazed by is the language they use. So what's cool about this business is it comes from quantum information. It's a pretty modern version of thinking about quantum mechanics. And it's always about you have an agent who makes an action on the world, and then the information they get from that action through the experiment, that's the actual updates their priors, updates their Bayesian, that's why it's called cubism, quantum Bayesian, updates how the information comes from the world. Now this turns out to be kind of the same language that we're using in a project that's about the physics of life, where we have grants from the Hamilton Foundation to look at cement information and the role of semantic information in living systems like cells. So, we have Shannon information, which is a probability distribution that tells you, basically how much surprise there is in a message. Semantic information focuses on meaning, right? Focuses on, and in a very simple way, just like how much of the information that the agent, the critter, is getting from the world actually helps it survive, right? That's the most basic idea, right? We can get all philosophical. This is it. Does it help me stay alive or not? And the whole question of agency and autonomy that occurs in this setting, just asking about how do cells move up a chemical gradient to get more food, kind of has the same feel, the same, sort of architecture as what's going on in quantum mechanics. So I think what you said is exactly what we bring this sort of recognition that there's always us, the agents, or in life, the agents interacting with and drawing in, giving information and passing information back as a way of doing science, doing hardcore science and experiment, but never forgetting that agency, which also means experience in some sense, is at the center of it.
So you think there could be something like cubism, quantum that creates a theory like the Nobel Prize winning theory, sort of like hardcore real theories that put the agent at the center?
Yes, that's what we're looking for. I think that is really, that's the exciting part. And it's the scientific triumphalism exists. If you understand why people love this, like, I have these equations, represent, this platonic idea of who they are, they exist externally on their own. It's kind of what fuzzy religion, right? It's sort of like somehow these equations are you're reading the mind of God. But this other approach is just as exciting, because what you're saying is there's us and the world. They're inseparable, right? It's always us and the world. And what we're now finding about is this kind of co-creation, this interaction, between the agent and the world, such that these powerful laws of physics that need an account, like in no way am I saying these laws aren't important, laws are amazing, but they need an account, but not an account that strips, that turns the experience, turns the agent into just an epiphany, that it pushes the agent out and makes it seem to be it's not the most important part.
So if you pull on this thread, and so there's a whole discipline born of this, putting the agent as the primary thing in a theory, a physics theory, like how is it possible to just break the whole thing open? So there's this whole effort of unifying general relativity and quantum mechanics, or coming up with theory of everything. What if these are like the tip of the iceberg? What if the agent thing is really important?
So, listen, that would be like kind of my dream. I'm not going to be the one to do it because I'm important to do it. But Marcelo and I have for a while have been sort of critical of where foundational physics has been for a while with string theory. I spent my whole life listening to talk about string theory real soon, and it's gotten ever more disconnected from, data observations. There were people talking for a while that it's post-empirical. And I always wanted to write a paper or an article that was like, physicists have been smoking their own stash, right? There's this way we've gotten used to, you have to out-weird the other person going, my theory is 38 dimensions, my theory is 22 dimensions, but it's got, psychedelic squirrels in it. And so there's a problem. I don't need to tell you there's a crisis in physics or there's a crisis in cosmology. Other people have used that. That's been the headline on Scientific American. So there's clearly another direction that has to be found. And maybe it has nothing to do with this. But I suspect that so many times the agent or the having to deal with the view from the inside or the role of agents thinking that you can replace the block universe with the actual experience of time. Clocks don't tell time. We use clocks to tell time. So maybe that even like the fundamental nature of time can't be used. That there's a new physics that comes from this tangential, informational, computational view. I don't know, but that's kind of what I think it would be fertile ground to explore.
Yeah, time is really important. Time is really important to us.
Yeah, that's what is time. So the way we attend to it is we've taken, this is when Husserl talks about the third substitution, we've taken Einstein's beautiful, powerful, formal system for viewing time, and we substituted that for the actual experience, right? So the block universe, where like News Tuesday is already written down, you know, the block universe, the four-dimensional universe, all events are already there, which is very potent for making certain kinds of predictions within the sort of, you know, the scientific framework. But, you know, it is not lived. And, you know, this was pointed out to Einstein, and he eventually recognized it. Very famous meeting between Henri Bergson, the most famous philosopher of like the early 20th century, and Einstein, where Einstein was giving talk on relativity. Bergson, whose whole thing was about time, about duration, he wanted to separate the scientific image of time, the map of time, from the actual terrain, which he used the word duration. Like we humans, where duration for us is full, it's sort of stretched out. It's got a little bit of the past, a little bit of the future, a little bit of the present. Music is the best example, right? You're hearing music, you're both already anticipating what's going to happen, and you are, you know, remembering what's going on. There's a kind of phenomenal structure there, which is different from the representation of time that you have with the formal mathematics and with you know, the way we would look at this is that the problem with the surreptitious substitution, the problem with the blind spots, is it says, oh no, the formal system is time, but really the only place time appears is with us, right? Where we're time, you know. So having a theory that actually could start with us, you know, and then stretch out into the universe rather than imposing this imaginary third-person view back on us, you know, that's a route towards a different way of approaching the world.
I just wonder who's the observer behind the agent in any kind of brain.
It's difficult, right? And so that's the work of the science ahead of us, right? So what happened with this idea of the structural invariance I was talking about? So, you know, we start with experience, which is irreducible. There's no atoms of experience, right? It's a whole. And we go through the whole process, which is a futile process, by the way. There's a philosopher, Robert who talks about this workshop. That starting in like the 1700s, we developed this communal space to work in, sometimes with literally a physical laboratory, where these ideas would be pulled apart, refined, argued over, and then validated and refined. So this idea of pulling out from experience these thinner, abstract, structural invariants, things that we could actually do science, and it's kind of like we call it an ascending spiral. So the problem with the way we do things now is we take those abstractions, which came from experience, and then with something like, you know, a computational model of consciousness or experience, I think we can put it back in. Like literally pulled out these super thin things, these abstractions, you know, neglecting experience because that's the only way to do science. And then you think somehow, oh, I'm going to put the jam experience back in, and then you don't have an explanation for it.
So do you think it's possible to show that something like free will is quote unquote real to integrate experience back into the physics model of the world?
What I would say is that free will is a given. And that's the thing about experience, right? So one of the things that Whitehead said, I really love this book, he says it's not the job of either science or philosophy to account for the concrete. It's the job to account for the abstract. The concrete, what's happening between us right now, is just given. You know, it's presented to us every day. It's presented to us. If you want an explanation, fine. The explanation actually doesn't add anything to it, right? So that free will, in some sense, is the nature of being an agent, right? To be an agent, agency and autonomy are sort of the two things that are, you know, they're equivalent. And so, in some sense, to be an agent is to be autonomous. And so then the question really to ask is, can you have an account for agency and autonomy that captures aspects of its arising, the way it and the world sort of co-arise. But the idea, you know, the reason that we argue about free will often is because we already have this blind spot view that the world is deterministic because of our equations, which themselves, we treat the equations as if they're more real than experience. You know, and the equations are a killer, you know, they don't corral experience. They are a thinner, you know, representation. As you like to say, don't confuse the map with the terrain. What's happening between us right now, and this, you know, all the weirdness of it, that's the terrain. The map is what I can write down on equations in the workshop to experiment on. Super powerful, needs an account, but experience overflow.
What if the experience is illusion? How do we know? What if the agency that we experience is an illusion?
Like, right, because that already requires to take that stance because you've already pushed yourself into that third person view, right? And so what we're saying is that's that third person view, which now you can say, like, oh, I've got a whole other set of entities, of ontological entities, things that I think exist in God's living room in sight, that are independent of me and of the living things on earth.
So you're pushing it elsewhere. This specific established is probably if this experience, the human experience, is an illusion, there's an observer. It's not an illusion, so you always have to find an observer somewhere.
Yeah, right, and that's why fundamentally the blind spot, especially the scientific triumphalist part, is following a religious impulse. It's wanting the God's eye view. It was really interesting, and when we think about this, and the way this gets talked about, especially publicly, there's a line of philosophical inquiry that this language gets out, and it is actually it's only one version of philosophy, right? So it is pretty much what we call the analytic tradition, right? But there's even in Europe, or in the Western tradition, from Western, what we call Western philosophy, there's phenomenology. There's Husserl, and Heidegger, and Merleau-Ponty, which are an entirely different track. They were really interested in the structure of experience. They spent all the time trying to understand, trying to develop a language that could kind of climb into the circle that is experience, right? Experience is not going to be able to start with axioms and work your into it. It's already given, so you have to kind of jump in and then try and find a language to account for the structure. But then, so that has not been part of this discussion about. You'll never, good luck finding a YouTube video where someone, a famous scientist, is talking about science from a phenomenological point of view, even though it's a huge branch of philosophy. And then you get the philosophies that occurred from other cores of civilization, right? So there's the Western core, out of which comes the Greeks and the Judeo-Christian Islamic tradition. So then you get India and Asia, and they develop their own highly complex societies that develop their own responses to these questions. And they, for reasons because they had contemplative practice, they were very focused on directly probe attention. They asked questions in ways that the West never really did. Phenomenology kind of started it, but there's philosophers like Nagarjuna, Vasubandhu, and they're like the Plato and Aristotle of those philosophers. And they were really focused on this. In the West, because we had the Judeo-Christian tradition, where we already had this kind of God who was going to be the frame on which you could always point to that frame. In the traditions that came from the classical philosophies of India and Asia, they started always, they wanted to know about experience. Their whole philosophies and their logic and their argumentation was based on, I've got this experience, I can't get out of this experience, how do I reason it? So I think there's like a lot of other philosophical traditions that we could draw from. Not like slavishly, we don't all but there are traditions that really try to work this out in a way that the Western tradition just didn't.
There's also the practical fact that it's difficult to build a logical system of health experience. It's difficult to have the rigorous science of health experience. And so as science advances, we'll make it better and better. Like the same, it's very difficult to have any kind of mathematical or kind of scientific rigor to why complexity emerges from simple objects instead of the scientific questions.
I think you can do it. I think there's aspects of it. As long as you're never trying to this is what experience is. I think that's kind of the where you're never going to have a causal account of experience because it's just given. But you can do lots about, and that's what's a good work is to how do I approach this in a way that's rigorous that I can do experiments also. Let's go, for example, I was reading this beautiful paper that was talking about this is what we're counting with our semantic information. Causal closure. Love this idea, right? The idea that, so we're talking about autopoiesis, right? The idea that living systems are, they are self-creating and self-maintaining. So the membrane, cell membrane is a great example, right? The cell membrane, you can't have a cell without a cell membrane. The cell membrane lets stuff through. keeps other stuff going, right? But the cell membrane is part of the processes, and it's a product of the processes that the cell membrane needs, right? In some sense, the cell membrane creates itself. So there's this strange, it's always looked like, there's always this strange loop. And so somehow figuring out how to jump into that strange loop is, the science that's ahead of us. And so this idea of causal closure, accounting for how we talk about downward causation, right? So reductionism says everything only depends on the micro. Everything depends on the atom, right? That's it. If you know the Lagrangian for the standard model, you are done. Of course, in principle, you need Gaussian linear function. In principle, you're done. Causal closure, and there's just reading this great paper that sort of argues with this. There's ways in which using epsilon machines, all this machinery from information that you can see ways in which the system can organize itself so that it decouples from the micro states. Now, the macro state fundamentally no longer needs the micro state for its own description, its own account. Whether that paper is true or not, it's an example of heading down that road. There's also Robert Rosenthal, who's a theoretical biologist, who he talked about closure to efficient laws, that living systems are organizationally closed or causally closed so that they don't depend on one another. He had a proof. It's very contentious. Some argue it's true and some argue it's not. But he said that because of this, living systems are not church terms. They cannot be represented as living systems. So, now they're not acting. They're not living systems. They will not be acting. They can only be partially captured by algorithms. Now, again, people fight back and forth about whether or not these kinds is valid. I'm saying I'm giving you examples of when you see the blind spot, you acknowledge the blind spot, it opens up a whole other class of scientific investigation. The book we thought was going to be really theoretical. Obviously, most public facing scientists are very sort of in that social science. And then the review from Science came out, and it was totally pro. They were very positive. We're like, oh my God, And then the review came out in Nature Physics, and it was totally positive. And then we made it out in the Wall Street Journal, because we kind of criticized, not capitalism, but we criticized sort of all industrial economies, that they were sort of been touched by the blind spot of socialism. It doesn't matter. It's extractive. Sort of had that sort of view that the world is just reducible to, resources. The Wall Street Journal takes a great view. So I feel like there's actually out there is some, among working scientists in particular, there is some dissatisfaction with this triumphalism. Recognition that we need to shift something in order to jump past these hurdles that we've been arguing about forever, and we're not, sort of stuck in a vortex.
Well, it is. I think there's a hunger to acknowledge that there's an elephant in that room, that we're just sort of it's everyone is doing it. It's like, yeah. There's the experience, and then there's the third person perspective on the world. And so to science, apply scientific rigor from the first person perspective. It's fascinating.
I think we can do it. It's also the thing, what's really interesting is that I think it's not just first person, it's first and second, right? Because science, one idea is that the idea that, science gives us this objective third person view. That's one way of talking about it. Objectively, there's a whole other way. Is that I do the experiment, you do the experiment, we talk to each other, we agree on methods, and we both get the same result. That is a very different way of thinking about it. And it acknowledges that, when we talk about agency and individuality are flexible, right? So there's a great paper, Big Extended by David Krakauer, where they look at sort of information theoretic measures of individuality. What we find is it's actually pretty fluid. Like, my liver cell is an individual. Really, it's part of the liver. And my liver is, a separate system. It's really part of me. But I'm an individual. Yay. But actually, I'm part of a society. And I couldn't be me without the entire community of, say, language users, right? I wouldn't be able to frame it. And my community of language users is part of the ecosystem, right? That are alive. That I am a part of a lineage, like Sarah Walker. And then those ecosystems are part of the body, right? We're never separable, as opposed to this very atomizing, the triumphalism this is science. It just wants like Boltzmann brains.
There's a fascinating degree to which agency is fluid. Like you're an individual, but you and I talking is a kind of individual.
Yeah.
And then the person listening to this right now is also an individual.
Right.
I mean, that's a weird thing.
That's a weird thing.
Right? There's a broadcast nature too.
This is my information theoretic. So the idea that we're pursuing now, which I get really excited about, is this idea of information orientation, right? Or organization, information organization. Because, right, physicalism is like everything happens. But, Conrad is apparently the one who came up with the word organism, because he recognized that life has a weird organization that was specifically different from machines. And so this idea that how do we engage with that organization, which is often can be cast in information theoretic terms or computational terms, is sort of it's not really quite physical, right? It's embodied in physical, in the physical as instantiated physical, but it also has this other realm of design. It's not design like intelligent design, but there's a organization itself is a relationship of constraints and information flow. And I think, again, that's an interesting way that we might get a very different kind of science that would slow us.
So going back to God and organism versus machine. I showed you a couple of liquid robots. Is it possible for machines to have agency?
I would not discount that possibility. I think there's no reason I would say that it's impossible that machines, whatever it manifests, that strange loop that we're talking about, that autopoiesis, I don't think there's a reason to say it can't happen in I think whatever it would be very different from us. Like the idea that it would be like, it would be just like us, but now it's instantiated. I think it might have a very different kind of experiential nature. I don't think what we have now, like the LMs, are really there. But I'm not going to say that it's not possible.
I wonder how far you can get with imitation, which is essentially what LLMs are. So imitation humans. And I wouldn't discount either possibility that through imitation you can achieve consciousness or agency or the ability to have experience. I think for most of us humans, we think, that's just fake, that's copy. But there's some degree to which we humans are just copying each other, which is are really good imitation machines. From babies who go on this world and we're just learning to imitate each other, and through the imitation and intention, imitation. The personality, perspective,
I think so. Possible, right? It's possible, but I think probably the views I'm advocating would say that one of the most important parts of agency is something called E4 theory of cognition. Embodiment, inaction, embedding, extension. But so the idea is that you actually have to be in a body, which is itself part of an environment that is the physical nature of it and of the extension in with other living systems as well is essential. So that's why I think the LLMs are not going to. It's not just imitation. It's going to require. This goes to the brain in the back thing. I did an article on brain in the back. It's really evidence of this work. Where they did the brain in the back argument, but they said, look, in the end, actually, the only way to actually get a real brain in the back is actually have a brain in the body. Bring your robot body, but it's still brain in the body. So I don't think LLMs will get there. If they can't, it really has to be embedded in the world. At least that's the E4.
For the 4E approach to cognition, cognition is not a personal system. It's also embodied, embedded, enacted, and extended by way of extracranial processes and structures. They're very much removed. 4E cognition is evaluation. I was wiping at two recent collections of reviews for 4E paradigm with a view to assessing the strengths and weaknesses. I mean, there's branches of what is cognition that's far, and you could go real far.
Right. There's a great story about an interaction between Jonas Salk, who's very much and Gregory Bateson, who was a cyberneticist. And Bateson was talking about said to Saul, he said, where's your mind? Up here. And what he really meant was this extended idea. It's not just to have experience. Experience is something. It's not a thing you have. It is a thing you do. Right? You almost perform it in a way, which is why both actually having a body, but having the body itself be in the world with other bodies is, from this perspective, is really important. And it's very attractive to me. Again, if we're really going to do science with them, we're going to have these ideas crash up against data. Crash up against. We can't just armchair it, or couch quarterback. But I think there's a lot of possibility here. It's a very radically different way of what we mean by nature.
What do you make of the fact that this individual observer, you as an individual observer, only get a finite amount of time to exist in this world? Like you said?
No, actually, it doesn't make me sad. So full reveal. I have been doing contemplative practice essentially for 30 years. Staring at a wall for 30 years. And it's taught me a lot, right? I really value what that practice has given me about the nature of experience. And one of the things it taught me is I don't really matter very much. This thing I call Adam Frank is really, it's kind of a construct. There's this process going on of which I am fundamentally, and that's super cool. But it's gonna go. I don't know where it came from. It's gonna go. I don't really need it to, and then who the hell knows? I'm not an advocate for the afterlife, but just that, what I love. Zen has this idea of beyond birth, and they don't mean reincarnation. What they mean is, dude, you don't even really understand what life is. You know what I mean? I'm like this, this core level of your own experience. So, your ideas about what death is are equally ill. And it's so, contemplative practice really tries to focus on experience itself. Spend 5 days at a Zen session doing contemplative practice from 7 a.m. until 9 p.m. And you'll really get a much deeper understanding of what my own experience is. What's it really like? You guys force you to learn how to stabilize your attention. Because your attention is kind of like this thing, it's usually over there, oh my foot hurts, oh I gotta do my taxes, oh that's what's that guy over there? Why is he wearing those shoes? And with contemplative practice, you learn how to stabilize it. And once you stabilize it, you can now begin to explore the phenomenal nature of it. So what I think I've learned from that is kind of whatever, I'm not really kind of real with the Adam Frank one, the identity thing. And the part of me that is real is, everything's coming and going. It's all coming and going. The world is just, this idea of codependent arising. Nothing exists. Nothing has self-nature. Nothing exists by itself. It's an endless, infinitely connected way.
Still, there's individual experience. You get attached to it, and it ends. It's good while it lasts, and it sucks that it ends. But you can be like, well, everything comes and goes. But I was eating ice cream yesterday on this awesome low carb ice cream called Delights here in Austin, and it ends. And I was staring at the empty container.
That's beautiful. I love that.
You could say well, that's how it all is, but
I think that's so much what I've learned from, because I love your idea of the but what I think contemplative practice is that it's not just, you're not just saying it, right? This is why, that's why I do koan. So this is a tradition in Zen that it was established, it was a teaching method that was established 1,000 years ago in the book of koan. And every koan, if you've ever read Gödel Escher Bach, they're kind of non-logical problems that you have to work on. One of my favorite ones was stop the sound of the distant bell. You're like, what? Every time my teacher gives it to me, I'm like, what are you talking about? This is this whole Zen thing of up is down, down is up. You must understand this. So, your job with these koans is to sit with them, until you sort of kind of, realize what the thing is trying to teach you, what aspect of experience it's trying to teach you. So there's no answer. And in fact, actually, you don't give an answer. You actually usually have to demonstrate. The first time when I sat, I did a koan, the guy was like, tell me the answer, show me the answer. What are you talking about? But after doing these for years, now, I've kind of learned the language of them. And so I could never tell you, if I told you the answer, I could give you a phone and tell you the answer. It's like, what? It's never, it's not the words. It's the, so like your experience is like, yeah, it's something just as it deepens over years. It really does take years. Just like anything in math, it took me years to understand what like, yeah, the words are like, it's not just like, oh, everything changes. You actually feel that movement. Like, you feel it like, and it really becomes, sometimes I have this feeling, like, and it's not connected to anything. That's what I've kind of gotten. It's just like, yeah, that passage, that infinite passage of moment to moment, that is truly the way things are. Like, not some okay because I have a feeling about it, okay? I want it to be okay. It just is okay. It's a really, pretty awesome.
It's beautiful. I can't say this to genetics, maybe it's the biochemistry of my brain, but I generally have that joy about experiences, amorphous joy. But it seems like, again, maybe it's my Eastern European, there's always like a melancholy that's also sitting next to joy. And I think it always feels like they're intricately linked. So the melancholy is about the finiteness of experience, and the joy is just about the beauty of experience, which is kind of similar.
Which is cool, actually, because that, I'm also, Eastern European as well, and I get it, right? I mean, but that's all. So the cool thing is, that is what it is. That is what it is, right? You don't have to do anything. You don't have to, like, manipulate or move it around or, like, yeah, this is the experience.
Can you speak to those just in practical nature, sitting there from somebody else? What's powerful, what's fascinating, what you learn from the experiences?
Yeah. So, you're not really, you're facing the wall, and what you're doing is you're just sitting with, there's different meditation practices, right? There's counting breaths. So that's usually what I do. I sit down and start counting. And for the first half hour, it's like blah, blah, blah. I'm thinking, like I said, I'm thinking about my taxes. I'm thinking about what I'm going to do later on. Yeah, got it. First time I ever did a full session, 2 day session, I swear to God, I had this crazy wonderland album practice through from beginning to end with the fuzzies back when they were LPs.
Nice.
And my mind was just like, I need to do something. So I literally played the whole album in order.
That's pretty cool.
Yeah, it was pretty amazing to see. The dynamics of the world. And this took me a while. I used to hate it. I do it, but after a while, the mind gets exhausted. Like, that part of my upper level, the roof bridge, and then you get bored. And now I realize that's what because you kind of control it. Now, it's a very physical practice. People think you're just sitting there not thinking or thinking about not thinking. Actually, it becomes a very physical process where you're really just following the breath, you're kind of riding the breath, and it gets very wild. And within that, it's, there's a path, because obviously there's been, Buddhism is always like, not about thinking, but there's a huge literature. So these guys are always about don't think. I've written all this stuff, but they're guideposts. They're like the finger pointing. And there's the idea of first, your mind is usually scattered, right? Right now when I walk out, I'm going to go get the my mind's going to be all over. But with sitting, first you concentrate so that there's no more scattering. Or the thoughts are still happening, but you're just not putting up there. You're not even paying attention to them. And then, as time goes on, you unify, which is this very powerful thing where self drops away, and there's just this presence, kind of like a raw presence. And that's often where the joy of but you sit with whatever. Maybe you can sit and you're going to have, like, maybe you're going to go through, like, an hour of being bummed out about your mom dying. You're just going to sit, whatever comes up, you're going to make it. That's why the sitting part. You're making it something that I'm going to sit with whatever comes up. And so I'm not being moved. And then what you come away with, actually, over time, that can change kind of who you are. Like, I'm still the asshole I was from New Jersey growing up. But I said,
Once Jersey was Jersey. But I love the Bruce Springsteen's blasting in your head. Why are we here? What do you think is the purpose, the meaning of the human existence?
It's good that we just had the last conversation because I'm going to give this answer, which is so important. It's love. And I'm not messing around. It's really actually what happens. So within Buddhism, there's the idea of the Bodhisattva principle. You're here to help. You're just here to help. right? Compassion. Like that's a really essential part of this path, of the Dharma path. When I first started, I was like, I'm here for knowledge, right? I'm here. I started contemplative practice because of the usual thing I was suffering. The reason everybody knows life was hard, but I also wanted knowledge. I wanted to understand whatever. And I found out that you can't get that. You can't get that. You can't go to this without compassion. Somehow in this process, you realize that it really is about helping all sentient beings. That's why they being here to help. So I know that sounds cornball, but especially for a guy from Jersey, where he's like, your main thing is to get over. But your job is to get over. But that's really what I found. And it's that joy. The joy. One of the things I have when I have like really, there's a kind of experience I'll have in practice in carry out the world, which is just this gratitude. In a certain way, right? Just the blue sky and the breath, just giving you itself completely unhindered. It holds nothing back. And that's kind of the experience. And then you kind of like, I need to be helpful. Who's not having this experience, It's just love for the world. Love for the world and all the beings who are suffering. Your worst political opponents, they're suffering. And our job is just to try and drop our biases in our stories and see this fundamental level that each life is occurring.
And there's many civilizations out there going through the same journey of suffering for his life.
Yeah, that may be a universal thing about what it means to be alive. Do that as they're coming to eat us.
Especially if they're a type 3 civilization.
Right. They got really big guns.
Well, this was truly mind-blowing, fascinating, just awesome conversation, Adam. Thank you for everything you do. Thank you for coming.
Thank you. This is a lot of fun.
Thanks for listening to this conversation with Adam. Right? Support this podcast. We think on our sponsors for this subscription. Now, I leave you with the words all day, wherever it was, wherever working, our feet with contemplation of the cosmos stir, tingling in the spine, the catching the voice, the faint sensation, as if a distant memory, or falling behind. We know we are approaching the greatest of mysteries. Thank you for listening. Now it's a speech. Yes.
There are cosplayers for like non-consciousness that maybe like the little cosplay games get rewritten like sometimes, maybe like you accidentally end up in another one. Does that make sense? Like maybe there's only so many consciousnesses that are actually present at once. Like maybe you're not present. If you take the alien idea one, it's the idea that we're all part of one. It's not like we're going to revive. We're just that consciousness experiencing life from all potential angles on this one planet. And so I mean, like, you're still a perception of that consciousness. Sure, because then when you die, you kind of just join back with it. You don't like the individual anymore. Like, what if some people are just empty? What if some people are just empty, and then you like take the wrong turn in the Wreck-It Ralph dreams one night, and you actually go to the wrong body, and then you try to back to your real body when you die. Sounds crazy now, but I'm saying it out loud. But yeah, no, it does. That's okay when there's no science in there, right? Well, I think they have a soul transfer machine in the Dosek facility. Yeah, maybe. I love the idea that this is like a video game where your FOV is what's loaded in front of you, but everybody actually hasn't loaded yet, so you turn around, everyone runs in. It's like, what would I do? I don't know, right? Quantum mechanics cannot be measured until they're observed, bro. Well, hold on. I just want to say for the record, I would believe this if you said it was more accurately like when characters from like Urkel would show up in Full House or whatever, and they would like, they shouldn't be there, but there they are. It's like, you're like, all right, well, this is funny. I don't know. I don't want to say I buy that. I think I would create a sequence at the end because the that thing that we're studying right now. It's actually the cool science that we actually get to watch get discovered while we live. Yeah, we don't get to go across the globe and we don't get to colonize planets. Right. We get to be here in the beginnings of quantum science, and that's fucking cool. And we find absolute PhD level understanding story that kind of goes along with my weird, how do you put it, Carl Pilkington-esque notion that I just had about swapping brain consciousness around. This story is about dreaming. This story's not about dreaming, it's about potent psychedelic drugs. But I'm not really sure there's much of a difference, which is something I'll actually be getting further into in just a second. But first, let's have Jesse read us part one of a story by Steve Cantwell on Naked.
Don't worry, and listeners out there, one day we'll go out tracking for mushrooms.
I would film the whole thing. I would record the audio of the whole experience. And if I'm someone's over there actually recording that thing. Everything about existence is perspective. No aspect of perspective is funnier than time. I have been a member of an existential little group called the Mormon Church for years. At the time of this story, I was kind of a pastor in the church called an Elders Quorum President. My neighbor was also a member of an existential organization, this one called the U.S. Army. You know what? I don't like the use of existential organization, but all right. Luckily, my friend was a lifer. While he was in Iraq, he would write emails planning for his next visit home at Christmas. He had been hearing about synthetic marijuana, which neither Uncle Sam nor Joseph Smith had yet commented on. I told Carl I'd get some in time for his Christmas visit. Yo, shout out to everyone I know. Everyone I know who's a Mormon is always trying to skirt the laws. Every single one says, yeah, I got an idea of how to get around this. I'm like, maybe Mormonism isn't for you. Whatever. It lets me know that humanity is alive. Yeah. A smoke shop virgin. I tried not to take the wares. The kids in front of me were buying packs of salvia, so I assumed this was synthetic weed I sought. I mistakenly asked for the same. There's a problem. That's going to be a Christmas. Oh no. Little baby Jesus is like, the smoke, we got him. It's the baby from Allen. Jesus has wings. Jesus? On Christmas, I walked next door armed with lamp-sized bomb and a pocket full of concentrated trouble. While the kids played with brand new toys, our wives prepared the big fancy Christmas dinner. My friend and I watched smoke before devouring the turkey feast. I went first to use my power with respect to his Mormon friend using a bomb for the first time. I loaded the big glass bowl with half foil packet, flash fried it with a micro torch, and took the kind of lungful you take to prove to your friend who kills people for a living that you are gruesome enough to hang. It tasted like burning snow tires. But I held my smoke like a hero until the floor beneath me turned into a whirlpool that sucked me in. Apparently, salvia is nothing at all like synthetic marijuana. I felt for a short time, down a swirling tube. When I came back out into the light, I was on the super realistic deck of a small ski boat and vomiting up water. Super realistic water that was coming out of my lungs, along with the kind of coughing that makes your fingertips ache. 3 strangers were gathered around me on the deck, talking excitedly. Man, we thought you drowned. The men were helping me off with my life jacket. Yeah. You were face down and still, and it felt like forever to turn around and pull you out. I stopped coughing. I explained to my water ski companions that I actually lived in Alaska and that all of this was super realistic. As I laughed and knocked on things to show how real everything was, my companions were exchanging worried expressions and rushed me to a nearby clinic. Cool. And here's part 2 from ROTHSCHILD, also intro.
Apparently, we were in Taik, Texas, a place about which I had zero previous knowledge. My companions, apparently my friends since kindergarten, told the doctor that I had almost drowned. My lifelong friends had expressed concern that I didn't remember any of them, and that I kept saying I lived in Alaska. The doctor gave the oxygen, hit my knee with a hammer, because the reflexes had shown a light in my eyes. He eventually told us that permanent amnesia was impossibly rare, and that my brain would probably shake itself off. was nice enough to leave me grinning in my living room, where I scooped around and waited for the salvia to wear off. I'd fallen asleep on the couch in the morning and woke up to urgent knocking. Called, apparently my friend, informed me that I hadn't shown up for work and drove me out to Peterson's farm, where I had blinked at a clipboard all day. Not only even pretending to supervise super realistic migration labor for a live outdoor, still waiting for the salvia to wear off. The work ended, and my friend offered to bring me to his house for dinner. I told him I just wanted to go back to my apartment and wait for this crop to wear off. I shook Paul's hand and complimented him on how real it seemed, which he didn't care for. I slept in the bed the second night, fully expecting to wake up in Alaska. Instead, I woke up again to Paul Hopkins. I hadn't shown up to work again, and this would repeat itself for every minute of every day for 8 years. I was trapped in Tyler, Texas. I will say Tyler, Texas is a real place. Like, it's not too far from me. It's like life on Mars. Like, nice show. Genuine question though. After like day 5, day 6, you're saying 8 years. So I mean, I understand that you can fast forward, but if you're saying this is all real time, I don't know. Day 3, I'd be like, you know what? That was a weird dream I had about that moment thing. I guess I'll go to work. They're like, I got bills to pay. Like, what do you mean? 8 years back. But he has, he has no memory of any of his life and those days. Weird dream. I still don't know anything. My memory of it. And that's still a problem. Like, I would go that way, I guess. At first, I was a man sleepwalking through an imaginary life. I didn't bother picking up my paychecks until there was no money left in my banking account. I wouldn't hang out with friends or answer tedious questions about my memory. I'd just go home every day and sit in my apartment and cry and wonder if I had imagined. You went to work. That's all I want to know. We're good. Yeah, if I had imagined my life in Alaska. It took 4 years to crack me, but after failing to find any trace in my previous life, I accepted that I had sustained brain damage and a weird drowning. The narrative that I had a family in Alaska that loved me began to feel like the kind of escapist fever dream a loser has in his brain while swimming through it. The belief that I had brain damage gave me a kind of guilt that allowed me to let go of my life in Alaska and start participating in my life in Thailand. One day at lunch, I told my handful of friends that I wanted to sing in the cover band they were always talking about for me. I started hanging out with them, interfacing through classic rock covers. We developed a kind of shorthand where they knew to include backstory or conversations when needed, and I learned to stop treating people like they were my information. Then, one day, I was walking across a park with my friends, carrying a bucket of chicken, when the grass beneath my feet turned into a wall, and I fell through the ground and back into the asphalt. The window, my now ex-wife was on the ground, holding me around the chest while I shook with seizure. I love, she said. I think it's coming out. My friend, who had often been thinking about how he would explain this to the police about he really hung up with the phone that died. Of course, nothing had. How does this sound in emergency cases? Very sorry, really off. Of course, nothing had changed in the 8 years I've been gone because the total relapse time of my seizure may have been as short as 45 seconds, best guess. Everyone was mad at me for selling stuff. Everyone was mad at me for playing around with friends for Christmas, but I was too weak yet at the wonder of my family's care. I had asked life in a borrowed pair of sweatpants, due to a super realistic accident in my slacks during the seizure, and still better than anything Tyler, Texas had offered. In the youth sense, I still have more questions and answers than doubts about reality and time, and some confusing emotions about friends and Tyler, and that nature I was still lucky to have. Yeah, pretty crazy. It's unfortunate what this room, like, that from that, I can imagine. Have you ever hallucinated a life on drugs? No.
Yes.
Never once.
Oh, I've told the story a million times.
Yeah, it's like for years.
Yeah, not life, but no, not years, but like hours. Like I definitely had it walk home and that was fake. Like it's happened, but that also wasn't salvageable. That was like hard. It was like we were drugs. We didn't choose that life. It got us. Although I guess we did. We were trying to press for us, but people with bad intentions got us. Yeah, exactly. It's possible that this. I absolutely have seen videos of dudes do salvia, and they have. When they come out of it, it's been 30, 40 seconds, and they're like, dude, all you got is killing. And they just go off with a crazy story. I definitely believe that it doesn't in your brain. something I would love for somebody to. If there's more scientists out there that want to educate us, please tell us about what salad does to a brain that makes it so goddamn crazy. Because it is so goddamn crazy. Yeah. There's so many videos on YouTube of people doing it. Yeah, dude, driving while solving is one of the best videos ever. I asked him, I'll be happy to shoot down and accept them, but he doesn't shoot down. Our dream is a place that you can go. So, for the last module that we're going to get you today, let's go back to another movie, which is actually, coincidentally, New Year's Party movie screening 2011, which was Christopher Nolan and Leonardo DiCaprio's Inception. Not sure what I'm shooting on as I was watching stuff, but all I can see is maybe minutes. It doesn't, it's not very, it's more important. I don't know what it's like to be. It's just very, yeah, I don't know what they're doing. But if you haven't seen it, it's about implanting ideas in a dream person's head to the outside world and sneaking into their mind by the highs and seamlessly convincing them with their own idea in the first place. That's what Inception is. And also, it's the plot for Persona 5 in it, too. And I'm not going to mention it again. I'm going to say that we should also maybe consider checking out Shin Megami Tensei 5 for the Switch if you want the battle system, but which is more challenging and giving you probably to make teenagers revenue as much as possible between ships with your day job at the same time high school, which weirdly isn't that relatable to me at 35 anymore. It's all going to teach a girl, but whatever. Yeah. Anyway, this isn't great. That's for you. It's for you, the man Jesse, playing Persona 5. But here is a new story about the idea of communicating both ways for someone while you're sleeping being absolutely real and occurring in this reality already. Back in February of 2021, the U.S. National Science Foundation, here's Jesse with a much abridged version of what that's all about. Pretty amazing stuff, to be honest with you. Researchers at Holler's Lab at Northwestern University in Illinois, along with researchers from France, Germany, and the Netherlands, have independently demonstrated two-way communication with people as they are lucidly dreaming during our sleep. Reported by the U.S. National Science Foundation, the breakthrough was achieved in the U.S. by Karen Campoli, Holler's doctoral student, and Christopher Mazurin, a volunteer research participant at the time of the study. And one of the first people to ever engage in real-time dialogue from a dream. Although our mind is active and dreams often occur during our REM sleep, our bodies are almost completely paralyzed. That presents an obvious challenge for communication since we can't move body parts we typically use to communicate. As the name rapid eye movement suggests, however, there is an exception. During our REM sleep, our eyes move around behind our eyelids in a seemingly random fashion, which often corresponds to the sleeper looking at various imagined things in dreams. If you dream that you're looking at something, your closed eyes move correspondingly, as if you're looking at something on the way. That phenomenon led researchers to a key insight. If eye movements were consciously controlled, the dreamer's eyes could become a vehicle for getting the message to the waking world. Yeah. So basically, the researchers were kind of having the same problem that I was having. I can't give you a picture of dreams. I can't do anything except like giving you reading. There's so much reading in this episode because all we can do is read descriptions of what people already experienced, like after they did it while they were asleep and they woke up and told us about it. Which is probably like a filter of perception that like sometimes changes completely, like the experience with the dream, even the illness. And because these people can't move the dream, they have to try to figure it away. So they use EEGs to do it to track in groups. So these people are really upset. And then here's what this will more about what happens. To prepare Mazurin and the other U.S. volunteers, properly wired each participant with electrodes that sense brain activity from the scalp behind the ears, on the chin, and critically near the eyes. Those were allowed the researchers to monitor and record every, even slight eye movements. When your eyes move in the sockets, the eyes have which is detected by the electrodes in the organ system. But we also trained each research participant to help them achieve this technique and instructed them on what to do at basic field. That included learning to recognize the specific sounds she would play when they control REM sleep, prompting the participants to realize their dream and thus become lucid. As a volunteer, Mazurin signaled his awareness after he played a randomly selected audio prove that you can communicate with somebody while they're sleeping, which is crazy. Like, while they're in REM sleep. I mean, actually double verify with sleep shift, or what they call it, and make sure the results really are what they are. So it's very likely that he really was in his REM cycle and stuff. But it also brings, like, where was he? Like, he said that he was dreaming that he was sleeping in the lab, and that somebody told him that he heard his voice at the answer. Right? He was in REM sleep, but he dreamed he was sleeping in the lab. So where was he? Like, how was he in the lab? Was he using input data from his senses while he was asleep and deciding in the lab? Is there a dream version of the lab? And then you think about, like, you kind of have that idea, like, just to go against what we were just talking about, like, living a whole life of dreams and stuff like that, right? You time dilates and shifts and stuff like that. But if somebody's talking to you, you can respond at any time and in real time with somebody in real space. Like in real time and space, in reality, you can talk to somebody who's dreaming and they hear at that same speed in the dream. I don't know. I don't know. There's something at the heart of that that's very fascinating to me. That makes it seem a little bit more interesting than the sort of underwhelming way that makes it seem. Have we had this conversation before about this exact thing? I don't know. Yeah, it's tripping me out. I swear to God, Sebastian has talked about this exact same thing before on this show. Maybe it was in Minnesota in 2021 when this happened, but I don't know. I'm hoping someone listening will say yes, we have. Otherwise, is this a dream? Like, I don't know, man. It's freaking me out. There's something weird about it, right? There's something interesting about that discovery to me that kind of like makes me feel like dreams are a real place. I don't know why. Though, of course, in Inception,
Reading the episode, I'm also like, see that man before we even did this episode. That's also fucking weird.
So, of course, I must say at this point, because the humility want me to make this clear. It's in the movie Inception, it's not just one of the guys who's sleeping. It's actually everyone who's sleeping while lucidly dreaming through somebody else's dreams. So it's really less like this real, tangible scientific discovery, and more like the incredibly dubious notion of dream telepathy, which nevertheless has at times been championed by Sigmund Freud to Jeff Mongoos's own Mander Folder, which, by the way, the animated movie about Jeff Mongoos or Simon Pegg. Have you guys seen La Llorona movie that came out a couple of years ago? Have you guys noticed how old we are now compared to when we started the show? Have you guys noticed that in the last 2 minutes, 100 years have passed by?
Well, because we'll have an episode on it in a couple of days. It's 6 years.
That's absolutely insane. I was just hearing about all other stuff that we don't know. And, anyway, it's all 20 years. Ancient, man. Anyway, there's a ton of different experiments into true dream telepathy over the years, which are people in dreams just communicating with each other while they're sleeping. I go sleep in my house, Jess was sleeping, so I think we'll meet up at the night house and have meetings. That's what dream telepathy is. But even in the talk he was going to give about it, which he didn't give, Freud seemed doubtful at best about the talk. And it didn't really get to be such proven. Amanda Folder brought cases with 2 decades later in the 40s, along with the other people that claims were almost immediately annihilated by extremely flimsy evidence. And most of the stories that they brought forward really just sound more like coincidences than real communication. And there's so much inconsistency around it that it was like, not good. I can keep it in here. There's been more serious studies since, including ones at the Maimonides Medical Center in New York in the 1960s and 70s that nevertheless lost credibility due to, again, messy data. And since then, there hasn't been another successful dream study. There was a paper in 2003 looking at the Maimonides studies that was trying to validate them, but then that paper got criticized for using shitty data. Any testing has been carried out since it's found zero evidence that dream telepathy has ever once taken place. But then, if you can't reliably communicate in dreams while both subjects are sleeping, then let's do what I said I was going to do earlier, head back to the world of psychedelic drugs for a second to answer the question, then what is it like to be in the world of dreams while awake? And maybe the answer to that question is just, it is hella tricky to be in that state. Because let's talk about DMT for a second. Everybody knows here what DMT is that right? Yeah, but I do not. Could you please explain it to me? You know, actually, instead of explaining to you, it'll give you a quote to me, Jesse, from the Imperial College in London, an article that is a clear definition for you to read to the people. So, DMT is a naturally occurring chemical found in minuscule amounts in the human brain, but also in larger amounts in a number of plant species around the world. For accounts from people who have taken DMT report intense visual hallucinations, often accompanied by strong emotional experiences, or even breakthroughs into what users describe as an alternate reality. Yeah, this in our brains, this chemical is associated with dreams. It's associated with death experiences, near death experiences. And it's really not much needed to get you going. I don't know, it's like the way for images. I don't know exactly. Nobody knows. So, they did a study at the National Institute for Health Research Imperial Clinical Research Facility. Again, using EEGs, electrode caps, just like we did in the other study. Gave these test subjects infusions of pilot DMT and just like tracked what happened with brain activity. And what they found was that it actually affects our brains much differently than most psychedelics do, just like psychedelics. So, not in the same way as psychedelics, but in a similar way, different than the rest of the psychedelics. So, for example, alpha waves, which are main brain waves we give in the awake, that's like the weak brain waves are the alpha waves, they go way down, which is weird. And then theta waves, which are like the dream waves, they go way up. They spike, even though these people are awake. So now, very quickly, dream wave, not go awake. And that's weird because most psychedelics like shrooms or LSD and them just drop all the brain waves down. Even more in that though is that it also makes the brain activity way more chaotic, which is like the opposite of what happens when you're asleep or you're asleep or you're brain activity is simple. And then even later than that is that from that chaos emerges an emergent brain pattern organically that forms a new type of order in the brain with the brain waves that results in a fully transportative waking experience. Okay? So here's a quote from Mathis to the researcher Chris Tierney, Center of Psychedelic Research. On the alter brain waves and participants' reports, it's clear these people are completely immersed in the experience. It's like daydreaming, and it's far more vivid than immersive. It's like dreaming, but with your eyes open. Here's another one to read from Dr. Robin Carhart Harris, who's the head of the Center for Psychedelic Research at Jesse Lee. DMT is particularly intriguing psychedelic. The usual vividness and depth of immersion produced by high doses of the substance seems to be on a scale above what is reported with more widely studied psychedelics such as psychedelic or magic mushrooms. It's hard to capture and communicate what it is like for people experiencing DMT, but likening it to dreaming while awake or near that experience is useful. Our sense is, I assume, that the research with DMT may report insights into the relationship between brain activity and consciousness. And this small study is the first step, along that. So, children, I ask you again, is there a place we all go when we dream? I think that after these three new relaxation modules we've covered here today, it's safe to say that yes, in some sense, there is. But is it a place within our own minds, or a place we legitimately share with each other across space? Or for us? I don't know. But alas, perhaps we'll cover that in another module next time, in part 2. And that's all the capital says. Time out. What is Chilligani's agenda here? I don't see an agenda already. They don't tell us anything. They just say go out and talk about it. What do you think they're trying to do? A lot of stuff about it. Getting the people's there's a lot of research about what ideas people say. That's all I'm saying. Are they suggesting that people listen to this podcast when they go to sleep at night? I don't know. I don't know what they're suggesting. I can't speak on that, and it would be against my safe speech comment. Yeah, I hope no one takes our audio and then splits the tracks. There's in fact a fourth audio track, which is just like, that's all I have in my pamphlet. I gotta say, it wasn't that bad of an episode after all, even though it was not my own outline, it was just the 2 hours outline. I thought it was pretty good. What's the last one I did? Magical paranormals or anything to this at all? I mean, maybe I should just let you. I should let you take judgment, like maybe till next time. You see, yeah. No, I got an answer for you. Incredibly magical. Dreams, as a concept, are insane. The idea that even like you can let your dog have a dream. The idea that there's footage of spiders, but if you can watch as living things close their eyes and in their most vulnerable state escape their current reality to go do something that is insane, like that's magic. It doesn't, like how you look at it, at the end of the day, it's still just something magical that is almost unexplainable. But we don't really have answers as a people, as scientists, as whatever. And it's fascinating. I love it. It doesn't mean that it's like, perfection, but it doesn't not mean, like, who knows, man? I mean, I don't know for sure how I feel about this. Maybe next time we'll finish our dream episode with the extra large unnamed supernatural. Maybe we'll have some idea about what things are, or maybe you already know what's going to happen next week. Your dream, just kidding. Or am I? Anyway, I'm going to talk about with the quote of a true story is told by my favorite comic book like Batman. Around the time when they took some psychedelic tablets and Kathmandu and makes it beings from another place to show them the nature of reality outside of time and space as they experience as humans here on this planet. On this place, just get your mind grapes juice a little bit. I'll read this for myself. I'm starting to grasp the concept. Our physical bodies are equivalent to computer game sprites for chess pieces. The entire universe I've grown up in will die now with a constructed playing field. The super reality I'm experiencing is simply what receiving with great concentration and look up to my hand. As a final demonstration, I'm shown how to detach a smaller structure foam block from the substance of my own fluid mirror body. The infant blob is holographic, I'm told, and contains the complete informational content of the parent intelligence. It anchors itself into the liquid information we're swimming through and begins to crackle and freeze at the edges. I can't imagine how I could have forgotten this. I know it's about to happen. The baby blob's hissing like sugar, growing and folding up all around until it's everywhere. This is how we start a game, and it's time to play again. My eyes are still open and there's a bolster supporting my neck. I can almost feel the extremities of my body extending out into directions we can't point to in three-dimensional space, but it's only for moments. Kathmandu jigsaws itself together in one awkward instant, and I'm back in the world, back in the game. Shake it. Patreon.com/295. If you want to write and have stuff like that, check out Grant Morrison on Substack. Thank you for listening to
Hello, everybody, and welcome back to my podcast. As always, my name is Michael. It's episode number 195. You just formed your own system. Episode number 238. As always, I'm going to be host Michael. I'm joined by my...
You want to turn off the podcast now? Why even bother? You didn't say the number.
Joined, as always, by my pet hamster and the stray dog that ate it, Jesse.
What is the new thing that you say something crazy and that there really is an anecdote behind it?
I don't think the mystery is part of the
I
charm.
feel like there's no mystery here. I feel like you had a dog and ate the hamster. Or a dog ate your hamster. Is that true? I'm going to say yes, because it makes your life a little worse.
Yes, and
Also, and more sad.
down some flowers. It helps
No.
break the sting of the loss of zip.
When God eats a hamster, he opens his mouth. That's what they
Did
say.
you say zippy?
I am the hamster.
I am taking that mantle.
I am the stray nut that is nibbled on Alex a little bit too much.
You know what I changed that? I'm like when you give, kind of want to get and you pretty much just acorns.
I want to keep talking about ham as much as I can every episode. You really are that guy now. Ever since this get activism, my hamminess system.
Also, we were on their show.
Yes, we were on their show, and we were like, I'm the ham guy. It's true. I mean, it's not true. I did some stuff.
It was a Disney book.
I'm not Disney. Yeah. No,
I'm going to just tell you like 4 years.
you're a closeted Disney adult. You don't want people to know. You're a little worried that people will judge you. But, bro, you know more about Disney than any other human being. No. Everybody with a brain like mine got an encyclopedic knowledge of something that they didn't expect around the time that they come to his age. And I did Disneyland, the Titanic, and World War II. Okay?
What is the age you refer to?
It's just like 12 to 18.
Aliens, U.S. history.
Mine were like movies, ladies, movies. Yeah. 12. Right? Oh yeah, I was born in my own. Yeah, movies. Yeah, we 12 years old. Yeah. And then like I don't know. What is the question?
It wasn't until I discovered Tabitha.net chat rooms that I worried about movies. Hey, what's up, guys? That's how you doing.
Well, folks, here we are again. Welcome back to part 2 of our episode of dreams, which I don't really call mine because, again, just to remind you, in case you forgot the magical heroes from last week, this one was kind of a collab with the real Illuminati, and as such, this episode was supported by some of the board-approved educational modules about dreams, and weirdly, a lot about what movies they screen at their yearly super secret New Year's party. I don't know what part of the story that is. I have not been invited to one of those parties. I don't know if either of you have. I personally have not. But speaking of support, to support us, head on over to patreon.com/SublimatingPod, like always. Where not only is there all kinds of great stuff you get in return, like ad-free episodes, mini-sodes, all from the perfect and cool this archive of our movie review show, Rotten Popcorn, and more. Key and more.
And the new T-shirt dropped from Mel that we had already done section.
Oh yeah,
it is sick. It is just absolutely awesome. Go check that shit out.
The perfect thing for the perfect adjectives for this. You have to go check out the shirt. It's the shirt that you want if you like the Slither shirt. Not only do you get that stuff, you are also added to some sort of like, it's not like the no-fly list. It's like the work-share list on the official registry of the Chillingham database. So instead of not being allowed on airplanes, you are allowed to hang out with the Chillingham. Isn't that cool? Is that not cool? Did I mess it up by mentioning the no-fly list? If not, just DM us, and we'll send a sleep entering retrieval team to you in the dream realm overnight. Anyway, we're going to stop being obtuse for a second. We'll talk. Yeah.
We're about to go to dreams. Right? So this is important and completely involved with this episode. Okay. Last week, we actually got, and I haven't gotten email from you. They tweeted us on Twitter about it. A guy who said that he was in a coma for 4 months and he had lived 2 years of an entirely separate life in those 4 months. And he has a whole lot of story about it. So hopefully you hear from him in the emails. He did tweet us about it.
That is interesting.
Absolutely right. I do wonder if there's a difference between like what happens to your brain and coma. I mean, there's got to be different kinds of stuff. So I don't know, but I just find that interesting. Like,
Can I take up the greatest thing that ever happened to me after that first video that I worked with? That I was working the register one day, like in the dead hours of like midday, and this lady, like 2 older ladies came in together, and they were like friends. And she was like, hey, so I just got out of coma that I was in for 10 years. What did I miss? And I was like, that was my day. What a great day. Like, I would love to hear any coma story. I'm so, as I'm going deeper into this, like, this subject, I'm just so interested in how the brain works. It seems like, you know, the more that we think about perception and how much perception seems to affect reality, like, I don't know, something about dreams seems even more wild.
there's a post yesterday too about somebody who scientifically broke down what salvia does to the brain.
I saw that. That was great.
Which is awesome. You know, TLDR is essentially like, we don't know, but we think it's a dopamine.
Yeah, we'll get to that in a minute. We'll do things like that. Yeah, we'll get that. This episode, which I think was a surprise later in the script. It's okay, we didn't just leave it just like this. Yeah, anyway, no more obtuse stuff. I threw you off. I'm so sorry. No, I just wanted to, and, yeah, my iCloud frozen. I mean, it took me some scrolling from this. Now we're back. I'm ready to stop being obtuse for a second and talk about my personal, unnecessary secret thing I've been choosing for the last half year. Basically, this is starting to pick up, so I know that I want you guys to get with that. I'll figure it out now. It's the 8 H's leading to episode H8. So far, we've had a hidden, heavyweights, and a horse. And this two-parter about dreams is head, obviously. So far, all the clues have matched up perfectly with topics. But since our last 4 are hello, huge, him again, and hero, it should be fairly simple for someone on the subreddit to guess at least one of them before it comes out, right? And also, because the Illuminati have a flair for the theatrical, they also wanted to share that some element of the first part of this episode could be considered a dream premonition for episode H8, which means it's now also possible to make an informed guess about what that episode is going to be about too, which is actually meaningful now because I finally figured out what I'm actually building that episode up into. So now you get it. There's clues. Also, this is a little trigger warning for you guys. This episode has some discussion of travel disasters, violence, and a kid that we will identify with briefly as part of one of the stories as the main character dies at one point. You have been warned. There's a dead kid. Proceed with caution. Anyway, patreon.com/chillinghallpod. Please care about my dumb, half-baked ARG shit. And finally, the Chillinghall always encourage lecturers to begin with a relevant personal anecdote, so I'll start by reviewing it after I learned that in 2012, the New Year's Eve party included a screening of Michael Shannon's movie Take Shelter, in which a man has dreams foretelling an apocalyptic disaster, I watched the movie and ended up Googling whether or not anyone actually has dreams that predict the future. What New Year's Eve party? No, it's not a New Year's Eve party. Right, no, okay, yeah. Yeah, we were told to. Yeah, we were told to, right. Right, yeah, right. Take Shelter was a big movie. Sometimes I wonder if what you're saying is crazy. Remember, you made up an alternate reality in which we've been around since 2012. In which case, cool. Well, yeah, I'm not. It's just a show that you and I have been around. Here's the thing. We're there branding. Right, no, you know what? Take Shelter. I'm on the same 2011 in September of 2011. They got a release copy at the news publisher. No, I can have your ways. I don't know. It all checks out. I just give you a little explanation because they hit me with that memory eraser. No, I know it's a wild ride. All right, okay. I'm just going to skeptic that you are. Yes, with all the evidence that he's been presented over the years, it's made it to a movie. Yeah, Will Smith shows up and zaps me. Yeah, Will Smith, what are you doing here? He's like, I had to get out of the house, man. Zap, and that's it. I'm so bored, man. I don't know why I remember that bit, but, So anyway, I had this premonition. I was checking to see if anybody had dream premonitions. And I ended up Googling, and I found a post on Quora from 4 years ago, which Jesse's going to read for us right now. There's somebody called Kenzie. So here's that for you right here. I absolutely do. That thing that they sucks. Here's the deal. This episode is about dreams, okay? This is something that already existed in the nation. So there's no way. If you would have said literally any other website, you could have been like on 4chan and like a little bit more credible. I'm not gonna lie. Currently, I am 16. I dream almost every night, and about 2 times a month, my dreams come true. I sound crazy when I tell people, and I try to research why it may be happening, but I can't find anything that would explain why it may be happening. I read that having a dream might alter actions, and what I decide to do, I read that having a dream might alter actions, I think it says might, and what I decide to do, but the things I predict are never anything I can alter with my actions. Okay, do that one hard. One example would be a dream that I had about 3 days ago. I was at dinner with my friend, and I had completely forgot the dream until the waiter brought the check. In that second, everything was exactly how I dreamed. My friend and the waiter were there, waiting. What? My friend and the waiter were waiting what they wore wearing in the dream, and the waiter was the exact person I had dreamed of. The waiter out the check down in the exact spot, and my friend said the same exact thing. Oh, I wonder what this one came out to be. I didn't even look at the check, and I asked her if the amount was $19.73, and it was. This stuff happens to me all the time, and I don't know what it means. So we have this incredibly realized. Stand my mission statement, by the way. We have this incredibly realized 16-year-old character that we meet in the forum, who is going through life, experiencing basically deja vu, but with the added twist of being right about things they could never have any knowledge of. And this was posted, this was posted, I believe, in 2014. I was going to say this is a heavy indictment of the public school system here in the United States, but I guess it's always been. Oh, yeah, no doubt. I'm from California, so I was really nice. But anyway, here's the top answer direct for inquiry after Mathis tweet from someone going by Zikaya Vaishnavi Maya. You are incredibly lucky. There are very few dream explorers who have such focus as yours. I am used to dreaming for 7 years, and I don't have such consistent luck with the future in my dreams. You are not going nuts, but you should ground yourself
impressive like did for dreaming.
So first of all, very interesting advice for how to deal with predicting the future. I don't really know what the advice has to do with predicting the future, and really the person is just kind of like asking why they're predicting the future. This person's like,
Can I say, I'm close with somebody, and I don't want to put their name up there because it can be seen as insane. But they are a lucid dreamer as well. For years, and they don't predict the future. That's what they got to make about. But their dreams are consistent in that there's, for whatever reason, there's like an ongoing weird war. They are, part of, or like see one of their weird occurrences, speaking with people who know their dreams, but they don't know they know their dreams, other people don't know. And it's like consistent, and the details are there, and people dream like very fucking fascinating. I don't know if it means anything, but I'm curious if there's anybody out there that has similar style, like weird dream.
I know, but it's all that's kind of the interesting thing, right? That actually ties to one of the words that you may have noticed in there that Matt is kind of like positively reps. It's kind of a weird word.
Yeah.
That word is oneironauts. Oneironauts, if you break it down, comes from the Greek oneiros, which means dream, naut, which means like sailor or explorer or traveler. And it really just means people who like take extra care in paying attention to and or influence their personal dreams. In this case, usually on some kind of like conscious basis, kind of like as a hobby or even like some kind of weird obsession, like the idea of traveling through dreams and experiencing dreams in some kind of conscious way. That's what it is. Not really. A lot of stuff we went to yesterday, last week, falls into the realm of like lucid dreaming, which we were just talking about, dream walking, dream telepathy. But as I looked into more words with the oneiro prefix, the one that really caught my attention was the word oneiromancy, which I figured could be like either sexy or magical. So, really on my own time, actually, that's the answer. I went deep. Lost a couple nights' sleep, but right until, ironically, perhaps overdramatically, I found myself in a state of something that I describe as what I imagine oneiro dreaming to be like, which, in case you're wondering, is defined by Wikipedia as, quote, a loosely termed dreamlike state caused by several conditions such as prolonged sleep deprivation, sensory deprivation, and drugs, often beginning with the inability to focus on things. It is considered a schizophrenia-like acute form of psychosis, which remits in about 60% of cases within a period of 2 years. It's pretty crazy. And that was crazy that I just randomly looked all this up for myself as part of this story. Because honestly, the very next day, I got the DM from the Illuminati, the real Illuminati, about doing this dream world training / recruitment / not actually recruitment / more general encouragement to join an organization episode thing. And I thought, that was perfect because the very first module in today's lesson is actually called What is Oneiromancy? So that's exactly what I'm getting to right now. What is Oneiromancy? Going back to the Greek. Yeah, go back to the Greek. We know what Oneiromancy is. But now I'll tell you that Mancy comes from Mantea, which means like prophecy, which makes Oneiromancy, anyone? You know? Exactly. It's a form of divination or predicting the future involving dreams, manifesting in all kinds of various forms across the board. According to Wikipedia, some of the oldest writings we have on the topic comes from Sumeria in about 3100 BC, which is for humans a long fucking time ago in the scale of civilization. And the writing came out of time that Sumerians were ancient in a way that Egypt is ancient today. They're like 1,000 years older than the ancient Egyptians. It's like Mesopotamian stuff. There's stories of like people coming across like ancient cities like huge walls, huge cities like this. And they like nobody there back in like more in like the 1700s. When there was like Lord of the Rings still going on. Yeah, exactly. Absolutely insane. I have no idea. I can't even imagine like Breath of the Wild. dreams about Oneiromancy came at a time where often kings and generals were regularly and seriously looking to dreams for further guidance or messaging from divine and mystical sources. The Mesopotamian notion was that in dreaming, some part of the soul actually left the body while you were sleeping and traveled to whatever place the dreams were occurring in, or the reality where those dreams were occurring, if it was like a more fantasy place. And oftentimes, in a lot of the cultures, good dreams came from like dark, godly, and bad dreams were more like a demonic thing. And when I say people saw it as very important, I mean that around 2130 BC, King Gudea of the city-state Lagash rebuilt an entire temple to the god Nibirusu and spent actual public resources on it because he was during the beginning of the year. I mean that Gilgamesh has prophetic dreams and epic Gilgamesh. And I mean that in around 860 BC, King Ashurbanipal II of Assyria built a temple to the god of Mahmud, who might possibly even be the god of dreams. And there's even a compendium of 11 stone tablets, the Istar Zakitu, if you want to think my pronunciation right, which has to be wrong, which uses all kinds of fun, funny language to help you divine the meaning of dreams in the same kind of like casual, half literary, half amateur, psychoanalytical way Jesse kind of does. And to give you an example of what I mean about these little sayings, here's something Jesse to me right now. Here's the first one. So you can kind of discuss if you think, sure, this is force speaking like you are incredibly lucky. No, next one, no, the next one next. If a man dreams he's eating a raven, he will have income? Yeah. So if a man dreams he's eating a raven, he will have income, right? He will have income? But that doesn't make sense in our language, but if you look at the translation for raven, you see that the translation for raven is argu, and you see that the translation for income is ear. So it's like it rhymes in the actual language, and it's like a fun, it's got like a fun tone, right? So if the man dreams is eating a raven, if the man dreams is eating argu, he will have guilty, right? That's kind of what the Bible is, right? So here's another one for you. See if we can pull out the meaning of this one. Which is to read. If a man dreams he's eating human flesh, seru, then he will have great riches. Sorrow. So basically the same message as the raven message, but this one just has a different point. Maybe it means that if you eat anything, you get rich. Like maybe eating means gaining. I don't know. But we can test that theory with this last one that's to do, which is a little bit. If someone has given him wood, you shall have no rival. Again, it's just a play on words. It's another thing. If you're Liru and Maru, it's like, okay, cool. Yeah. If someone's given him wood, you shall have no rival. Alright. So so it's like, this one is not so sensical. It's more of like a guide. It feels more like, almost like tarot, something like that, where it's just a little bit more like, this means this. And here's like the ways that it can mean this, but like, there's not really any logical system behind it beyond like my own interpretation. Exactly like that. It's like there's logic to it, but it's not necessarily tied to some rubric or something like that. In other parts of the world, we know, like for example, that the Bible has cases when everyone's in it, like when Joseph, as in the dream code Joseph, dreams of the future, interprets the Pharaoh's dreams, right? It's kind of like in romancy. Or when Joseph, as in the Genesis Joseph, is told not to be afraid of marrying his wife Mary. He's being told about how the future will be for his dreams, right? If you want to get even more obvious, in ancient Greece, referring to the necromancer Termidorius' 5-book treatise, Oneiromancy, which he wrote sometime in the 2nd century AD. According to Wikipedia, quote, the first 3 volumes were intended for the general public, providing an encyclopedic treatment of the subject matter of dreams. And the remaining 2 volumes were written for private use of the author's son, the novice dream interpreter, which sounds honestly like the first act of the Doctor Who episode, but I also just love it as a detail because I love that there's like a trade of like dream divining and there's like You might be like, oh my God, you must know how to interpret dreams. Which to me means you took it fucking serious, right? You know what I mean? Like if you're writing your kid a book, you believe this shit, right? So maybe that's something to consider as you go forward. Here's the first of a couple quotes from this guy, Terminator's, and I'll have Marcus read for you. First quote from him. I did not rely upon any secret theory of probabilities, but rather on experience and testimony of actual human. Yeah, so he seems like I said, he kind of it does not seem like he's like a scam artist in his positioning himself as a dream diviner. Like it seems that the people in his culture take this to be a serious thing. According to experts, one thing that was interesting about this book was that it sort of allowed for like the theory in it allowed for various people's lives to have an effect on which symbols stand for which things in their dreams. Like like fisherman's Shakespeare, the ocean themes kind of deal, which I think is like pretty clever and insightful for somebody who is working with so little modern knowledge. And in the Portrait to the Sun, he explains that learning as much about the subject as possible is key to good dream interpretation, and that leaning on how they feel about every separate element in it is the path to understanding their dreams. Which honestly, I feel like Jesse is like pretty much along the lines of what your theories from children dreams too, right? I mean, yeah, for the most part, like, you're not like, oh, a raven, you're getting rich, too. You're like, well, what are you? You're fucking security guards. Maybe the raven means, outside the security building. You're trying to tell a story. You're trying to profile. Right. I mean, obviously, you don't have Arby, so you're not giving that movie. Yeah. If you want that movie, you don't get that Arby. That's like dream interpretation. Like that living bird, if you want that much. But like I said, the first 3 books are, like, for everyone. First one's about the body. There's a quote from it, and Marcus giving an idea of the type of stuff that's in there. All tools that signify things and acts, signify disagreements, factions, and influence. Tools that single out surfaces predicting end-to-end. He's still saying that there's like rules, like he's saying like, and this is something that we often talk about when it comes to when we dream of us as kids, we're like, oh, we're talking about childhood cycle and stuff like that. So like he's providing room for anything that cuts, maybe like I said, like somebody who's a fisherman might have a fish knife, or somebody who's a warrior might have a sword or whatever, right? Like they're all things that cut. So it's like that's kind of the vibe. The second book is about natural objects, animals, and the weather. And here's a quote from Marcus from chapter 12 of that book about how animals should be treated in dreams, which I love. There is an affinity between all wild animals and our animals. The wolf signifies a binding. That's the case that we need to not openly, but with that we will handle. Any animal you see is like a symbol of what's against you. Just like and the third book is miscellaneous, so Wikipedia has no quotes. But they do go on to explain that there are also 95 case studies in real life that have the dream predictions actually came true. So, do with that information what that will as we move into our next short module, which is called Oneirogens. So first of all, what are Oneirogens? Going back to the Greek, Oneiro again means dream, and gen here means to create, which in the case of the word Oneirogens refers specifically to substances or stimuli which are meant to produce or enhance dream states and dream consciousness. Which, according to Wikipedia, is, quote, characterized by an immersive dream state similar to REM sleep, which can range from realistic to alien or abstract. Right? Now, I want to make clear, according to the Illuminati official, this is an offshore module, but I decided to include it anyway because A, it's short, B, it's interesting, and C, there's a fun, completely surprise payoff from the last episode that we're going to get into right now. You have no idea what it is, and that has not been mentioned at any other point during this episode. There's literally tons of Oneirogens out there. There's mudwort, binaural beats can induce dream states, Mexican prayer, meditation, sleep deprivation, the African dream being.
What, the African dream being? Is that the cousin of the Boston dream being?
The African dream being but like which one? The ones where it's like, or is it like, and which one? I bet you both are useful. I bet you both are useful, but I bet you can literally find if you went on YouTube right now, like, success words for good ideation and routines. What about like Pokemon card openings, like pack openings, ASMR? Like, do you think that could unlock like my mental capacity?
For the first time, ASMR just worked out.
If you're talking about the dynamic pretty correct, if you are like Logan Paul and you visualize the Charizard card as like the pinnacle like all luxury items, right? Maybe that does mean that to you. You know what I mean? Maybe, but also, what if it's just like saying the word Charizard unlocks the fire thing? Are you talking about like a pragmatic, literal level? I don't know about that. I don't know about literal, but I mean, in the real world, I see you. I don't think that answer is good. I know maybe Memphis does, and give it a shot. I don't have to vote for fun. I don't think it doesn't vote for fun. I can't get no, you're right. Sounds like program. You're right. It sounds like an amateur phone sex operator who has a line that he runs from like a sticker that he puts on a whole himself. Yeah, no. For that party line, it's me and that commercial with Kate and Ross. That's trivia. It's a little cute. Anyway, African dreaming. But the one I wanted to touch on first is the one we started with the bit last week. So let's start with the total surprise payoff. Here's a little asking you shall receive. Salvi did an update for Jesse to read. And a friend of the show whose user that you may recognize from another episode we did recently where Jesse and that post right here. How Salvia interacts with the brain to cause dissociative hallucination. A very brief explanation by Powerfest the Great. Hello, my fellow Childrenauts. The most recent episode of Training Days Part 1. The boys ask what salvia does to the brain and makes it so damn crazy. To put this down into easy to digest form, I'm going to talk about two key players in the brain on a person just salvia. Salvinorin A, or Sal-A, and the kappa opioid receptor, or KOR. We sound like strong characters. Sal-A is a psychotropic molecule found in salvia divinorum. Take down the firewall, Sal. I can't do that for you. Take down the firewall, Sal-A, or I'm going to call it Sal-B. And it's similar to other hallucinogens, such as DMT, psilocybin, and mescaline. However, it's interestingly different from these other hallucinogens because it highly prefers to bind to KOR versus other opioid receptors. It isn't an alkaloid due to its lack of nitrogen, and it doesn't act like other hallucinogens, which act as a serotonin antagonist. This means that Sal-A doesn't cause hallucinations by other activating person's serotonin response, but rather through a more distinct molecular pathway. These new properties make SA's effect so different relative to other psychotropics. How Sal-A causes its intense hallucinations is still unclear, but there is evidence that KOR regulates dopamine transmission by indirectly increasing the uptake of extracellular dopamine. This happens because KOR and dopamine transporter happen to be next to each other on nerve terminals and exist as a physical complex. Hi everyone, hi, it's Jesse Fox. You gotta help me. Please reread what you post. You gotta help me. All day today, Alex is like, here, read this, and words are next to words that shouldn't be there. And I gotta read it, and I'm doing a thing, and everyone's gonna be like, doesn't know how to read if you're doing it? That's what you're saying to me. Help me out, guys. This is Patreon.com/swimmerbar. So everyone know that Jesse's not illiterate. We can really use that. Like I am. We can really. Every time we find a read, they give me the one that's like words that don't even got words, bro. They don't even have meanings next to things. And I'm like, what is going on? Any little bit helps, guys. Patreon.com/swimmerbar. This happens because core and dopamine transporter happen to be next to each other on nerve terminals that exist as a physical complex. This means that when cell A bonds to core, it affects the function of dopamine transport. Research in schizophrenia has shown that high levels of dopamine in the limbic system plays a major role in hallucinations and delusions. This is confirmed with treatment of central dopamine activity blockers, which reduce hallucinations. While the nature of cell A in the brain is unclear, we can postulate that it may induce a brief psychosis in the user by binding to topic horror and temporarily flooding brain with dopamine. During this dopamine overload, the user experiences intense hallucinations until the body is able to bring everything back to equilibrium. There's a lot more on this topic, especially when discussing core and its role in consciousness, addiction, pain, and overall role in the brain. But I want to try and keep this post on the shorter side and not lose myself doing a deep dive while writing it for you. And I do want to say that other than a few typos in the grammatical type, this guy really put in the work to write a nice little thing for this. That was suggested. It actually has like peer-reviewed sources cited on the actual post. And I'm a former teacher. I appreciate it. Yeah. However, I'm talking to Chris. That's like this is like an 89. I'm not going to even get it. Yeah. It's an 89. I get it. Good work, people. I get it. But they are gentlemen and stuff. I think, I'm not saying otherwise. I'm just saying. That's just in my script right here. I'm just saying. You're going to get a 3.0. You're going to get a 3.8. Yeah, maybe you graduated. You're getting out of school. Yeah. She's out of college. Yeah, you graduated. But you know I got some points. Yeah. Yeah. You do better than the core post, which is all I can ask. It is a ball. Also, as a follow-up, here's a post from Mathis Tariq from the 2005 Streamer.org forums where user Mr. Molotov of the Ganja Patrol actually reports a case of salvage of norm causing a case of accurate onaromancy, okay? So, time out. Before you post this, before you give it to this man to read, I need you to know, Marcus the Great, that the bomb patrol guy, the Ganja patrol guy has better sentence structure. I was so disappointed in the world. Yeah, I was so disappointed. Don't worry, your worldview will live another day, Jesse. Your worldview will live another day. Here's Mr. Molotov of the Ganja Patrol. Now that we know what salvage does to the brain, we can consider that during this experience, this man was having what's likely a dopamine overload that was so extreme that it's like completely dissociative. Like psychosis, what he said, right? Yeah. So here it is that, I smoked a huge bowl of myself, 20x stuff, and and it said the premonitions about what would happen this Thanksgiving. Well, two of them came true. Someone ran out and got messed up. Jeff left me in a strange because he triple succeeded and got in the scooter, crash and burn. And then I had visions of my Jeff bleeding out into my arms. And the next day, both things happened. It's symbolic, yeah. Hey, if you ever have any kind of experience, it's intense. I was in a bathtub. I felt like I was pretty crazy. And these beings were trying to get me out from the bath, but I escaped from the door and found myself playing a couple blood that wore off. The only thing I hate myself, it's expensive. And the smoke tastes like shit. He did type out black. So just the outlet. This guy did a hit of salvia. Had a hallucination of someone riding a scooter, crashing and burning, and then saw his girlfriend fade out of his arms. And then the next day went to Thanksgiving and crashed on the scooter and his girlfriend broke up with him. I mean, that's certainly an interpretation of the dream coming true. Like, on the one hand, you can go online and you can write anything down. Yeah. But on the other hand, like, this is a forum for drug users universe, like this guy's going to write this. Like, it doesn't really make him look good or bad if he probably got hurt. It seems like he doesn't have a girlfriend anymore. I don't know. I think there's something interesting about that. Like, if we think about it in terms of, can you have so much dopamine in your body that you start to predict the future?
That's why I have ADHD. Prevent me from predicting the future. So the dopamine is really binding to its right place. What ADHD is, Jesse, if you have ADHD too, we're just both suppressed oracles.
That's not true. I make predictions all the time, so I can be correct. If we're talking specifically about Star Wars, maybe I'm like a genius in all geniuses. But here's the thing, I didn't dream it. I just used context clues to guess it based on what I knew. Same. Absolutely same. Yeah. I know how to write a story, so I absolutely am like, oh, that's me too.
And you also know what corporation they're trying to do.
But I'm not going to accept if you call me Cox. We can make this happen. Me and my mom both had a dream one time that our friend's mom died on a cruise ship. But it didn't happen. So I don't know. But that happened one night. I don't know. But before we move on to the next module, just because it's so fun to me, I really, just for a second, I want to go back to the African dream beam for a second. I'm going to show you a picture of it, and then I want you guys to let me know how it rates compared to what you were imagining. But first, here's a quote from the comments of that picture for Jesse to read from user Douche to get you ready, to get everybody ready for what we're about to see.
Maybe the African dream beam is what the English sees when it smokes something.
Maybe.
Or it smokes illegal nuts.
The best part about this is I just noticed it was so high when we posted it. I gotta get you 2 shots of it. So for a minute, I thought I was browsing all our stuff. What is this bug? It was good. Alright, so that's Steve Schnauzer, and here's the African Green Bean. Let's keep them what we're looking at here. What we're doing. Oh no, I see this. What is this bug? Is hilarious.
That would scare the fuck out of me.
Yeah, I would be terrified.
Because it's like, hey, 4 foot, maybe 5 foot tall, giant looking like green bean.
Yeah, imagine a green bean, but it's the size of a human.
You know, what are those things called? Trilobites? Those big, like,
Imagine a teapot that's round inside of a
yeah.
It's huge. And now, this is the Median Tata, I think it's what it's called. Here's the user testimonial from user Lambda on the effects of the green beam from 2018 for Jesse to read from a very interesting website that I recently discovered called arrowwig.org, where people post their experiences with various substances for a cause somewhere between science and downtown journalism. So here's a little piece for you, the guy who tried the African dream beam. I received a freebie of 40K and 40X extract and Tano reading powder in a package that I ordered recently. Decided to give it a shot last night. I haven't had much or any luck with, how do you say, onoregens? You've been saying it all day. Onoregens. I was going to word in this one that you just need to sense it. Okay. In the past, most words, I see, both sweet and bitter, all did very near for me. However, with reading, I'm willing to concede something's going on there. I haven't had a recallable dream at least a month, maybe not. And so the dreams I had during the night took some shortly after placing, I felt a little strange. Almost like I was entering into a waking dream, but I was still fully conscious and capable. It could have been placebo, but it's not. I had some trouble actually getting to sleep and lie in bed for an hour and a half before night. That's when I sleep with intense, somewhat disturbing dream after dream after dream all night long. Finally, the most disturbing and vividly recallable dream I had was an alternate hell version of this universe. I lived in a suburb in America in an extremist group that was like a combination of ISIS, neo-Nazis, and KKK informed. That's like a lot of varying degrees of what it says. And torturing black men and cutting off parts of them and forcing them to be naked in public. They broke into homes and took people in the night. I had a black friend in the dream, so they wanted to kill me too because they thought I was an M sympathizer. They broke into my home and I hid in the garage under a blanket of dark. When I woke up, I wasn't super scared or sweating or anything, but I was like, what the hell was that? Honestly, appropriate response is never really a dream. And really, despite the certain dreams, I felt clear-headed and calm. The next morning, I felt and still feel a sense of light euphoria, energy, clarity of mind, and enhancement of color. When I went outside, the colors in the grass were in mutual confusion. I could see the blues of the grass so vividly. It's a beautiful day. This could be due to finally having some powerful dreams, which I've been lacking for a long time. A good night's rest does that a lot. I just want to point out to the record, this is fascinating. When it says I saw the grass, I saw the blues, it makes me think about in the past. This is not related to dreams at all, but the color blue was non-existent. It was the bluest of the color. It's like an unnatural color, right? Basically, in the past, our ancestors saw everything that would be like in spectrums of greens or shades of greens. And blue wasn't a thing until I guess someone made it up. I don't like there was no blue sky. Like blue wasn't blue was a made up color that I guess always existed, but people just saw it. Honestly, don't know. Look it up. It's like a shade of green, maybe. Yeah, they always thought it was shades of other things. And so I love the idea here because you can see the blue so vividly. It almost makes you think something got high. It was like, whoa, there's another color, guys. See, that's blue. Oh shit, that's a new color. Yeah, I don't know. It's super interesting.
The feeling of afterward is familiar to our couple coming off of Western. Similarly, you have like for a couple of weeks last week, like a clear clarity of mind feeling very good. And like I could see the forest in the trees for a while. I would say the color enhancement was genuinely the trick. It didn't really happen. Yeah, but everything felt more saturated when I was on the side.
Like HD sunglasses vibes.
Yeah, I literally just sat outside for a couple hours and just enjoyed like looking at like I noticed like moss on my fence that I hadn't noticed before. So it's very like yeah, that's very familiar sounding.
Yeah, I like that. Well, do you guys think it's possible that diseases can affect your dream state, or awkward behaviors, or possibly allow you to see visions of the future? I don't know about that. If so, if not, how do you explain Mr. Molotov's Thanksgiving? Like, assuming he's telling the truth, what happened?
No, let's even go through it. Like, I'm not going to say no fully because of the countless studies that have been going on with CIA and FBI doing like the viewing and like all that other stuff, and the results of the body overall were always very new and fascinating. Like, they would this a group would be right like 67% of the time, which was not enough to be sure of what they were saying, but then right more often than wrong. There's a lot there. What it means, fucking knows it can be nothing. It could just be. I don't know, beyond me, that's everything. But I won't say fully no. I won't say fully no. It's impossible.
Right. I'm not with that. Can I ask a question about this? Did you post this one? This one was from 2018. I mean, it's still contemporary. One where I was like, I feel like there was a lot of stuff happening in 2018 at the time. It was very like on his mind, white supremacy, you know. Yeah. So not much different between that and in terms of things getting better. But I think in 2018 things were pretty, in the national conversation. We got run over at a it was bad. You don't forget, it was pretty crazy. It's still crazy, but it was like COVID and got even worse. Yeah. Have you guys ever used binaural beats or meditated to induce dream state? Or did you notice anything different about it? Like, do you think it implies that there are different mindsets that can create different things? I don't know. What do you guys think? How do you think it works?
I mean, like, I think it's deeply, like, I've heard that binaural, I know that stuff like works and meditation with like guided meditation stuff can definitely change how. I mean, there's already just different types of meditation alone that can do achieve different things. And meditation is like very real. So yeah, I think it has to do with. I wouldn't put that in there. Like, yeah, very possible. What's happening? I don't know, man. Because like most of my research in like that world of like the idea, like, you're talking about the ideas, like, in a scientific sense, I think a lot of the theory is the brain is a consciousness generator, essentially, like a radio dial. Our consciousness is generated through our brain synapses and stuff. That I think people are when the brain is more of a receiver for consciousness or whatever it is, and that's why we can't figure out where it comes from.
I don't know that answers the final. Like, if you go to YouTube, right? There's videos on there. It's like this one not yet so good with these video dreams, and I never did them because I'm not gonna lie. It seems like a scam. Oh yeah, first off, definitely, but more importantly, every time I'm like, they're trying to brainwash me. Every time I think that way. I'm like, yeah, I want you to have access to my brain. But maybe that's the vibe, is that you need your apes, get your apes. You need so there's like, I wonder if there's a thing about brain waves and then the audio waves of the vinyl syncing up in a way that it lowers your heart rate, like makes you more calm and lets you can sleep more. I feel like that's at the base level what it is, but honestly I don't know anything about it, so they could be giving me the vibe for ape in this case. It's terrible investment.
It's interesting too because at least with psilocybin, what it does with the brain is, when they believe your personality, who you are, they find that part of the brain and make your activities with that area. It's more active than the rest of your brain. I know obviously it's way more active, but with psilocybin, especially if you do like a higher dose, it brings the activity of that brain down to equal levels with the rest of your brain, and that's where people say they feel that ego thing, where they feel like they want everything, they don't really feel like they're an individual, everything's collective, and then it kind of reboots it essentially when the psilocybin goes off. You see that typical slowly come back, and during that is where they say the neural pathways are stimulated during that, for like scientific purposes.
That wouldn't be the same thing with something like salvia, which is flooding you with dopamine.
Yeah, does it bring that activity down though? I would imagine flooding with dopamine wouldn't.
I don't think if it's just flooding the dopamine, that's not messing with the neural pathways. That's literally just like,
That's what I'm saying.
I don't experience anything, and then it's
So
just
like the guy who represents more of a psychotic break kind of feeling, and I think it's psilocybin. Just different. But do they achieve the same thing?
I would assume not.
Yeah, I don't know if it's necessarily the same thing, but if that's the organ that it's affecting, right? And it's interacting with the rest, and it's creating all the experience of the same future. Yeah. Would you guys ever do it? Would you guys ever try like the dream bean or the final, like, I would take a full episode. I propose this to you all there. Yeah. The three of us in a room. We just get on the drugs, film it all, put out the episode, and explain the stuff we saw after the fact. We do like episode 1 or 2. Oh, this is the thing. This is exit. Yeah,
And then we just do it, and then we have like, alright, so here's some conversation. Guys, I saw a dog. You told me. Alex is dead. We miss him. Yeah. Alex killed in a freak ham accident. He walks into a door that wasn't there, but he's gone in real life. And one of the things we brought from the other world is still on the table. We don't know where he is. He walked into the reality which we were not in the face, abducted by aliens. Finally got what he wanted. Sadly, I was left, me and the dog at home. I've done missions twice hoping to see aliens. Instead I had emotional journeys and not what I want. Maybe that's the alien, bro. Maybe that's the alien. Oh, shit. Oh, fuck. The alien was the emotions we had along the way. I'd also be down to do something along the lines of like we all try to make like a kind of meditation for a month, and then we do like sort of like like in the idea of like doing things that are paranormal or supernatural is interesting. Sure. Like, do you think that you guys would be more convinced that dreams can have a potential with more concrete, well-documented behavioral examples? Yeah, I mean, we would need it, but how do you prove it other than like that having dreamed it before? And how concrete? Well, luckily, that's exactly the topic of the next module. We're now announcing case studies in the field. All right. Yeah. This is a list of real-world 2013, an Italian woman who went by the name at Yolanda de Mena on Twitter tweeted this, which Mathis will read for us now thanks to Google Translate.
My boyfriend woke up last night at 4 a.m. saying he had dreamed of a new pope called Francis I, and that today Benedict will resign.
So that was on February 11th, 2013. The tweet was deleted between when I started researching this episode and when it's when now, but I did have a LinkedIn tweet at one point. But it's gone. Pope Benedict announced his resignation 17 days later, on February 20th, 2013, and it was indeed succeeded by Pope Francis, who was born George Jorge Mario Bergoglio on March 13th, 2013. Giuliani agents included an addendum that, according to Business Insider, a lawyer named Christopher Connors bought and launched the website PopeFrancis.com 3 years earlier in 2010 with no explanation. But today it looks to be some kind of dead redirect to like a Vatican City URL. So IBK, or is that what .va is?
I don't know what that is.
That's your .va is .va.
Yeah, that's everything. I guess too.
That's what I'm assuming, but it could be like fucking .Virginia for all I know. I don't know. They got me back up, bro. What do you guys go up? PopeFrancis.com. You guys gonna get their site too then? Because it says his name to me as the other, but it's a different website. Yeah, it's not really. Oh, hold on. I'm in. Not secure.
Because Vatican.va refused.
What do you got? You got something different?
Well, I got the top some things that not secure, and that's at Vatican.va.
Well, the top says Pope Francis, and it says the Holy See. Yeah, exactly. I don't know what the hell. I don't know what the hell this website is. I don't know if the same website was there. But what do you think about this? What do you think about this tweet? It's real. I can verify this tweet is real. I mean, I'm looking at the Vatican.va doing some real website. I think. Well, I just mean this person said, my boyfriend woke up at 4 a.m. He said he dreamed of a new pope called Francis I, Benedict's going to resign. And that happened. Like, that's too specific to be just a pure guess, right? Like the fact that he pulled the name out, that it's going to be Francis, right?
The only thing I can think of is, I'm not talking about a step aside. I would really think to explain the way. There used to be a Twitter account called something or another. And they had a bunch of old posts that predicted things that would happen. But it came out that you could, some weird back-end HTML or something, you could like adjust it so that the date was changed. Date was different, yeah. Than what you actually posted. Like you could manually do it and click the site to provide a different date.
I'll say this. I went to this tweet. I saw this tweet on Twitter.
It's the same. The tweet would actively say the date underneath it, even if it was wrong.
Oh, well, okay, but now it's gone. Yeah, the tweet is now gone. But I did physically view this tweet on the website. I can go. So it's gone in the last few days. I don't know about the last few days. It's been a couple. A couple months somewhere in there. You know, I gotta work on all my episodes at once, so it's kind of random.
So, past couple months is still pretty recent. Yeah, it's weird that it got back.
Yeah, so that's one. That's one weird dream thing that happened. Up next, in May of 1979, an office manager in Cincinnati called David Booth had the same dream 10 minutes in a row of a plane flipping over and crashing into the runway in flames. At first, he just thought it was weird, but after happening so many times in a row exactly the same way, he actually contacted the FAA, who apparently took his description seriously and narrowed the craft down to either a DC-10 or a Boeing 727. But since he had no dates or details besides that this crash was going to happen somewhere somehow, there's nothing anyone could do, and it had its last nightmare on May 24, 1970. The next morning, on May 25th, minutes after takeoff from O'Hare Airport in Chicago, American Airlines Flight 191 crashed after one of the engines came away from the wing, damaging both the wiring and hydraulic systems of the plane, and the pilot lost control. He watched this unfold in horror from home in front of his TV, and he was investigated several times by the authorities for making a prediction, but was never a suspect in the crash, which was later attributed to sloppy maintenance. Also, preliminary agents include the addendum that Lindsay Ratner, the actress who played Bionic Woman, and I think also the president from Death Stranding, if I'm not mistaken, was supposed to board that flight, but went home from the airport with a horrible stomach illness before she did, with tightness. And apparently, when she got in the car to leave, she was immediately fine. JFK on the plane, and he got 4 in it. What do you know that? I mean, it's pretty weird. Yeah, I mean, I guess the flip side needs to be what about all the other people that died? Maybe they didn't have dreams about it, right? Like that we know of. I know also, this is something that just caught to mind just now, that I believe Seth MacFarlane, the Family Guy guy that was supposed to be on the 9/11 plane. Yes. Yep. That's true. He just like, dude, he's like, felt like he shouldn't go, or he like missed it for some reason. Yeah, and it's like, he was doing this new synchronicities. Yeah, I do want to point out Lindsay Wagner was awake and not asleep at this, but the guy had between 10 nights in a row with the 10 nights leading up to the crash. That's pretty crazy. So he was upset about it enough that he overslept due to it. He overslept due to it. McFarlane? Yeah. So not the same thing. Not on narrow means. But still. He did. And the last example we have comes from October 19th, 1966. Errol May Jones, 10-year-old girl in the Welsh Mountain village of Aberfan, told her mother, and I'm so sorry for this, told her mother that she had a horrible dream where she found out that her school was gone, and in its place was just a big black pile hovering over Houston. And apparently in the week prior to this, she had also mentioned that she wasn't afraid to die because she'd be with her friends Peter and June soon, who had also died young, scaring the shit out of her mom. Unfortunately, 2 days later, on October 21st, 1966, was the Aberfan mining disaster, which you might have thought of the moment I mentioned the name if you're from the area that happened. Basically, a colliery spoil tip that they'd started, which is basically like mining waste pile, slag heap, that they'd started back then, which on the mountain 8 years earlier got saturated with water and slid down the hill in a slurry, killing 144 people in the village, which unfortunately 116 of which were children. Because right in the tip's path was the Pathless Junior School where Errol died in class. As a horrible addendum, the Chilingani agents included the Errol School had sent a petition to the National Cold War 3 years earlier, complaining of the danger, and it even slipped once in 1965, but nobody was hurt, so nothing was done, and it was never investigated, because it would probably end up closing the mine. Anyway, capitalism kills. Next sponsor. Safety is way. Yeah, I mean, and if I've been totally super about this, like the story of these girls, like heart wrenching and stuff, it could be, like part of the message of like we should have done something about this earlier, because that turned out being, it ended up being quite a big thing. This stuff right here that they didn't do anything, and it was like a whole big scandal and all that stuff. Yeah, so maybe this story of her having this dream of dying and being like excited to see her dead friends and stuff is like part of that, could be, but I don't think so. I think this is just like a weird, scary sort of some story that has happened this, because there's always sort of weird paranormal super disasters. Not aside, people always have this sort of like dream-like moments in the time leading up to disasters and stuff like that. You always hear stuff like that. So I don't know. In this case, it's a dream that's like that. I've heard plenty of things like this. To not totally ignore the notion of some dreams. That's the best I can say. But man, what a fucked yeah. The next module is kind of more like a workbook type thing for me, but I think I did a pretty good job, if I do say so myself. This one is called, I don't know how to say the title of this one, so display it. Basically, the Illuminati revealed to me that they're a huge fan of dreams. That's the big thing. They're really interested in dreams right now, as you can tell by their human tastes. But more specifically, they wanted to present these next 3 accounts of dreams from ourselves, aka, because I promised that I would do some dream interpretations in the dreams episode. AKA people that they've identified, these people that the Illuminati have identified as potential Illuminati. I think this one I put the guys upstairs. That's tough. That's really off. They need to work on that. Illuminati. 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 Right, no, it doesn't make it good. Dream sailors and the Illuminati. Yeah, this is real. Let them know. I'll take over the punishment, but I disagree with say this is real. It's something that I agree with you on. And then, so they wanted to potentially, they wanted to see what we thought of their potential truly not cameras. And they also want to ask Chelsea to interpret the dreams now that we've learned so much more about the nature of dreams and and pondering some of the mysteries of dreams. And maybe, I've learned a lot today, I'm right. Yeah, and maybe incorporating the idea that maybe dreams could possibly be literally connected to reality in some way, maybe in some way, we don't know. In some sort of quantum way. I'll do it. I'm honest. I got it. First one is called Dream Telepathy. It's from a user called ROTHSCHILD, who, in full disclosure, may be engaged to. But she finally caught up on all the episodes and actually just wrote this naturally after listening to our last episode. So I'll speak to her. Here it is.
Listening to the end of this man part one, I was thinking about a weird dream experience. In my dream, I saw my brother at a funeral and he was crying. I didn't know why I couldn't get closer to comfort him, and I had to stay at a certain distance away. When I woke up, I felt like I should calm because he was too sad, but when I did, he told me he was all fine. I told him about my dream, and I got really freaked out. He told me that the same night, he had a dream where his friend's dad had died, and he had to go to his funeral. In all reality, the person in question was fine, but it was unsettling that I had seen the funeral that my brother had dreamed. I can't explain it, but this same thing reminded me of this, so I'm not sure. Have you guys had anything like anything?
And other than that, one time when me and my mom were like, jump down the cruise! And we were like, what cruise?
I think it's cool. I definitely remember having, when I was a kid, it used to be, I mean, my mom had said that show a couple similar things about my grandmother who was basically talk to us. This is post my grandmother. So I was like, no, my grandmother passed when I was 8. This is probably like right around 8, 9 times, something like that, just a couple years afterwards. Nothing, just like talking, checking in on them, making sure everything was good, and that's how it was. I don't really remember the details of it being like a pleasant kind of like conversation. And having that conversation with my mom and me, and my mom's like, oh, so did I, what are you doing? And, you know, it was just like a weird similarity, but also it could be that you just thinking about, oh, that something wrong.
Yeah, it's like, it's coincidental enough that it's significant. If something crosses the line with like, that's like a little too uncanny. I don't know if there's a feeling to it, right? Yeah, like, I feel if you dream about death, it may take away your breath, but if the subject is living, it won't forgive it. That's fucking good, dude, because that's from the fucking, I got that from Mesopotamia. Yeah, that's in the Mesopotamia dream book. That's pretty good. Yeah, yeah. You rate it. Really, money machine. Yeah, money, you'll be safe. And so you just need to modernize rhymes, but we got it. If you were just a raven, there is some money that you would be saving. Yeah. All right. So there you go. Next one comes from a user called Easily Offended Hero. Hello, today I had sleep paralysis. A few times in my life, and each time it was pretty scary. Not very descriptive in me, but today's experience made them feel like simple anxiety. Like it tripped on slightly around. In truth, today's experience was not only terrifying, it was also pretty weird. Normally, sleep paralysis feels paralyzing. You know you're sleeping where you are, but with some folks, they might see or feel presences or hear things that are generally creepy. Today, I became conscious of this during a nightmare I was already having. This started at my great-grandparents' house in northwest United States. The nightmare started off with me visiting them. I missed them, to be honest. They lived in a trailer where a regular house might have been. They had a stellar yard, fences all over to keep quiet. At the start, there was a group of dogs that looked like they were built for murder. Demon shit, honestly. They greeted me with barks that seemed normal enough, though, and I could see past the fence my great-grandmother, and I could see past the fence my great-grandmother in the dark of the door in front of me. I remember it seemed weird that it was dark in their house during the day. So I go in, the door closes behind me, and it's just dark. And then I found myself sleeping on the a dream, so my actions are thought out. I get up to look at their eldest bride. Okay. I did so for a certain amount of time. Obviously unclear how long, but then I heard keying from the bathroom. I got excited. Because I haven't seen my grandfather since he passed. And the scream was clearly coming from the standing position, so I looked over and saw the door. So the sorry was open. I started So the sorry was open to the bathroom. I walked over to turn the light on for him, but then the room was empty. No one was peeing. Scary, right? It was then I remembered that we were both passed on. And I remembered, and I'm in the East Coast. I could look to the back of the couch. Then I felt the presences that stole the images of my fallen family memories. I was awake at that point in terms of sleep paralysis. Awake in the way to know what's going on. I could feel my body. I could feel the desire to move a toe or finger, or even let out some of my voice to break the phenomenon. But the things that took the image of my family held me in the nightmare. I truly felt like I was in two places at once, experiencing nightmare and the paralysis. They were malicious. I felt angry. There was a hesitation in them to touch me, and when they got close, I could hear the dogs bark and they would stop. It made them angry. I remember feeling like they were insulting me, cursing me, that I was at fault for something I was in danger of. I knew this like how you know when you're hungry. They are meant to harm you. I stopped struggling to get out of it. I really thought I was going to die on my brother's couch where I was supposed to be at. I remember wondering what the cause of my death would look like to others. I wondered why they had to take the image of some of the only adults that were nice to me when I was a kid. I knew I wasn't truly nice. It wasn't truly nice. It was around then the dogs came up, most barking, one licked me, and then I was out of it. That place, I was still in sleep paralysis, not being able to move no matter how I tried. I could feel the light from the window and smell my sweat, but I was stuck. Their presence still lingered around, but less intense. A part of me worries I brought the nightmare back. But I felt confident and struggled to wake up for a bit longer before I actually did. I woke up by trying to kick as hard as I could, works every time after a few trips. I made myself some humor and to drink, and stood outside for a bit to contemplate. For me, the scariest part of this experience was the silence. A few times I had sleep paralysis, I could hear all the sleep, felt like I was surrounded by a crowd. This was an escape of two malicious beings. That said, nothing but gentle, edible evidence for it. There was no misunderstanding of what it meant. Well, that is the abrupt ending to my story. Thanks to whoever reads. Would love to hear any sleep paralysis stories for the boys or the sub in general. It's chill to read on the chill. Love the podcast. Dude, Alex, do you like this? It's chill to read on the chill. Love the podcast. Hope to be confused by Alex for. No, never mind. This is definitely someone who's good. Did I write this? Hope Mathis? Hope Mathis, Van Claps, Alien Cheeks, and may they be redheaded for Jesse, much like I do. Yes, what is your instruction? Bro, I was going to ask you the same thing. You wrote that on his own shit, but you were going to write when you were doing other shit. Yeah, you know, plus 5 points for that. Please understand. Well, what do you think about that? On the level of their demonic entities co-opting memories of his dead family members to suck his memories out? What are we talking about? I think we should be writing about this script for a different. Do you think he encountered a dream entity, or do you think he had a symbolic dream that should be interpreted? I think it's interpreted, and it's probably something from sleep paralysis. That's the second one. He said he got sleep paralysis in the middle of the night. Like he went from it being a nightmare to sleep paralysis. if you wake on the couch, your dreams are your couch. No, there you go. Okay. It has a slight message to it. It carries meaning. I didn't have much time to go on that. Yeah, Mississippi. You nailed it. I mean, you nailed it. You understood it. Very well. Precisely. It feels to me. This feels like the opposite of the story that I closed the pod out with last time. Where Grant Morrison met the beings from like the other kids that showed him how like realities are born from our own perceptions of reality. Right? This is this is like more like vampiric sort of entity that's like taking the reality that you made by like siphoning it out of you.
Do you think the DC multiverse is sucks?
I think that it might even be unconscious distortion. Yeah, I think the truth might be emerging from our subconscious in a way that is unexpected.
Did you see that it dropped like an hour, 2 to 3 hours ago? Did the Marvel Scorsese ad for the Super Bowl?
No,
It's about it's about aliens being in the skies above us the entire time, and us not looking up and being like phones, and at the very end, the whole thing is like a switch goes down. It's like reality that we make or something. It's all aliens, and it's all planes, and it's all UFOs, and it's fucking. I'm like, that's what Scorsese ad for the Super Bowl. Well, I mean, hey, all for first base, I guess.
interesting. Well, I got one more for you. I'm going to drop this one for the chief just because I don't want to this one. So there it is. Give it a read first, and then we can close out for you.
Leonard Cohen, so this dream might be triggering for some people. Just the heads up. It's pretty violent and graphic. Adding 18 plus characters in case there's some additional context, but I'll save it for after I share the dream, just so you can just so you get drained along the same thing. I used to have this dream about once a month for several years. It's very realistic. Like, it starts with me walking through a dark forest at night. I hear the sound of footsteps all around the forest, like several people walking through the dark all around me. I start to walk faster. The longer I walk, the faster and more aggressive those other footsteps become. At some point, it starts raining blood, and I begin to hear whispering from all around me as well. It isn't like a bunch of people whispering, just different insensible things, but rather like many people all whispering the same incomprehensible thing at the same time. The best way I could describe it would be like the hiss incantation from the game Control. Jesse knows what I'm talking about. I know too. Jesse, you. Then I just put it in running, and suddenly I can hear yelling and see flashlights pointing around in the forest all around me until everyone can recognize. Then somebody starts shooting a rifle at me. At this point, I burst out running into a clearing in the trees to see a huge dirt mound. I climb to the top of the dirt mound to realize I'm climbing over dead bodies. Then I see a grenade on the ground in front of me. I never hear any fire of the rock, but I feel myself get picked up off my feet and land head first on the mound of dirt bodies. The mound opens up and swallows me. The last thing I remember before I wake up is the smell of fresh grass and sound of helicopter. I always woke up physically shaking. I would have to sit on the edge of my bed and calm myself. The context, I have complex PTSD, and then later in go through this nightmare was a result of my abusive now significant other repeatedly poking at one of my very clearly established PTSD triggers on purpose to get a negative reaction. She sucked. The nightmare itself was just a whole bunch of fragments from different traumatic memories of mine holding together into one single Frankenstein's monster of the night terror, though I'm not going to go into much detail about my experiences. The lesson here is to be kind to one another, respect boundaries, and be supportive of those who care. If you don't, it can have some awful negative consequences for any relationship. Not that this girl ever cared about it. Oh, and don't worry, I'm doing that better now. I dumped that girl. She stole my PlayStation and sold them a I would have seen them get on the street. That's my PlayStation. But that's a whole other story. For those of you going through the aftermath of a traumatic experience, no matter what the experience might have been, just know that all the normal day-to-day things that seem much harder to achieve right now, will in fact get easier as you move slower and deeper. And it takes time for you. Survivor's Guilt got easier for me as I work to keep living for this. It gets better. Currently living with love in my life, and housing and supporting a relationship, and couldn't be happier. everyone. Wish you all the best with all team up. And yes, really fun to watch.
Yeah, so that's it for this episode. Patreon.com/SwimRunning Pod. I just want to say that I think this one to the end because I think it's a good illustration of kind of the point I'm trying to walk us towards here, which is just, obviously it's sort of an esoteric, sort of philosophical. I don't even know it's a philosophical so much. It's just like metaphysical. But like, we're talking about aliens, and we're talking about redefining aliens as beings from another reality, right? Or another dimension, or another plane, as Brush is starting to be careful to call that, rather than refer to them as people from another planet, right? And it just seems so interesting that, like, if you consider the brain and our imagination as like a way to travel through realities based on our own perceptions, and what our brain is as an interface with some sort of substance called reality, right? Like, is there much of a difference between, like, could aliens be in our dreams? Could aliens be dream entities? Could dreams be other realms? Could things that we make up or dream about or think of, like even the aliens in fiction, could they be subconscious representations of real aliens? Could it all just be one concept? Could the concept of aliens be aliens? Is that weird? Is it all aliens?
We kind of talked about in that kind of idea before, the idea that maybe they are on the perception of what is real, and they can create them, or they like use that as a way to like brain uses that as a way to like interpret. Again, like one of my favorite examples, like one of our brains built for Linux, and they're like on Windows essentially, and they're trying to like perceive whatever this information is, and our brain just does it the best way it can. And that can be fucking chaotic and broken.
Yeah, like an ant just can't walk up to you and like start speaking English, or even like ant-ease that you can't translate. It's not so simple.
Like, they have this big improvement, dolphins and whales who do have some sort of primitive and vocal communication. They can't just go up before children as to what the fuck that,
Is there a term for like compatible, like a sphere of compatible consciousnesses? You know what I mean? I can look at a dog, and the dog and me are like in the same sphere of compatible consciousnesses, in that like we both are aware that each other's consciousness exists. Right?
So there's like, because like, there's a recent study, and this is like 6 months ago, 6 months, that showed that even fish have a level of self-awareness. Like, yeah, I think there is levels of, I don't know if you want to call it consciousness.
I mean, self-awareness is one thing, but like, it's like,
I have to be conscious of self-awareness.
well, right? But it's also like, I can perceive of a dog as another living creature because of the way I see the world. Can an ant even, is an ant even aware that a dog exists?
I see what you're saying. Yeah. Because the dog knows that we are a living thing, we just think we're a living dog.
Yeah, like a dog probably has similar perception to us because we can kind of like perceive each other fairly accurately. It's like, I don't know, there's something to that. I don't know, there's something to that. I think that maybe like that notion of aliens will help us understand it better.
You're asking questions that you can't answer because you still don't even know what consciousness is, how it's getting later.
But that's exactly what I think this dreams angle is kind of interesting, because it's not really, I didn't do this to make an episode about aliens, I just thought it was interesting the way that dreams are kind of like this barrier between different realities in our own brains, and the way that quantum physics has sort of shown us that our brains and physics are more close related than we thought.
The multiverse storylines, the time walking in, you're all stuff.
Even just like Inception was like in 2010.
Yeah.
The way that we think about reality now versus the way we think about reality in 2010 is like totally different.
100%. It's fascinating topic that I'm not
Yeah. So, do you not want to hear the ancient Sumerian response to that dream, Alex? We're just going to move on. I was going to let you close up our episode. Really. Yeah. You don't want to say that. You don't want me to say me, the response to this dream about blood rain, and of course, I really want to see it. I want you to see it as the last one that we spent. I'm sure the wisdom is going to be deep. It is. Very deep. Oh, you want me to say it now? Yeah, we're here. This is it. I have nothing more to say. I thought you were going to wait to the end. That's what the H's mean. Fighting each other about what episode 8, H8airspatreon.com/295. Jesse, take it away. Final word. In the words of Gilgamesh, forests at night may give you a fright, and blood rain from the sky may lead you to die. But if your ex sells your PlayStation, run away without hesitation. Well, there it is. That's conventional pragmatic wisdom for the modern human being. From Gilgamesh. That word for word. Gilgamesh from Final Fantasy. It's in the saga. Yeah. Says that to Enkidu. Like, bro, she steals your PlayStation. Get out. Get out. Without hesitation. Yeah. Gilgamesh loves Final Fantasy 16 and thinks it's a great direction for the series. It's hyped to see innovation in such a stuffy old franchise. It's unfortunate for the kids who love it. That's it. Good to see you. All right. See you guys next week. We'll also do a mini segment. Anytime I come to you in the pod. Bye. Hello, everybody. Welcome to the G-Unity podcast. I was one of your hosts, Mike Marvin. I don't know who they are. There's two. One, I would say, Spencer. Leo and Trinity. I don't understand that. I don't know who they just got you right on it. There's two. Leo and Kennedy and Claire. You will tell. I think you know this with our famous duo. Ancient charm has been going through the lists ever since. I'm trying to think. Which one of you is, he is just Hello, everybody. Welcome to the GUINNESS podcast. It's always one of your hosts, Mike Marvin. Welcome back. See you. 27th, 2022. If you didn't notice, the theme of my Disney episode is that Disney is slowly convincing everybody to be unable to tell the difference between what's real and what's fake. I don't know if it's 100% true, but it seems to be working. I just put it that way. A website that I know quite well, Inside the Magic.com, a trusted video, video articles, Disney, everything Disney related website, posted an article entitled Disney Parks Aladdin actors are reportedly allowed to kill guests. And I'm going to quote you from the article for you guys, and that's stuff in context. It's recently, the cloud Disney Disney shared what is perhaps one of the most unique photographs in Disney Parks casting behind it. The stipulation reportedly applies only to the actors who portray Aladdin at Disney properties. For the post, the handbook's top safety section reportedly reads, quote, although we want every Disney guest to have fun, our number one priority is safety. Because of this, Aladdin will never under any circumstances kill a park guest unless it is absolutely necessary to save the lives of a greater number of park guests. This is referred to as Aladdin's exemption. Final Games decides Disney is not confirmed at any point that this is actually the document of the handbook, but it does seem like Aladdin's exemption would be difficult to meet. And that last line is a bit of that seems like a really crazy thing to do. And you know, crazy. I mean, with let's feed up the Taik by the yes, exactly. It's like which is the video version. Yeah, no, I don't think that either. Because it's sort of like fandom articles and stuff like that. And in 2015, 7 freaking years ago, they wrote an article that was called "This is the handbook each actor who plays Aladdin at Disney World is given." And it has a bunch of other things about Aladdin. Here's another quote from that same article that I just read about. Aladdin is the street urchin who owns a blue slave. He wears a tiny red hat and is extremely poor. When interacting with the public, Aladdin should always keep a cover and try to steal money/food by any means possible short of physical violence. Aladdin uses trickery and charisma to steal, not brute strength. Aladdin is Muslim, but not especially religious. What compared to rules, certain rules, if a park gets these eating food, Aladdin must always try to steal it from you. Aladdin thinks slavery is sometimes okay. But in the head of mind, all of the world is a magical illusion the genie created in China. Aladdin should never say, I want to eat my delicious monkey Abu. Even though Aladdin is always extremely hungry, he would never eat his food. If Aladdin is asked for his honor, he should approve an inspirational quote from the Quran beneath his name. Aladdin once rode on Space Mountain and thought he would be teleported to heaven. When performing alongside Jasmine, Aladdin should never kiss her or engage in any other type of physical affection because Aladdin suspects she's actually the genie in one of his many disguises. The genie wants to have sex with Aladdin to prevent her being enslaved. What? So this is the tone of the article that they took this quote from and made it into a word. This is just a trace the quote. The one that's inside the magic. Inside the magic. Literally inside the magic. It's the quote. That they quoted a 7-year-old Clipper article that says Aladdin is a Muslim and writes a Quran underneath his article. That's incredible. That's incredible because people are just so happy. That's not true. People are very fucking stupid. So please, when you read these goofy things with the types of things that you would talk about, you really do have to take them seriously. That's why we do longer episodes. That's the best I've done. Rather than being a researcher or historical documenter, is I'm unearthing a story that exists, that comes from a lot of different websites and things that make one big branching story like that. And it doesn't really matter if that story is true because the part that's interesting is just the fact that it exists and how it exists and why it exists. And we have how it would be angry. And those articles just like an edgy, article like this fucking shit is like insane. Like people, somebody was like, that seems pretty hard to make up. That's a good reason for your life. And it's weird. Like, don't do that shit. Like, don't do that. No. Jesse, why don't you take it next? Between two teams. Today I come very nervous. Because usually I come on here with some science thing, some type of nonsense. Today, we're going to take you to the Spanish internet. It's like the normal internet, but Spanish. Right. And over there is a video. The reason why I say Spanish anyway is because this article says it, and it was very funny. Is that like Black Twitter? Just imagine so. Yeah, I guess. Yeah, I've never heard of that. Yeah. Yeah. They have captured some sort of something crawling around on camera. They don't know what it is. This is simply sadly, the only video I could find that would let me link it to you directly is a TikTok, and it has some stupid voiceover on colleges in advanced YouTube. But what is this? Tell me what's this. It's not wasting time.
Okay, so I'm going to mute this at the top. Okay, there's a. It kind of looks like a Fresno nightclub. Initially, this is like a lump with two legs. But, okay, nope. That looks like it looks like a crawling. It looks like what on all fours. What? That's gotta be fake, dude. What? That's a spit and upside down moving face that's crawling like a crab. This is like Japanese ghost horror movie shit. It's upside down. What? It's like, if it is a person, it's like a person. It's pretty awful. Where is this supposed to be again? Somewhere on the Spanish internet. It doesn't say anything. It just says the first picture caught on camera, and then that's it. Now people are like, it's news their days rounds. So their day is they're crab walking to the children of the studio to tell us that they might be uploading. Damn, I got somebody told that. It's a weird video, right? Like, even if it's a fake fan-made thing, like, still creepy. So, it's like they loaded up that shitty Dobby video like 10 times. Yeah, I know other cameras fucking real. That's what I just said about news, but other cameras fucking real. It's uncomfortable, yeah. It's like, I love the comments. Here's one. The Duncan says, "But God, you will protect us all from all evil and danger. So this incident made life around the first two. So basically, it is a 3-camera angle video. Yeah. The first one, it shows you kind of coming from the right, and the second one shows you coming from the left. And it may just be a flipped angle on that one. I don't know. Or maybe the same shot just flipped. But then there's direct, directly on, head on to the thing. And that's where you see this like upside down fucking camera. Yeah. You can see the coming around the corner. At first it kind of looks silly, and then you watch it again and you're like, interesting. And the third shot is just like, I don't care if this is fake. That's some bullshit and shit. I don't like that. So yeah, I figured I'd let you do enjoy that. Hopefully it'll be posted over on the subreddit. I've watched it different watching it. Yeah, it's very weird. It makes me feel gross the more I watch it. Yeah, it's very strange. Yeah, I feel like it's probably like a person younger doing this would be like security camera data. I guess it's very the way she's posture is so weird. Even if it's a hoax. This comment sums it up perfectly. This is the dumbest shit I've wasted 5 minutes on. This is a 20-second video. You know what? I watched that shit like 15 times. That's what I'm saying, yeah. It's fascinating. You're just like, so I'm like, what is this? Science, I love government stuff. So, it's before we got this people that put things, you see that scientists have actually achieved nuclear fusion for the first time. This shit is with your engine is that you're going to get more energy back than you put into it, which is where infinite energy comes from. And they were, with the amount of energy they put in the molecule, they got a reaction that gave them more energy back, which is the first thing you can accomplish, which is huge for the scientific world. That's so awesome. And maybe the future of our entire species. So, yeah, whole species literally could like game time on that being, more of a happens. That's super cool. Another quick science thing is they refound the last known Tasmanian tiger remains. They discovered them in a museum. Because they were lost. They lost the Tasmanian. Oh, because it was in a zoo. And then it died, right? Yeah, it was in a zoo. It died in captivity in 1946. And the remains are gone. They found it. So now they can film them, I guess, if they want to. I mean, they technically could. That would be super interesting because Tasmanian tiger look cool as shit. Yeah, they're very weird. You can look it up. I like them too. Yeah, we're about species that have gone extinct in our own species of lifetime. It was interesting. I think it's so well. Yeah, I believe that. I don't know if I can taste the sweet, succulent dance right there. Yeah, you can eat one. That's right. But the real thing that comes through is that Congress passed their budget, which includes one of the largest UFO budgets we've ever seen. And I think we go over just like some of the stuff that it relates to. The fact that they're doing all these special projects with UFOs. And you talked about before, they have all the different scientists and stuff. Yeah, so this here is from the U.S. Senate today on the 15th, literally today. With 83 to 11 approval for the National Defense Authorization Act, the giant budget that they do every single year. The bill contains several important new provisions pertaining to what they now call unidentified anomalous phenomena. They call it area phenomena, which people have been reporting on since July. They include a new quote-unquote secure system through which people who work for government agencies or government contractors who have done so in the past may report what they know about UFO-related matters to the Pentagon's All-Domain Anomaly Resolution Office, AARO, without fear of violating classification laws and with protection from reprisal by any government agency or contractor. So if you go come forward with stuff, no one can be punished by or yelled at by the people who you work with, which I guess, is a beautiful probably for that. That's going to be a big watershed. Like, if that's really what it's been, this could be it. Yeah, this could be huge. Yeah. The other things of interest as well is that the information that they gather is being passed down to under the Professional Armed Services and Intelligence Committees and the top professional leaders. Another part of the thing that I find interesting, and this is what I was going to talk about, is the bill also included a mandate for a review of government archives on UAP dating back all the way to January 1st, 1945. So they are now re-reviewing. That's like when UFOs started to show up. That's like exactly when. And so this is being talked about kind of in a few different places, Black Vault and so on, which we talked about last week. But this is fascinating because, we're getting, again, like weird tangential confirmations that maybe people are being touched by, due to classification or what have you. The fact that they want to go back, if you look at every single report, starting in 1945, the day of 1945, weird. These are kind of weird for something that is supposedly just other aircraft that they promised us, in the article we talked about a couple weeks back. There's a whole lot of other weird shit that's going to be happening in the background still. So, I don't know, it leaves me still on that frustrating edge of like, what? But this is big. It's big for the budget, it's big for the protections they guarantee, and this is an interesting tidbits of what they're actually doing in terms of researching that. Yep, it kind of flips up. I find that fascinating and I love that. So I don't know, does it aim you in any particular direction? Do you feel like it nudges you further in maybe there is something going on that's not human made? Seems possible. It's a lot of people say. I know. And it seems possible. And it's so ridiculous and pointless to come down and definitively I'm not really saying, but like this, to me, this keeps me on the side of like, again, I don't know, but it feels like it's big
started to spend money in the past. And it's all sorts of stuff, right? I mean, that's what the Stars Academy for. I mean, they were working with that, and they maybe are. Yeah, there's a lot of weird stuff. The problem is that most of the time on that is like the goofy stuff, like the time they spent $28 million on green pattern camouflage for troops going into Afghanistan. Right? It's like, that makes sense. But then I'm looking for like what they spent on weird stuff. And did it work there? Did they do anything? Yeah, it's like how we end up with Velcro and things like that. Like spending on that kind of weird stuff. Even get the free shirts. You know how, Alex, trust me, do you know how they use those free shells? I do. I confirm by the regular now. You think you want it. It is 2 shells to pool, 1 shell to scoop. You're welcome. You're welcome now. That's all we need to watch demolition man, Marcus. That's all we need to watch demolition man. Well, you need to be on that movie, really. You all called everybody at some point. It means like Alex fucking saying what they were. Regardless, though, like, I don't know, this aspect of like the budget and like the protections and stuff doesn't seem like it's an investment in something stupid as much as like a continuation of what I would consider very slow, subtle heat exposure. Disclosure? Just the fucking Jesus Christ. Well, I think that this is, it's interesting that you're spending money on it. Would it amount to anything? I think, I mean, again, people who believe in like government cover-ups and stuff, spending money, hiring these people to come on, this could easily just be like, the courageous cover up that. Right? Who knows? They're not the little protections at the very least. Going forward, that's like, it's fascinating. Yeah, that's it. More interesting about their news, like there's a bunch of sightings and stuff happening. I mean, there's more of Columbia City, like fucking today. And then, so, go look. The news of those sightings have picked up, as I've been saying, for a couple of weeks. I wonder when we'll see them die down. But I haven't heard from that. I mean, that's what I want, is like, never, hopefully, go back to some things. But it's like, the Manchester is like, utopian futures. Whatever, just like on the Star Wars, I hope the Star Trek personality, Zeppelin complaints, Zeppelin that's me. You get to be Jordan LaForge, and I get to be, like, we're in the back seat. Yeah. Oh, yeah, dude. I love this one. Hey, Jordan LaForge, that's the best thing you've ever talked about. I like Jordan. He's such a like with the ladies. That's true. I know, Glenn Rogers helps everybody, and Jordan has a hard time with the hand. Yeah. I'm not. You're doing this. You think that's so much like more with us, and we don't need the ball. Thank you so much. It's good for Tom for sponsoring today's episode. Now we can particularly fun. Why is that? That's not even some type of creepy genre.
Boys, are you really crazy or what? 2022 is just enough time. We've got one more episode in 2022, and that's it. Well,
This one?
No, next week.
Oh, yeah.
Okay, yeah. And then that's it. We're going to 2023, and we start 2023 off with a bang.
A big bang.
A big bang.
What's the bang?
Super.
Oh, yeah. Is it a secret?
We can't hold on.
Whoa. We're doing a true crime thing. We're still in tackled the Alex thing.
He's the one who's going to say
We're doing a true crime last week. I'm doing that with like almost certainly as my next one.
We're not doing a serial killer, I'll say that. We're not doing true crime, but it's like similar to MKX style.
It's about those guys that cheated the Monopoly at Darwin's game.
No, we're using the 730. We're using the 730. I want to cut you.
That's gonna be great. Okay.
Yeah, that's gonna be full of really fun times. But it is, we're getting towards the end of the year, which means Alex bought us a list.
That's right. I said I did a green stone tease in the previous episode, but not that green stone, the type of green that gets you stoned. This is my review of Leafly's weirdest, wildest weed stories of 2022 by Bruce Barcott and Kendrick Downs, baby. So there's a couple of them. First one is Minnesota in July, or actually a little bit before July. They passed a law that they didn't realize legalized 5 mg THC edibles in Minnesota. They thought that it was going to be like, regulation law that kind of like made it harder for people to do it, but they actually legalized it. There's a quote from Senator Jim Abler, who said, "That doesn't legalize marijuana. We didn't just do that, did we?" And they did. And but turns out the whole government is in favor of it, so it's probably not going to happen. They're not going to reverse it, and then they're probably going to give the rest of it.
Taste of the tax dollars. I'm trying to get it from the road.
Yeah, they're probably going to go the rest of the way next time. Next story. Mike Tyson put out edibles this year that are in the shape of ears. Which is absolutely insane because he actually bit off his ear. He actually bit off Evander Holyfield's ear, and then Evander Holyfield turned around and licensed the ears, and now has holy ears as well, which are his version of the fucking ear gummies. So that seems like a weird fucked up thing, the GTA-esque thing. And then there was Louisiana Democratic Senate candidate Gary Chambers, who smoked a blunt in his ad because he wanted to show that he was serious about weed reform. He said, "Most of the people police arrest aren't dealers, but rather people with small amounts of pot, just like me." And then he fucking smoked a blunt in his ad, which I think is genius. No, Louisiana's a bunch of squares, you know? Yeah. Also, Circle K, for October, in Florida, they would have weed pickup kiosks at Circle K. At Circle K? Strange. I'm so afraid of Circle K, my friends. And, I guess this is oh wait. Then they canceled it. The Florida Health Department canceled it. The quote says, "Florida has never approved a medical marijuana treatment center to operate out of a gas station." Also, there was a Chica bong that was sold. It's like a cheap net, it's a bong. It was sold for $41.22, but it's sold out now. But it's sold by Dead Stop. Looks hilarious. It's like literally just a bong and it looks like a cheap net. Kind of actually classy looking. Like it looks kind of like a little like Mesoamerican pottery. It looks nice. Also, the National Park Service in October said that the Sonoran Desert toad needs to. You guys got to stop looking at it.
Yeah, please leave the wildlife alone, everybody.
Yeah,
you gotta stop. We're looking at
you're really not supposed to lick them anyway. like the real way that you're supposed to do it is to like get that and then dry it out and then smoke it. But a lot of scientists have been putting forth, like, this is just my own commentary. A lot of scientists have put forth effort to replicate this chemical without having to bother toads, and it does exactly the same thing. It's the exact same chemical, but now the same like weird like environmental hippies that were like into smoking the toad. Now that the toad is being threatened, they don't want to try the like synthetic version because they're like, it's not the same, man. So the politics are stupid, guys. Then there was this time this year when the DEA, the Drug Education Foundation, put out a like emoji cheat sheet of like what emojis mean what drugs. And they had things like football or fire could be oxy, or a palm or a fir tree or a fire or a cloud could mean weed, or a mushroom could mean mushrooms, or the maple leaf, the like Canadian maple leaf emoji could be drugs. Universal for drugs. Drugs. People started making so much fun of it, they actually deleted the truth.
Just like, are we going to turn into these people as we enter our 40s and 50s? Like, we're like, we're become so out of touch that we don't understand emojis.
Go back and look at in the 1980s what 40-year-old people looked like. And just really,
they are very, 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 like,
I think there's been a slight change of people and the way people act. Is it for better or worse? I guess time will tell. But there's definitely a change, that's for sure.
Absolutely, that's a change.
I mean, look, here's my thing. Don't talk about shit that you don't fully understand. And no one will make fun of it. In North India, there's a story about hundreds of pounds of weed that were seized by the police, were eaten, like 350 pounds, or 850 pounds actually, of weed were eaten by rats. That's hilarious. So some people say it was destroyed by rain and flooding. Some people say it was destroyed by rats. I think this got destroyed too. Probably. Also, scientists can't stick in fish. They found out that if you give hemp to cows, they chill out. Hilarious. It both increases lying behavior and decreases biomarkers of stress and inflammation in cows. It's like they just like fucking gave cows CBD.
Yeah, exactly. That's CBD.
Yeah. Also in Lampang in Thailand, they've been feeding chickens weed water. They've been like infusing the water with weed, and it has provided chickens with higher quality meat, higher quality eggs, fewer antibiotics needed. Some of the chickens don't need any antibiotics.
But you get less stressed, which is good for their immune system. Yeah, more. They're also like relaxed. Yeah, I bet you nothing
to this. Don't say the minute you say they feed the chickens that are meant for slaughter weed. Somebody is about to make a post tomorrow that's like, don't you get it, idiots? You're smoking that dope, and that's because the government's trying to keep you docile while they kill you. It's gonna happen. You set this up. It's your problem now. Yeah. Not me. Well, I'm just saying this. Yeah, I'm sure. But yeah. I'm good. I like the music and I eat good food. Yeah. There was this weather. It's like literally chickens have superpowers. Chickens in this area normally sell for about $1.70, 60 baht. But his chickens sell for double. So I'm thinking about that. 120 chicken.
There's an opportunity for a product called Netflix.
Right. But speaking of that, if you think that's, let me just blow your mind right now. The next thing I'm going to say is that Wingstop on April 18th put out glazed and glazed flavor. I bought them twice. Yeah, literally weed flavored chicken wings that don't get you high. But what they do, having bought them not once but twice because I like it so much, is that it is the same if you went to like the Korean style Sichuan, like the Sichuan pepper tequila where it makes your mouth numb. It's that. Okay. It's got terpenes and hemp seeds and strawberry and cayenne. That's all it is. It was a good flavor, dude.
People say indica and sativa is a lie. It's all about the terpenes.
I mean, there's definitely a big difference between indica and sativa. Like, it didn't make you high at all. But it definitely had a different flavor that was like super fun. And it made your tongue numb, which is like, I'm here for that. Yeah. Wow. There was a Brooklyn prosecutor this month who got in trouble Jersey to California. I don't know what the fuck that's about. I don't know how much that weed is.
Just like that's such a fucking deal.
Like, yeah, I don't know how cheap that weed was going to be, but I bet you were going to be real cheap. They seized like almost over 1,000 pounds of weed. Because 800 pounds that was stolen at gunpoint from an auto body shop in Plainfield, and in 2015, and then they keep finding it. It's just insane. This is why it needs to be regulated. This is nuts. Like, there's no way this is safe or smart, or it's just, yeah, it's so stupid. Reading this again, I think that the actual crime happened a couple years ago, but they pleaded guilty this month. Oh, okay. But still, it's insane. Also, in San Bernardino, in California, these cops got in trouble at the sheriff's department for seizing the cash, like the cannabis truck, the cannabis business cash transfer trucks for legal weed dispensaries and stuff. The cops were like shaking them down, and they, like, in 3 separate occasions, seized a total of over $1 million under asset forfeiture. So pretty fucking nuts. Okay, but apparently trucks were operating with state law. In a lawsuit, the company asserted the stop protection were meant to bolster the sheriff's department budget while harassing illegal cannabis companies. And the joint agreement between Imperial and the sheriff's department said that the deputies, quote, are not highway robbers as previously reported in the media. So, as part of the settlement or something, where they returned the money to the company, they agreed to say that the cops were robbing the roads.
Dude, you want to hear something crazy? Thing real quick? Yeah. I was listening to a podcast, because a 3-hour podcast with a interviewing cops, right? They were saying a lot of shit that I agree with, obviously. One of the biggest things is kept using the word optics. Everything bad happening with the cops was always bad optics. And this line fell out of his mouth, and I knew fucking mad when I see it. Rodney King killed the nightclub. What? No, the club, the stick, the beating stick.
Like his assaults, like, got those out of people's hands.
Yeah, and he said it in a way, it was phrased in a way that was like a shame that they don't have them anymore. Like, Rodney King killed the club. And I was just absolutely, what? How did that come out of your lips? How? That's fucking wild. It made me, oh man, it made me so evil. I stuff that in my heart to skip. Anyway, so everything is so evil. It's so exactly.
And speaking of people that are evil, Dr. Oz was running against John Fetterman earlier this year. And he said that weed should not be legalized this year because Pennsylvanians need to get back their mojo and get back to work.
Again, spreading the continued misinformation, because it's proven now statistically, scientifically proven live that stoners are less productive than lead.
It's a little rough. I'm just going to say, maybe that's part of the reason why it's not in the election, other than many. Not someone you should ever vote for this and that he does not live in the state of Pennsylvania. Anyway, this is pretty crazy. In February this year, there was a couple who got married, and they decided that it would be hilarious to put THC in the lasagna that everybody was eating. Everybody went insane, and people needed medical attention. People were falling ill, barfing. People were freaking out. Somebody sued the caterers for $30,000. Absolutely wild. This is from a guy who wants weed. People weed without their consent to do it. Exactly. Absolutely insane. Also, there are these guys at MJ BizCon in November of this year. Is that Mary Jane BizCon? Oh, yeah. Yeah, it's a hilarious thing for a convention. There was a movement in weed called Buy Weed from Women. Pretty good idea. And I know a lot of, my delivery service, a lot of people still follow the idea of buying weed from women because it's a great way to, get some businesses in the hands of people that maybe struggle to get it. This other company decided that they would walk around the convention in T-shirts that said buy weed from rich white people. And they just got like bodied by the entire convention. Like everybody, like they went viral for being like stores are not prepared. Were they trying to be like, were they trying to joke? Because I was going to make a joke that like, oh, buy my weed from former politicians turning weed salesmen, which is surprisingly a large amount of people. You know how they're in their Congress, they're like, it's the devil's lettuce, it'll kill you. And then after that, they're like, I have a majority shareholder stock in this big deal. And you're like, bro, what? I remember I watched Thief, 1984, and like put a screenshot of like how I look like Jim Belushi in Thief, and then Jim Belushi was like, hell yeah, brother. And I followed his like links to his page, and he had a weed company, and I was like, is that just like what happens when you like a guy who doesn't want to see rain when you're 50 is just kind of weed? Honestly, there is, I think it's because Summer Song is like, it was the new big catch industry. But yeah, maybe it's like NFTs. Take the over. You can, yeah, especially like California's crazy. Where I live, there were multiple different stores run by different companies that are like big, not like mom and pop shops. I'm talking like Men, yeah, like all that stuff. And you're just like, all right, I guess this is huge now. Yep. I'm not against it. I'm not against it. In 2022, the consumption of alcohol dropped while the consumption of weed skyrocketed over 200%. Congrats, everybody. Yeah, people don't like to get really depressed, turns out. Yeah. See, like, I know how to drink shit with her. It seems like the French have it right with the, like, one glass of wine, maybe per day. Check this out. Grand finale for my thing here. I apologize, guys. Grand finale for my thing here. Reddit user Gerard Binge posted this picture to r/trees. I'm gonna just give you guys it because it's so funny. Yeah, r/trees is like the marijuana subway. But it's great because I can get guys who show up and like post trees sometimes, and like their plans are amazing. It's not hydroponics. Let's be real. That's important too. Like that's that's important. You see this? Yeah, I'm looking. I put it on the Twitter. I'm watching it. Oh, what? Oh, what? Wait a minute. Sorry, guys. My graphic got destroyed. You have to see the picture. You have to see the picture. It's only worth it. It's a picture. I'm very excited. You gotta see the picture. Okay, good. That's good. Bang, and then you can read. Jesse, read this out. Found this picture of me at a Christmas play and realized my friends gave me a bomb to take as a gift for baby Jesus. It really is a bomb. It has a dark chance. Dress up like the wise man. The one has a frankincense. And I guess, well, I don't know which one. One looks like he's got a slow cooker filled with cheese and champagne. Yeah. And then myrrh, and then frankincense is the bomb, I guess? Yeah. Yeah, that's hilarious. That's so funny. You know what? It explains why Jesus is such a chill dude. Dude, frankincense would be a great strain. Frankincense? I think it's 2 words though. Not the same word. You keep this up for yeah. I'm with you. Oh, the image is like Frankenstein, but it's Jesus Christ. Yeah, I love that because he is one of you, man. Right? You have like a chicken bean voice. Oh, yeah. We gotta get into the meat business. We're about to age. It's on you boys because I'm in Texas, so I ain't happening. Jesse, what are you doing? Well, so I really quickly have a really fascinating story, but I just want to tell you it's solstice, y'all. We want to talk about before. It's just the day a little romantic adventure show. Yeah, very cute. But in Smithsonian Mag, we have an article that's fascinating. It's about, again, our science is so cool, and especially dinosaurs, how you love a good dinosaur story. I love dinosaurs. So paleontologists, a while ago, discovered this graveyard of ichthyosaurs in Nevada. And, these are these things that are kind of like giant-ass dolphin-looking, will definitely eat you creatures, right? And to, there are all these corpses. And they're like, oh, wow, there's so many dead dinosaurs here. They couldn't figure out why. Turns out the answer, after all their research and digging deep, is that it's a lot of very big female specimens and then little kind of like baby specimens. And they realize this is where they would go as a spawning group. And so either they died in birth or they were hunted there because there was a lot around. Either way, they concluded this was a spawning ground, which is why there's so many of them. And I think that's super interesting. And I was like, well, that's cool to know. But that's not what that is about, because today is the 21st, and I don't know when you listen to this, listener, but it's the solstice, it's the winter solstice, and as you may not know, it is the longest night and shortest day in the Northern Hemisphere. And I wanted to give you some cool facts about the winter solstice. So the word solstice translates to sun stands still. In ancient cultures, viewed the winter solstice as a time of death and birth. And weirdly enough, a lot of those things happened on the solstice. But let's actually talk about those ancient cultures before we get crazy. First off, you have the pagan festivals and all those things. The pagan festival of Yule honored the winter solstice, and Druids believe that the mistletoe, for example, this parasitic green plant that grows at the base of along oak branches and stuff like that. They thought it was the soul of the tree, which I think is really cute. So the tree's like, yeah. It also, and by the way, it seems weird that a lot of that translated to Christmas, but not saying it was so, whatever. In Scandinavia, they celebrated St. Lucia's Day, winter solstice, in the celebrations of the Hopi people. Winter solstice marks that perfect day as well. In the Chaco Canyon in New Mexico, there's ancient ancestral Puebloans built elaborate, like first off they had a huge city there, but they also had these weird like sun symbols that when the sun strikes these petroglyphs at exactly the summer and winter solstice, they become these like bright glistening sundials. Very cool stuff. All the way to the death star. You have things like Stonehenge being aligned with winter solstice. And the Nazca lines of Root being aligned this summer or winter solstice. The sun illuminates an ancient Irish tune on the winter solstice. You have these traditions of, like I was saying, a lot of winter celebrates of the solstice will get super high on mushrooms. This is a thing that transcends a lot of cultures. And because the reason why is the winter solstice, like I said, is this time being the darkest, shortest day of the year, but also it's viewed as kind of rebirth and connection with the spirit realm. And weirdly enough, speaking of rebirth, the Pilgrims landed at Plymouth on December 21st. Mercury discovered radium on the 21st. The Apollo mission to the moon was launched on the Apollo 8 mission was launched in 1968 on the 21st. Interesting family things there. And I thought this was kind of interesting that during the winter solstice, the specific, how do I best describe this? The North Pole, during, there's an exact moment there's a winter solstice. Like, they know the time is at 9:40 p.m. UTC, the North Pole is spaced the furthest away from the sun. So that's the winter solstice moment. And just another fun fact that I think is very funny to remind me of an incredibly wacky game that came I played a long time ago. Many people thought the world was going to end on the winter solstice in 2012. Hey! September 21st, 2012 was the date 13.0.0.0.0 of the Mesoamerican long calendar for the Mayans. It marked the end of 5,126 years cycle. Obviously nothing happened, but you working words with other timelines. And then my favorite fact, which I think is the best one, which is super interesting. And when you hear it, you're like, wait, what? But when you realize what it says, it's actually pretty genius. The Earth, again, it's the sun during the winter seasons.
Oh, it's cool.
It's because the northern hemisphere is turned away. So in the southern hemisphere, they're getting roasted right now.
Australia
It's
is
like unavoidably mystical, just by nature of the fact that it is what it is.
Yeah.
It's because you understand why it's the with nature. You know what I mean? It's yes. Absolutely. You understand why all these different, peoples in the past, where the sun really, let's be real, no matter what duties you create, the sun is doing all the work. And so there's a lot of like sun worship, like sun acknowledgement, and when it disappears, you're kind of like, oh no! And you can understand why they would, you put candles on a tree, light that thing up, or maybe like get together and have celebrations, or maybe it makes sense. And so if you think about this time, you think about the community that, like, everyone, it's dark, it's kind of miserable, half the world, at least the northern hemisphere, all freezing and rise up, and everyone's kind of, it's a little community thing, and I think it's kind of built into the nature of who we are, that we always talk about seasonal depression, but a lot of the cure of seasonal depression is to get out of the house, like, go be a part of things, and do, which again, seems to be like ancient in origin of like, come on, it's cold as hell, we're getting a damn cave, let's go party, let's eat these mushrooms and forget about it.
Yeah, no, then they were melting into the ground.
Oh, push it out of the way. I don't know off topic. Last night I was in bed reading Reddit, and it must be on the front page. There was an entire post about some dude discovering that salvia was a thing. We're on the top. Some dude discovering salvia was a thing, and he asked about it. He said, like, has anyone ever had chips with this? What's this like? And all the comments are essentially boiled down to,
Wanting never again.
you last about 5 minutes, and the total experience would be 15. I would never do it again. This is what happened. And every single one is like, dude, space-time ripped open, and I felt the reality. And it's just like, that sounds cool. That sounds good. It sounds
I want to experience that, but I'm too scared right now. I'm not going. I don't want to break my brain.
One guy talks about how he lived an entire life. One guy, I swear to you, this guy goes, I lived a life as a tree, and I was cut down and forced to get a log in a log cabin.
Yes,
and that was right. And I was like, bro,
There's one guy that talked about he became a thread in the couch, and at the end, he didn't want to leave the threads. He said, I'm not keeping on the thread. And then he had to, like, adjust for like 10 minutes. And when he came to, he was holding his shoe.
But then some guy posted a bunch of, he was like, look, I'm going to be OG here, I've done it a bunch. Either do very little, so you have like a kind of weird trip like in your room, or do a ton, so that you like disassociate from reality. He's like, when you're in the middle and you think you're like doing a medium dose, your body is still feeling things and reacting, but your brain is saying crazy stuff. So you feel like you're there and you're in it, you're losing your mind. And he's like, no, you either go very low or blow your mind. There's no between. I was like, I feel like it's a whole trip. It's still terrifying.
Also, yeah, it's terrifying. I would like to experience that once before I die. So, like, when I'm at 80, and when I'm in episode 6,000,
he's like, do it with friends, one at a time, be there for each other. He's like, don't. He's like, sometimes you do like road trips and they're like, experience. Yeah. Like, sometimes experience like friends in Texanism. He's like, and sometimes they will end up being like in a river being chased by fish. Don't put that one on a pedestal, gang. I see what you're saying. Yeah, it makes you just look like a primordial woman. There's a reason why, for the most part, it's real. And it's because it is not a place to be returned to.
oh, but yeah, sure. Nobody's like, there's no
There's
book
no
for
chance of addiction to it. It's
Yeah.
not messy because
You're
your
really
mind
not
is love it.
No, yeah, mushrooms, like, you can walk away being like, I see society for what it is. I'm a better person now, I face my demons, and society doesn't work like this. It shouldn't be working like this. And then the government's like, no, we can't have that.
Let me be very clear. Salvia is a mint. It's literally part of the mint family.
That's awesome.
That's not so fun. It's like sage, right? It's like some kind of like, just, yeah, it's like, I guess to me it's like, it makes you high for like 5 minutes, and then you spend another 10 trying to figure out what the hell just happened, and then you're fine. And everyone's like,
yeah, so you're back to like reality.
and everyone, I think that's the illusion of like, oh, it's so, like, it's just a real quick thing, dude, so like, just try it. And it's like, we're like party drug, it is no party drug. That thing, could be like I lived a lifetime with another person, and then as the mood you go into in the party with the door closes behind you when you get yourself. You might jump out the window of the room that you're in. You just don't want to. You don't want to bad mood. I'll stick with my mushrooms, and it's always been a year since I've done. You're fine if you do. You're gonna be fine. Just go. Yeah, it's not gonna kill you. It's not gonna like. It's not that drug, but it will like. Your mind is what it does to your brain. Some guy was like, it literally is like a hard reset. It's the pursuit of knowledge. Somebody was saying like, somebody was saying that like rewires mushrooms a lot. Somebody was saying like rewires your sense of touch to your like eye senses and stuff like that, where you just like lose your mind. I don't want awful. I don't want anything. That's so awful. But I will say, videos on YouTube are the funniest things I've ever seen. He's like sitting on stairs for something. Don't sit on stairs. He like fall over. Be like, whoa, where am I? I don't want that. I've been gone for 1,000 years. Well, I'm gonna hold mine thing off for next week, and we'll end next year on Coast to Coast list of the strangest UFO encounters of 2020. Oh yes, hell yes. Oh yeah, that's gonna be great. That's a great mini. It's gonna be next week's mini-sode. Thank you guys so much for watching and supporting us up here. Have a page on the Discord for free. I hope you enjoyed this mini-sode compilation. We'll see you guys next time. Peace. Thank you so much for Talkspace for starting. At this point, I don't know what to say. If you've been listening to the show for so long, you know how much mental health means to you. Even outside of Talkspace, just in general, mental health is such an important place in your life. It shapes basically the 30 years of my life. Long story. But let's just say, without therapy, I don't know what I would do. I'm here that incredibly good. Therapy is just, listen, the way I look at it, you take care of your body, you take care of your teeth, you take care of your skin. Why does everybody ignore the brain? Because you talk to nature, because you talk to people that do anything. That's not how it works. Science is showing that's not how it works. Therapy is great. And with Talkspace, you can find a therapist that works right for you. And if you're worried about seeing a therapist or psychiatrist, wondering if you can help you, anybody has time to find one and you have to come afford them, then you need to talk Talkspace. If you do everything online, Talkspace is good data to help you out accessible and affordable. Sometimes people wait for something to add on these talking therapists. I would say, don't do that. Just go to Talkspace and look for the practice. With Talkspace, you can sign up online and get personalized match guided as free and within 48 hours. It's incredibly convenient to have virtual sessions with a licensed therapist from the comfort of your home. With no need for community appointments, just sign up work for lifetime therapy to attend sessions. It's mental health and unique needs. Talkspace also lets you send messages to your therapist so you don't have to wait for the next session. And this all sounds like something you've been wanting to give a try. There's no better time than right now. As a listener to this podcast, you get $80 off your first month with Talkspace. You go to Talkspace.com/chill. And that's the licensed therapist today. All you gotta do is go to Talkspace.com/chill and get $8 off your first month and show your support for the show. That's Talkspace.com/chill. Thank you again, Talkspace. Nope. Okay, well, let's educate yourselves. You invented the melon. That's right. Melons are named after you. No, he was like in the Department of Defense. So he is a former Deputy Assistant Secretary of Defense for Intelligence, former Minority Staff Director, Senate Select Committee on Intelligence. So he was, government guy. And he put out a memo, like a blog post on December 24th, very, very shortly after Biden signed the law, the omnibus spending bill, which is has the UFO legislation. Sure. And in this post, he says a few things that once others in the cap, that at the very least, some of those MJ-12 documents are real. Now, if you remember from the MJ-12 episode, just that you brought up like looking real and like you
some of those documents. And the reason is, in this post, he goes over the 5 big things that the new law allows people who are within UOP work to do. It provides greatly enhanced authorities and resources for the All-Domain Anomaly Resolution Office, or AARO, which now reports directly to the leaders of the Defense Department Intelligence Committees, what they were doing before. As we brought up last time, it mandates a review of all intelligence documents involving UAPs from 1945 to present, requires DOD, DHS, and the IC to identify any non-disclosure agreements related to UAP and provide those to the new AARO office. So, how many people have signed in with the audit NDAs we don't know yet? It directs the new AARO office to develop a UAP science plan to assess the sometimes mysterious and mind-bending capabilities being reported, as well as a collection plan to leverage America's vast technical intelligence apparatus to determine where these objects are coming from and the capabilities of components. And finally, it provides a secure process for anyone who has signed an official U.S. government secrecy agreement related to UAP to come forward and reveal that information to AARO and to Congress, regardless of the level of classification, fear of attribution, or prosecution. So it's the big things that are kind of come out in the UAP thing, and then he goes on to say a few things that are kind of interesting. He talks about, because even before this whistleblower legislation, the signing the law, federal individuals were providing Congress information alleging that the U.S. government has recovered into technology. I don't know about that last part, but we do know that people have been having closed-door meetings in Congress for all of 2022 about UAP stuff, even at the public. This process began in 2019 when I brought astrophysicist Dr. Eric Davis to Capitol Hill to meet with staff from the Senate Intelligence and Armed Services Committees. Dr. Davis, author of the famous Wilson-Davis memo, provided specific information lending credence to what was known as sensational reports that an official U.S. government program is actively seeking to exploit recovered technology. The Wilson-Davis memo is kind of classy. The Wilson-Davis memo, we talked about Roswell a little bit, talked about Ninja Truck a little bit. I don't think we went into it great deal or great depth, but the memo, I will leave you to it because it was entered into congressional evidence in this summer. I brought up during it, so you can now get it off of Congress's website, which is
basically, all Ninja, it almost doesn't matter what it says so much as if it bounces back and forth whether it's true or not. It's the thing that's important. Right. It confirms this entire video game style mythology.
Again, yes and no, because the MJ12 thing, I don't think all of those documents are real. I think there's fake documents in there. And I don't think it adds to the magical aspect, only that the government has had a small group of people that are experts on UFOs kind of doing things before. Again, I said off camera, NASA's kind of doing that now. It's out public. They have their own list of 10 people that are specialists in the field to address the UFO thing. The reason that the memo, if it's real, is important, which comes from October 16th of 2002, is specifically the quote where it says, Miller asked the question on MJ12/UFO Cabal, Crash UFO, confirmed to Carl Miller late June 97, and told that P. Miller was right. There is such an organization in existence. That's your first thing. This is only 2 pages to the memo. It's not very short memo. And then he goes, what did you tell? Because I found it, where I looked, who I talked to, but did not name everyone there. Then we're going to go to Sean Miller, WD 42502, please evaluate. Didn't tell Miller everything. Miller knows what I did from the Pentagon Root Reference Group, so it's more Miller. Miller can make good educated guess how two contractors that bring in hardware do not pay Miller. Sounds hard tough to pay for a nice deal at a home and private beach program. So basically, we confirm that the MJ12 thing, and then it would also put not evidence, but more weight in Bob Lazar's corner, but I still don't think Bob Lazar's legit. I think, much like me and Ash talking about on camera, the man is very good at being very vague and always giving himself.
He never adds into the conversation. Like I'm saying,
The only thing he ever really added was the only thing I would say he ever brought forward is, well, he did have a VHS tape of what potentially a UFO in the 80s, which had filmed with his friends. But the whole element, like 117 well. This is Christopher Lawrence. And he posted this blog. That's his website. That's Christopher Lawrence. I'll give you his Twitter as well, where he kind of links it. He's big in the UFO world. He's also very much in line with usually him and Lou Elizondo end up coming up together quite often, because Lou Elizondo is also, that literally worked for the government and to what the company is a student, because, we'll see. But yeah, it's not proof. But if this is yet another edge toward, is the under-12 document real, then, man, who fucking knows? If they are real, how much of it is real? What parts of it are real? Because, there's that giant bogus that was revealed by the FBI, and some of the thing is, and that was part of what we talked about in the J12 episode, some of the papers look super legit. Others look legit, but if you know what to look for, look fabricated. So it's just fucking weird, everything horribly, designed documents that are supposed to look like the documents. Yes.
The biggest problem with this is, even in the thing you said there, is, I don't know how to best describe this, it's not the most eloquent way, but just the example here is, I'm not claiming the information provided to Congress or to the AARO proves that there has been a visit of extraterrestrials. However, and then proceeds to say a bunch of stuff, and then it says the media is doing a disservice to not investigate this, basically. And that is, unfortunately, for our current state of affairs in the world, literally on the same lines of when someone makes up a thing, says, well, I saw that congressperson go look with Satan at the pizza parlor. And it's the media's fault for not investigating it. It's so why are you putting it on the media?
The media did cover it. The media did cover it when those videos leaked. They covered it for a few days. It was a big
they were talking about it. I think the thing here is it's always kind of I put forward. Why won't anyone else cover it? It's I don't know, bro. People say it's potentially good. Right. There's no reason.
because now it's up to those who have gone quiet to
The moment an accurate piece of information is revealed, right, the moment that any of this legislation reveals actual information to the public, is the moment that the media is going to immediately follow it, because everybody's going to care about it. Right, but it falls in the same fallacy of when you're lying to someone, and you're it's on you to prove that I'm lying. It's the same thing.
to me the other day. You made a point, and I was well, and he's you know what I mean? I go, no.
That's not how you provide me the evidence, and then we go from there. You can't be you know what I'm talking about. It just is no. Yeah, and it's literally you say, I'm not taking the information provided as proof. But here's a bunch of things that I think could be proof. The media needs to figure it out. What? That's not how this works, though. And that's the problem, because that's how we get on that weird, QAnon shit.
Yeah, as we talked about before, I agree with what you said. Because, again, when you take this, it's not, as I said at the very start, it's not proof that the NJ documents are real. It's simply how the feather recap. And that feathers is pretty fucking loud.
Yeah, one day it's the lunar which it's the gravestone, and next day you wake up with the redstone. So I don't know what's happening.
It's another one of those fascinating developments in the UFP 2022, and I'm eager to see what 2023 brings us. Just to keep an eye on. I will keep an eye on the weird stuff that just happens behind the scenes that nobody really talks about. And they do anything, but it's something to keep your eye on.
I was literally talking today with a good friend of ours who came over to work on a project. And he was asking about some nuggets, he was listening, he was asking about aliens, and she thinks it's fascinating. But he was you have to believe that there's, something if the U.S. government is saying all this stuff. And I was I believe something, absolutely. But the thing that interests me more isn't what it is. I mean, I guess that's part of it. But the idea that the government, by admitting they don't know what it is, they're either saying, one, this is something that another country has made, you can't control the flies over our airspace, or two, it's something that is not from this planet or from the planet. Either way, it's fascinating. I don't think we're caring at the end of the day what it actually is. The fact is that something is happening, and the government's I don't know. And that's, it seems like we're making the government take a shit on the government. can't control their own airspace. Like, their job is to protect the country, and then openly being like, we really can't do that. That's a public thing. Yeah. So that's
Exactly. It's very interesting, and like at the same time, they're also with they're doing that because they also be alerting all enemies that their shit works.
Yeah.
Right? Wouldn't that not be just an admission that their shit is working by us saying we don't know what it is?
Exactly. They would never, if it was real enemy tech, they would never admit it was real. They would never say,
That's what I'm saying. So what is it? It's like we don't know that. We don't know. And I've said it before, and like you said, Jesse, and I was like, it's more believe the government doesn't fucking know what they're doing than to have a contract with people at least to
they do like ants, dude. Ants don't know what a person is.
Exactly.
You don't meet with the ants and have a conversation with them.
Yeah.
Right? Like,
one of the things the guy put this blog, I think it's called speculation, is like the AI angle. And it's like, yeah, I find it interesting because not necessarily that I believe it's an AI, but it may very well be, these are things that are not from here. They may very well just be unmanned drones. Just like rockets. Like nothing with anything in it, no living beings in it. Just like sitting around, looking at us, and then going away. Because it seems to be a lot of what happens. The other thing is, it may just be from under the water. If that's what they're doing. I don't know. That being said, this Minnesota that we're going to put is coast to coast, strange to coast, and it's pretty good shit. We'll start right here with the transmedia UFO photographs submerged in Lake Titicaca, everybody. So if you're right here, the article, there we go, we got the video right there. You need to tell me what you see because I don't see anything. And I can't quite tell what it is. It's from ARV. So this is a car. I don't know about this. Yeah, I don't know. It's very weird. On the road. Yeah, it's right the rods. You can all get the rods at. Oh yeah, we go 1,000 rods and they're spinning all over the place. Oh yeah, we have 1,000 rods. I don't think too. 1,000 rods is so nice. It looks like it's hard to run. I cannot understand what you're saying. I mean, literally, you're right. Snowball that dude with the 1,000 rod, she is just spinning her wrist like a crazy person. Yeah, dude, she's got a loose control. He's like, yeah. Witnesses number 2. Witnesses in Israel were mystified this year by a lot of glowing object that resembled a lake that frozen in place over a city. There you go, boys. It's the next one for you. This is a weird thing over the city. You can kind of see it starts right after the video at 47 seconds. Okay. And it's just this weird thing in the sky. It's just like New Way Home. It does have that vibe, yeah. And the whole video, it doesn't. Dude, that's pretty cool. There's like some weird, very weird. But I wonder if that's like a natural phenomenon of like electrical discharge or something like that. Could be, but it doesn't also look like the graphics weird. Yeah, it looks like it's a video with the camera moves that seems way too, like it's not in track. Yeah, like it's bobbing. The problem is that it's only focused up at the, there's a tree line, like there's one tree and then there's that, which is fine. I'm curious what, like, there was that one thing that happened in Vegas that everyone tweeted at us. Yes. Did you see that graphics? Like this past week? Yes, I know exactly. Literally, it is literally the reflective nature of the cloud cover with the lights of Vegas. And that could be this because it's cloudy and it's moist. A little like Hadera. Yeah, one light that we can see is like illumination coming from the construction frame. Dude, 100% positive, 124 positive. It's exactly 124. Then it's spread into the front and the back and the little cap. You get it. The top that blades to the middle. It's a great. Yeah, I was like, oh, sorry. You have to both the debunkable shit. Lights around circumference was reported by multiple residents of Eastern Tennessee, including one professional photographer who managed to snap a picture of the RV. You may have seen this photo. This came from It looks like a jellyfish almost, honestly.
Yeah, I really like this one. Like, it looks cool, I guess. I mean, it does quality. It is. It is on its own.
Well, I bet you guys are excited to see the UFO that was spotted over Buckingham Palace during the Queen's Jubilee parade. Yes. Did you know that happened? She went home. The Queen's. So, yeah, it's going to start right away. And it's right behind the gates. And it's above the smoke. So we know it's above the smoke at the very least. It looks good. It could be a really close bug, though. It could be anything, right? Could be a drone. It could be. I was going to say it could be a drone. Could be a drone. Yeah. Could be just a paradox effect of a bug. For those who are looking, closer kids see. It really is like the jets of the squad across, sweeping the colors of the right behind it. It's white, really. It looks kind of dance, and then it just zooms in a pretty straight line. It's really circular too. Yes, it's like a really random story footage. And the perception on the computer. Can't go on the woods. That's my favorite video. Well, there you go. As you feeling impressed by that? I don't know what that is. Certainly, when they do that with the colors, it's kind of sort of that's something. Yeah. Halfway through the list here, a woman in Mexico captured footage of a truly bizarre star-shaped object hovering in the sky, and the anomaly was later filmed by another witness the following day, which is what we'll see. Obviously, with the YouTube video that is also TikTok. The YouTube video that's also the TikTok version has like, oh no, this looks kind of fake to me. This looks like, if it's really there, it looks like a 3D object or like a moon or something. I don't even agree with this thing. This looks fake to me. I think we talked about this one earlier here, and I think there is some sort of balloon that is exactly shaped like this. So they sell, and it's like marketed for weather stuff. Like, I don't want to be that guy who's like, it's a weather balloon, but I'm pretty sure that you can go look it up online, and it's exactly just like this. It does kind of look like either a spiky top or some kind of like it has somebody suggested a star with your type. A kid just has that string and just tighting. If you wonder what this looks like, imagine like the secret boss in Final Fantasy VIII. Like, it has this like bizarre shape to it that seems so otherworldly. It's like that alien thing that's like famously in the atmosphere, kind of. Second question, an object that's like floating just outside of the atmosphere. It just left. Not too long ago. That long thing, and it left, and nobody knows how it left or why it left. It's just gone. Yeah, it's been like that was the thing I wanted. Remember how last week? Oh my God! Do you remember last week I said there was something I wanted to talk about, but I remembered I had an update for it's gone. I can't remember. That was it. That the home thing left. They left our orbit. Maybe this is where it went. Maybe this was it. Just it's so weird. Jesse, remember you know what we were talking about, right? Yeah, I don't. But I don't know what it was. It was a long rock. That long ass angle. Part of the reason why we developed that team. Because the team that we learn how to learn asteroids, we need to learn how to like go visit things and tell them what the hell they are. Yeah, there it is. It was around, it came out in 2017 in Ghana. Named Al-Mu'awiyah, by its discoverers, is up to 1/4 mile long, with entirely long, 10 times as long as it is wide. The aspect ratio is greater than that of any asteroid or comet observed in our solar system to date. That's from mass. And it's moving faster the closer it comes, right? Yeah, and I want to see if I'm right. I'm going to slow it down. One of the two. They're like, those asteroids don't do that. Interesting. You know what? They came by. It left. Is it footage in it? I'm looking at it now. Wait, it just like up and left this like month, this week? On October 16th, it moved back north of the elliptic plane and passed beyond the orbit of Mars. On November 1st, Oumuamua passed beyond Jupiter's orbit. In May 28th, and beyond, it moved beyond Neptune's orbit this year, 2022. So it started leaving a while ago. It's like now gone. We can't see it anymore.
You know what's crazy? So on the solarsystem.nasa.gov website, I can send you this. They have a model of its trajectory, and it literally makes a direct course to Earth and then stays with Earth for a long time. That is weird, dude.
Yeah, man.
It goes with our trajectory around the sun, and then just goes with us, and then goes somewhere else.
So it's starting 2017, right? So, briefly classified as for the lunar.
I mean, it's past the outer planet satellite, but
That's what it's doing. Yeah, that's how. Yeah, look at that. Just comes by.
it literally goes in line with Earth and then like scoots around outside of Earth for a little bit and then zips away. Either that, I mean, like, that could be very cool coincidence, which is cool, admittedly,
Yeah.
but also like, okay.
No known asteroid or comet from our solar system varies so widely in brightness with such a large ratio between length and width. The most elongated objects we have seen today are no more than 3 times longer than that.
But again, this is one of those things where, and that's what looking directly at it, we see like 70% of the stuff.
Right.
Look at us.
See, it's like, I don't understand.
So we, I mean, like, really, truthfully, we don't particularly know. It could be everyone's like this. This is genuine fact.
Yeah, I'm just thinking like a few large ground-based telescopes continue to track the fading object as it recedes from our planet. 2 of NASA's space telescopes, Hubble and Spitzer, track the object traveling about 85,700 miles per hour relative to the Sun. Its outbound path is about 4 degrees above the plane of planets that orbit the Sun. The object passed Mars orbit around November 1st, and it passed Jupiter's, so a while back, beyond Saturn, and now it's beyond Neptune. The reason I think it was in news this year is because it's now out of our ability to see it.
What's crazy about this is, based on the thing they have on this website, it isn't like it comes in from outside, passes the outer planets, and it comes to us and goes back out. This shit comes from the z-axis, so straight to us, right to us, and then it's like, oh, okay, and then heads out degrees angle. Yeah. That's not, I've never seen it like, that's crazy. Either that happens all the time and it's done, which is possible, or that is awesome. A pretty good diagram for that.
Yeah, it's weird because when astronomers want to say, oh no, it passes through the inner solar system about once per year, but they have objects similar to passes through the inner solar system about once per year, but they have faint and hard to spot and have been missed until now. So you know what I mean? Like,
It's scary. Cool.
yeah, that balloon looks like.
Now that's some cool space stuff. I love that.
What the fuck, man? Alright, last few. Pakistani man was up scratching his head when there was an eerie black triangle that hovered over a city for hours. And I'm going to send you the video as always.
In Pakistan, I believe this is a U.S. drone, to be honest.
Yeah,
You say stuff like getting in or
yeah, it's hovering. It's just hovering. Ominously. Look, it doesn't fake to me, not the way it seems to move. But maybe it is. It's hard to fucking tell.
this just looks like it's very small. This looks like a gas.
There were ones.
remarkable, but like not fake looking. You're right.
Yeah, correct. But nothing remarkable.
And it does kind of line up with what you imagine from being on the ground. When he zooms in, everything that checks out ratio-wise. You know what I mean? We haven't seen face. It's legit.
It's another really interesting thing. This one is just a weird nature. When visiting the National Park, Devil's Punchbowl, a British woman, did something of a agility when she looked overhead and saw what seemed to be a cube-shaped cloud.
I've never heard a cube-shaped cloud. It's another cube-shaped cloud. Oh, I mean, it's a cube-shaped cloud. That's fucking weird. It is a cube-shaped cloud.
Ever seen Nope?
No. It's exactly like the Nope.
Yeah, there you go. It is straight up a cube-shaped She doesn't. She goes back and forth, but
admittedly, it is a 90-degree shaped, 90-degree angle shape. We don't know what the back looks like.
it looks like a 3D cube.
That's a different idea. I think different. But that is, I love a weird cloud shape. I love an unnecessary base in that video.
So I just have not really good answer for it. Next up is something straight out of Kansas City, what appears to be a partially cloaked UFO, which was inadvertently filmed by a home security system at a residence. Well, now, even the most trustworthy kinds of things out there, you can, that just looks to me like, you can have a handbook, go jump to 17 seconds.
What?
Yeah.
What? This is insane.
This is fucking insane. You see cars driving by, so it's not like, yeah, there it goes. It's like a triangle looking thing.
This is fucking like a navigate right here. The longer you look at it, it looks like one of the Covenant ships from Halo.
Yeah, they zoom out and you can see in the background how big it looks. Because that was a zoomed in version of it.
I mean, that's a thing. It also kind of, at some levels, it's like the ship that all of the guys in every Avengers movie get to. Yeah, we're not doing things like shit. It's like
it disappears. So it disappears behind the tree. This is not like a bug really close. It literally disappears behind the tree.
Something about it feels like a projection to me.
I mean, yes, I kind of get that
Something that
feeling
seems
that
a
it
little
might be a
weird
tree.
about it, but I like it. It looks like a light navigator. It is weird. Looking.
Yeah, there's the looking. All right, this next one is, taking with a grain of salt in my mind, but this is a fantastic set of photos that circulated on social media about August, completely showing the flying saucer that floated over the city in Mexico. And you can see why we took with a grain of salt. And we, but that's it. No, that's the picture. You go down to some other pictures.
This one looks like he's hanging from the fucking line.
Yeah, it looks small.
It looks like it looks like a plate. It looks like a yeah. Unlike the previous one to Pakistan, this one looks. It doesn't look like it has the depth. It looks like it is closer to the air almost.
I agree.
It definitely looks like a small fixie.
That one never didn't convince me.
Also, it's just the photo. Like,
Three more.
I don't buy it. I don't buy it. Go on camera phone, take it down. Take your photos.
Taking a break from his overnight job to film a storm sweeping across the area, a Texas man captured footage of an inexplicable object that suddenly fell from the sky. And I will see if I can find a good time for you. You go to
I watched the storm
15 seconds. 15 seconds and watch it as it slips so you can see it with you.
Well, I mean, that is
Something
something
weird. It could literally just be a meteor.
but even getting it, if it was a meteor, even capturing that is pretty cool.
This is
UFO in the most general sense. Right. It's unidentified.
Yeah, even if the article's like, oh, people say it's a meteor. I think it's a meteor.
I believe it is a meteor.
Yeah, exactly. All right, 2 more to go. Next up, a particularly puzzling case at Taiwan featured a pair of floating blue streaks that were joined by a group of orbs which appeared out of thin air and then encircled the entire sky.
This year, we saw some cool looking ones, and I'm not good on this. I'm upset.
I know. I think we've seen better.
We've seen better ones. Because it's synth music and
This once I'm waiting for the point where they get encircled by a little orbs. Okay, yeah.
oh, that's like it's kind of happening, right?
Yeah, but like you can see them getting circled a little bit maybe easier. It's kind of faint around.
Can I say correction? Do you think that's the top and lights? Okay, that's fog cloud ahead. You think there's the stadium, and those are the lights of the stadium, the top of it, and then the lights around it are the spotlights of this, like a show or the outside of the arena. When it's super cloudy like this, it's hard for me to say that it's good to end. Yeah, because it looks like lights. It looks like a projection, genuinely.
Yeah, it does look like another view.
It is striking. I mean, it looks great. Like, it's just, it looks cool. The same thing you have to work on it.
All right, well, we got one more. This is from Mexico. in the multiple mass sighting in Mexico, multiple groups of people saw things that seemed to be a slowly rotating disc in the sky.
Well, I think this one is like legit.
I think we talked about it.
Yeah, I think we saw it.
I'm trying to remember. This came out in September. Yes, we definitely are. This is one of the ones that was kind of cool, actually. Like, very weird.
This is real because we have multiple views.
Yeah, there's other angles to it and stuff. There's other things.
I'm sure I've seen, but
Some people say it was like, it could have been SpaceX Starlink satellites. But usually, yeah, exactly. We've seen those.
yeah, the thing that's interesting about this, and again, I don't know what it is, but nothing that is a satellite or a rocket does what happens at like 109.
Yeah,
It
exactly.
cycles through lights.
Yeah.
It goes like 2 and 2 and that's, and the angle isn't a reflection on the ground. No. And this would be a lot of actors and a lot of visual effects.
Multiple drones. Yeah.
And see, this is this is like a little. This is the last one was the last one.
Me too. Honestly, that's it for our minisodes here at 2022. I think if anything, in 2022 as a whole, I think this was the year I moved Jesse slightly more toward the alien world. Not necessarily an alien world, but I've always been interested further to the world of curiosity and asking questions.
I love curiosity.
Thank you guys for supporting the show all year long. This was it's been such a fun time. We'll be back after the new year with the first episode of 2023. I don't want to spoil what it is, but what you know. Until then, I'll see you next time.
Yeah.
Anyway, you are going to see outside Belgium and enjoy this. I know you're going backwards, so I stepped back inside never. Holy shit, yeah. So, yeah, I look at you. Hello, everybody, and welcome to my podcast, episode 236, because I think Minnesota was 35, so I'm 35, I don't know, somewhere on there. Anyway, I'm going to request that one. Joined by, good stuff, thank you so much. I'm joined by the ChatGPT and Google Car of LA, or Jesse Boys, our jobs in the AI week has taken the video and shit.
I don't know. Have you seen the internet lately that it's been posted that the AI is going nuts? ChatGPT lost his mind.
So yeah, apparently ChatGPT is responding with a mix of English and Spanish nonsensical phrases, repeating "it is" and "it is" over and over and over. I tried to instigate it last night and I couldn't get it to.
It was speaking in like whimsical, colorful, like Spanish, like it was like almost like emotes. It felt the joie de vivre. Like it was like waxy poetic almost. Like it was fucking scary. Like I know that it's just a language model and that it's just going wild and like of course the language model going wild is gonna be like extravagant talking, right?
Yeah.
But like man, I've never seen something like that more like a Cyberpunk 77 side quest unfolding in my life. And by the way, I'm big about it because everyone's funny is about it. Yeah, I'm a GPT, just a gangster berating about town. Oh shit! And he's chatting, so you know he's social. He's got lots of friends. Yep, he's got so many friends. Most of my friends, not people you want to be friends with, but they get their work done. We get the job past Jesse. He's a social butterfly about town. Ask his neighbors. He's that homeless guy that I know about on the street. He's walking up and down. It's fascinating. Speaking in broken Spanglish and talking about the Jabberwock as he's walking up the boulevard. This is actually no joke. This weekend, I went to our favorite sausage place, Worcester. Hey, like a local fellow from Germany, because he wanted to go there specifically for that. Here's the thing. When we were done, we were right outside, we walked outside, we're standing there waiting for him, and this dude, random guy, walking in the rain, stops, turns to us in the rain, just like, hey man, is this the place with the rattlesnake and rabbit sausage? And I was like, yeah. And then we had a 45-minute conversation. Oh my God, in the rain.
I think he was AI generated.
We were under an auto. He stood in the rain. He was high out of his mind.
It was an AI generated, not fully understanding what he was supposed to do.
But yeah, on the RP server with the AI and data mods program. Yeah, and he kept talking to us and was like, you know what's crazy? Some places people eat crickets, so we think that's weird. Here, we process meat. I think that's weird. I was like, he's kind of on to something.
I like that. He's kind of like the same as acting for day. He went each one way.
That's one thing. Yeah.
The AI thing also, that's the AI movie before we went back to show. I think obviously with Alex's classified is on top of Sora dropping, which was OpenAI's video thing, Google rather quietly released their new AI to a limited number of users called Google Gemini. I don't know how many people it's invited. It's also a large language model. I got access to it in a premium version and advanced version. And the difference between this and Bard, or at least any large language models, is that after a certain amount of time or a certain amount of information you input, the AI has an inability to maintain context of the conversation. So if you type out a really huge thing, it loses it. Okay, sure. This, the new one does, it is able to maintain it. They tested it by feeding it the entire manual for the Apollo 11 mission, and then asking it questions and fixing it, and it did it fast, fine, and it maintained all that information. It also is the first one of the first AIs to understand nuanced instructions, able to reason through problems logically, and provide insightful responses. So it's actually like, not reasoning, according to Google.
This is great news for everyone who leaves comments about this show and other shows. It's like, you guys keep talking about stuff that isn't the topic. You keep going on, you having jokes. All I know is about those murders. Well, pretty soon, GPT the podcast will tell you all the information. You don't have to have fun. You don't have to listen to a bunch of real guys like us. You don't have to do that. Listen to a digital prostitute historian who can do anything that you want. It's so phenomenal. So you have that to look forward to as an alternative to this. Speaking of digital prostitutes, head on over to patreon.com/Shooter95, the website where you can hire us to make podcasts for you for money. That's right. I know it sounds salacious, but if you listen to us out here barking at you from this digital street corner, you can rest assured that we are clean, we are strong, and we are ready to give you some of the best paranormal podcasts that you have ever seen in your life. So head over to patreon.com/Shooter95, put your money in our wallets to keep us going.
Thank you so much.
Yeah, you are, you know what? You are so welcome.
Today, boys, we're still getting back. We're returning to a time we haven't been to in a while. The 1800s of West. Oh, yeah. Last time when we were there, I think it was Kentucky Kansas. I think I could double check. It was.
Oh, you mean the cable off of Kentucky?
Not from Kentucky, Kansas, who like in cartoonish ways of David. Today, though, we're speaking about somebody who's actually made their way in pop culture in a surprising way, especially with the story of Texas. Today, we're talking about the bandit queen known as Belle Starr. I don't know if you know anything
Bellstar, the Bandit Queen before. Yeah. I would be remiss if I said that I knew anything else.
Okay, cool. Well, this is going to be a two-parter, and today we're going to talk exclusively about the legend, who she is in pop culture and in a lot of history books from the past anyway, and a lot of what crimes she supposedly committed, who she ran with, and then next week we're going to go through the actual life of Bellstar, where a surprising amount of that might actually hold up, and other bits not necessarily as much. For our main sources for this series, I used two books, specifically one called Bellstar, the Bandit Queen by Burton Rasta, and then I also read Bellstar and Her Times, the Literature, the Facts, and the Legends by Glenn Shirley. That book is phenomenal. If you're only going to read one book about Bellstar, read that one. It is, we'll be talking about that book more in the next episode, but it's probably one of my favorite factually written true crime books in general, even though it's only so take a look at those. I highly recommend both books. But yeah, if you've never heard of Bellstar, the so-called Bandit Queen of the Wild West, let me tell you, her story is kind of a mix of facts and legend. She was born named Mira Maribel Shirley on February 5th of 1848.
How does this sound like an 80s anime voice? But I don't know, there's something about it has like a magical girl vibe to me. I don't know why.
Bellstar, the Bandit Queen, yeah, I could absolutely see it anime being.
You know, I don't know.
Like a magic pistol she threw
Yeah,
through.
it's the whole West.
She spins with that pop-out umbrella, and as it pulls away, she's in a new outfit, spinning a pistol.
Yeah, and it's still got the same thing.
You get it. Yeah, it's fine. Somebody else. So Bellstar was actually born near Maribel Shirley on February 1848 in Taik, Missouri. And she's one of the few people we actually have like a little bit of information on as to who her parents were in this era, what they did, and what her life growing up might have been. Her parents, John Shirley and Elizabeth Eliza Pennington, were prominent figures in their community, enjoyed a comfortable lifestyle, and actively participated in social and economic affairs all the time. John Shirley was actually like an entrepreneurial man. He engaged in a bunch of different business ventures, including farming, blacksmithing, real estate, reflecting his diverse interests and ambitious nature as an individual. Bell was the child of his third wife. So he had two wives prior. Each wife gave him 1 to 2 kids. And he remarried to Elizabeth, who would be his last wife, and Bell was a product of that union. His activities extended beyond accumulating wealth, though. They were also driven by a desire to create a legacy and provide stability for his family. John's entrepreneurial endeavors were not solely motivated just by financial gain, but also he was well known within the community of just being a very community-driven individual. He liked to help out where he could.
Really liked it because he was so community-driven.
Yeah, really. Whether that was selfish reasons or not, I have no idea. And then there was Eliza Pennington, Bell's mother, who was known for her hospitality and unwavering dedication to her family as well. She ensured that Bell and her siblings received a quality education, emphasizing not only academic knowledge, but also the social graces expected of upper echelons of society. To give you an idea of where these people are in Wild West, they are well up. They're doing very well for themselves. The focus on education was somewhat progressive for the time, obviously, particularly in the emphasis on educated daughters as well as sons, indicating that a family that valued intellectual and cultural development, and Eliza's influence on Bell's upbringing instilled in her a strong sense of self-worth and a desire for personal fulfillment beyond traditional domestic roles.
So you're telling me we've got like a gentle lady there?
Yes, but it's interesting too because this part of her life, I think, really informed why she brought up against the law system. Because she was raised in an environment as close to equal as men as she could be for that time. In education, she was very close with her brother. She loved to ride horseback.
This is going to be a fucking fire story. It's like Netflix's Eleanor Holmes. Yeah, that's what I want. Netflix's Eleanor Holmes. I'm pretty sure it's Enola T. Holmes. I clearly didn't watch it, but I know the vibe. Witcher in 11 too much.
Bell also apparently got in fights occasionally to help herself. So she got to adulthood, and there was a certain expectation of her as a woman of the time. She probably didn't like her. So she very much kind of struck out on her own a lot, and the people she ran with, which is true, she ran with a lot of these criminals, were really informed, I think, a sense of independence that was over there. This was the way she was raised, east of them.
Sounds so cool so far. You already put on the great. There's like so many fucking things going on. You are a comic book adventure tale. Now, how many years of whip practice did you have?
Oh, about, I think, 12 years of active whip practice.
Yeah, how many years of star
That's
shooting?
because they were stark Southern Confederacy supporters.
Oh. How many puzzles did she have to solve that her family created instead of expressing love verbally? They did it through puzzle solving.
That puzzle was wrestling.
Right. So, all right, love to be happy. Right. So was her brother killed in a way that he then left clues for her to follow based on the trainings that he gave her as a child? So dark.
Right, yes, I think so. What, who are you referencing?
Did Tom Hanks in any way help in a role that would lead her on a multilingual, multinational, worldwide historical adventure?
What the Vinci Code,
Da Vinci? Da Vinci?
Yeah, so, you know, Eliza was actually a rather off mother, and education was kind of like there, but grew up rather well off.
This is the coolest character that ever talked about in the show.
And then, you know, not too long after, about 15 years after Civil War, the Civil War began, and the Civil War itself had a profound impact on the Shirley family as a whole, as it obviously did on other families across Missouri and the wider South. Missouri's position as a border state made it a very tumultuous place, with loyalty split in warfare very. The Shirleys were staunch supporters of the Confederacy, a stance that placed them at odds with their Unionist neighbors and forces. And this period was marked by significant upheaval for the family, including the loss of their property and a forced relocation to Science, Texas after the war. Because they were just huge supporters of the Confederacy. But beyond that, we don't have a huge amount of details as to like what they did and how they were involved in the war, other than we knew they were forced to. This move proved to be a turning point for young health. Texas in the post-war years was a place of reinvention and opportunity, but also lawlessness and desperation. The Shirley family, having lost much of their privilege status and wealth, found themselves in a community where former Confederate soldiers, outlaws, and adventurers all mingled in one place. And it was here that Belle's fascination with the outlaw lifestyle began to take root. She was just surrounded by these people, influenced not only by the people she was meeting, but the stories they would tell, which I imagine many of them were wholeheartedly embellished. But for a young kid, this is like, it's magical in a way. Like the stories of these heroes that fight against the law that took everything. In the years that followed, Belle's daughter would become a very legendary figure in the annals of the wild. Her legend involved in robberies, stagecoach, stagecoach holdups, horse theft, as well as the relationships with notorious outlaws such as Jesse James and the Younger Brothers, cemented a reputation as the bandit queen. But beyond the sensationalized stories and the mistakes surrounding her life, Belle's story is a complex and fascinating woman who defies societal norms and leans on unearned, leaving a lasting imprint on the history of the American frontier. And that much is true. She truly was just a very forward-thinking woman.
It is absolutely crazy to me that the Wild West, because it's so nuts, it's so easy to glorify and like like Jesse James, like all these new bandits, in this case, now stuff like clearly criminals, but it's like, damn, they were cool as hell.
Let me read this to you. You reminds me of part of the book I took over to. And basically, the author says there are essentials to a formula that are fairly consistent that breed this kind of itemization. You get what you're doing. And he goes, the essentials embrace fundamental psychological facts. One, civilized man, no matter how circumspect, law-abiding, conventional, and tame he may be, has a subconscious desire for revolt against law, against restraint, against civilizing forces of war. Two, thus, even when he deplores, he always has a measure of particularly if the outrage was perpetrated by a representative or representatives of the forces of law and order. The civilized man is able to make the outlaw hero his fighter in the righting of injustice by spectacular revenge. So every civilized man is at times or feels himself to be the victim of an injustice which he cannot right or forces against which he cannot take revenge. So his outlaw hero performs for him, cleansing his emotions of hate and vicariously carrying in a brilliant, courageous, and superior manner the representatives of the merciful forces the civilized man hates. And finally, 4, the outlaw hero must die, preferably through treachery or against horrific odds, and never in a fair and open fight. So there must be a retribution for the outlaw, not only to satisfy the moral conscience of the civilized man, but also because the fighter or the scapegoat who bears the weight of one's sins must die so that civilization and civilized man may.
Yeah, no, that must never be changed. That's a really great summary of exactly the time. It's why all the best Western movies, the main character does not make it out. Yeah, I'll tell you right now, that whole story that you just described already played in my head about this character.
Right, exactly. And this was written in the late 1800s by a man by the name of Richard K. Fox. And he really was talking about why people buy these 25-cent paperbacks and these dime novels about these outlaw heroes that people like were clamoring for.
It literally is also a plot of straight up, if you're playing a Grand Theft Auto, or you're playing Cyberpunk, you're playing Red Dead, yeah, literally the plots are like, look, you're the coolest life, burnout, you die boring. And it's like, okay, I understand what it can translate to someone, and they take this on themselves. In fact, Bellstar, if you look up, Bellstar trying to find an image of her, half of them, out of all the media created of her, normal Bellstar looks like a normal ass woman from the West. Yep. But all the media, she's this glamorous, beautiful bae who's like, gonna kick out dudes with guns and stuff. And it's ultra glamorized because the idea is damn.
It's the same thing with Billy the Kid. Like, Billy the Kid's legend is much bigger than the reality of his history. One day we'll talk about Billy the Kid for sure. The same thing with just like all the media representations of Billy the Kid and not the guilty, like, dude who maybe killed 3 people.
It's the Lord of the Rings that's true. It's like we just can't. I'm never going to get hearing stories about this exact character. You know what I mean?
Yeah, it's just great because this is a party that just kind of. So they moved to Texas. They came back in school. They were forced to move to Texas, and despite the challenges in their life, they remained committed to the education of upbringing culture. Bell, described as an intelligent and quick-witted from a young age, received an education that was unusual for him at the time, studying subjects like classical literature, piano, and what else but the social graces. Like Renard, like how to act in front of public behavior. Like a lady, exactly. This education not just served to refine his character, but also instilled in her a sense of independence and a desire for a life less ordinary. And her exposure to the harsh realities of the frontier, combined with the romanticized tales of outlaws and rebels that she grew up around hearing, began to shape her worldview. Bell admired the resilience and freedom these figures seemed to represent, a stark contrast to the structured, constrained roles available to women at the time in society. This admiration, coupled with her own spirited nature, set the stage for the life of adventure and notoriety that she would later pursue. The dynamic within the Shirley family also really played a crucial role in her development. She was close with her brother John, who would later become involved in criminal activities himself, and this relationship may have further localized the idea of living outside of the law for Bell. Additionally, the early loss of her brother Bud during the Civil War left a lasting impact on Bell, reinforcing her disdain for the federal government and sympathy for the federal cause. She really, it's all just like, she's at the perfect age for her brain just being molded into this criminal. And I always remember the Wild West, people were shooting everybody else for the smallest fucking reasons. People were just getting shot in the street, you get hanged, it was just, death was everywhere.
Thank God we were past that.
Yeah, no, thank God we don't do that. So young Bell, with her sharp wit, riding skills, undeniable, quickly adapted into she became acquainted very early in her life with notable figures of the time, like I said earlier, Jesse James and the Younger Brothers. But she knew them from the teenhood on, who were often welcomed by the Shirley family. These interactions undoubtedly influenced Bell as well, who was growing increasingly fascinated with the outlaw lifestyle. In the Wild West, Bell's star was the infamous Lady Outlaw had a love life as well that was as handled as a barbed wire fence they put around his head. Oh, it was some little poetic licenses. He's spicing it up. Yeah, I'm in Texas guy, I gotta bring the southern to the, It was more strangling than a barbed wire fence in after thunder, a thunder tussle. A thunder heat. Looking at reads up there are not an insignificant amount of people ago. It was one. Oh! Yeah, weird, huh? Yeah, I always say that, I'll tell you to check this on that cousins. You know what? It isn't hard to get to your cousins. A lot. Yeah, it's like second or third cousin. I love you guys out there. I do. But, you gotta talk, dude. That's just between me. I love you, but I love y'all, but I'm so worried. Oh my god. Every husband that she got pitched to became a part of her legend as the bandit queen. So we're gonna go on every husband. Yeah, can't multiple. Don't worry, we're gonna go through all of them. So let's go on a ride and uncover some of the crazy stories about how she met and married each of her husbands. A mix of love, loyalty, backstabbing, all played out against the backdrop of people dying constantly in the Wild West. Belle's first time getting married was with a man by the name of Jim. Now, you know who Jim Reed is? Jim Reed in history is not only known for his deeds, but also as the first husband of Belle's daughter. In fact, that might be the thing he's most famous for, in my opinion. It's crossed in the aftermath of the Civil War by deeds. Small-time crimes, like stealing stagecoach robberies, stealing cattle, that kind of thing. He's not really known beyond his time being married to Belle and at the end of their marriage. There's not too much more about this particular marriage. This marriage was also super important because it set the scene for the rest of this girl's life. They first met in the early 1860s when Belle, she's in the early 1860s. She is like,